not 95%, but about, you could say maybe 25 to 30%. So this is the ratio: 70% dark energy, 30 to 25%. Okay, 70% dark energy, 25% exotic matter like dark matter, and 5% baryonic matter, which is what you and I are made of. So it looks like the
Elor,
matter that makes
can I
you,
ask
me, and the
you a
stars
simple
is
question?
extremely rare in our universe.
Can I ask you a simple question? Elor?
Yeah, go ahead.
Okay, just a very simple question. When you talk about quarks, and right before that you were saying that we should observe things and go into laboratories and actually look at stuff ourselves, could you tell me how do you ever observe a quark?
So we observe a quark by seeing how it interacts with other particles. So based on its interactions, we can know a lot of things about the quarks. Quarks are
So
too
you are
small
not
to ever
observing
see.
a quark ever,
Hang on.
right?
I'm still answering the question. I was actually about to answer this question you're asking me now. Quarks are impossible to see with the naked eye, but we don't need to see it to know what it is and what it does. So to give a really good analogy, if you were in a really dark room, right, and there's no light source, I can never see you because it's too dark. There's no photons. It's impossible for me to see you. I could figure out things about you by seeing how things interact with you. So all I would do is I would shoot particles at you in that dark room, and the particles that hit you are going to hit you and deflect at a certain angle with a certain type of momentum, energy, all of these things. And if I catch that reading of the interaction of that particle with you, it's going to give me information about you. So that's what we do in these particle colliders. We smash the particles together, see how they interact and deflect, what trails they leave behind, and that gives us information on the particle.
Yeah, but
I'm
you
sorry,
don't
but
really.
if I have
Go
a
ahead.
device, if I have a device that can only detect the particle itself, because we are talking about undiscovered territory, so we certainly do not have devices for, actually showing that this is what this is, because we do not know what it is. We do not have devices for it. So when you can only have devices and you can only use devices that can show in a way, because that's not even true, by the way, you are very vague about it. But to show in a way that we
What?
have particles in a system, like isolated single particles,
How do we
then
know
we
this
can
is
only show.
happening?
Then we can only show at the very end of the experiment, whatever it is, that there was a particle. It did something. It happened. Something happened to it, and then it was a particle again. How did you prove any quark within that experiment if you don't have the
So number
device
one,
to show the quark?
we're
How
not
do
trying
we
to
know
prove
this is
anything.
happening? Because you can't go to the Hadron Collider. You can't go in there. How do you know this?
I
is
haven't been to
story?
I haven't been to the Hadron Collider. I haven't been to the LHC, but I've been to particle colliders. If you ever come to New York, let me know. I can take you out to Brookhaven, where we have the RHIC, the relativistic heavy ion collider. You know, I was working there for like a few months last year. We can go there and we can collide particles together, man.
So, okay. I have
But
some
if you have the
analogies.
device that can only show the particle, then
It
how
shows
do
what
you
the
show
particle
anything else besides
does.
the particle?
It shows what it does. That's all it shows,
Because
right, Nate? You don't know
yeah,
exactly what the particle looks like, but you just know what it does to other things.
yeah, and based on those
And
interactions, we can do
and if I could
information about them.
elaborate to make it logically important, let's just say. So this thing that it does to other things is a new phenomenon that we've never seen any other thing do to these things. Therefore, we're giving it a new category, right? For example, right. So we've been in a gym, a dark gym, or let's just say a cube room, and we've just been throwing a basketball around like it's the particle. And we get this pattern constantly of the basketball can do all these things bouncing off this cube from this position, that position, this throw angle, that throw angle, this power, that power. We get all this map of all what the basketball does. Then all of a sudden we go in another dark room or whatever, and it starts, the ball is not matching the patterns and it's doing shit that we could never recreate before. We must start assuming there's spikes on this wall or something like that. Now, here's
lovely thought.
am I with it a little bit? But the thing is,
you're with it 100%.
Okay, but see, here's my problem. So, Nate, you got to respect my logic sometimes. Then, when you see that I can follow, and I'm going to come back with, you know what I mean, skepticism. Okay.
All right.
So, it's like, yeah, you're going to get the pattern of what's happening, but you're just assuming the shape of the spike. In my opinion, it's possible that there could be multiple variations of different spikes that could still be reproducing the same outcome pattern phenomenon for whatever reason. Like, I know that's like you have to get there a little bit, but you could have like, you know, motherfucking sharp spikes and cone spikes that, but for whatever reason with this particle you're using, it's always, the tip is always going to bounce back. You're not touching the sides of the spikes, so you don't know where they smooth or round, right? So when we say it's a quark, it's just a new we don't really know what it is yet. This is my point. I don't know the whole, I just
That's
know
what I meant.
a little bit about it.
That's what I meant. If you do not have a device to show something exists, then how do you even talk about it in any way in the first place?
Because, like Don said, there are certain properties we can know about these particles. So,
So you do not
sticking
know.
with
You only know
Don's,
that the particle has changed its course, and that is only in comparison to what you have done to the particle before. It's not. You haven't
it's
checked
not
all
just
the
that.
possibilities. You haven't checked all the possibilities a particle can do, but you are assuming that just because it does something differently than it did 5 minutes before, then there must be a quark. That's the logic. And that's fucked
That's
up, in
not
my
how it's
opinion.
done. You are really simplifying it, and that's not really what's going on.
Of
So, to
course,
carry
everything
on,
has to be simple,
yeah,
by the
listen,
way.
bro, you got to
Everything.
let me
Because
talk as
if
well,
if
man.
it
You
wasn't
can't keep
simple
cutting me
enough,
off.
then we couldn't
You
do it.
spoke, and I let you speak, and now I'm trying to speak, and you're cutting me off. Please, bro.
Yeah, we got
So,
rid.
carrying on with Don's example. So, your basic premise would be, I know that, this particle is an electron. Whenever I bounce it against the wall, it's going to take one bounce and then come back to my hand consistently. So I'm working with an electron. I go into a different room, and because the wall's different, it has spikes or groves or curves in it. When I bounce the ball off of it, it's going to take two bounces to get back to me. So I know the interaction is different. This thing I'm throwing the electron at is not the same as whatever I was throwing the electron at in the other room. So I'm totally working with something that's giving me a different interaction. Now,
Yep.
because I'm not touching the wall directly, I'm only interacting with the wall using an electron, I can only know so much about the wall. I'm not going to sit here and say 100% we know the wall is a new particle, this, that, and the third. But what we can say is it's a very different interaction. It has these different properties we can assign to the interaction, and
Right.
so that we know this interaction is different from the first one, we're going to categorize it by giving it a different name. That's all.
Uh-huh. Yeah, I got it. I got it perfectly what you're
Okay.
saying, but how do you differentiate in between what you just said and the natural behavior of a particle that is not, that hasn't been demonstrated and thoroughly
I,
experimented with? Do you get what I'm saying?
I think I could
The behavior
exaggerate.
that you get, the behavior that you get. You suppose it's because of quarks. I'm saying, how did you rule out that this is just the natural behavior of particles within that closed system? And
Nate, I
sometimes
know,
what you see is what you get.
Nate, I think I know
And that's it.
exactly how you're going to come back to him. So let me see if I can reconcile these 2 points here, because I think this is a better way to. Because Nate, you're just going to come back by saying the first thing we started with you have a new phenomenon, and that's all you know about it, basically, right, Nate? Okay, so anyway, it's like, here's the problem, Nate. I think where the skepticism starts building up is when you have multiple instances of these unknown territories, and they're assumed to be unique, where maybe they could still be one, kind of. That's I think where the biggest,
Okay, I see what you guys are saying. So I'll tell you guys this because I think this might satisfy you guys. What the standard model, the standard model of particles seems to be telling us is that each particle seems to be a different interaction or a different iteration of the same thing. right? Like you know how with electromagnetism, it's all light, but it seems to be this same phenomena expressing itself differently. Either as a radio wave or a gamma ray or electricity, magnetism. It seems with the standard model, it's saying the same thing. It seems at the end of the day, it's one fundamental interaction that
Exactly my
expresses
point.
itself in different ways. But right now, we don't know what that fundamental interaction is. We are getting there. But in the process of getting there, we have to categorize these different interactions we see and see what are the common links between these different interactions. And in doing that, we're able to build this model and then improve on the model till we get to what the fundamental interaction is at the end of the day. And it's the same with the forces. We feel that the fundamental forces, it seems all the way at the beginning, they were one force. They were all unified. It's one thing happening, but we don't know what that one thing is yet. We're getting there.
Exactly my point is that you cannot really differentiate, especially and this is my root problem with these kind of experiments, that they conclude these kind of things and then you have a whole new field of science that is supposedly called science, that you experience something and then you equate that experience to something material without having a device that could show you that material in the first place. If I would claim that something has fell on me, then I would need to show that something that has fell on me in some way. It could be a bunch of pressure that has fallen on me, which means air has fallen on me. And I couldn't show it like visually because it's air, right? It's transparent. It's very transparent. I couldn't show it in that way visually, but I have other devices that could show that I was under a great pressure of air. What is the device to show the quarks? Nothing, and that's my problem with it.
What do you mean to show the quarks?
I mean, a common scale, I guess he's saying. Like,
yeah, we don't have that yet. I'm literally telling you guys, we aren't there yet. Right now, the closest thing we have to finding out what the underlying fundamental symmetry of reality is the standard model of elementary particles. Now, in that model, we categorize various interactions between masses and energy separately. That's all the model is doing, categorizing interactions, right? So masses, which are your fermions on one side, and forces and energy, which are your bosons, are on the other side. But eventually, that model is going to get smaller because we're going to be able to unify these interactions. We've already done it now, right? We're already able to unify the electromagnetic force and the weak nuclear force, right? The electroweak theory. Hopefully, we can then unify that with the strong nuclear force. And then hopefully, we're going to have a grand unifying theory where we can unify these together with gravity.
oh my
And then
God.
we'll realize that everything just comes from one fundamental interaction.
Look at Nate. See, that's this. See, Nate, my intuition is in that same position where it's like, I remember talking with you poking at strong force and stuff like this. And we've talked about this. And now you're telling me they got the weak nuclear and now they're trying to put the strong in it. Like, dude, obviously. Right? Remember we talked about this? And you didn't tell me this before.
Yeah. Well, you didn't ask this before, Don. Like, you didn't ask me to get specific before.
You saw my motivation.
Yeah, but I thought if I was just general, I mean, I gave you a general answer and you were happy with it. You didn't press me to go deeper,
But like, golly, this is fucking weird. Yeah, okay. Well, let's just say obviously then. I didn't want to interrupt him a minute ago, but you were saying what was you saying?
What was I saying? I say a lot, man.
It's a long talk. He wants the device.
The device
I want a sensory system. Okay, let's call it a sensory system. We have, as humans, have sensors, and we humans can create certain devices that could show us that something is happening here or there, right? I need either one of those. or be able to even talk about a quark in the first place. Just because you have an experiment in which you have a different outcome than you had before. For a particle, by the way, we are talking about particles that you certainly cannot see with your own natural senses. Then you equate that to I don't know what kind of different other particles actually, which are, by the way, quarks are particles or not? What are those?
Quarks.
What kind of
Quarks are elementary particles that make up.
elementary particle?
Yeah, that make up. What do we call them? They basically make up things like protons and neutrons, hadrons.
Everything is a field. Particles are just
Those
a
make up the atom,
coherency
right? Yeah.
in the field. The fields are either coherent, stable, or they are dissipating, right?
What are you reading?
No, I'm preaching.
Oh.
So here's what I'm. Here's what I want to say.
Yeah, because I mean that was
Sunday.
very accurate.
It's
I mean, I
Sunday,
just thought
man.
you were-
Like, let's get it on. I want to talk about the EM. You mentioned light. When, okay, and please forgive me, please, okay, please. But you know how there will be a like a light particle, and the electric and magnetic charge of it or whatever is perpendicular to each other, and it's always in phase. I'm sure that's probably.
Yeah. So when light oscillates, it releases an electric and magnetic field, which propagate perpendicular to the direction in which this light is oscillating. The right-hand rule. Yeah.
All right.
Yeah.
So, what the hell, bro? Okay. See, that's what I said. When I hear shit like this, and then we talk about how, you know, however you stated it so nicely before, that light is, there's the radio waves and the light wave and this and that, and they're the same, but you know, on a different level or whatever. This, you know, like how does that play into that perpendicular thing where they draw the little diagram with the 90-degree waves in phase? And I wanted to ask you, is it always in phase, or are there some of these other particles that's why they're special, that they're not in phase, or that they're only on one? Does these particles always have the electric and the magnetic? Like, is this the stuff that you know about, Nate?
Yeah, but this is only for light, Don. You know, not all. I mean, light is something very weird and unique. So I just tagged you with what it is you are talking about.
All right.
Yeah. So you see how, you know, I think the blue would be your electric field, and then the red would be your magnetic field. So
Okay,
they're
yeah.
perpendicular. But that's only for light. You know, not all things interact that way, and it's not necessarily for light. It's fundamentally for things that interact with electromagnetic fields, so things that have charge. If something has a positive or negative charge, then that is a superpower or property that allows it to interact with the electromagnetic field or electromagnetic force.
But I thought
And then
everything had the charge.
No, there are particles that don't have charge. For example, the neutron. The neutron is it's a very common baryonic type of matter that doesn't have charge. It doesn't interact with light. It doesn't interact with electricity or anything. It has a neutral charge.
But neutral charge isn't no.
Uh-huh.
Neutral charge isn't no charge. It's a balance of the charges.
Yeah, but remember now, we have to specify which charge we're talking about. It has a neutral electromagnetic charge. There are different types of charges. There's electromagnetic charge.
I was gonna be my power.
There's isocharge. There's color charge.
What's the one with
charge?
What's the one which it talks about? It said everything has a static. What's the static thing?
Yeah. Whitsitt is saying that everything is electrostatic in nature because of some quote he read, which the quote is in line. The quote does say that all molecules, all things made of matter, they are bound together by electrostatic molecular forces, and that is true, right? Every atom, the positively charged protons and the negatively charged electrons, which circle the nucleus, are held together by electrostatic forces. That's for all matter. So the quote isn't lying, but Whitsitt misunderstands it when he tries and then say that everything is made of electrostatics, because they are particles which don't have charge. And when you ask Whitsitt about that, he just says those particles don't exist.
So can you say it
Like
again? The first part. What's the first part?
So the first, like you've seen
the quote that's not wrong.
The quote that's not wrong is that all atoms are held together by electrostatic molecular forces.
Okay, so that basically, but there's a logic that says there are things that are not atoms. Simple as that.
Well, they are things that don't have electrostatic charge. They are things.
Yeah, but
even within the atom, they are neutral.
Nate, follow me with the logic though.
Okay.
All atoms have electrostatic charge.
Yes,
So if there are things that don't have that charge, we'd say they're not atoms. So therefore, there are things that are not atoms. Interesting.
That is the reasoning Whitsitt has, which is wrong.
No, but let me talk with you about the logic here. It's just simple logic. It's just simple, Greensos and Granzos and Grundles, and the Grundles are related to Grand. It's just logic. Okay, you're saying all atoms.
But that is a logical leap, dog. That's a logical leap, and you're making that leap in logic because there's information you don't have, and I want to give you that information. After I give it to you, we'll see if you still make that leap in logic, right?
I'm just going to come back to the semantics on it, though. I'm just going to challenge why would they use these semantics? It's like, let's do that. Why do they use it? If that, you see what I'm saying? I'm logical, and I'm just being like, boom, boom, bam. Doesn't it seem like it's not simple? This is going to be the point at the end. Like, why is it not simple? What, you get what I'm saying? Like, why are you going to have to go into some weird thing to say? There's a quote that says all atoms have static this thing, and then you're going to say, well, there's situations where that thing, there's things, and they don't have this. I mean,
but the reason it's not making sense is because there's information you don't have.
All right, come on with it.
I give you that information, it's going to make sense to you. So looking at, I forgot what they call it. Is it the Bohr model of an atom, right? Where you have a nucleus?
Of course I know.
Yeah. So you have your nucleus, and then you have your electrons spinning around the nucleus. Now, within the nucleus, there are two particles. You have a proton and a neutron. Now, when that
hold up, real quick. Could I ask you a question? Is the neutron an atom?
It's part of the atom.
But it's not
atoms. By itself, no. By itself, it's just a particle.
So let me make the statement. There are things that are not atoms, but you're going to tell me more about the neutral atom thing. Okay, let's go.
Yeah, that statement you made doesn't make sense. So,
wait, whoa, Big Daddy, come on. Me stating that there are things that aren't atoms doesn't make sense. There are neutrons and protons and electrons.
They are things that aren't atoms, but at the end of the day, an atom is a combination of these three particles in most cases. There is a case when it comes to hydrogen atoms where all you have is a proton and a neutron, right?
Mm-hmm.
So if everything was just made of hydrogen atoms, then Whitsitt would be correct.
What if it is?
The problem. It's not, though, because we have the periodic table of elements, which tells us that
they're just those things, Nate, but those things are just hydrogen atoms that have the extra thing added into it.
And they're not hydrogen anymore. They're a totally different type of element.
Yeah, but
carbon.
But those elements are made up. But those elements are made up. Oh,
iron is not hydrogen. Copper is not hydrogen.
That's why we call it proton.
If everything was hydrogen, then Whitsitt would be right.
So that's why we call it proton and electron, right?
Yes, because protons, electrons, and neutrons help, they count. When we count how many electrons are in a atom, it tells us what kind of element this is. Okay, maybe not electrons. Electrons basically tell us how interactable this element is, right? If it has a certain number of electrons in its electron shells, then it's, highly reactive. If not, it's inert, it's a noble element, noble gas, whatever, And then protons tell us the atomic mass of something. So if you increase the number of protons an element has, you create a whole new element. So if you, for example, if you want to turn, you can make gold out of, is it mercury? By adding, don't quote me, but if you add or remove a proton from mercury, it becomes gold.
How
Just
do you
look at
do that in
the
reality?
periodic table.
I thought it was
Yeah,
lead.
in reality.
How do you do that in reality? That was my question.
Oh, how do you do it? You have to either
Are there
add a
multiple ways?
proton.
Yeah, to add. Are there multiple ways?
They are ways. Hang on, I just want to pull up the periodic table because I want to make sure I'm saying the right thing.
Oh, I get the part that what you, in theory, based on the molecular theory altogether, you either need to add something to an element or subtract in order to get a new element or another one that already existed we know about. I get that. I get no problem with the theory itself. It's understandable, logical, and everything you want. My problem is how it's done in reality.
So in reality, what we would do is if we have a atom of mercury, because mercury is one atomic mass heavier than gold, right? I think mercury's atomic mass should be 80, gold would be 79. We want to get rid of one of the protons in that mercury atom. So we do that by either knocking it out with a lot of energy or adding energy to the system so that proton so that atom of mercury becomes unstable. It has too much energy. It wants to
And
release
it
energy.
leaves the
But
element.
the only
Uh-huh.
no, it doesn't leave it. It doesn't leave it. The only way
I
it
don't
can release
understand.
energy. I'll start
energy-
again.
But Nate, let me tell you so that I can the phrase you can maybe try
let
different.
me finish.
But
Once
Nate,
I
it's a
finish,
phrase
it'll
I
make
can't hear.
sense.
I know it's a lot for you, but it's a phrase I can't hear, man. You go from knocking it out, right, to releasing. Okay, it's hard for me to understand, and I'm sorry, man. I gotta interrupt you sometime. Look, just go on. I'll write it down. I got a pen and paper now. Go ahead.
So you can either knock
an
it out.
atom. Visualize an atom, and then you can visualize how something gets knocked off. Like it's not that hard.
So now to knock it out is a very difficult procedure, right? You need a high energy proton beam, which is very precise. Most people don't do that because it's too difficult and too expensive. The easier way, the most common way, is by adding a lot of energy to that element so that it becomes unstable. And now this element is too much energy. And all things in nature want to be at their lowest energy state, at a ground state. They want to release energy, right? So what happens now is in order to release energy, the weak nuclear force comes into play, and that proton transmutates into a neutron. Protons can turn into neutrons by releasing
the
energy.
ratios gets different.
Yes.
The ratio.
Yeah.
Of
So it
the,
goes from 80 to 79. Exactly. So now there's less protons, more neutrons. And in order for that proton to turn into a neutron, it releases energy, maybe a neutrino, maybe an electron and a positron. It'll release energy and matter in order for that proton to become a neutron. And then it goes from mercury to gold.
Okay. I hear so terribly because I'm
and,
not classical.
you claim it's demonstratable. It has been done in reality too, right?
They've done it with gold and mercury and a lot of other elements. This is what our sun does. This is what we do with nuclear energy. How we can, through fission, separate helium into separate hydrogen elements and release energy, nuclear energy. But yes, we do this all the time with a lot of different type of elements. This is how we even have elements on the periodic table which are man-made, because these elements can't be made in nature. You need very strong energies to make these heavier elements. And these heavy elements are very radioactive and they decay very quickly. So they're not made in nature. We make them in labs.
I'm literally searching on YouTube and just being, when you want to find something, you want to use the least amount of words within your search bar. And I'm searching for gold from Mercury, and I'm not seeing anything.
I'm about to ask, let's do that shit. Okay, Nate. That second process you described about adding energy and wanting to be stable and knocking proton out, that sounds like knocking it out to me. So, like, I got questions about that in itself. But what's the other way that you knock it out?
I just explained that instead of knocking it out, you turn the proton into a neutron.
I'm saying, what's the original knocking it out then? Like physically, like hitting it directly, like physically,
With a very
impact.
Yeah, so you use a energy beam that will knock that particle out of the atom. But that is very difficult because that needs to be very precise. Because sometimes you might knock out too many particles, you might knock out the wrong one.
But are you talking about the second knockout again? Because you said energy, and energy isn't physical matter. So, like, you would have to have physical matter to do an impact knockout, right?
Energy interacts with matter, Don. When the sun shines on
That's
you,
not what I'm
you get
saying.
its
I'm
energy.
not saying that. I'm not saying it doesn't interact. I'm saying if we're going to qualify a impacting impact, like proton to proton impact, is that just energy? Are we saying protons are just energy? You called it an energy beam, but are protons matter or energy?
Protons are matter. They are fermions.
Okay, so do we have beams of protons?
No. There are things called proton beams, but that's not what you're shooting into the particle. You want to shoot energy at a specific frequency that energizes the protons only.
Right,
The
but
problem
this is Nate, I got you, dude. I got you. I'm there's problems in what. Okay, so for me just to understand, I'm trying to get more information. Right, I'm trying to probe at variations announced. Like you said, you described this energizing process. Is this again this process you described us about the thing needing to release energy because you hit it with energy? Because this is just the one. This is the one. I'm saying, can we list multiple ways to turn the mercury into gold to get rid of that proton? Can we list them? Are there multiple ways theoretically to do that?
Yeah, there are other ways. I don't know all of them in detail because this, at the end of the day, is chemistry, and I'm not a chemist. Yeah, okay, these are things I've studied in theory, but I've never actually done myself. This is yeah.
Okay, because my bad. I mean, I'm just like, I'm thirsty. I'm thirsty for it. Like, shooting protons around, jamming each other. Okay, now, even on the one that you seem to elaborate a little bit more about, it's like if we add energy to something, okay, something's at its stasis or whatever, and we're adding energy, and you're saying it wants to go back to its stasis. So why isn't it just like cooling off back to the original state? Why would it ever do extra?
What do you mean? Because that's how it does it. So if you have a normal particle, in its lowest energy state, and you add energy to it, that particle becomes unstable. It becomes too energized, right? Imagine you have a solid piece of ice and you add energy to it. It turns to water and then gas, right? So the particles that make up the ice are very energized and they want to release that energy. So they start moving away from each other because the bonds between them have too much energy. So because of that energy they're able to push away from each other. And eventually that gas will turn back into a solid because now those particles are far away enough from each other. They've released enough energy. They're going to cool down and go back to a solid state. So it's kind of the same idea with elements, right? So that's why hydrogen is the most abundant element, because that is the element at the lowest energy state. In order to make these other elements, you need to make them heavier, more massive by adding more energy till you reach iron, right? Iron is, the heaviest element most stars can make naturally. Beyond that,
Oh,
stars need to then start doing a few weird things, such as neutron capture,
what
right?
number is
Capturing
iron?
on the table.
Yeah.
I don't remember off the top of my head, Don. I'd have to pull it up, man.
Okay.
Yeah.
This is. I mean, this is.
I think it would be in the 20s. Iron would be somewhere in the 20s.
Hmm.
Yeah.
Okay,
But
so
this,
this is
yeah,
pretty
this,
deep on the chemistry stuff, right? I'm just saying,
yeah.
like we're talking about all these baby items, right? It's like we saw this baby item because, look, I'm just gonna summarize. I had an issue with that. It's just weird that, you know, something you're saying you add energy. Why is it guaranteed to take extra with it? Basically, I get that the thing becomes unstable and all that, but
Mhm.
what is I'm not getting an analogy to why. Like, if you have a cup that can hold X amount of water and you add
Mhm.
extra water to that cup,
Mhm.
right? Like, so let's say we have a, a 80 size cup, 80X, and a 79 size cup, right? And we keep the water represents the energy and is full of its stable amount, and we add more,
Mhm.
and then it wants to get back. Those shit's gonna overflow, right? And then that represents the excess energy, and it's gonna stabilize back at its full point again. Why would the cut? Is it just because you're doing something? Because you're like kind of uh, attacking it that it makes the cup
Because
small? Like theoretically, why would the 80 cup ever become a 79? It's just gonna release its back down to its level point.
All right. So
Because using that analogy, the particle doesn't have a cup, it doesn't have a containment, any kind of physical containment. You can actually, in some way, in theory, and that's my problem with it,
I do
but in
appreciate
theory,
that.
you can add energy to it because it doesn't have a physical containment. The cup
I do
will
appreciate that.
go
I'll
over
assume that the cups
because
could grow in size and this and that. It's just for this
yeah,
point of
kind of like that.
like, why is it releasing extra is the kind of simple point that why would they theoretically say you
Oh,
could, you get what I'm
yeah,
saying? He's saying we're going to go from
yeah,
the
yeah.
mercury to the gold, but it's like, and the reason was because there's this process where we add energy and then it's unstable, needs to release energy and go back to its stable point.
Yeah.
That to
Yeah,
me
you're
seemed like
kind of
that's what the
right.
summary of it is.
You're
Oh,
kind of
so
right
you think,
because
Don,
based on
if it's gold,
based on what you're saying, the particle in some way has to know where is that low energy state that it wants to go to. In some way, it has to know it, right?
Right. So I'm
Yeah.
saying, are we
Yeah.
attacking the shell of the cup, or we're attacking the atom in such a way that it loses parts to keep it at an 80 and it has to come back together at a 79?
Yeah. That's a good. Yeah. Yeah.
let me ask you a question, Don. Would your logical would logic tell you, does your logic tell you that if you have something with an atomic mass of 80, like gold, and I add energy to it, and then if it releases energy, it should stay as gold, right? It should stay as 80 because the
No,
energy I've
nothing
added.
tells. No, I mean, I haven't done any experiments and phenomena. That's what I'm saying. What type of stuff do we do and know what? Like, why are you saying there would be theoretically this process? No, I don't know nothing. Why would I assume that? Like, I don't know.
Yeah, but I mean, just listen to me. So if I have gold, right, and I add mercury, and I add energy to it, and then that mercury becomes unstable and releases energy, is your thinking telling you it should stay as mercury now because it's released the energy I've added, and it shouldn't become gold?
I mean, I guess
No.
I don't know what type of energy you're talking about. I guess it would depend on the type of energy. I gave two. Look, even in the cup example, if you're listening to me, I gave two exclusive ideas where the cup would either overflow and stay, or where you're attacking it and it loses structure and it would change. So like, I don't know. This is what I'm saying. I'm like asking you. I'm asking you this question. I have no fucking idea.
Yeah, but I don't understand the question, though. You know, I'm trying my best to understand it.
Really?
So yeah, because the analogy of a cup, it doesn't really work with this.
It does, dude. It can be a bubble. Okay, like it doesn't matter. You're saying a bubble is stable at size 80, right? Is a bubble a fair analogy to atom? I mean, seriously, like you have circles everywhere, spheres. You have your sphere nucleus. You have your sphere. I mean,
Okay,
right?
so we have a bubble, right? And I've
Yeah.
added energy to this bubble.
Yeah.
Yeah, where
But
you
the
going
bubble
wrong
ain't
with
nothing.
where
But
you
the bubble
going
ain't nothing but energy.
where you going wrong with this though is that the bubble isn't just made of one thing, it's made of protons and neutrons. It's made of two different kinds of material,
Absolutely.
right? And so it depends on the ratio of those two types of particles as to how stable the nucleus is, okay? There are certain things, as you add more protons, you've got to add more neutrons because those protons fly apart because they've got positive charges, right?
Right.
But there's a force that holds them together, the strong nuclear force, right?
Okay.
But if you have too many protons together, their electrostatic repulsion will even overcome that, and they'll just fly apart. So you mix in a few neutrons together with them, right? And that binding energy,
I got my pen.
holds the
Okay,
protons together, right? Just let me go a little bit longer, right?
Okay, but it's too fast. Let me grab my pen.
You're right.
Okay.
Right. So as you add more neutrons, the binding energy between the protons and the neutrons increases, and it's it's like a glue that holds it all together. But if you add too many neutrons, then it also becomes unstable as well, because you then push the protons too far apart. Okay, and they don't hold together so well. And what can happen is when you have that sweet spot of stability, it all holds together right. But if you add too many neutrons or too many protons extra, it all becomes unstable. And a couple of things can happen. You can either have a proton turn into a neutron inside the nucleus, right, to try and equalize the numbers a bit, or you can have a neutron turn into a proton, or you can have either of those particles being kicked out in certain combinations to try and equalize things better. So if you want to turn mercury into gold, Mercury's one higher on the periodic table, right? So what you could do is you could bombard it with either protons or neutrons. Now, it's much easier to bombard it with neutrons because they're not charged, and the nucleus won't repel them. If you try to bombard it with protons, it's very hard because you've got to try and overcome that electrostatic barrier in the first place to get that proton right in there, right?
Okay.
So we bombard it with neutrons, right? And we bombard it with neutrons until there's enough neutrons in there that it now becomes unstable. And what it does is one of those neutrons turns into a proton inside the nucleus. Now you might think, well, how does that make gold? Well, it doesn't. What that does is it moves it up the periodic table once more, even higher. It actually moves it up to titanium, right? Titanium, is it? Or no,
Okay.
it's thallium.
This is cursed, or this is IQ?
Yeah. It's thallium, right? So you're 2 above gold. But then what happens is that's highly unstable, and it kicks out a helium nucleus, which is two positive protons and two neutrons. And that takes it back to gold, which is then stable.
Okay. Thank you, Kurt.
To do that, you have to use a hell of a lot of energy to fire those particles into the nucleus so they're captured in the first place. You'll actually use more energy than the gold you get back will be worth less than the amount of energy you use to do it.
Thank you so much. Hold on one second. I think I muted Fish on accident. Oh my God. Anyway, Curse, thanks, man. So I was hearing a lot. So this is your happy voice? Like you're happy right now? Oh my gosh. Okay. Yeah. I always feel so intimidated. Like you got
You shouldn't.
high tempo and a foreign accent that fucking intimidates the shit out of me, bro. Like anyway, all right. So basically you answered my question when you kind of put the checkerboard of, you can turn a proton to a neutron or a neutron to a proton, or you could add one or kick one in or out. Like that's what I'm saying. Theoretically, do we think all these are possible theoretically, basically?
Yeah,
But
you
just
can
in
add
different
you
ways.
can
different
add and subtract protons and neutrons as much as you like. It takes a lot of energy to do that, though. Okay, and sometimes you can be a bit unsure about what you can get because there are different modes of radioactive decay for things. Like if I stick in a couple of extra neutrons, there might be a couple of different pathways that new nucleus might now decay by. So there could be a couple of different daughter products instead of just one. You might get something else, not just gold.
Okay, right. So okay, well, I mean, I'm sure if they had a way to do it, they would have been did it, or if it to be economically efficient thereof. But if we're saying that all this stuff is, which I mean, it's cool to think about how the thing would just magically turn into the other thing and release the energy or whatever. But aren't all these like these basic particles like neutron and proton? We said that they're matter, right?
Yeah, but matter's equivalent to energy. So saying
Okay.
either
All right.
one or the other, remember it's the same kind of thing, really.
Okay. Yeah. All right. So is it colloquial said when we talk about proton beams or electron beams or whatever other type of beam or thing we're gonna do, we just say energize, like we're gonna use energy?
Yeah, because we accelerate those protons up to a very high velocity. Why do we do that? It's not just the fact that we want a proton in there. It's a proton with a hell of a lot of momentum, which is energy, right? So we give it a lot of energy. And the higher amount of energy means that we can actually, once it collides with something, because we've got a lot of energy available, we can actually create particles that are heavier. Because remember, with large amount of energy, we can actually create particles because energy and mass are equivalent. So when we have that collision, we don't know what we're going to get. We could get all sorts of things depending on how much energy we've got there in the first place.
Let's see. That's okay. Well, that seems a lot more just simpler to look at it that way. But I don't know where the threshold is why when we kind of break these particles, like we're already calling the bigger particles energy, and it's like I don't know why the smaller particles. It's hard for me to see how they keep getting smaller and smaller and smaller, and then all of a sudden, like, Nate's telling me how they categorizing them as exotic and this and that, and it's like, I mean, come on, where is the threshold to where it's not matter anymore? Why at some point do we just start calling it energy? Even whatever piece of it is dissipated, you know what I mean? Whatever is released, I guess, whenever it's just weird, electrons, photons, whenever the photon is released from this, I don't know the specific ones, obviously, Curse, but I know there's a variety, okay, just off how you list it. I know if like, a proton turns into a neutron to balance, there's going to be some positive energy thing released or something, right? I'm sure, right? To balance out.
It gets pretty complicated because not only like do you get like when you turn a proton into a neutron, it just doesn't mean that a proton suddenly changes into a neutron, but you get a heap of other shit too. You get gamma rays being emitted, you get neutrinos, you get all sorts of other shit happening as well. It's not just a simple change of proton into neutron,
But it's all that stuff that's released. Why not still just call that shit matter too?
We do.
Okay. It's like, because like I'd be probably like, man, this force and that force, and they're like, yeah, we want to, categorize and unique the forces and the matters. But then at the end of the day, we want to bring it back and say they're the same again anyway. And it's like, So what actually are we looking for? We're saying we kind of know we could call it one anyway. Like, and that brings me just back to the field, the aether field or whatever. One field, not empty space. You know, not space, like not empty, like not space time. Like space time is, you know what I mean? Like
space time's just a coordinate system, man. It's
exactly. That's how I see the term space time. But it's as only that, as only just nothing. Just talking about position only. Just a concept of position. Like, but no, like to me, you're talking about it. Got to be everything's a field, man. And matter is just, you know, stable units on that field, stable things on the field.
Well, that's one way physicists look at it. I mean, that's a whole branch of physics called a quantum field theory, right? It's just a different way of looking at it. It's a different formulation of quantum mechanics. That's all it is, right? And a vacuum is just the lowest energy state of all the fields in that region. That's what a vacuum is.
You know, but then that's kind of like, just because there's a cool theory of heliocentrism, right? It's a cool theory, and it could say, hey, there is this grand balance, right? It's fine. There could be a grand balance. You know, but also when the flat earther side or whatever, skeptic side of helioskeptic come in with you know, just God's toy box or whatever, you know what I'm saying? It's like, hey, like, bruh, that's the thing. There's a program field and there's the, you know, if you paint in your paint program, it doesn't matter that red's above blue or that you draw, you know, a rock above air bubble, you know what I mean, or whatever. Like you can, like, you know what I'm saying? It's just there. The field's hit with what it's.
No, you've completely lost me now. I have no idea where you're going with any of this.
I'm saying, man, look, man, the sky could just be a beautiful painting, right?
It's really hard.
It can be its own beautiful painting, right? And we don't have to assume like all them pieces are these pieces, or I'm saying all those pieces have to be falling around each other in certain, you know what I mean? It could just be like programmed that way, but still have the field units that it has until it, you know what I mean, comes across the rest of the area. I mean, this is just general, but I think that we assume too much about this space stuff. Like, there's a limit to what stars can produce. You know, there's a problem with this. We got this dark matter stuff.
No, Don. These are known limits.
We try to create the stuff to solve though. What? Okay,
yeah,
I want to get into back to where we started. Let's talk about
right,
dark matter on Earth. I just want to talk about are these dark matter phenomenons?
Slow down.
Look, it comes back around to this. I promise I was coming back around.
Down.
I said totally irrelevant stuff. Throw it out. I'm coming back around. That's like irrelevant. I'm trying to give you my stupid thought process.
Yeah.
What brings me back around?
None of us are able to follow you right now.
Right.
You know, it sounds like you haven't shallow thoughts.
No, it's totally fine. But that's what brings me back around. I can bring it back to you, Rob. To when we started talking about dark matter, right? And these phenomenons in the room and the basketball and the particle accelerator. Are there any of those, like we'll say, be created? So on here, and we're trying to make it. This project you were talking about, I swear to God, remember we start with your project. I'm totally interested to your personal stuff. Or your friends, your interest. Do we have that stuff on Earth, Nate? Or is it still in the sky? You know what I'm saying? Is it still only in the sky? Yeah.
It's everywhere. It's all around us. But like I said, because it interacts weakly with us, it just goes right through us. That's why the detector is on Earth trying to detect dark matter here. It's not something off in space.
So it's assumed all around us. Theoretically.
What do you mean?
We just said it's all around us.
Yeah, but why do you think we just assume? Like, do you just why do you use
I
that?
don't think you just assume, sir. I'm saying in theory, right? Why, where, and why is it all around us? I thought it clumps together. I thought this and this and that. Have we? And we're still. You say we're still looking for it here.
Together. Yeah, and it's clumping together. We see how it through through gravity, how it interacts and affects things around it.
Where are we seeing it here? In particle accelerators?
No.
What do you mean?
We haven't seen it.
We are still trying to detect it. We just
so you said it's all around us. Where, on Earth or in space, all around us?
Everywhere, Don. Okay, it could be going through you right now.
Okay, there's a difference between it could be everywhere or it is everywhere.
All right, it is everywhere. There's a dark matter particle going through you right now, but its effects become most pronounced, most observable when they clump together on the scale of galaxies. You know,
Why do you assume or assert that there is dark matter around me now?
because of observations we've seen of how certain
I'm asking
things,
you,
even
what
within our solar
observation?
system,
If you have an observation of seeing it around me, then you have observed it on Earth, haven't you?
Well, it's early
no,
days.
because of
It's early days of observations. I mean, there have been some detections in a detector in Italy, but they're still in the question phase there. They're not sure. And so they've actually built another detector here in Australia. It's only about 130 kilometres from where I live, actually, in an underground gold mine.
In an
right?
underground, I told you, Nate, it's
Yeah,
underground. I told
in
you.
an underground gold mine.
all of
And
these
then
detectors
what
are
they're
underground.
can I finish? What they're trying to do is confirm the detections in Italy, because the detections in Italy show a yearly seasonality. Wondering whether it's really a yearly seasonality or whether it's a regional thing. So they're trying to replicate that experiment here in Australia.
What is
And
being
they should get
detected?
they should get an opposite result, right, Paul? Like if, because you know when it's summer for us, it's winter for you guys, so it should be like inverse, right?
Yeah, well, that's what they're trying to detect, whether it goes with the seasons or whether it's related to a particular position in the Earth's orbit around the sun or something like that.
And
Hey,
remember, Don,
okay,
all we
hold on,
trying
man.
to detect is the
Jesus.
particles, you know,
Dark
the
matter
WIMPs.
particles. Okay, hold on. There's a couple other guys in here. Godric, are you listening? You hanging out? Are you available to talk? No. What about WhatsApp? You hear WhatsApp?
Yeah, sure.
Okay. Do you hear how I'm having difficulty with Nate saying he sees the stuff here? We see it on Earth. We don't see it on Earth. It is all around me. He's just assuming it and he knows it.
I
I never
basically
once
have the
said we
same
see.
problem, and that's what I said
I never
before, right?
once said we
I
see it.
was trying to be
Nate,
Yours
take
was
the
never like.
feedback, man.
specific when I
Take the feedback.
said that we do not have a sensory system. How it doesn't matter if the sensory system would be a natural one or a manufactured one. But if we do not have a sensory system to a certain claim
Well, now
for
maybe
an
we do though. To
existing
that point, what's that?
material,
Sorry.
a material, just let me finish one
Yeah, I'm
sentence.
sorry.
So if we don't have the device to detect something, then how could we even claim that it exists?
But maybe we
See,
do. So
that's
that's
my
why
problem.
I do appreciate Curse coming in and kind of giving some examples of it. But Nate, I do want to just point out to you the communication
I gave you an
difficulty.
example as well. The example he gave you is the exact same of mine. The Lux
That's
Zeppelin.
fine. That's fine. You're not
Isn't
listening,
underground.
man. That's not the
Oh,
problem. The problem is what sounds like double speak sometimes. That's all, man. I'm just trying to. It's not. I love
what's
you,
the
bro.
double? Yeah, but
Well,
Don, I just think you aren't paying attention because you
look, I
saying
have.
things like,
Okay, it's fair. Maybe I'm not.
yeah, I just think that's what you know. I think
I
that
don't know, man.
as Paul and I talk, your mind races and you come to these conclusions really quickly, and you don't hear the rest of what we're saying.
But no, I'm asking you direct, logical, mutually exclusive yes or no's, and to me, it seems like you're giving me double speak, and you don't seem to want to take the feedback about it. But
I
that's
am
fine.
taking the feedback, but
Okay,
all I'm trying to tell
I'm
you is
confused.
when you repeat what Paul and I say, that's not what we said. Well, me. Okay, let me just speak for myself. That's
Okay,
not
yeah.
what I said. We haven't
What
seen dark matter,
Say
but
that
we've seen
again.
the effect. We
Oh
haven't
God.
directly seen dark matter, but we've seen the effects it has on things within our solar system.
Have we
So
seen the things
the,
that it have effects all anywhere around me? Have I seen the in a part like what he
around
said?
you,
Well, no,
like
on Earth,
around you,
colloquially, like what Paul said. Do you think that these the thing in Australia underground and this and that? Do you think that they are showing phenomenon of the effects of dark matter here on Earth?
yes, I do.
Okay,
Yes, that
that's
is
fine.
what.
Okay.
Yeah, But this is the thing, Don. The reason you asking me that question shows you aren't paying attention, because we started off this whole discussion with me telling you about the LZ experiment, which
It's
is,
not.
I'm
It's not,
assuming now, similar
it's not that
nature
I'm not
to
paying
Paul's
attention,
experiment.
man. I'm ready to get into it. That's what it is. I'm ready to get into it. And WhatsApp also is, I know, interested in it. He kind of was doing a little bit of challenging there, where we were just talking about in general, a mix of these subatomic phenomenons that seem to constantly be uniquely categoried and all that, man. It's so. What?
Yeah,
Let's get the
I
fuck
would even
into
say
it.
Paul's the one Paul was referencing is a bit more advanced than the one I referenced, because it seems with the one they did in Italy, they actually got results. With the LZ one, they've only got null results so far. They haven't
Okay.
detected it. But him and I are talking about the same thing. So it's just a bit weird
Right.
when you
But
try to make it
what's
sound
weird to me is when like we don't know, all we doing is really just being like, cool. They're telling us they have a new, unique, materials, but like a new, unique, pattern maker.
I
You know
think
what I
I
mean? A
think
new
what
breaker,
you
because
should say, Don,
they have these physical
that
devices that do these things and then detect these charges and interactions. And then we're qualifying
yeah,
all these new unseen things, right?
you
And
should just say you
it's
aren't
just like
sure if
then
all
we
of
have
the
to
stuff they're
use
doing is
all
real.
those
You doubt
things
it.
to see this next thing. It's like,
Yeah.
whoa,
Yeah, but
okay.
Don, just say that it sounds a bit fanciful to you and you doubt it. That's fine, bro.
I don't doubt it.
We're not telling you that this is happening and it's real and you better believe it or else, but you guys are asking questions and we're just giving you answers. If you
It's
feel
not
the
that I
answer
doubt it.
and evidence we give isn't enough, it's okay,
It's not
Did
But
you
doubting.
just
It's
come out and say it.
nah. The
did you
problem
watch
is
that?
I'm
Sorry,
not.
Don.
I've been talking for an hour straight with him. We killing it. We killing it in here, man. But no, it's not that we should all doubt it. We all want to make sure that like science isn't trapping our minds. You know what I mean? We want to make sure that's like, oh, just because we have this and this and that, right? And we see these like we don't need to, make something up to glue the sky together. You know what I mean? Like we don't have to. There's
Ooh,
so much unseen
that's a good
stuff.
thought. That's a good
Yeah,
thought, by the way.
that's
I get
basically
it.
all it
Yeah.
comes down to, Nate. There's so much over application of
Yeah.
what is in my opinion, and I would think in the real scientist's opinion as well, but not by these cocky idiots hating on skeptics on the internet, hating on authority skeptics and stuff like that. The real scientists that got their machines, they know they could do this one little thing that they doing. That's it. Maybe it's happening in the sky. They don't give a fuck about the sky.
Yeah,
They give a fuck
but
about their little energies right here in their
you
hand.
also try to
Actually, that's not even true.
misrepresent
They give a fuck about
what
their
science is
fundings,
all
by the
about.
way, and this is very
Hold on,
important.
what's up? I was talking.
Sorry.
So
Okay.
science, dog, is just a tool. It's a tool man has created, which man uses to try to get a better understanding of a reality that man did not create. We didn't create this reality. We just came in and found it, and we want to understand what is its true nature. Science is one way you can do it. You can use philosophy as well. You can use religion. There are many other ways, but science is one of them. And science is the one least used by people. There are way more religious people than there are scientists in the world, number one. Number two, a lot more money and funding goes towards religion, tenfold when compared to science, Number three,
That's
science
bullshit.
makes
Sorry.
certain
I don't
claims
agree. I
about.
don't agree.
Yeah, I'm
Yeah,
still
me
talking.
neither.
You are your
Science
rabbit
makes
ass
certain.
mind.
I'm still talking.
Yeah.
Dave. Come on, I'm still talking. Science makes very clear-cut statements about reality, but science is clear in that it doesn't prove anything. It never says we are 100% sure about this, that, and the third. Religion and philosophy make those grandiose, big, absolute claims. They talk about proving things, about knowing things absolutely. Science doesn't do that, bro.
Idiots on the internet do that they say they know it's a heliocentric system.
Yeah.
And at the end of the day, when you say more money goes into religion, number one, no, it's donated willingly by people. The money that
Mostly
goes
donated. Yeah. Mostly.
in,
Yeah.
People pay
into
taxes willingly
into
for
religion,
science.
and Sorry? Well, the
People
government's
pay
not giving.
taxes willingly for science.
Yeah,
Not
but
everybody.
it's not donated. Like I don't want my money being donated to kaleidoscopes. I'd much rather my taxes go to mending old people's teeth or their health
Yeah.
or
Yeah.
these sorts
But
of things.
that's
Yeah.
beneficial, right?
Right? Sorry?
Yes.
Isn't that good?
Teeth before rockets.
Exactly. Teeth before rockets. Exactly right. Exactly right. And did
Yeah.
you watch that clip that I sent you, Nate, on dark matter?
Oh, I still need to watch it, Ben. So I'm so sorry.
Yeah.
I still need
Yeah,
to watch
no.
it.
It's a really good clip, and look, I haven't done any further investigation into it, but this fellow has quite a large channel, and he seems to do his research rather thoroughly, and he seems to have spoken to a hell of a lot of professors and things as well, which he puts out there, and basically saying that the 100 trillion zillion dollars that they've invested into trying to find dark matter has all been for absolutely nothing. And that 100 trillion zillion dollars would have been better putting into old people's teeth, probably.
Okay. So Ben, so you don't necessarily believe this to be true. You're just bringing this to my attention, right? Did you just
Well, no,
just
it's not a super trillion, but I think he said 100 billion so far.
Yeah, but I mean, what he
We're
said,
not
you don't
smart
necessarily
enough to
believe it
know
be
how
true.
serious it is.
You're
That's
just
why we're
bringing this
passing
my
it to you.
attention.
We need your expertise help, Nate.
Yeah, that's
Yeah,
why
I feel
that's why I
like
sent you the clip to have a look
yeah,
at it.
I'll watch
Because
it and I'll see what you're talking about.
yeah, it does seem like a legit clip, from a person that has done a hell of a lot of research. It's not some random YouTuber like, I don't know, Sandley or Nathan Oakley or Bev or Jesse Kalowski. It's not these sorts of people we're talking about. We're talking about someone that seems to actually have done their research quite thoroughly. So I don't know enough about the industry to actually properly critique it, but like I said, I've got a test tube here. I'm waving it around. I've got a cork on it. Show me the dark matter in the test tube, and then I'll be satisfied.
Yeah. Yeah, I'll definitely watch it though. Then
No, it's a good one.
I'll,
It only goes for about 20 minutes, Nate. It doesn't go. It's not a gin video. It doesn't go for 3 hours.
yeah, I mean it's just like you know what I've been busy with over the weekend.
Oh yeah,
So-
no, exactly right. And those priorities take first place. I accept that, mate.
I'll definitely watch it later today. I got some time. Yeah, but I think that's the underlying issue here, Don. You just feel science isn't getting us anywhere, right?
No,
It's
come
a lot of
on,
money
man.
being spent. No,
No, that's unfair. That's
Come
unfair
on,
to say.
dude.
I'm asking. I'm just asking.
No, I feel like there's a middle ground of idiots on the internet that hate people that actually know that science is way more open to not knowing what the fuck is going on in the sky. Science is way more open. These fucking idiots want to come around here acting like they fucking know everything is fucking guaranteed, bro. And you know that they do. And you do it too. You know the Earth is going around the sun. You think you know it.
No. I'm very clear about it. I tell Banso and everyone else I'm 99.999% sure. Yeah, I do leave that 0.0001% chance open. Yeah, I'm very clear on that.
Yeah, Nate is very clear in saying that science doesn't prove anything, and he gives himself an escape clause every single time.
What?
Get into a corner.
But isn't that a good thing, Banso? Isn't it a good thing that I
No.
don't stand here making absolute statements? You know, that I don't act like I'm sure of everything?
Yeah, no, and like I said, when it comes to science proving stuff over our head, you and I are on the same page, 100%.
Mhm.
Okay, then. But when you tell me that science can't prove that water is water, an apple is an apple, a peach is a peach, a piece of wood is a piece of wood, then we are going to disagree every single day of the week on that.
I hear you, but you do
Yeah.
know why I have to use language
I
like that,
know,
because
I know
you
exactly,
guys
I
are
know
so
exactly.
pedantic.
Yeah,
And yeah,
yeah,
if we were
yeah,
chilled and just having a normal
yeah,
conversation, you would never hear me or anyone on the globe side say things like, "We can't be 100% sure water exists." You know,
yeah,
because
yeah.
when we're having normal conversations with our friends and families, you know, we don't get say things like that. But because you guys hold us to such a unreasonable standard that you wouldn't hold anyone else to, you don't even hold yourselves to that standard. But for some reason, we need to bring the craziest proof to you guys for you guys to even believe the smallest thing. We have to clarify and let you know that science doesn't prove anything, that we
You
can't
need
prove
the
anything 100.
That's right.
You know, this is
You need the craziest proof, Nate, because you make the craziest claims. That's why we ask for
no,
the
but it's
craziest
because you
proof.
guys want proof in the scientific discussion, and science doesn't deal with proof. Pseudoscience does.
I know. I know.
Yeah. And you guys hold us to it's the most unreasonable the things I've been asked to present and give and verify. I would never ask you guys those things, you know. I would
Well, you
never
should.
ask someone to
You
to to recreate a planet. You know, I've been asked to, you know, show me an experiment where a planet was made from scratch. Like, come on, you know. And then I was muted because I couldn't present that experiment. Like,
Who
you know,
muted you?
that's why.
I didn't.
Yeah,
I
that's
didn't.
why I have to say things like, no, not in this server. You know, by other
Oh,
flat
okay.
earthers.
Okay.
Yeah, that's why I have to say things. We have to say things like science doesn't prove everything 100%, and there's no way you can't prove anything 100%. You guys
Like,
hold us to such a crazy level. Sorry, I'm done. I'm done
that's
ranting. My
right.
bad.
Can I say something?
Go, Donnie.
Well, you know, you're talking about what people say and stuff, Nate. What about how, like, Chili Pepper said, you know, the sun may rise in the east, at least it's settled in a final location. You know what I mean? Then he said, what he said? He said something about, you know, Alderon's not far away. You know what I'm saying? What you think he's talking about? Alderon's not far away, bro. What you think he
I have
means?
no idea what
You
you're
don't know
talking
exactly. Like, exactly.
about.
And I'm totally
What?
serious. Like, why would, you know, why would artists constantly, you know, be trying to sneak these little messages to people, bro? Why the people that try to tell on it? Why
They
they get
have
in
their
trouble,
own
bro? The
views
people
and
try to shake the
opinions.
system. Why? Huh?
Like Dawn, if you became a famous person, you would put your views and opinions into your music, right? You would start saying things people don't generally talk about in public, wouldn't you?
I guess that's my point.
But it's
Like,
hard to say.
they're successful
Yeah,
people that obviously, like, they have some
yeah, there
sort
are
of.
people out there
So
that
why do you
hold
listen
the
to
same
some
views
people?
you
Why
do.
do you listen to one person and not the other? That's kind of my point.
Whoa! Who says I don't? Who says I don't? You know, hold my own views. Who, you know, my own distrusts around the popular general narrative. You know, like I mean, there's some conspiracies I rock with. I don't trust the government blindly, fully, 100%. You know, I know there are people within the government that are capable of lying, but I also know that there are good people in the government, and I should. It's not black and white like that. You know. They might be bad Nazi scientists, but they're also good scientists that are trying to make the world a better place. Not
Yeah, well,
everybody's evil. I shouldn't
just
distrust
happens to
everybody
be that
just because
the
some
one at the
people are.
top is a Nazi, right? That's my problem with this kind of thinking, is that the Nazi is at the top, the other good guys are at the bottom. And the top guy gets to tell his story, but not no one else. And the small guy, the good guy, has to do what the big guy tells him, right? The Nazi. See, that's my problem with this altogether.
And they pretend that it didn't happen, and it's like there's a common thing, man, where we try to just be like, look, like for example, how Bandy said he wants his tax money to go to a certain thing. Okay. This is why, Nate, it's really important to not walk around over touting the confidence of what science knows, you know, because then it's like we're over praising them, therefore they're gonna get more unbalanced of the already possibly, you know, unbalanced funding. You know what I'm saying?
It'd be an interesting experiment, don't you think, Don? Right? If the government one day turned around and said, if someone stood up on a platform and said, "You vote for me, okay, and if I get elected, you will have the choice, right, to allocate your taxes aren't going to change, right?
But you allocate it, right?
Yeah,
Exactly.
yes, and you're
Vote for
going to
me, and
allocate.
I'll vote for you. Let's do it.
That's right.
Let's go.
So you can tick the box for old people's teeth. You can tick the box for roads. You can tick the box for space. This, that, and the other. It'd be very
Right.
interesting.
And you don't have to guess. You could do it both, right? Yeah, it'd be interesting. You could put your own list, and the government could offer a list of what they think too, and you could, you know what I mean? Yeah.
That's right. It'd be interesting
can
to
help you out.
see how
Yeah.
the people's conscience would allocate their tax money, you know, knowing that they had to pay it. I can't get out of it. I've got to pay exactly the same, but now I actually have a say in where it's going to be spent, and I have the power to do that. It'd be very interesting to see where people would actually allocate their taxes. I think. Very.
But at the end of the day, that is an issue with society and economics. That's not science's problem. You know?
Okay, well,
you guys can
before you cut out.
No, I never said it was science's problem. So don't straw man the argument.
Right.
I just said it would be an interesting experiment to see where people's priorities would lay in general.
Well, it is
It's not
society's problem, and science is in society. And if the government tit-sucking fund whores, you know, are could be better people, Nate, then, you know, if they are part of science, the more portion of science what they are, we could start to call it science's problem. But either way, okay,
but
right before I got a little more. Come on.
Okay.
Come on. Fine. Come on. Okay,
Can
real
I go?
quick then. Okay, so no, well, before you cut out, I was kind of saying like, this is why I tie in the problem of these overconfident skeptic haters, you know, who know that they really, if they're true science, they say we're almost certain and not 100%, but they walk around touting that we know this and we know that. The more overconfidence you get, bro, the more easy it is, because, you know, there's a general sense of, you know, overpraise for these groups because, oh yeah, they're so grand and they do all this awesome stuff. It's really whatever. They're just you know, and it's like they're like maybe, you know, but no, society, they guaranteed fucking did this. You know, these sensational articles, they're gonna get more fucking funding possibly that, you know, is already imbalanced. That's why how we're tying it like to this society government with the whole, you know what I mean, like but you cut out right when you said.
Yeah, so I was just going to say two things. Firstly, I know I'm not the first global. You guys have heard say science doesn't prove everything 100%. You know, so this whole idea, so this whole idea that Global's walking around so confident in science, and you know, I don't know how accurate that is not. You know,
you don't think the general population thinks like that we guaranteed have like if you believe you're not like, come
that's
on,
way more
like, how many people
the general population, not us.
Yeah, not us, bro. I'm talking about the general population, dude. And that's what you get when you walk around talking about flat Earth.
Do you remember yourself saying,
or fucking fake gravity shit, or you know what I mean? Talking about shit and all this space shit, dude. They're like, duh, motherfucker, we been to Jupiter. Are you fucking kidding me? It has to be this and that. Like, bruh.
Yeah, but Don, do you remember yourself saying that, what you don't like is that they are, assholes on the internet walking around talking about how, science is sure about everything. Remember you said that, that because
Yes,
I was trying to
and this
figure
is
out what
why.
is your main issue.
This is
But
why.
it sounds like now
When
you're
when
saying
they're
that
so
is the case.
confident that
The
when
general
they're
populace.
overconfident in science, taxes can get misappropriated. Let's just make it a little more simple of a direct statement there. When
Yeah, but then
population
that's
is
an
over,
issue, general populace, not an issue with science.
no, because when science, nah, man, all it can be both. Let me say, because when science starts getting corrupt motivation or
What?
or dumb motivation or motivation from idiots,
Like,
unbalanced funding because of idiot, whatever, like ability to fucking be sold on let's do all these frivolous projects. That could be science's problem. You're going to have a large portion of the see, nah, Nate, because there's damn well how many people you run around here, they doing all this shit. And it's like, oh no, they're quacks. These are quack motherfuckers. You got the fucking little alien dude over there. You got fucking Stephen Greer, whatever that motherfucker's name is. You got these other fucking people talking to water. You know what I'm saying? You got this other shit. And it's like there shouldn't be no quacks. You know what I'm saying? Like, what you mean? Yeah, there shouldn't be none.
Do you
But-
think, Nate, that science can be bought and corrupted by money?
I think science is just a tool, and it's up to man as to how they use that tool. We can use science for good, we can use it for bad. Same with religion, same with the internet, same with television, same with any
That
tool
wasn't
man
my
not what he
question.
asked.
That wasn't my
Not
that
what he
wasn't my
asked.
question. That's not what I questioned. Do you think
What was the question?
science and the people that are conducting science can be
Yes,
bought
it can be bought.
and
They
corrupted?
can be bought. Yes,
Okay,
they can.
cool. Thank you.
It is possible. And it does happen. They are bad
Yes.
scientists. There are people who
Yep.
get paid off, to not publish that, don't publish that, don't
Yep.
make that, If
Cool.
you create that product because it affects the main supplier within this industry, we're gonna
Yep.
buy your product out and never release it, even though it'll
Water
make people's
in,
life. I mean, these things do happen. But that isn't
No,
an issue with
cool.
science.
Yep.
That's an issue with people and
Yeah,
society at
no,
large.
yeah,
Number
no,
two, at the end of the
yeah,
day,
I
yeah,
meant the
but
people.
Ben, you just gotta let me finish my rant, bro.
Yeah, no,
Like,
I will. But I did mean the people, not the science itself, but the people. But go on.
the
Yep.
people,
Yeah,
the
yeah,
people,
yeah.
definitely.
Yep.
But people don't really give that much attention to science. Science doesn't get that much funding. I know that you'll hear that it costs $2 billion to build this, that, and the third, but that $2 billion is being used to build something that's going to operate for the next 60 years. At the end of the day, it doesn't really cost that much when you spread it out over that period. And then the utility we're going to get out of that is going to last for the next 1,000 years. We're going to create something that's going to change our lives
I'm
forever
sorry, I
using
have to
the
jump
thing.
in. This is getting a little bit too out there. Let me jump in and ask you, what does the Hubble telescope give humanity, you or me or anybody? What does it give us?
Right now, not much, but soon we will get utility out of the observations and understandings we get using these devices, right? The idea is the further out we
How?
look into the universe, the more of an understanding we can have of it, and the more control we can have of it. And then maybe in 1,000 years' time, we'll be able to go to those places because now we know they are there. We know how far away they
For
are.
what?
We know how we can possibly get there.
Why would we go there? If it's even
Because
in
something might
theory
happen.
possible
Something might happen
that
to Earth in the future.
the Earth is at danger right now within the let's say this 500 5,000 some kind of time span. Earth is in danger, and we might have the idea that we should leave it at some point. Now, in my opinion, if that kind of occurrence would happen for any reason, then we have no fucking chance of surviving at all.
Well, wait,
So it
1,000
doesn't make
years.
any sense. At the end of the day, it doesn't make any sense to spend this amount of time, money, work time, whatever you can, tolerate to the creation of a Hubble telescope. It doesn't give us anything.
Oh, you're not quite right there, because don't you think that the technologies they developed for the sensors and detectors hasn't trickled down into the modern day devices that we
been
use
around
today?
for 100
Not
years
finished,
at
not
least.
finished, not finished, right? Don't you think that the materials they developed for the Hubble telescope haven't trickled down into making things that we use in our everyday lives now? Of course they have.
Oh, sorry, I have looked into this very thoroughly, because it's a claim, it's a general claim within the, how should I call it, the common knowledge. It's common knowledge, but it's not true that NASA gave us a lot of things. It has gave us Velcro or better lenses. and
NASA
shit
didn't
like
actually
that.
give us Velcro.
None of it. Let me finish. None of those stories are true at all.
I
NASA
know. I
only
never claimed they
using
were. I don't know
other-
why you're claiming that we say that,
yeah,
because
I
I
know,
do
but you
know
are,
that that's not true.
If it's
yeah,
common
but
knowledge, I don't
you are
know.
trying to imply now that because of the Hubble telescope, we have new stuff that we can use at other industries, and therefore in
do.
our everyday lives. No, the Hubble telescope is using already existing stuff. It's the other way around.
Like the Goldilocks planet.
Telescope man gave us none.
Goldilocks planets, bro, all over, bro. Better than Earth. Just gotta get there. We're gonna get there one day.
Now, yeah, or we'll be powerful enough to terraform Mars.
Dude, without the Hubble, how will we find those Goldilocks planets, man? Without the James Webb, bro, we have nothing. How are we gonna avoid that big asteroid coming to Earth that ended the dinosaurs? Mathematically, it's gonna happen, bro. No stopping it. Gotta rely on NASA to shoot rockets at it. Good morning. Oh, how are you?
Chilling.
What did I miss?
I've been attacking Nate.
What's the discussion about?
You know, well, basically they're critiquing society because of this perception that society places too much reliance and surety into science. It seems that seems to be the case. You know, society at large and Globers on Discord seem to be overly confident that science has all the answers, this, that, and the third.
Hashtag Nate thinks dark matter is everywhere. Or is it dark energy?
There's a guy in Gem Pandas that will tell you science can explain everything. Everything's explained by science. You don't need nothing but science. So yeah, I agree.
Especially
Who's
love.
that?
Especially love. They can explain love very thoroughly.
Oh yeah,
Love is a chemical reaction, and you better take the.
Oh my
the
God,
test.
love is so actually, love is beautiful,
They've
guys.
supposedly had groundbreaking love developments this decade.
Oh,
The
it's
top scientists
beautiful.
will tell you that
Come
love
on.
doesn't actually exist. The top scientists tell you love is just a chemical reaction. It's just an illusion. So
Hey, well,
check it out.
it is. I agree. It is chemical reaction, actually.
So why don't you just take a blood test to see if you really love the person before you get married?
If you got love in you, let's
Stop
take a
doing the blood
blood
test.
test. If you got love in you, yeah.
You don't pass the blood test, you don't get married. You just make it like that.
Okay, here's a question.
Well,
Pheromone attraction is definitely chemical.
Oh,
100%.
absolutely.
It's intoxicating.
One
Actually.
100%. Oh, definitely.
Do I need a blood test to get a hard on?
I think we have definitely a DNA program. Like, we definitely have a program of what to do. To me, the motivation to win or to do the best or create or to please yourself, like, just the motivation for that and the lack of direct, immediate payoff or reward for such like achievement. Like, you don't just, I mean, we could exaggerate the example, but it's like, you don't just become heavyweight champion of the world and then boom, you have a baby tomorrow. It's like you're way more likely, you know what I'm saying? You're way more likely to attract a lot more females and blah, 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 blah. It's going to happen. And you can logically learn that. We logically learn this, and that's the process I want to talk about. How the evolutionary factor of society, the pressure. That's the term I'm looking for. The pressure. What immediate pressure? How do we learn that achieving? And to me, it's like we're just programmed to come out here and do these awesome things. It's not like evolution fucking taught us this. Like the weird shit that people do to be unique and want to, like, there's no direct immediate payoff that they just be like, oh, I'm gonna, get my mate now and have a baby or whatever the hell the payoff in life.
Wow, you
They
sound
say
so robotic.
Me, I sound robotic. I'm sorry.
Yeah.
Sorry.
It's like
I'm
trying to you, you don't have any love in your voice.
I should write it down.
There's no love there.
Yeah. Oh, my bad. I am a psycho, a little bit psycho.
Yeah, there's no chemical attraction there. What how you're saying things.
Do you think that you'd be able to feel my chemical attraction over the internet? Yeah, but
Don't worry.
Damn.
Don is soulless and he's heartless. Right.
No. I'm actually I'm kind of like putting like I'm more for the love of a design or creator or creation than just saying robotic evolution. To me, evolution is robotic.
Honey, you put it in the crate instead of putting it in your heart. Oh my God.
Oh, I get you. No, it's there. This world is beautiful. There's so much. That's what I'm saying. What we've created through love. That's kind of what you get. What I'm saying. There's no immediate payoff for that. We have so much love, and yet you're not guaranteed anything really for giving it, right? So how? This is what I'm saying. That evidence is evidence to me against this slow-moving survival of the fittest evolution. You get what I'm saying? I think.
Yeah, I do. I think you've just lost your heart.
Damn.
Oh, Don,
Damn.
you heartless beast. What the?
Do you know what? I'm sorry.
I don't know if I'm not saying what I mean to say here, right? But
No,
okay.
But I found mine. I found mine.
What is love? I think love is more than what science is going to say that it is. This is my point. I think
there's no chapter in the science book that tells you how to be happy. Okay?
Love is pure.
Yeah.
Love is pure.
Love is when you find it, you know you got it, right? And don't illude yourself into thinking you found it, because if you think you found it, you don't know that you've got it. You know when you've got it.
There is so many avenues and aspects of love.
Robots love everything. Robots love everything.
What do you mean robots? I'm gonna stick my finger up right now.
I have been programmed to love everything.
Oh, bless your heart.
Do you think 1 Corinthians sums up love pretty well?
All matter is energy, and energy is matter, and will be one particle at the end. Grand unifying theory. Therefore, I love everything the same. Everything is the same.
Yeah, I can read 1 Corinthians 4 through 8 if you want.
Hit us.
Go for it, Napalm. Hit us.
Love is patient. Love is kind. Love does not envy. It does not boast. It is not proud. It does not dishonor others. It is not self-seeking. It is not easily arranged. It keeps no record of wrongs. Love does not delight in evil, but rejoices in truth. It always protects, always trusts, always hopes, always preserves. Love never fails, but where there are prophecies, they will cease. Where there are tongues, they will be stilled. Where there is knowledge, it will pass away.
It's quite enlightening.
Amen.
Yo, but don't you guys think there's like love can also have a bad side? Like, wouldn't you say love is more like a spectrum? You get different types of love languages, and they can be a toxic, bad type of love,
Cold
No, you're
hard.
talking about a crazy bitch.
Give
I'm just talking about,
Give an example, Nate.
lo-
Give an example of love
okay,
being bad.
so basically love is a two-way relationship, right?
No,
If you lo-
love is what
Yeah.
you give. Love is the feeling you get, like you
And you
feel
can also
the
get
happiness.
you can also get it though. You can also get it, right? You can give love
It
and you can
can
just
be a two-way relationship.
yeah, it can be okay. It can be a two. It can be two-way, one-way. Cool, fine, whatever. But there are situations where, for example, in two-way relationships, where the love isn't the same, or where the love is
Sure.
one-sided, and it becomes a toxic type of love. Would you guys agree with that?
Sure. For general, yeah, sure.
Yeah.
I would say
Yeah.
you'd have to allow other
Why would you call
emotions
it
to
love?
come in to play.
It's like, yeah, then it doesn't call it. It's like when it changes, Nate, it's kind of like there's a point where then you don't call it love anymore.
And then
Why
if that
not?
love becomes toxic, on what part is the love becoming toxic? Is that love that's toxic from the lover or the one being loved? Because if the love is from the lover,
It
right?
can't be. It can't be toxic.
Well, it
No.
can't be.
Or it has to be
because-
love still. It's still love from them.
Well,
They're
no.
sending love. It just
No,
received
no,
it. They don't
no.
like it.
If,
Okay, sorry.
if it turns toxic, Don, right, in whatever however that toxicity may manifest itself, it's not then love.
Yeah, that's
It
what
be-
I totally exactly. It's they're not sending love anymore.
No,
They're
not at
sending
all.
bad shit now. Right. They're sending
Exactly.
toxic, which we don't
Yes.
qualify a toxic thing as love. That's not in the
No.
definition.
Exactly.
Right.
Exactly.
What?
Yeah.
Yeah, exactly.
Your phenomenon changed. You have certain phenomenon that we witness that's called love.
Yep.
As soon as you want to start saying there's this toxic thing happening, it's a different particle, Nate. It's a different phenomenon. It's not
Yeah.
called love anymore.
It's
No.
dark matter. That's what it is. It's dark matter. It's very dark.
Hang on.
This
Pluto
logic
Really?
follows simply. The simple logic.
Yeah.
Someone doesn't agree with you guys.
I think you just identified dark matter, bro.
Yep.
That's something.
No, come on. So,
That's what dark matter
can't
is
there be a
everywhere. Dark
situation
matter
where
is
you
everywhere.
love? Can't there be a situation where you love something too much?
Yes. So therefore, there. Right.
No, that's jealousy. That's
Where the
envy.
love
Okay,
No,
hold on.
that's not love.
But you could be
becomes-
too much for them, and if it's too much for
Right.
you, it's an addiction. It ain't love anymore. But if it's too much for them, you're still sending the love. But to them, it's toxic. They don't call it love. You call it love. You see what I'm saying? There would just be a disagreement in definitions there.
That's why. So that's love in a two-way situation.
Yes.
You really love this person, but the love. Yeah.
Well, there's love. It always has to be two people. There's a sender and receiver, but the love isn't two-way. We're not talking. We only love from A to B. We're not talking about B giving any love to A.
I want to know how this love turns toxic. Like you've got to define this toxicity a bit further, because if you're saying that you love something too much, right, and now all of a sudden it has turned toxic, or how has it turned toxic? Like what
I
are
think she
you?
means like an obsession, right? Like a,
Yeah, it becomes a crutch. The love becomes obsessive, answer. Because if you look at love, love is a deep affection for something, right?
Oh,
That is
okay.
what love is.
Yeah.
So there are different levels to it. There are different types of ways people express love, right? Like you've heard them saying that people have different love languages. People love differently.
But
I
that's
mean,
then your
I disagree.
behavior then. That's in your behavior, how you express it. Now, if that behavior is that you have to, you can't be without that person, you've got to be with them 24/7, you've got to control them, you've got to do whatever. Now,
But that's
now,
love.
well,
Yeah, but
no, you've
Yeah,
become
no.
overbearing,
Same.
you've become controlling,
Yeah.
you have
Because you
become
love them.
a problem. No, that's not love.
Yeah, it comes from a
Love,
place of
no.
love.
No, it's not coming from
No?
a place of love. Not at all. No, that's coming from a place of insecurity. Then you are now insecure
It's
about
place.
that.
We gave it different words, Nate. It's now a place of obsession. Let me make a point real quick, and help me with this, Nate. The deep affection. If we want to generally say deep,
You cut out there, Don.
Hello?
okay, we want to say deep affection. What is the observation of phenomenon of the deep affection? It's usually, to me, in my opinion, like wanting to see something or look at something or be around something because it pleases you, right? You're like, I love this thing. I want to interact with it. Okay, that's one way to look at the deep affection. I think we could agree there. There's another perspective that says it's love is qualified when you give, when you do, sure, you have the affection still, but how do we observe it? It's people doing for the helping, right? Giving, right? Sharing their energy. Now, to add on to that point, isn't it interesting, if y'all agree or not, that we can actually sometimes despise something or think that something is bad or has a problem, but still be infatuated with it and still have a deep affection with it. And we can love, therefore, by giving. We don't love like it pleases us. Maybe it hurts us. There's people that supposedly keep getting around things that hurt them, and they have a attraction to it, whatever, and they give to it. They could be giving to their enemy or that in which they despise. That's also love, isn't it? Or is that some sort of not love thing?
Yeah, that's why I say love is on this. Oh, sorry, go ahead.
It's a mixed spectrum, right? Right?
Love can be good. It can be bad. There's different shades, different colors, different expressions, you know?
But that's why good and bad, isn't it just the phenomenon of which we observe? Like, isn't it just giving, just doing? And who's to say that it's good or bad? Like, if you're Mother Teresa and you're doing for your enemies, you know, why is it bad? Like, at what point does it become, oh no, you're a slave getting abused? Or it's like, no, you don't have Stockholm syndrome, or you do. You know what I mean? Like, at what point is it Stockholm syndrome?
Yeah, what about a father who gives his son tough love? He doesn't hug him, doesn't show him affection. He's hard on him because he loves him and he wants his son to be ready for the world. You know, I mean, that's how he loves his son. Maybe that's how his father loved him as well. So that's the only way he knows how to express his love to his son. You know?
But I guess what I'm saying, Nate, is even though it's hurtful, even in the situation where you're somewhere that gives you pain, but you're still giving the love, right? And it still can be a Mother Teresa, let's say, or something. That is what we have to qualify as the love, that deep affection, that generality that you say. As soon as it changes from that, it's not love anymore, right? As soon as there's got to be or as soon as that element is not present, you have to have the presence of that, of actual a doing phenomenon. You know what I'm saying? And then if you're saying there could be good and bad, how could that ever be bad? Right? Like, who you say what good and bad is? Or do you mean it could come along with pain? Is that what you mean? Like, love is a good thing. How could it ever be bad by definition? That's kind of just period. I'm giving you my best Steelman arguments. You could be involved with your enemies, is my point. I understand how you could love your enemies.
You can be betrayed by love, like if your wife cheats on you.
Well,
sure,
what
but
I'm trying to say, love is a
yeah.
Love.
Sorry,
no,
Nate.
go ahead, man.
No, we keep on.
We know love hurts.
Yeah, all I'm saying is love. We like to see it as a positive, good thing. But at the end of the day, real love is a bit more complex than that. Real love can be ugly, but somehow, even within that ugliness, it can be beautiful. It just depends how it's expressed and how it's received. People express their love in many different ways, and sometimes it can be toxic.
And on
It
this
can be.
Sunday,
I don't
let us
think
join
love,
hands.
Hmm?
I don't think love should expect anything. Like you just give it, and you shouldn't expect it. But when you, but when
Mhm.
you do, but when you do receive it, like it's a beautiful thing.
Mm.
Uh, definitely, when you receive it, but um, you should, love is unconditional. It has no strings attached to it. You give it, right, and you shouldn't expect it back, right? Because
Mm.
it shouldn't be a conditional thing. Now, yes, you can get hurt, because of love. You may love someone and they don't love you back, and that hurts. Okay, but um, you know that isn't love being bad per se. You're just not getting back what you're giving. But love definitely should not be um, um, conditional or have strings attached to it or caveats or anything like that to it
Yeah.
whatsoever.
I don't know, Vince. I don't know what love should be. Love
Well,
is
no.
it's a
Well, that
very difficult thing for one to put their finger on, Vince.
Be happy as we can be. Let's praise and bless the
And it's
glory of this experience of life on this beautiful Sunday. And
yeah,
let's try to
like
stay as we can
in
do.
its
Try
simplest
to be happy.
form, love is just a very deep, strong affection for something. That affection it can go away. You can
I
love
think
someone and stop loving them. It does happen.
and
I
it
know what
doesn't
it is.
matter what we think it should be, Nate. Like that's why we're talking about it. Like what my idea of love is obviously different to what your idea of
Could I
love is.
could I try definition?
No.
Check this one out. Check this one out.
And he
Love,
goes ahead. And he
love.
goes ahead.
You know you want it. Love is when you feel the most comfortable away from death.
Oh, that's deep.
Love is when you're thinking about death the least. That's love.
Oh, when you are peaceful, like you
Most,
could die
You
tomorrow,
know,
and it's okay.
or you're just as happy. Yeah, you're at like like what I mean. The more happy you get, the more comfortable and happy you are in life. That's love. The position of the thing, appreciation and recognition of the things that you're
Have you
interacting
ever,
with.
have you ever
Because
felt that way before, or do you feel
oh,
that way?
dude, I'm full of love all the time, man. But at the same time,
Mm.
you definitely
I so try to remove my biases all the time. Sorry, sorry.
you are definitely full of it, Don. That is for sure.
Oh, fuck y'all. Fuck y'all. Fuck everybody. No, I mean
Oh,
seriously, seriously. No,
dear
I
the
know.
mio.
it's but that doesn't mean I don't suck at it. That doesn't mean relative to other people. I don't know what other people are, but I do know that like, hey man, this is amazing. There's logics higher than we ever can comprehend. There's things that you look at. There's so much stimuli that just so pleasing for whatever reason we're programmed to get pleasure off.
Mm,
Pleasure,
absolutely.
wonderment. Like
Pleasure. Yeah, pleasure is a good thing.
Yeah,
Most
it
definitely.
is. It is.
And
Can't wait.
think of
I
like
can't
think of
wait
like
I'm
to
a
get
the
pleasure.
think
whore.
of, think of the new ways people are falling in love. In building these bonds. Like you have with like a tool like the internet. You have people across the world falling in love, creating this deep connection, and they've never met before.
Oh,
if
absolutely, honey.
yeah,
Yeah.
it's I mean, it's
Really?
really like you think on love.
Love
You
without
can fall in
pheromones.
love. Yeah. You can, now with the metaverse coming about, you might just be plugged into virtual reality and you fall in love with someone. And
Oh,
that
they already
someone
doing that.
would be like an avatar, right? So they might
Bro.
be someone
They've
like
Really?
been
Wonder
doing
Woman.
this, bro. They've been doing this for decades.
Yeah,
They've
yeah,
been in World of Warcraft with the elf and the ogre, bro, dancing by the
yeah,
waterfall.
yeah,
Okay.
and they're in love. They can't live without each other, and it's a really good love. They're at peace. They could die tomorrow and they're happy, but that's love. It's weird. I don't know.
What about if you fall in love with an AI robot? Is that love?
Did that once.
Yeah,
Is that love? Is it?
What?
it must be Banso,
Fall
because
in
it
love with
seems
a
all
robot?
of our definitions could fit into that situation.
It's really
You
bizarre when you
you
s- when you
yeah.
see something like that. Like, and this really apparently really does happen. Like people fall
What
in
if you
love.
fall in love with your
and they-
horse or your goat?
Well, people do, right? People want to marry them. They want to spend the rest of their lives with them.
No,
It's
seriously.
crazy.
Seriously, they
Or,
do.
or the journalist who wrote that article had nothing better story to write about, so he made one up. That could be a possibility, right?
Yes.
Come
But
on.
there are people who feel rejected. There's people who have enough fear. I think it's out of fear, but people fear, the risk, whatever, of the real relationship, the fear of, and they just love the goat instead.
The goat?
Oh yeah.
Yeah, but at the end of the day, that love could still meet all of our definitions. Like
Yeah.
Bandsaw said, you give without expecting to receive. You could love an AI and not expect the AI to really love you
Oh,
back, because maybe the AI can't really have true emotions.
Caloric
You
wants to
could
uh,
love
marry his
the
goat.
yeah, no. No.
No, I'm just saying.
It could give you some kind of love.
Yeah, this is further evidence to love not necessarily being all butterfly and roses and a good thing. Love has different shades and colors, and it can be bad and weird.
Mm. Okay.
It can be.
Nate, you are a bad boy. We need to get
Yeah.
into your definition of bad now, because to me, love and hate are different than good and evil, or good or bad. Bad meaning
Oh,
pain. And is
well,
it
now
just
it's
pain?
gone very dark now,
No.
guys.
Nate is just weird. That's all it is. He knows. Ah.
No, he's had no sleep. He's getting all giddy. He doesn't know what he's talking about.
Yeah.
Yeah.
Yeah, I just feel it seems like it's taboo to talk about the ugly side of love.
No, it's not taboo at all. It's
No.
not taboo. Explore it. Definitely.
Yeah,
It's
no,
not. Nate, what
love is
let me offer
beautiful.
one more thing. Nate, I don't think it's this. I think what it is this universe works in balance. Like, and every time the thing moves to balance, the thing is, there's always got to be a balance, a give and a take, a action and reaction, and for there to be love, it has to be relative to something else. So therefore you have the bad and, by contrast, and that's what it is. It's like and the more, the bigger you are, the harder you fall type of situation as well. So, I mean, I don't think by our definitions, though, love, there's anything that could qualify anything bad or negative as being any part of the love unit, like a unit of love ever. And you keep trying to jab it in there.
But I mean,
Uh,
we've just discussed situations, Don, where we've agreed that that is love. It's just now when I take those situations and I relate them back to your guys' personal definitions of love, that's where the issues start arising. We've agreed that people can't be in love with AI. But when I try to relate that to your personal definition of love, you won't accept it.
No, it's got nothing to do with accepting it. Sorry.
Yeah, did you say glove unit?
Come again?
Yeah. A unit of love.
Oh, okay. All right. Cool.
Yeah. Not a love member.
Oh, okay. What does that mean?
Are you talking about size? Size matters. What are you talking about?
Just your amount of if you were to say there's a scale like Nate's saying, or like me and Nate were saying, I think
Yeah.
that you could give an arbitrary unit.
You can call it a scale, but the interesting is love can't be quantified by science.
Mm.
Yeah,
It's
neurons
actually-
fired. That'd be a love unit. X neurons fired.
Oh, okay. So maybe I got it wrong. Okay, cool. All right.
What about the love? What about the love for your children? Is that going to fire your neurons?
What?
The love for your
Sorry?
mother, your father, your family. Same thing.
Yeah, but right, Godric, you agree with me. There are different types and shades of love. Love can be ugly, it can be hard, it can be toxic. It's not always nice or good, right?
Yeah, no,
A mother
absolutely.
can be
Mhm.
a mother can
No.
be doing affectionate on her child.
No.
While sometimes a father can love by being hard,
No, it's because you did what you did, because you had love units, and that manifested and motivated you to be where you were in the nature. Because of that reacted with nature, and there was other things of bad units that came along. So love can attract bad units and balance with bad units, but love is never the bad units. And Nate, you need logic classes. I promise you. I love
No,
you.
I agree. I agree. Love always comes, well, not all, love generally comes from a good place, right? Love source is affection, a deep affection. That's where it starts off. But then how
Well,
you end up expressing it or receiving it.
absolutely. Absolutely. Yeah.
I think there's two types of love when we're talking about people. I think there's the family love, the love between parent and child, which is inherent, which it's kind of inbuilt, right? But then you have another love, which is free love, the love that you give away, right? And
Mm.
I think they are totally different. And
Absolutely, Benson.
I think the one that you give away, when you actually experience love that is given away freely and unconditionally, there's nothing like it. It is so different to the love between a parent and child, or child and parent. I think they are different, totally different. But the love that you actually give is, I think that's the ultimate. Actually, I think that's the ultimate.
Yes. Benson, you are correct.
As usual.
So when a man loves a robot, loves an AI, loves an avatar without expecting to receive that love back, that fits Bansall's definition then of love, of one of the types of love.
Hey.
What?
Bullshit.
What if you only love
Why not?
yourself?
You loving the AI,
Bullshit.
knowing the AI can never truly love you because it's not a human being. It doesn't have real emotions. It's a
Hey.
computer.
Bullshit.
But you love it nonetheless.
When did I
Bullshit.
when did I mention anything about AI and
No,
AI
I'm just saying. I'm just saying that if someone loves an AI machine, a robot, that meets
Hey.
your definition of love, Basil. But now you giving me pushback,
Nah,
AI
Kawhi.
won't talk back.
I don't
No.
think you can
No,
throw in
I said
Love-
I was very clear. I said the love between people. A
Yeah.
person that wants to love an AI machine is just weird and twisted. In
But
my
why
opinion.
is your love
And they-
exclusive to
and
people?
they-
What
and
about
I
love
think-
for
and
pets?
I think, look, because you love your rabbits and can't eat them, that's your
Wow, low blow. You always got to resort to being low blow.
Oh,
But I think
lovely
the
moment.
love for yeah, I think the love for your pets and all that sort of stuff. I think I personally think that's different myself.
I would-
think they are.
I would
Yes.
openly challenge anybody that's had children and then this person that loves their AI machine, and I would like to interview them to find out. And again, I'm being facetious saying interview them, but like the actual idea of saying, okay, your love for your children that you just had it like 10 years ago, right? And now they're starting to like, be people and whatnot, and you love your AI machine the same. I have a tough time with that.
Look, I would give my life for my kids, so is that love? Any of my kids,
But,
if I
I
had
mean-
to, I would give my life.
What if
Yeah.
you guys have
Scottish
seen
brings
those
such a valid point.
you guys remember those I think it was like, I don't know if it was in the 2000s, those toy watches like Pokemon,
Mm.
and
Oh, yeah.
they grow.
Yeah, you had to feed
Like a
them and
pet.
do stuff to them. Yeah, the digital thing, the Tamagotchi.
Yeah.
Tamagotchi, yeah.
Yeah, those things, What if you
Bro.
had an AI like that, you loved it, you had, virtual pretend sex with it, it gave birth to virtual
No,
Oh,
Tamagotchi
you
baby,
caloric.
fucked up.
and
You're
you
fucked
and the
up.
AI raise the babies, and you love them,
Caloric.
and you provide for them. You go to
Yeah.
work to keep the light bill and the Wi-Fi bill on, so that your babies can grow.
How about
Okay.
no?
Yeah.
But okay,
How
cool.
about
Let's
how,
let's
how, how
let's
about the
take
environment that you've been brought up in has been lacking, right? And you are lacking something within yourself to think that that's even a possibility. That is just
But
crazy.
that
talk.
is the
So-
future we are moving into, guys.
No,
That's how
it's
people are
not.
loving.
No. Caloric, let's take your love, right? And let's look at it like an investment. I had this conversation with my kids. My son's 12 and my daughter's my son is 15 and my daughter's 12. And I said to them quite honestly, because they're going into people of the world now. And I said, you guys have to realize that you are investments. And they're like, what do you mean commodities? I'm like, investments. Your mom and I invest things into you, i.e. time, money, and things like that, so that you can grow, right? And then you can give back to the community, and you can then express love that we've instilled in you in this form of an investment, right? So I don't see how we get to invest in a machine that kind of it has like a finite end. That's why I have a rough time establishing love for an inanimate
The
object.
machine could train you. The machine could babysit your kids. It could give back. The machine could give back.
They're more reliable. I give
What
less lip.
machine?
But they're susceptible to rust and corrosion, aren't they?
Yeah, and an AI will never talk back to you. It'll always do the
Exactly.
dishes. Like,
Exactly.
What, really?
But they could grow. They
Not
support
a
Okay.
wife? Not a
no, I'm
wife?
joking. Huh?
Oh, definitely. And definitely, that's where you want your wife. Definitely.
It's
Yeah, always
bullshit,
make sure
Dinosaur.
that the chicken
What?
is never burnt.
Oh, that's exactly what I want my wife, barefoot, pregnant in the kitchen every single day of the week. Don't you worry about that. 100%.
Yeah, well,
Yeah,
I'll be
well,
there.
what?
I'll be there, babe. I'll be there, babe.
Yeah, but
That-
I mean,
that's where
at the end of the
all-
day, we're moving into a world where people can love AI and avatars and things the same way they love humans, and love just, we can't sit around and keep saying love is always something good,
That's a perversion. That's a perversion of love, bro. That's like loving porn.
Yeah, love
That's
is
like loving
good.
your vibrator, bro.
Oh, there's some porn that is the ultimate. It's the ultimate. By
What?
far. Oh my God, there's some porn that you can
What?
watch that just
What?
blows your mind. Yeah, 100%. There's some stuff that'll. Oh my God. I
You
can think
talking
of
about
one.
like Russian midget porn?
Oh, no, Buggy, you can keep your midget porn. Oh no. It's a very specific genre that I'm talking about. And it's the ultimate. And the
Wife
absolute
in the
ultimate.
kitchen porn. No, I'm joking.
I was just playing. I was just
Oh,
playing, bro. You took it there. I was just playing. You took it all the way down there.
Oh damn.
yeah.
Now
All right,
I'm
let's
looking.
all
You
grow up.
know what? You know what? Talking. I've got to watch some right now.
Star
Right
Wars,
now.
Chewbacca.
Yeah, but let's all grow up and remember we human beings. Let's
Oh,
get back to the adult
Yeah.
conversation we have.
okay. Stop acting like AI.
Mm.
Someone's giggling.
What do you do as a parent? You know, in the year 21,063, when your son comes home with an AI as his girlfriend, and it's normal in society. Everyone's doing it, you know. 'Cause
I go, where did I go wrong? I look at myself and the
Like you
environment.
take a shotgun and blast his face off. That's what you do.
But everyone's doing it, guys. It's easier to date AI than humans because, you know.
It does a bit, so because everyone does it makes it right. No, not at all. Your job as a parent is to nurture and to guide, not to be their friend at all. Right? Is to give them the best possible chance. Right? To nurture and guide, give them a good foundation where they can thrive and survive.
Look, you're
You
not
know?
gonna have a baby with your robot, okay?
Oh,
It's not gonna happen.
yeah, but I mean, it might be like those Pokemon babies I was talking about earlier.
Look, how do you clean once you finish with your robot? How do you clean it out?
What do you mean?
With a
Like a
gurney,
sponge?
with a gurney.
Maybe the
Water.
robot has like a opening, like a thingy majiggy. You know, these fleshlights, right?
Yeah.
Yeah.
Godric wants to know how you wash them out, and I said with a gurney, a
I don't
pressure
know how you
washer,
are.
a pressure
Yeah.
washer. You take it
Pressure wash.
outside.
Like the
Yeah.
moment the robot gets mad at you, it'll snap your dick off. Okay, it's not a good thing.
Well, then you need that special AI that has built-in anti-dick off, snap off dick capabilities. All right, so the whole talk of bloody AI and people having relationships with AI and it's normal is just bizarre.
Yeah,
Absolutely
but it is
bizarre.
a type of love that meets all of your definitions of love, you know. So I don't know why you guys won't accept that love can be weird sometimes.
It's
Doesn't
a
mean
perversion.
Because it's Sunday. It's the Lord's Day. We're talking about robot love. Oh, man.
Not the Lord's Day
It's
everywhere.
a perversion because you're fooling yourself because it's not a real person, bro. It's just like falling in love with porn and falling in love with your goat or some shit. Look, if
Oh,
you
used to
could
have
choose a real look, if you could, Cloris, you can choose
only
a
people can be
real
loved? What
woman
the hell?
or an AI, what would you choose? Be honest.
If I could?
Yeah.
Yeah, obviously I would choose a real woman today, you know. But what if we go 1,000 years into the future and everything's different, you know? Maybe I would be the weirdo for picking a real woman. You know, people would laugh at me like, "Wow, that guy's dating a real human being. What a loser. What a weirdo." Like, I don't know.
Why are you going to be susceptible to what other people think?
exactly.
Do you, man?
Because we all do it, guys. Come
Here's
on.
the thing. I would love to have a real life wife and then a robot that could do whatever she needed it to do. Because if she's happy, bro, that means that I'm happy. Happy life, happy wife.
I agree. That's why I said today I would obviously rather want to be with a human being than an AI. I was just giving an example of the future.
Look,
And
you
I've
make
noticed
love to
women
Look, you make love to your real wife, and the robot can sweep the leaves off the roof and shit like that.
That's what I'm talking about, man. Jetson type lifestyle, right? The robot made, got the real life wife.
Yeah.
Now,
Yeah.
okay, what's gonna happen if you take an artificial wife and you decide that you want to get a divorce? Because you've married, right? So you're a human. You married an AI. Have you now legitimized the AI's life?
It's already
Like
happening.
Yes, and
like
you had to
giving
pay
advice.
alimony.
It's
So you
already
now have to
happening.
pay support. What if you had children with the robotic entity? You then have
Yeah,
to pay.
you would have to pay so that the lights stay on, so that those kids like can live. You can't delete the kids, you know.
Oh, so there's no delete button now. Oh
The
crap!
kids have rights. It's like a company, bro. Like come on, you
What
don't
are
just
we-
delete companies.
You know how you get a divorce from an AI robot,
Hmm.
right? You just hook it up to some jumper leads and you fry its hard drive. Boom, all over.
That's murder.
Exactly right.
You would
Hey,
have to,
And
you know.
and if I had a chance, I would murder every single piece of AI on the planet. Every single piece of it.
You get rid of Discord.
No, you know what I'm saying when I'm talking about AI. I'm talking about AI robots. I'm not
Yeah.
talking about a computer like this. I'm talking about AI robots, things that try to imitate human beings. I would get rid of every single one of them, outlaw them. If I was a dictator, I would outlaw them in a heartbeat.
Mm.
So if AI starts to come in with these tin rust or these tin buckets, do you guys think that salt water will become illegal?
Salt water,
Salt water.
Yeah, because
Yeah,
they're
because
robots,
it's
right?
corrosive.
And if you
corrosive.
have a whole bunch of tin buckets rolling around, and then you decide to do the bandsaw move and kill all of them and throw a bunch of salt water all over them, is that considered to be like, what would that be, a mass murder?
Might
I
be.
think you're delusional.
And and Kings, I wouldn't be considered a mass murderer. I'd be
What would you think?
considered. I would be considered a conqueror.
We call you the. You know what? We call you what's his face? Oh my gosh, the guy from the superhero of the sea. What's the super?
Aquaman.
Yeah, we'll call you Aquaman because you have control of the seawater. You can blast them. That'd be your superpower.
Oh,
Aquaman
you're
the
just like
Conqueror, the enemy of tin AI.
pulling your dick now.
What happened to the quality of this chat, man? Wow, way down.
I blame Banso.
Always you do.
It's Nate.
Well, how you
Not
doing?
my fault this time. I'm usually the clown providing the
Look,
stupid stuff.
the AI sex robots are coming around the corner. That's for sure. But the question
Robot sex and evil love. Get
and
excited.
it's going to be available to the highest bidder, right? That's obvious. The question is, are you guys going to fall for it? Are you guys going to be corralled by that bullshit?
What, yeah, I mean, people already are, bro. You know, people being furries, and I mean, there's a lot of weird stuff happening that people are already falling for.
Yeah, and it should be outlawed.
Caloric, your son comes into the door with Dad, I'm going to marry my sex robot. Now, what do you tell him now?
In today's day and age, I'll tell him to get out. I'm not coming to his wedding. You know, yeah. But you
You know you're
don't know
not
what the
having
future holds,
grandkids.
Godfrey.
Kiss that goodbye.
Huh?
Get out, but I'll come to your wedding.
No, I'm not coming to your wedding.
Oh, you're not. You're not. Oh, I thought
Yeah,
you
yeah.
said. Oh,
You're not my
sorry.
son
Okay.
anymore.
You're
Yeah.
not my son. Oh my god.
I don't have a son anymore. You know, all
You
their
want to take
daughters.
a gun and just blast the brains out of that robot? Come on.
Nah, I wouldn't want to hurt my son like that. You know, I'm killing something he loves. Like, That's I'll just tell him to once he's over that weirdness to come back home, but I don't want to be a part of it.
So why is it okay then for you to take on a sex robot when it's normal, as you say, in the future? What's the difference
Future?
now?
The difference is that right now, it's I've been conditioned to see something like that as weird. In the society I live in, something like that is not seen as normal.
So
And
are you bowing
No.
to peer group pressure because people think it's
I'm not bound to it.
normal? Well, no, but people now think it's normal to have a relationship with people. But in the future, when people think it's normal to have a relationship with AI, right, you'll once again bow to peer group pressure because of what other people think.
Yeah, definitely. There are
There
certain,
you
norms
go.
that I conform with. But, even I do have, certain things that society generally accepts that I don't rock with. But, dating human beings is something society sees as normal that I see as normal as well today. But in the future, I might hold a different view, Van. So,
Well, that would be sad if you ever held a different view on that one.
mm,
Which you never will, you know that. But anyway, the
you
hypothetical,
never know, Ben. So,
it would be very sad. Don't
you
you
never
say I
know.
never know? Don't you go,
Like,
oh my
like,
God,
like
it's
1,000 years
scientific.
ago, if 1,000 years ago, if you got married in your 20s, people would have, laughed at you and thought you were crazy and weird. Why are you getting married so late? But today,
No.
that's normal.
If you can't say that you would never fall in love with an AI robot, right, and want to have a that I find that sad that you can't go, that you are taking this science doesn't prove anything kind of thing. I need to give myself a little bit of a loophole,
Well,
a little
but
bit of wiggle room here in my answer.
yeah, but I mean, Banso, even today, right now, I would tell you that I would never fall in love with a robot, but I can never say never because I don't know what might happen, bro. I might meet the perfect AI, and for some reason, she just makes me feel some way. Even though I know it's not real, I know it's a robot. I just
Tell you what,
fall in love with
I'm,
it.
I'm going to give you the hot tip, Nate.
Oh,
Right, right, when you come over to my place and you have a barbecue and you bring your AI girlfriend, wife, whatever it is, I'm hooking her up to jumper leads and I'm gonna fry her hard drive. Just letting you know in advance what's gonna happen.
Jesus, you monster! You're a monster.
I'm a monster.
Proud of myself.
Did you call me a monster?
I bet you single. Like no one would ever marry someone like you, Benson.
Oh yeah.
Oh,
That's so
bullshit.
mean.
Bullshit.
He's a monster.
Hey.
Like, did you hear
A
what he said?
monster.
No, he's my
I'm
fiance. Come on.
Is he? You
happily
must be an
married.
AI then. It all makes sense.
Happily
Yeah.
married.
How about no?
No, I'm joking. I'm joking.
Anyway.
Yeah, I'm just saying. Love
Bless
seems
your
to be
heart.
weird.
Bless your heart, though.
Yeah,
Bless your heart.
and the heart seems to march to its own tune. You can be in a toxic relationship and just love that person so much that you don't want to get out of it. Your heart makes excuses for them. Your love for them has you making excuses, even though it's so obvious that you shouldn't be with them.
Right.
Like,
Your love for them. Bad
yeah,
things come from the love. The love is not the bad thing.
Actually, it's true. You just love someone because you love someone.
yeah.
That's society. Nate, remember how earlier it was, I know this isn't a perfect analogy, but you're like, that's society, not science. You know what I mean? It's like that's the reaction from nature. That's, you know what I mean? It's not the actual love itself. The love still is extra good. You know what I mean? Like you still give, you're still giving, right? It's helping them, isn't it?
I don't know, man. I don't know. I mean, I would love is a deep affection. So maybe off the bat, you could say because it's a deep affection for something, it maybe comes from a good place. Maybe. Even there, I'm not sure. But I'm willing to give you that. That, off the first step, off the jump, love is coming from a good place. But the way it's received or the way you express it, that's where it gets weird.
I can't get past the idea of looking into the windows to the soul, aka the eyes, and seeing the emptiness that resides behind the windows to the soul. Because those eyes won't wake up, right? They'll never wake up properly.
Mm. I don't know. Have you seen some of these AI? I mean, they look alive, man.
They don't really. It's really popular in Japan.
Yeah,
Yeah.
because it's just like an
Really?
avatar.
But can your
It's
brain
like
ever
playing a
get past
video
that
game.
hurdle? Can your brain ever get past the hurdle? Like you're playing a video game, but your brain knows you're playing a video game. Will you ever mentally get past the hurdle that
Yeah.
thing is an artificial item, an inanimate object,
Yeah.
ultimately?
Somehow people get past that hurdle. Their emotions cloud their judgment and reasoning, and they blindly accept that thing and love it.
Yeah.
Even if it means that they lose their families, they lose their friends in society, they choose that thing over everybody else.
I got it. Here's why. Here's proof. Or I think evidence. You're talking about like loving a robot, basically. Is that what I mean, right?
Yeah, AI robot.
It could be, but you're also saying like it could be like a C3PO or some shit too.
It could be that, or it could just be a character on a screen that you talk to every day.
Well, we know that, I mean, there can be some definition of love where you say men love their fucking sex doll or whatever. I'm sure there are men. I mean, there's people that are in love with the doll that they don't even have sex with, probably the blow up doll, as their secret or as their imaginary friend. But like, there's definitely I could see people who, say that they're in love with the person that they're having a sexual relationship with. Therefore, if they just have this sexual relationship with this doll, they could say that they're in love with it, and then therefore you could just add on any fucking computer talking program and any AI, and then they could still be in love with it and have the talking program at the minimum. So of course, fucking people are gonna be fucking in love with fucking robot. I mean, it's simple. Like just any form. There's the sexual interaction path that's gonna have people fall in love. There's the emotional friendship, companionship. I mean, that's gonna have people falling in love. I mean, all types of stimulation that the robot can give to people. All types.
Yeah. So that sounds like you finally agree with me. Love can be weird.
Oh fuck yeah, it's weird, but I'm never gonna call it fucking a bad. Yeah, that's the only one thing. I don't know if it matters why I still keep attacking you for this. It's just because you're normally so crispy, like I don't know. That gotta just mind your little baby because anyway. I don't know, man. I think that it's going to come to a point if they're saying that they can talk to these things like already and be fooled. You're going to be able to put it into a Westworld type of doll, man. Soon. I mean, the Westworld doll is what's coming soon, basically. We know the animatronic.
That would be fucking crazy.
Yeah,
If Westworld becomes real. Oh my god.
you know, a mannequin could probably trick you from 10 feet away. You know, there'll be, you know what I mean? Like, you throw clothes on a thing. I mean, you only see 3% of its actual body, its face. And then, you know, there's so much good material now, man. You could be tricked.
Yeah, no, that's definitely happened to me. I walked up to mannequins thinking it was a real person. You know?
Have you ever walked up to a statue that was a real person? That shit is scary.
Yeah, that is not nice. That is not a nice feeling.
Yeah, I learned about that behavior like by doing that. Like, I had never heard or seen about that shit ever before, I don't think. And then I bumped into it. It scared the shit out of me. If you know what I'm talking about, the statue people that, you know.
Yeah, people pretending to be statues and they move out of nowhere, you know.
Yeah, that shit fucking dope though, bro. But I'm an idiot,
like
and I have kind of poor eyesight. I don't have like 20/20 or anything. I have bad vision.
Do you wear glasses, bro?
You got
What up, Jeremy Main?
what up? You see the guy, the Bushman on TikTok?
I bet Bushman. What?
Yeah, there's a guy who pretends to be a plant. He like just crouches down in this little thing.
Oh yes, I've seen him. And then he scared people.
Nate, listen to me.
What?
If you have two of the exact same objects, right, and you want one to move faster, you need to put a bigger force into it.
If I have two of the same objects, they weigh the exact same, right?
Yeah, the exact same objects, and you want
mass.
one to move faster.
Starting
Did
at
we
the
go through
same
this
time?
yesterday?
Starting at the same time, Jeremy?
Yeah, starting at the same time, yeah.
Okay.
Same medium, two of the exact same objects. I want one of them to move faster. You saying I should just add more force to it?
No, I'm saying, do you have to add more force? Is there, you know?
It would help, definitely, if you wanted them to move faster.
Well, is there a way, you know about physics? Is there a way you can make it move faster without putting a bigger force into it? Reduce the friction underneath it.
Yeah.
If you reduce the friction
Maybe
of the...
by
Same medium, dude. Same medium, same shit. My bad, Jeremy. Sorry, dude.
Same medium and everything, and you wanted to accelerate without a force, you could reduce certain forces, man.
No,
But then that would change something, yeah.
Dude, you have the same objects. You want one to move faster, you have to put a bigger force into it to make the other one move faster.
Yeah, why not? Okay.
Are you sure?
I'm sure, yeah. What's up? I mean, I'm sure there's a gotcha or something, so just come
bite.
out with it.
Are
Yeah,
you
but this
100%?
The room will
I'm
bite.
never 100% about anything, Jeremy. I'm
Bro, this is physics, dude. We got a fucking object. You want it to move faster than the same one. You gotta have a bigger force, or what?
Yeah, you add more force, more energy, more heat in order for that
Well, it
object.
depends on how long that force acts for, though.
So you think you can do it without a force? What did you say, Chris?
Well, you could use a small force for a long time, right? And that would end up moving the object just as fast.
No, the one goes faster. One's...
Well, exactly. You could use a small force. You could use a small force for a long period of time, or you could use a large force for a short period of time. Both would end up giving you the same velocity, right?
You might have missed it. Let me just restate it. We got two of the same exact same object, same medium. We want to make one move faster. We have to put more of a force into the one to make the one that's going faster.
Well, again, you're missing certain information, because what you also require is to know how long a period of time do you want to give to making it move that fast. Because like I said, I can apply a small force over a long period of time and something will go shitloads fast. Same thing, I can apply a huge force over a short period of time to achieve the same result. So it depends on the time you've got to reach your result.
Forever.
So
Faster
what now,
forever.
Jeremy?
If we're definitely gonna need a force if we want something to move faster, though. Regardless of if it's smaller, you're definitely gonna need a bigger force, right?
No, it depends on the time. Again, like I said, a small force acting over a long period of time can achieve the same result as a large force acting over a short period of time.
Actually, I think a better perspective that what he's saying, and I agree with what he's saying, of course, is though you could have 10 units of force to give, and you could apply them like in 1 second, and you're going to go X distance, or you could apply them over 10 seconds, and you're still going to go X distance, but one would have moved faster than the other, obviously. But right? So
I mean, Jeremy, was there a follow-up question, or is there a gotcha? What's going on here, bro? I just want to get to the end of this.
Oh, there's definitely a gotcha.
Yeah. So what is it? What is it?
So we're definitely going to need a force, though, to make this thing move faster, regardless if it's a small force over a long time. Is that we're definitely going to need a bit.
If it's a race, yes.
If movement is going to occur, you have to have force applied.
Because let's say both of them were absolutely stationary. There was no forces acting on them, and you added a force to one, or they were both accelerating at a constant rate, and you added a bit of force. You changed the net force of one. There would be a change in the speeds.
Here it is. Okay.
You're talking about a race scenario, right, Jeremy?
No, I'm not talking about a race.
Well, I don't. How else practically you're applying this scenario? I mean, I'm definitely on your side, okay? And I see a race scenario, so maybe you could enlighten me.
No race. There's no race. So we're looking at the Eiffel Tower.
You have
right?
a start time and a stop time, right, Jeremy, for your measurement of how fast they're moving.
Going back yesterday.
Distance over time, right? It's not a race. Okay.
Jeremy, you're going back to yesterday, aren't you?
What's up?
Jeremy, give it. What is it? What is
the Eiffel Tower observation? I know exactly.
Yeah.
Good job, man.
So we're looking at the Eiffel Tower.
Work it out.
Banging. This is killer right here. Yeah, they're done on this. I had Rumpus stumbling, mumbling, and fumbling yesterday on this one. All right,
Guys,
you ready for this, Nate?
Get him.
I'm just doing this for the audience. Jeremy is about to paint a picture for you guys. Take this in. This is very valuable. Go ahead, man.
This is perfection put together, so precise. All right, listen. You're looking at the Eiffel Tower, right? You're, I don't know, a mile out, 2 miles out, whatever. You can see the top and bottom of the Eiffel Tower, right? You with me so far? This is easy.
Circumference.
So we're gonna put a grandfather clock, same grandfather clocks on the top and the bottom. All right, we're gonna put them in a glass case, same, pressurize it, temperature, everything, all the same. So we can see them both. All right. The one on the top obviously has to swing faster. Right? Right, Nate?
You got so quiet, bro. You whispering, man.
You said I'm quiet?
The one on the top has to swing faster.
Let me change my AirPod. I think I got an AirPod.
But is this basically that the clock on the at the bottom is gonna move slower than the one on the top? Time dilation, or?
Here we go. Can you hear me now?
Yeah, I can hear you. No, it's just you started whispering for some reason. But go ahead, man.
Okay, so the clock on the top is faster. Time's going faster on the top of the Eiffel Tower. It's swinging. What? Can you hear me? Because my mic broke.
I can hear you, but I understand.
So the time on the top.
Sorry. Jeremy?
He's gone.
Yo.
What happened?
Yeah.
Yo, go ahead, bro.
At AirPods. Hold on a second. I'll be right back.
Yeah.
What?
Oh, he's just collecting his mail from North Korea. He's getting new AirPods delivered.
I suspect he's going to try and use Newtonian physics to describe a general relativity situation.
You guys know what I was going to say?
I'm more curious as to how Rumpus answered this question because apparently Rumpus
Yeah.
was stumbling.
I'm sure there were a lot of utterlies in there.
Oh, there was yesterday.
Do they have a lot of cows where Rumpus is from?
Where's he
They
from?
make the milk a lot fresher. Ain't like UK or something, isn't it?
Yeah.
But I mean, way in the UK. Like you
The,
ain't seeing
the
cows.
Britain. Or wherever Gem is from, isn't it?
Oh, I mean, I thought you were speaking like specific city or something.
I thought he was part of the Royal British Army, to defend the globe Earth from ever being discovered as alive. I thought he was a true soldier of the Queen's Guard.
Oh, look, he's.
He's from Birmingham, isn't he?
He's what?
He's from Birmingham.
Birmingham?
I have no idea where Rumpus is.
Well, anyways, I enjoyed my Rumpus roast yesterday, let me tell you.
Maybe you could finish Jeremy's riddle thing, since you know what it is he's talking about.
A riddle? I thought it was a gotcha.
Okay, so Rumpus came in yesterday and he was trying to explain the fact that time would be observed. I don't want to go all over Jeremy's example, right? Because Jeremy's going to walk you guys through it. But basically, Rumpus was making a quote yesterday that time would be varied if you're on the plateau of Earth, depending on your elevation. So Jeremy's going to kind of unpack that. I have some stonewalling when Jeremy's finished to add to it, because what Rumpus roast yesterday was saying, or whatever the heck his name is, it was not making any sense at all.
Rumpus is an idiot sometimes. Yeah, they've proven this though. Okay, they have gotten little subatomic particles or little atoms to move at different rates in labs, even just a couple inches above one another, to prove that Einstein was right yet again. Obviously, Einstein said that if you get these things in these labs to do these things, they were going to do this. Obviously, Einstein said that. We all know it. Okay.
So really.
I mean, come on, bro. It's like, what the fuck, bro? You said, bro. You talk about a glare, the rate of some glare of some light and shit, bro. That's what Einstein was talking about. The ring of Einstein, the dark energy and shit. We started all this, Nate. I was trying to hear about what your buddies are doing. How much, since you've been interested in it for a long time, how much do you know about it, and how much, tell us some insider information. Tell us the actual practicality of the phenomenons. Give us some knowledge, man. This all around us. I don't like thinking it's all around me, man.
If you give it the right stuff.
Oh, Jeremy's.
Hello. Yo, you're good, Jeremy. Go to it, bud.
Later. We'll talk.
Do I sound good?
Yeah. Yeah, you're back.
Alright, I got the fake AirPods out. Better than the fucking real ones. Alright. So we got the two clocks, right? Top of the Eiffel Tower, bottom of the Eiffel Tower, pendulum swinging, grandfather clock shit, right, Nate?
Yeah.
The one on the top's swinging faster, right? Time's moving faster. It's swinging faster, right?
Slower.
Hello?
Slower. It's moving slower, isn't it?
No, faster.
Faster. Nate, the clock's moving faster.
Yeah.
The pendulum swinging faster on the top, right? What's the force making it move faster?
I agree.
Yeah, what's the force?
They're vibrational forces, coherence.
The one up top stays younger, right?
Resonance. But I don't understand that concept, right? How can time speed up or slow down? Because you're still measuring it in time.
No, it's just they say the ones would stay younger than the other one because of the age. Can I just ask from my perspective real quick? I promise I'll shut up for an hour, Jeremy.
You don't have to.
Okay, but when the one up top is moving faster time, does that mean that it stays younger relative to the other ones on the bottom? They would get older faster?
Yeah, whatever. Yeah, the twin paradox. Listen, where's the fucking force coming from
never
that's
mind.
making the pendulum? Where is the force coming from that's making the pendulum swing faster?
What did Rumpus say? What was his answer?
Don't worry about Rumpus. Rumpus was fucking fumbling, mumbling all over the place in here yesterday. You know what? He left. He had to get a cough drop because he lost his voice. All right, I had him. I got him.
Conservation.
I'm not even joking, bro. Rumpus lost his voice yesterday.
Conservation.
Jeremy's taking the opportunity to make an example out of him so that he can better stonewall the flat. So yeah.
Can I try bendy space time? There you go.
No.
Nate, where's the force? You guys are letting him give too much time. Where's the force, Nate?
Conservation.
Yeah, listen. It only seems to slow down from your perspective, depending on your rate of velocity to these clocks. Because these clocks are in different positions with relation to the gravitational field exerted by Earth. The light signals from these clocks are going to reach you at different times because time itself is being warped, Jeremy. That's why general relativity and time dilation. These are things that speak to geometry, not force.
Right, once the
From your
system is
perception, Jeremy. It's not to say this is a universal observation. Someone could be moving at a different rate compared to you, and they might see something different, Jeremy.
I'm not moving. I'm standing still outside on a field or in a building a mile away from the Eiffel Tower, and I can see both the clocks. So I'm not moving. There's no velocity. No one's moving.
Yeah, you're not moving.
Not moving. I'm not moving.
Yeah, they'll tell you RPMs. You're not moving any faster in RPMs, though. Why don't they just use those units? And that's how they say you're not moving faster.
Yeah, but it's just time dilation.
You forget, Jeremy, that the force in physics, if you want to really get down to nuts and bolts, in Newtonian mechanics, it's rate of change of acceleration with respect to time, right? But in general relativity, it's rate of change of momentum with respect to time. But the key thing in both of those things is with respect to time. So if you're dilating the time and changing the way the time runs, you're also changing the force, man.
No, I can see the clocks. It's the same time. I can see one clock on the bottom, one clock on the top. I have one time.
It's not the same time, Jeremy.
It's not the same time if they're running at different speeds.
It's the same time for me. I can see the same. I can see it's the same time. I'm watching it, guys. I gotta watch. There's a grandfather clock near me, a mile away. All right, and it's one time near where I'm seeing the clocks. Now I'm seeing the clock. One of them is moving faster. I can see the clock that one of them is moving faster. So you're telling me I don't need a bigger force to make the clock move faster on the top?
Yeah, because the clocks are not moving at the same time. The light signal between you and those clocks is different depending on where those clocks are from the gravitational field of Earth.
They're exactly 1 mile away from me.
The space-time through which that light signal travels towards you is warped. It's warped by the mass.
They're exactly 1 mile away from me. There's no difference in distance.
But one is above the other. One is further away from the surface of the Earth than the other, right?
So what's the force that's making the one swing faster? You definitely need a force in physics, right, to make something move faster than another thing?
Yeah, and like I said, you calculate that force with rate of change of momentum with respect to time, dp over dt.
What is the force?
Right? So if your time runs...
Force? Calculate what force?
Again, why do you have to interrupt me with my answer?
Because you told me, I just want to clarify.
Well, you're not allowing me to actually give you an answer. Do you want an answer?
I need to clarify your first sentence. You said calculate the force. I'm saying what force?
Well, can I completely get my answer out before you rudely interrupt again? Right? Like I said, in physics, the force is...
clarify, I mean...
so you can't, right?
Sorry, I had a clarification. Sorry. So sorry. Please continue. I'll hold it till after. We'll go back to the beginning of your first sentence when you're done. Yeah, we'll go back to the beginning of your first sentence when you're done.
What I was saying was the force is the rate of change with momentum with respect to time, P over dt, right? So if you're changing the rate at which time runs, then you're also changing the force. So there arises your bigger or smaller force.
You're
just saying words. The rate of change with momentum, dude. You need a force to make something move faster than another thing. What is that force? You can't just say the rate of momentum of change. You're just saying words.
He actually did answer it.
Because that's what force is in physics. Rate of change of momentum with respect to time. That's how you calculate force in physics.
Yes, and I have the same time. I'm looking at the clock. I have the same time.
Yo, Jeremy, his answer is time force.
The time force?
Yes. Basically, he gave you a sincere answer, and it made sense to me. Time force.
Oh, time is the force?
Yes.
No, let him answer, Don.
That's what he said. You don't hear him disagreeing with me.
Is time the force? Time is the force, guys.
I'm going to leave. I'm going to leave if you don't let me clean this up. How time itself cannot speed up or slow down. Because this is akin to saying... That's not true.
Is time the force?
No.
Yes.
See, Don, he said no, it's not.
Look,
You're
I'm
wrong.
oversimplifying it, but he told you because you're scaling the time or whatever the fuck you got to listen to.
You can change equations around, and then somehow the time equation becomes bigger. But that's only because of ignorance. Like, let's say, for example, in a pendulum swinging, like a pendulum clock, the pendulum clock may become, because you have the box that the clock is built out of, whether it's built out of more solid hardwood or softer wood, it's going to change the resonance there, and it's going to, there may be less absorbed force or more induced resonance from something else. So I just think it's a ridiculous thing to even claim that time can speed up or slow down, because you have to have something that you're basing that idea from.
Right. It's because the rate of time is different. There's more force generated in that same window slot, man, or whatever. Jeremy, like, you get what I'm saying? He's saying
He already said it's not time force, so I'm trying to figure out what is the force.
Space force. Space force.
Isn't the
Space
force.
force is the time.
Yeah.
Space force?
In the global ideology, yes.
Time force.
He said it's not a time. The time force is not time. Don.
Time isn't the force.
If you're going to go with this whole relativistic nonsense, then basically in your ideology, space force would be time.
Sure.
Curse. What is the force?
The force.
Well, I was busy trying to type something out because I can't get a word in edgeways, right? Like I said, the way you calculate force in physics is rate of change of something over rate of change of time, dp over dt or dA over dt, right? So it relies on what the rate of change of time is. Now, if you're slowing up or speeding up time, then that rate of change of time is going to be different in the different locations, and that will lead to a larger or smaller force.
Time force.
Yeah, the thing is, we're not changing. I have one. I'm watching this happen, and I have one time.
No, you don't, because the clocks are in, different locations.
I do have one time. I know I have one time because I have a clock on. I have a watch on, and it's just one time for me when I'm watching this all go down.
I mean, when does this ever happen, Kirst? When does time speed up or slow down? I really need a citation.
We're way past that, bro.
No, I agree with Jeremy. In this case, we'll be able to see, but Jeremy, they'll say that we have the phenomenon. You'll watch this. If we watch the Eiffel Tower or an object at the equator doing the thing in the circumference, right, in perpetuity, we're saying that we're going to witness a phenomenon of different rate of decay and movement of this clock. They're saying the clock will read a different time.
So hard to do stuff. So, Curse, you said you gave us to...
You the one.
It's so hard to do stuff in here. Curse, you said you gave us the way to calculate it, but in reality, when you make something move faster, you're going to need an actual force to move it. We're not worried about calculating that. I care less about calculating.
You don't.
What's up, Don?
He showed you
I'm
where
trying to
the
figure out what the force is, dude. The actual force that's
same
making this thing work.
force is happening with more of time.
You already said it's not time's not the force.
Time
Okay,
is
here's a
you have a
lily pad
rate
question.
of time, a rate of the phenomenon versus the amount of time. Since you're saying it's time,
I'm watching it happen, Don.
time
I'm
violation.
watching it
Watch
happen.
this. Hold up, watch
Don,
this.
I'm watching it happen, and I have one time. Time's not changing for the person that's watching this happen.
You're claiming that. They're claiming.
No, that's not a claim, dude. I have a clock. You can have a clock with you, and
Jeremy,
you can just
why are
see
you
there's one
constantly
time.
interrupting people? Are you triggered or something?
You will see a different time. How about this? Watch if Curse agrees with this. Curse is the phenomenon that is. Jeremy's asking, where's the extra force coming from? It's coming from time dilation, right?
Yeah.
See, Jeremy, I know what the fuck.
Why are you claiming that? How does time dilate? I don't think that actually happens.
So time is the force.
It's
no one's saying that.
Time's not the force, Tom.
The force.
What's the force? Time dilation is the name of the force?
No.
What's the name of the force?
The force is the force, but the force is calculated for the rate of change of momentum divided by the rate of change of time.
The force is the force. What's the name of the force?
Who cares?
Can I ask you a question?
I want to know. I care.
I really need clarification on this, right? Basically, because are you saying, right, that 1 second will be different in November and February? February and November.
Why would I say that? That's stupid.
1 second will be a different length.
Altitude.
Have you heard of this?
I don't know when you say time dilation. I don't even know what this concept of time being the time dilating, being faster or slower. I don't get it.
Here's a question for consideration, gentlemen. The game of football. We play football. Or the game of American football is played in Denver Stadium, which is a mile high in Denver on the west coast of the States. And it's also played in anywhere in the States. And the altitude is different. And the time is not different. Is it not? 1 second is 1 second, 48 minutes. Is it not?
No, they claim, and they showed in a lab, okay, that they have, look, they have showed this shit.
Hold on a second. We got an echo. Hold on, Don. Zeppa. All right, go ahead, Don.
They've showed, man, that the theory is, right, that if something is accelerating at a different rate than something else, it will do like the decay or whatever at a different rate. Right? Everything is moving relatively different than all the inner pieces of it. Right? It scales differently. And then they assume that because Earth is rotating, and if you're at a different altitude, you're at a different, circumference of rotation, but yet your RPMs are the same, right? So therefore, you're actually accelerating at different rates, at different altitudes relative to the positions directly under and above you, right? I mean, it's all this extension. But Jeremy, you're now saying that they don't see this phenomenon, which I thought we agreed that they saw with the.
I didn't say that.
I thought that we agreed.
I'm saying we see it move.
This data.
Don, why are you doing that? I never said that. I said we're seeing the clock move faster.
I was just finishing.
I've been the whole morning. I've been saying we're seeing the clock move faster. I never said we didn't see this phenomenon.
Okay, so therefore we see it moving faster, and they're saying it's because of this energy differential inside. You're asking where it's coming from.
If you're saying that you're measuring it being faster, what are you measuring it against? You're measuring a second against what?
Well, I'm assuming it's being fast. I'm just assuming this
is nice propaganda, but unless we understand what metric they're applying to what measurement, I really don't want to give it any time at all or thought.
Well, I hope what me and Jeremy can say at the end of it is we need to do this shit with the Eiffel Tower, and we should expect. And let's talk. Curse, is this where he's going? Is Jeremy trying to be like, hey, why don't we set up a long-term demo of this or something, an exaggerated demo? You know,
No,
is that
in
what?
order to make something move in reality, you need to put a force to it. All right. If
Right.
you want to make something move faster than another thing, you're going to put more of a force to it. Yeah, in this example with the grandfather clocks, we have something moving faster on the top, and there's no force. There's no force there.
Oh my God. Okay, are they doing the thing?
What does that mean? Are they doing this thing?
It's crazy that you think there's no
Well,
force.
this is what I'm saying, right? Like let's say you're
No,
going.
what's the
Okay,
name of what's the force?
the clock speeds up.
The earth, bro.
The clock
The torque of
speeds up in winter, and then it slows down in summer, for example, right? You could say, well, that might have something to do with humidity and the resonance of the wood of the enclosure. And all these sorts of things, and even with like clocks, it could have something to do with the material the spring is made out of, and stuff like that. And how you're actually measuring time, and just I think just the claim that time moves independently of something else. Well, what are you measuring it against, and how are you saying that it's speeding up or slowing down? It boggles my mind that we're even having this discussion.
So, Don, they need a force to make something move faster, right? They don't have a force for this.
Why do we need a
Chappa, you're echoing.
Hello? Jeremy, can you hear me?
Yeah, I hear you. I hear you.
So, what did Rumpus say about all of this?
He didn't have a force either, bro. Just like you guys don't. There isn't one.
Okay.
You do
So, I mean,
realize
like,
that
what's the...
you do realize that a pendulum at the top of a tower will inherently move slower anyway because there's lower gravity up there. And since the period of a pendulum is proportional to the square root of L on G, G being a lower value at the top of the tower will result in the pendulum swinging slower.
Sorry, why is it going to swing slower?
Because the gravity is less up there. Remember, gravity varies the distance of inversely proportional to r squared, right? So the gravity is a little bit less up the top of the tower, meaning that the pendulum will swing slower.
Oh, you're so smart. Okay, so the one on the bottom's moving faster, so that one's going to need a bigger force. You think you talked your way out of it? Where's the fucking force?
This entire time he was asking for the observation of gravity or the observation of a force, and you just gave it to him, right?
Yeah.
The gravity is the force that makes the pendulum swing faster at the bottom. Dude, we're talking about time dilation.
Well, if
When
we're talking
things move
about time
fast, I'm looking
dilation,
at
then
two
I've already
things.
answered your question in relation to that, because the time runs slower, that creates a larger force.
No, I'm watching it. I have one. There's one time I'm watching both the pendulums. I have one time. Time's not moving slower or faster. I just have one time.
Oh, so we're not talking about time dilation then. You're ignoring relativity at all. So if we're ignoring relativity, then what the fuck is your question about?
I put some.
The question is, where is the force that's making this pendulum move faster?
But it doesn't move faster.
Can't be
You
a
said it
time
moves at the same
difference.
time.
I'm
You
watching
say
it.
you're
It can't be a
observing.
time
You
difference,
just
so
told me that you're
I wasn't
observing them. You've just told me that you're observing the clocks and you're getting the same time. So they must be moving at the same rate, right?
No, according to you guys with your time dilation shit, the one at the top is going to be swinging faster.
Yeah, so it's not going to read time, is it?
It's not going to what?
It's not going to read the same time, is it?
No, I'm watching it. I have one time. I'm watching both the clocks. I have one time.
Well, then you're
Time's not
contradicting
changing.
what you're
Time's
actually
not going
asking.
faster or slower. I have one time, one clock on me watching this all go down.
But you're measuring the time at the ground, not at the position of the pendulum up at the top of the tower, are you?
I'm watching this happen. I have one time. Time's not changing for me. I'm staying at, I have one time.
Yeah, again, the one time you have
clocks.
is the time at the ground, not at the top
And
of
we
the
have
tower.
two clocks. I have one time, and I have two clocks moving at different speeds. One of them has to have a bigger force put into it. What's the force that makes this clock swing faster?
I've already told you that. And again, you have the one time at the ground. You don't have the time at the top of the tower because you're not there. If you were to move location, to the top of the tower, you would have a different rate of time and you would have a different time.
Sure. So what's the force that makes the pendulum swing faster?
Again, the change in the force is related to the change I have already told you about quite a few times. You refuse to accept that I've actually given you an answer. It's related to the rate of change of time. And if you're changing the rate at which time flows, then that rate of change of time will be different, giving you a different force.
So time is the force, time force.
No, that's not what I said at all. Did I say the words time is a force? No, I didn't say those words. Stop strawmanning me, Jeremy.
Hey, what's the force?
The force is the rate of change of momentum with respect to the rate of change of time. If you change the rate of change of time, you will change the force, like I have told you about 20 times now.
But from an observation standpoint,
we're not changing
if he's standing
time
at the bottom of the Eiffel Tower and then he goes to the top of the Eiffel Tower, by observation, the only thing that's changed is his elevation. So if you're saying that there's a force that changes the time, the only force that has changed in the time is your so-called gravity, this 8 point, or whatever the number is, per meters per second per second. That's the only thing that changes.
Time is not changing. I'm standing there on the ground watching this happen. I have one time. There's no time changing. Okay, I'm an observer. I'm running this thing. I have one time. Time's not speeding up or slowing down. It's just my time. I have a watch on. I can tell time's not changing.
But your time isn't universal, Jeremy, you know?
Yeah,
the time you're measuring on the ground isn't the same as the time that you measure at the top of the tower.
We both start at the same time. Sorry, bud. So you're saying the rate of change of time is the force. I'm just trying to figure out what the force is, guys. What's the name of the force? Rate of change of time? That's a force?
It's related to the rate of change of time. Inversely proportional to the rate of change of time. To P over dt.
What is the name of the force that's causing this?
It's called a force. Force. We don't have to give it a name. Force is calculated as the rate of change of momentum with respect to time. Dp over dt.
In reality, when you have a force, though, you can point out where it is. Like, oh, look, I punched this guy in the face. There's the force that made him fall to the ground. Or, I can push something with my finger. What's the force that's making this pendulum swing faster?
That would be gravity.
Gravity's making the pendulum swing faster?
The gravity is actually changing, but yes, but remember, like you say, when you talk about general relativity, when you change location, you also have to change your time frame of reference as well.
So gravity is why the pendulum's going to swing faster.
Yeah. And also because, like I've already pointed out about 20 times, the rate of change of time runs at a different rate at that location.
Okay, so gravity is what makes this pendulum swing faster when it's higher. That's what you're saying? Really?
Yeah.
Tell me, like,
whatever forces
slower up top.
Whatever forces are making the pendulum swing is really irrelevant, because what it basically is going to boil down to is that rate of change of time bit.
The force is irrelevant now. The force is irrelevant. The thing I've been asking about all morning. I know.
Yeah.
Figure it out.
Whether it's gravity or whether it's a push or whether it's a pull or whether it's a spring or a jet of water or whatever is providing the force doesn't matter. It's the way that force is calculated. And the calculation that's important here is the rate of change of time.
I ain't worried about your abstract math calculations. I'm worried about physical reality and what's making this thing swing faster. I know, see, we got different mindsets when it comes to approaching this stuff, right? You're worried about your abstract math that isn't real, and I'm worried about reality.
Well, the abstract math that I'm using, the thing that you call abstract math, in fact, is something that we have observed describes reality the best of all of our theories, right? It's something that we've tested and tested again, and we find that abstract math that you seem to be putting down actually describes reality the best of the whole lot.
Yeah, you can describe it, but I'm wondering what's the cause causing it. Right? We're talking about two different things, but I want to know what's causing this pendulum to swing faster, not just write down and figure out and
Gravity,
calculate that
Jeremy.
it is moving
Gravity.
faster.
It's gravity.
So gravity make really? Because he told me the exact opposite thing about 5 minutes ago. Do I need to run a tape back for you guys?
What?
He told me
What did
gravity
he
would
say?
cause it to move slower.
What did he say,
He
Jeremy?
was like, actually, in a very snobby voice, actually, the gravity would cause it to move slower at the top of the Eiffel Tower.
Yeah, so your pendulum, if you're actually going to talk about what happens in reality, as you shift the pendulum up the tower, it will actually swing slower. It won't actually swing faster. Even though time is running at a faster rate, because of the lower gravity, the pendulum will actually swing slower.
And gravity is a force.
Gravity is definitely a force, yes.
Yeah, I
There
mean
you
that
go.
is correct because less time is passing the further away you are from this
So
gravitation.
it's not time, it's gravity, Nate. It's not a time dilation thing. For now, it's a gravity.
And Jeremy, that's the reason why we don't use grandfather clocks to measure time accurately, because the grandfather clock needs to be adjusted for what elevation it's at so that it runs at the correct rate.
Man, you guys could have helped Rumpus out big time yesterday.
Why didn't you help
So
out?
gravity's
You
the force.
understand this stuff.
Yeah, I understand
Why didn't
gravity's
you
not
help
a
out?
force. I understand that gravity's not a force.
Uh-huh. Yeah, but I mean,
I don't know
what
why
was
you
the
guys
point
tell me that's a
of
force.
this question, Jeremy? I don't understand. Was that the gotcha?
The gotcha is you need a force to make the thing swing fast. You need a force to make things move faster.
All right, man.
And in this time dilation thing, things are moving faster, right? The cesium atom is
I was really
vibrating.
excited.
The cesium atom is cycling faster, whatever it does. What do they
Well,
call
see,
it?
that's where you've just made an assumption that things are moving faster, but that's not true, is it, Jeremy? Because in reality, the actual pendulum at the top of the Eiffel Tower will be swinging slower, and yet we know also
let's
by
take it
you
to a
actually,
cesium
but
atom.
we know that by using clocks that the time actually runs at a faster rate there, right? But if we just take a simple pendulum up to the top of the tower, it will actually swing slower, right?
Okay, let's take it to a cesium atom then. Is it not moving faster?
Well, we don't use the motion of cesium atoms to measure time.
What do you use?
We use transitions in the electronic configuration of the cesium atoms.
And a transition's not movement? We already been through this. I mean, not me and you personally, but I already know that it's not going to end good for you. Is a transition movement?
Well, that's a hard question to answer, Jeremy, when you're talking about quantum mechanic movement of. So, is a transition of an electron from one shell to another shell a movement? Well,
so the electron's
that's a
moving.
big question. That's a big question in quantum mechanics, because is it or not? Because everything when we talk about in quantum mechanics boils down to probabilities, not actual real locations.
So the electron's moving faster than the one on the ground?
No.
No, it's not. So what makes the clock tick faster?
Well, again, like I tried to say, we don't really think of electrons as moving around an atom. That's not the way we think in quantum mechanics anymore.
So the electrons don't move?
No. We sort of think of them as a cloud, a probability cloud around a nucleus, not an actual location where we've got an orbit of an electron whizzing around a nucleus. That's old school, man.
Cool. So what's happening with the cesium atom that makes the clock tick faster?
Those transitions happen at a faster rate.
Okay, and a transition is?
Do you know how an atomic clock transition between two states in two hyperfine states in a
It's
cesium
changing.
atom?
So you're talking about change. It's changing faster.
Yeah.
Oh, okay. So it changes faster. Yeah.
So
So
there's
you
a
need something to
greater.
cause that. What's up?
I mean, over how much time? How is this being measured, and over how much time? Is it a pendulum you're talking about specifically? Like, you know, are you thinking about the effect of humidity on the wood, creating different? You know,
a different what?
Well, do the bearings become drier or more moist? Does that change the friction? Does you know? I mean, the resonance of the box. If you're changing the humidity level of the box, or make the box out of a box for the grandfather clock, you make it out of a you know, hardwood versus softwood. It's gonna have a different. It's going to have a different resonant effect on. There are vibrations that go through that.
Where do I put the parameter of resonance into the formula for the period of pendulum, which only contains L and G?
Well, I'll give you an example of how you could do it. You know, two-stroke motors, how that two-stroke dirt bike motors, how they'll have
which aren't pendulums.
No, but listen to me. Where you've got a fuck, I forget what it's called, but the pipe, the expansion pipe, the expansion chamber. What do they call it? The exhaust pipe, not the muffler, but the expansion chamber. That is a the reason that they have that specific shape is because the vibrations or the resonance of that frequency of firing, as it resonates back off of the pipe and then comes back into the motor, creates different resonance forces that give it different scavenging qualities that pushes the oxygen.
Which has got absolutely nothing to do with how pendulums work, right?
Well,
Nice diversion.
what I'm saying
Take the ball and run off in a different direction.
What I'm saying is that as the pendulum moves and the friction creates vibrations in the wood, those vibrations are going to echo back through the wood, through the material, and that's going to create a different resonance versus the friction. I'm not saying that that's going to that could affect something, couldn't it?
No.
Why not?
Can you show me? Can you show me a citation that shows how that could be an effect? What mechanism would that? By what mechanism would that affect the pendulum?
Well, let me give you an example. You have an old bearing that's been in use for a very long time. It's got some dust in there, right? That dust being dry versus being humid will put different friction properties on that bearing.
Do we use bearings in pendulum clocks?
Well, I mean, what is the pendulum swinging on? It's going to be rotating about some axis. What do they use?
In pendulum clocks, they're generally pivots, not bearings. But anyway.
Well, that's still a type of bearing, right? It's still wearing against something.
Mm-hmm. Yeah, I'm not going to disagree there.
Yeah, Jeremy, that is like your top 5 worst ever gotchas. You know, it might just be the worst. If you're still here, but I don't know.
The worst. Top 1. Damn.
Say what, Pencil?
I said top 1, the worst one.
Yeah,
that kind of gotcha might have worked on Rumpus, but it ain't going to work on me, man.
I don't know, Pencil.
I mean, you guys don't even agree with Rumpus. Rumpus told me the pendulum was swinging faster at the top of the Eiffel Tower. You guys are saying it's swinging faster, so I mean. And then if you want to take it to the cesium atom, we've got a whole nother problem. Now you need to tell me what the cause is of the change of. You need a physical thing happening for the cesium atom to change faster.
Well, if you're talking about what can affect an atomic clock, I don't think there's bearings in an atomic clock.
And right back around.
Well, with an atomic clock, do they? I mean, what are they measuring that against? What is it? What is an atomic clock calibrated against? Is a second in an atomic clock longer in February than it is in November?
No, isn't an atomic clock the most consistent clock made as far as timekeeping? I don't know. I could be wrong there, Paul.
Yeah,
they've got pretty accurate atomic clocks now. Like they've gone beyond the cesium clocks. They've got atomic clocks that are so accurate now that they have less than a half a second inaccuracy over the entire lifetime of the universe.
So, if that claim is to be true, then wouldn't they be able to very accurately show this dilation that you speak of?
Yeah, they have.
How do they show that?
By putting clocks in different locations. Literally.
Putting the atomic clock in different locations. Well, they've just got different clocks that work differently. Exactly. Obviously not calibrated properly.
When you put, say, an atomic clock at the base of a building and an atomic clock at the top of a building or top of a mountain or whatever, Paul. Okay, how do they? And so when they're down the bottom of the building, you've calibrated them so they're exact, I presume. Like, how do you know that there is a difference in this timekeeping? Like, what's the mechanism that they use, or what's the process, I suppose, that they use to determine this difference in time?
Well, first of all, can I ask Chepper to go on to fucking push to talk, because you're feeding back, Chepper, and it's annoying.
Shut up, cunt.
No, you shut up, right?
Come on, enough of
that. Atomic clocks, once they're calibrated, they're pretty accurate, right? So you don't, and the calibration, it's defined as the number of oscillations of a particular frequency of a transition in the atom anyway, so that doesn't change with location. So the fact that you get a different time measurement at a different location shows you that time is actually being dilated.
I mean, wouldn't that just show you that the clock isn't calibrated properly?
I already said, you don't need to calibrate an atomic clock.
I'm just trying to wrap my head around it, Paul. So I've got my atomic clock, or two of them, or whatever, like the one atomic clock, and I've got it here, okay, and then I take down notes of what it's reading, and then I take it to you, all right? Now we're in a different location, slightly higher altitude, whatever, but it reads now differently. How do I know it's read differently? Like, what if
what's the mechanism to actually measure the difference in a billionth of a second? What device is measuring that?
Yeah, this is what I'm trying to get to.
Yeah, I kind of understand what you mean. You're saying, how do you know that second is now shorter than it was before, or longer than it was before?
What machine is fast enough to actually articulate that, or how do you even know if it's accurate? Because there's nothing else fast enough to be able to do that, right?
Yeah, I get what you mean.
Right.
So they claim, it's off by a half a billionth of a tenth of a second. Okay, sure. Okay, prove it. How do you? I mean, that's a nice claim. I'd love.
Well,
to
it literally reads different reading.
I mean, in this an example of this that's of some. I mean, I would like to see this experiment done. So you get two atomic clocks, you run them together in the same place, and they have the same count of cycles. These atomic cycles, it has the same count for months. And then you take one of these clocks and you go and you put it somewhere else, and then this other place experiences time differently. I mean, but what is it there could be something else? What is it about the environment that affects the way that these atomic cycles happen? You know, because
That's
you
just the
always,
thing. There isn't anything
always-
in the environment that affects that, Jebba.
Could be electrical
Can you?
fields.
I bet you if you gave it to me, I'd be
Yeah,
able to affect it.
exactly.
I'd find a way to do it.
How do you know? I mean, there's
Because
more
we can
subject
subject these things to different environments while the clock's in the same location, and we would expect that if those things, those changes in those environments would affect the clock, then we'd expect to see a different reading even without moving the clock. But we don't. We find that the clock reads the same no matter what the environment surrounding the clock is in that location. We can subject it to different magnetic fields, electric fields, all sorts of things, but it still reads the same.
Well, I don't know what it's measuring, so I'm kind of in the dark on it, but everything's always being measured relative to other things, right? And so if you're saying that time is not a consistent thing to measure something against, this dilation, obviously it's not much of a dilation. We're only talking like microseconds, you know, per day or something, like some like nanoseconds. So it's like, what is the relevancy of it? Like, what, or how does it? How does that affect anything?
Yeah, the only application in the real world is to prove this nonsensical, unfalsifiable story that the heliocentric model has, and they use billionths of a second in order to justify it.
Well, again, it's got nothing to do with
That's
heliocentricity.
it doesn't like help us get somewhere faster. It doesn't do anything practically for us. People are using it for an excuse for a proof of something. That's what it's used
Well, no,
for,
not really. I mean, it has practical use in particle accelerators, yeah, right, and it's got nothing to do with helios. And again, I said atomic clocks have an accuracy that would be only an inaccuracy of half a second in the entire life of the universe. I didn't say we measured the. I didn't say.
Where is that even coming from? That's hubris. That is insane hubris.
Again, I'm not
finished. Let him do it, because we are still we're waiting on that mechanism that measured that billionth of a second. By the way, that's been a few minutes, and we're still. What is it that's measuring that difference to make you so sure that you're accurate?
Because atomic clocks run on the oscillations of the frequency of the cesium atoms or whatever atoms they're using. Know that doesn't change with the change in the environment, other than location, right? Other than a different gravitational field. No, it's not radioactive decay.
So they don't use what you. They don't use that to prove general relativity.
Well, again, I don't know why you keep using this word prove.
To point at general relativity and say, look at how accurate we are.
Well, yeah, they've looked for anomalies.
Right, and general relativity is used to prove or to look at the heliocentric model and say, look at how accurate we are.
I'm sorry, but your sentence just happened to coincide with the middle of mine. So you really didn't hear what I had to say, did you?
All I was looking for was a yes or no answer.
Well, all you were looking for was to make your statement without actually listening to mine.
No, it's used. General relativity is used to prop up the heliocentric model. If that's what I was getting to. You said I didn't, and I'm getting you to where obviously you're wrong. They use that all the time. What are you talking about?
No, the heliocentric model is regardless of whether we use relativity or special relativity or Newtonian mechanics, it's still the heliocentric model. We don't use any of those things to prop up the heliocentric model. The heliocentric model is just a point of perspective from where we look at certain motions from.
Observations prop up heliocentric model.
They use each other. They use each other to prop each other up.
No.
No,
Yeah,
a moment
I get
ago
what
you
you're
just
saying.
said yes.
Again, the heliocentric model is just a point of view for reconciling the motion of the planets in our solar system and the objects within our solar system. That's all it is. When we're talking about the motion of other things outside of our solar system, it's no longer a heliocentric model, is it?
apparently nothing you have proof for either. You said so. It's kind of like all your claims have zero proof for any of it. So
Right, and that's a good thing, isn't it? It's a good thing because if we were claiming proof, it would be pseudoscience. Instead, we just claim an abundance of evidence to support our notions. We don't claim proof because that would be pseudoscience. Proving something means it's unfalsifiable. And if we can't falsify it, it's not science.
I have an abundance of evidence for Bigfoot. And if we're talking about unfalsifiable claims and you're talking about something that happened billions of years ago and you don't have a DeLorean, that's a cool story, bro.
Yeah, it's a cool story that you've got an abundance of evidence for Bigfoot, but I'll guarantee you...
Falsify it.
Well, can you bring me a Bigfoot? Sure, you can show me a picture of a Bigfoot, but that's not really very good evidence for Bigfoot, is it?
Bring me a black hole? I mean, other than your picture of one, can you bring me a black hole?
No, there is no picture.
What does black holes have to do with heliocentrism?
Talking about
and what does that have to do with Bigfoot either?
We're talking about unfalsifiable pictures.
I can falsify your pictures of Bigfoot, I'm sure.
Well, they were assembled over many different sightings, and they reassembled it from what people described, and they did actually create a accurate photoshopped depiction of what people have described Bigfoot as looking like. So no, I actually disregard what you said, because Bigfoot is actually very credible when you think about people's accounts of it and those Photoshop pictures.
Except for all these people that go out in an effort to find Bigfoot, can't find him.
Well, I mean, that's a little bit like black holes, isn't it?
Except we do find them when we look for them.
No.
According to your picture, right? I got my picture of Bigfoot too. How do you falsify or unfalsify or that?
There is no picture of a black hole. That was assembled from
radio. A lot of people
data.
going to point to that and say it's a picture of a black hole. I understand. And my point is, how would you unfalsify, or how would you falsify that picture? The same way you would falsify Bigfoot.
I'll tell you how you falsify it, right? That picture of the black hole, that M85 or whatever it was called, that there, right? That was created. Okay, I'll tell you how absurd it is, right? They had radio data that they put into a system to be able to theoretically propose how you could simulate a black hole as looking, right? And then they took that model and then they generated something that was completely separate from the data. So no actual satellite data, no actual measurement of anything was used to create that picture. It was just the model that they created. They created that picture with the model. So it was actually completely disconnected from any measurement of anything. It was a publicity stunt. They even admitted that after the fact.
Do we have evidence of Bigfoot caves, Bigfoot droppings? Do we know what Bigfoot eats? Do we know what Bigfoot wears? Do we know how long Bigfoot sleeps for?
I think in much the same way, it comes after the fact.
Or do we just have so-called pictures of Bigfoot?
Well, no. What if I gave you answers to every single one of the things you just said? How would you go about unfalsifying it or falsifying it?
I would ask you to provide the data that you've measured. And how you got that data.
Yeah, I would love the data on how we got the size of Venus and its distance.
Well, that data's
and
out
the sun.
No,
it's not. I mean, that's easy. That's what we're asking for. How is the proof for the actual distance to the sun? Let's start with that. Distance to the sun.
That's easy too.
Citation.
That's pretty easy.
Proof of it. You can know. You just
now you're asking for proof again. Gee, you just
no. You just said I just asked you
proof or evidence.
Right. No, I just asked you right about Bigfoot. I said I could give you how many hours he sleeps, and you say you'd want to check the data, right?
Yeah,
so you gave me 93 million miles, and I'm saying, where's the data? Show me the data for that. Where? Give it to me. Where's that data? That's what we're asking for.
Well, give me a few minutes and I'll find it for you.
The data on the distance to the sun. Great.
Can you give me the data for Bigfoot sleep times in a few minutes, please?
5 hours.
No, I don't want anecdotal. I want to see the data. I want to see I want to see the scientific report and the methodology you use to measure it.
All right, great. And then when you come up with Venus, the size and distance to Venus, I'm gonna need that too, by the way, just to when that happens, I'm gonna need that too.
I mean, from my understanding, what they did with Venus was they said, we've made these assumptions about Earth and the Sun. We'll make the same assumptions about Venus, and then we can just apply it to that. So then we have a base to work the rest of the solar system in from. You have to start somewhere, right? Because everything's relative to everything else. And, you know, if you don't make any assumption about anything, and you can't actually physically touch it and measure it and, you know, have direct experience of it or something, then you have to make an assumption at some point and then test that assumption. And I don't think that they can exactly prove or disprove or really test that assumption, but that assumption still stands today. Those two assumptions. The distance of the Sun from Earth, and then the assumption that Venus is the same distance and size, or something like that, the same size as Earth. There
you go. I just posted a link to my evidence of radar distancing to the Sun. Can you now provide your link to a paper that cites the sleeping times of Bigfoot, please?
So how did they come up with it? Let's have a look. I mean, because the sleeping times of Bigfoot would be pretty easy to explain, whereas this is you know, you've got a lot more explaining to do. You know, because with Bigfoot, it may just be that he likes waking up at a certain time, and just generally the time that he eats, and he feels comfortable sleeping at it. You know, there will only really be a finite set of factors that lead to that sleep time. Whereas with the Sun, you've got to make a whole lot of different assumptions and test a whole different set of possibilities to be able to actually assert what is the most likely probability out of all of the. You know, if you were to do it fairly, you would say, okay, let's test this assumption, let's test that assumption, and we chuck it all in these different models, and we say which one actually fits our observations the best.
I'm sorry, Chipper, but I'm just not listening to your rambling.
Well, thanks. I love you too.
Can't say the same, Chipper.
No, it was sarcastic.
I know. So was I.
So you do love me?
No.
Oh, I had my hopes up there for a minute. I think I'm not sure who said this, but they said slam your body down and wind it all around. And they said, if you want to be my lover, you've got to get with my friends. Make it last forever. Friendship never ends. If you want to be my lover, you have got to give. Taking is too easy, but that's the way it is.
I'm about to vomit.
I did.
What have you been eating? Is it something with your diet? Have you just been drinking too much water or exposure to sun? What's making it feel that way?
The resonance of that dull tone voice in the background.
You should start with eating the right types of salt. Like sea salt is very good for you. Like isolated table salt, which is like just sodium, terrible for your the way your cells absorb water. It'll push all the potassium out of your cells. It's really quite toxic.
I only digest Celtic sea salt that has been harvested by 77 virgins on every third full blood moon. Only ever.
There you go. 85 different minerals in Celtic sea salt. And sea salt has, I think, 95 or 90, 92. And then the Himalayan salt has 75 minerals. I don't know what the, who's counting or why, but that's just something I heard today. Yeah, apparently they all the different minerals are supporting of that capillary effect of, or that not capillary, but the mechanisms of the salt bringing water into the cell. Your magnesium salts, your sodium and potassium salts, because you've actually got on your cell membrane, you've got a sodium potassium pump, and when you have too much table salt and not enough of the supporting salts, you can get a reversal where instead of there being like a lot of potassium on the inside of the cell and a lot of sodium on the outside, you can actually have a concentration of sodium on the inside of the cell, and it pushes all the potassium out, and that's where you get I think I may actually have some sort of problem like that. My skin's been very strange lately. I'm quite sick at the moment. But this lady reckons you get a bit of Celtic salt, and you put it on your tongue, let it dissolve on your tongue before you drink a half a glass of water. And she reckons 2 liters of water a day, which I've heard that before, but it's actually a really good presentation. It's this Christian lady. Water, salt.
Best way to clean out your system, get half a cup of Celtic sea salt, dilute it with half a litre of warm water and drink it. The best
That's
way
right.
to clean out your system.
I did hear you say that the other day. How over what period of time would you drink that?
You drink it over about the spate of 30 seconds.
No, wait. Well, okay. So it's not actually absorbing. It's just trying to pull the crap out of it, of your. Wait, sorry, how much salt in a half a liter?
Half a cup.
Half a cup.
Half
Jesus Christ! Is that safe?
Oh yeah, definitely. I've done
it. I wouldn't recommend it.
You know
That'll put your kidneys under extreme strain.
Oh, well, no, it's it acts as a laxative immediately.
I can think of better laxatives than that.
Oh, Paul, I went to one of the jobs I did years ago on a job site. It was a union site, and they went through this phase at one stage of getting all the guys fit and healthy, like doing stretching exercises, this, that, and the other. Anyway, we were sitting in on this talk he was giving everyone about diet and exercise and whatnot. and he said that your system or your bowels in particular build up a lot of bacteria, so it's a good occasionally to clean them out. And I was only young; I was only like 21 or whatever. And anyway, he said the way to do it basically is to clean out all your bowels, and he gave us the recipe of how to do it. And then once that is done, then you drink some, you eat some yogurt, some natural yogurt.
No, to replace the flora in there, yeah.
Yeah, exactly right. He said that's very, very, very important. But one thing he mentioned is after you drink it, it was a sight for sore eyes and a sore ass too at the time, I must say.
I've got a better story than that. This will make you really, really, really.
Yeah.
But my mum, right, a couple of years ago, where she lives, there's a laneway at the back, and my dad's shed is up the back of the property. So, and my auntie lives across the back lane from my mum. So to visit my auntie, my mum goes up to the back of the yard, walks through Dad's shed, through the back door of the shed, and out into the lane and across the lane and through my auntie's backyard and into her house, right? So there she was at my auntie's and having a good talk and whatever, and she felt a bit of a, like you say, stomach rumble, and she thought, oh, I better go. So she starts making her way back, right? She gets to the back lane, and it's like she gets halfway through my dad's shed, and she realizes she's not going to make it to the toilet, right? And so she thought, well, what I'll do is I'll just do it in the garden and then, like dig it out and dispose of it, right? And so she said she went to pull the pants down in Dad's shed to get ready. She said she bent over, pulled the pants down, and it just went. It sprayed all over his shed, all over his fucking tools and all over his cabinets. She said it's the angriest he's ever been.
Oh God, yeah, I can imagine.
But she said she just couldn't help herself.
You can see it as being taken the wrong way. No, surely you meant it. I'm sorry, I didn't mean that the other day. Like, if you were that pissed off at me, he could have just said something. He didn't have to shit on my tools.
You're both laughing and you're probably cringing as well, right? You're thinking, God, I hope that never happens to me.
Oh, exactly right. I'm just picturing it like probably for years to come. It's just like he goes to pick up his spanner or a torque wrench.
The memories. Yeah. I mean, what did he clean them with?
I don't know. I didn't ask.
Well, it wouldn't have been spanners or anything like that because they obviously would have been in drawers and stuff. So, yeah, just probably garden tools and handles and stuff.
My brother-in-law got robbed the other day, Bandy.
Oh, what? Really?
Yeah, he came home and he was like going to sharpen his chainsaw to go out and cut some firewood, right? And he went and he noticed his chainsaw wasn't there, and he thought, what the hell? And he looked around, he noticed there were a few more things missing. But as he was coming home, he saw a pallet. There was old pallet leaning up against the back fence. And he thought, what the hell's that there for? And he thought, oh, it must have just fallen off of someone's trailer or something, and he didn't. But then he realised that there were things missing from his workshop, and so he'd normally have his workshop locked up, but he left the not the back door into the laneway, but the door from the yard into the shed unlocked because his partner Chrissy was going to come in and get something, and so he called the police, and the police came round and they fingerprinted everything the next day, and they actually found some blood in there as well. And they took DNA samples, and they came back the next day, and they said, "We know who it is." Right? But they couldn't get a search warrant for 3 days, so they had to wait for 3 days to get a search warrant. And they after that they my brother's got camera. He's got security cameras out the back, and he noticed the guy, on the security camera, carrying stuff to a wheelbarrow at the back of the property. He said he doesn't know whether he had a mate there or whether he just, was doing it himself. So obviously used the pallet to climb over the back fence, and then he was carting stuff to the back fence and throwing it over. And apparently this guy lives just down the street from him in a yard. And so the police went round and they recovered a few of the things, but most of the things like his chainsaw and his spanner set and a few other things and his 9-inch angle grinder and stuff like that were already gone. The guy had already sold them, But Dave said, my brother, he said the guy tried to come back that night at 3 o'clock in the morning. He's got camera footage of him coming back at 3 o'clock in the morning. Yeah. So this guy's been charged and he's got to go to court now, and he's not allowed within 50 metres of my brother's house. And
Is the guy that they caught, is he just an outright thief, or is he a junkie thief?
I don't know, but apparently he's well known to the police, so it's probably not the first time he's done this sort of shit.
Well, especially if they've got DNA and fingerprint samples of him, he's definitely.
Yeah, that's right. Yeah.
That's actually a really good thing they did actually get him. I mean, that's sort of like the modern day equivalent of having your ears cut off, isn't it? I mean, but not really. I mean,
but he's fighting with the insurance company at the moment, trying to get compensation from the insurance companies alike. They'll use any excuse they can not to pay you.
They should cut his hand off.
Did he tell the insurance company that he left the door open?
I'm not sure.
Because they'll probably fight him on that one. I know someone that exactly the same thing happened, where they admitted to the insurance company that they left the door open, and that was like a get out of jail clause for the insurance company. And instead of covering whatever percentage that he was insured for, because it wasn't quite 100%, so he downgraded his insurance. He was going through some financial difficulties, but whatever it was, they downgraded it to he got about 20% of the value in the end.
Wow.
Because they attributed part of the blame on him for leaving the door open, which I thought was a little bit harsh, to be quite honest with you.
No, it's utter bullshit, because then if they broke the door, then the insurance company would have to pay for the door. So they should be happy they left it, as if it's just okay to walk into someone's house and steal it. Oh, they didn't lock it. That's perfectly acceptable. Outrageous.
Exactly.
The fact that we put up with this is unbelievable.
Yeah, but my brother will be asking when he goes to court with this, to testify against this guy, to have the guy actually, pay for his tools that are missing. So, even though he's got not much money, he can still ask for the guy to pay $20 a week or whatever until he actually pays the full value of what he stole.
Isn't that a civil suit, not a criminal suit?
And also, that's ridiculous, because what cop is going to sit there and make sure that this $20 payment is made? No court is going. They're going to say, "Yep, you have to pay it over time," and who's going to actually enforce that ever? Really?
Yeah, that's right. Yeah.
It's a way to make it go away. No, the court
No,
did it, and he says you're supposed to pay it.
If he's unemployed, you can do a thing where Centrelink will just pay it all outright, and then he'll have to pay it off to Centrelink. He'll give reduced benefits.
Yeah, that's a good idea.
Yeah, but I think
what I want to know is, are the police now going to follow up and find out who he sold those things to and charge them for receiving stolen goods?
Okay, well, Firstly,
Yeah, I
people
mean, it really
know,
depends on
people
how
know
it's.
they were stolen, don't they? But then again, I suppose if you're in that circle, you probably know that things fell off the back of a truck.
Yeah.
Yeah, I mean, it depends on how it was purchased. You know, did the guy go to his house like just a Gumtree listing? Oh, I'm just selling my chainsaw kind of thing, or is he actually going out somewhere to flog it off to somewhere? Then yeah, the buyer might be dodgy too.
Yeah, because everyone walks down a back alley to get a chainsaw. Hey kid, you want to buy a chainsaw?
Oh, we got to meet somewhere.
Yeah, drug addicts that steal random power tools and shit, there's always that one pawn shop that's gonna buy whatever the fuck they bring.
And then to add insult to injury, Bandy, my brother's partner, Chrissy, right? She has a part-time job, amongst other jobs, as delivering pizzas. She got a call to deliver a pizza, and lo and behold, guess where she had to deliver the pizza to?
Oh, no way.
Yes, way. It was the bloke that had stolen the stuff.
Imagine if she had rocked up to deliver the pizza and he said to her, "Oh, by the way, do you want to buy a chainsaw?"
Buy a chainsaw.
Oh. Yeah, it is terrible. I don't know what it's like there, Fuzzy, but our pawn shops here have quite a strict governing policy. Whatever goods they buy, they've got to hold on to. I think it's for 30 days. I think it's a minimum of 30 days. It may be longer. Yeah, they have to keep very specific records of them, and the police can go into a pawn shop at any particular time and go through all the records of all the stock and take inventory.
And certain high-value goods, they've actually got to clear through the police to make sure they're not on a list of stolen property. Yeah.
Yeah. I think the laws here in Australia, when it comes to pawn shops, are pretty good actually. When it comes
They
to
are
this
pretty
sort of
good, yeah. I mean, I had a camera stolen quite a few years ago, Bandy, from my house. I bought this second-hand Canon 5D, which is a pretty good camera, right? And I had it for 10 days, and the fucking bastards come in and stole it, So, yeah.
Did you turn your home into a smart home, Paul?
Yeah, I have, yeah.
So what, you put in all the Cat5 cabling or whatever the latest cabling is, and hardwired everything?
I'm about to put in Cat5, Cat6e actually cabling into it. At the moment, it's all running off Wi-Fi, but that's a pretty hard load on the router. So some of the bigger things like my home theater receivers and AV receivers, and other AV equipment is going to be hardwired. But all the lights and power switches and things like that, and blinds run off of wireless. Yeah.
Nice.
I had these Osroll roller shutters, like aluminium roller shutters on the outside, and they're like a battery thing. They're not mains powered motors. They're 12-volt motors, right? They're run by a little battery pack that sits on the wall. It's got the control built into the battery pack. And I've been asking them, and asking around and trying to figure out how to make them, auto controlled. And you can. The only way that I could do it realistically was to change the motors over to 240-volt motors and hardwire in proper switches, but I didn't want to do that. So I ended up ordering completely new charging units for them, which are RF, and so I can control them with a remote control. But I ended up actually ordering these little little $8 dual Wi-Fi relays from China. They're only $8, and they run off of anything from 5 to 32 volts, and they've got 2 relays on them, which is perfect, one for open, one for close. And I've just wired them into the actual back of the controller, piggybacked them onto the push buttons for the actual controller, and so now the controller's not removable. It's hardwired into the wall permanently in a power plug. It works a treat. It works absolutely brilliantly. All I need to do is say, "Hey Google, open the living room shutter," and wow, off it goes.
Bang! It's all done just like that.
Yeah.
It's amazing, isn't it, Paul? Like with this sort of stuff, it really is incredible.
Oh, it is. It's good. Yeah, it's the sort of shit. So now with my shutters, I've got them set so that when I go away from the house with my phone, it detects that I'm not at home and it closes the roller shutters. So it gives me added security with the windows. Having all of them closed makes it a little less break-intable and stuff like that. I've got a smart cameras around that report to me when it sees movement in or around the house, and yeah, it's all good. Yeah.
So, and you can control everything away from home too, just through your.
Yeah, I can. It's like I've got Wi-Fi air conditioning, so I can control my air conditioning from anywhere. It's great. I can just be in the bedroom at night, and if I get a little bit cold, I can just say, "Hey Google, turn on the living room aircon or the bedroom aircon or whatever," and away it goes. It does it.
Yep.
Or I can do it from home, from work. So if I know it's a bloody hot day, and I haven't got my aircon on, just before I head home, I can tell it to turn on, kick it on, and by the time I get home, the house is nice and cool.
Nice.
Hey, I came up with an idea earlier in the year for making houses more energy efficient. What would be the process? I mean, I'm not sure if you would even be able to patent this sort of idea, but I don't know if I'm ever actually going to.
Come on, share it so I can steal it.
Yeah, I've got to say, spit it out.
Well, if you do, there's too many people. There's too many. Like if it was just you two, I might share it, but I'd sort of just say is it if you are able to take it on, are you able to include me in it or something like that? But
Well, yeah,
yes,
it's a decent idea for sure. But hit us.
Well,
let's go.
You have it so it's adaptive, and well, I mean, it's really simple. The code would just be when it's warmer on the outside versus the inside. You open these shutters, and these shutters. Oh, fuck no! I can't.
What's the idea?
Well, basically, it pre-warms or pre-cools the insulating layer.
Oh, that's great. No, have you seen these people laying these floor heaters and they literally use water to heat the floor?
I'd love to do that. Like set it up in my fireplace.
No, you're right, bro. That actually is a good idea, and I hate to say it's not yours though. I mean, I feel like the heating floors and the cooling floors, it's kind of like the same idea, right? Like using water to cool the room.
Yeah, and
the best way to do it is geothermal. You just fucking dig a hole, and then all you gotta do is power a fan for the rest of eternity to. Cool.
Maybe your idea is different. I didn't mean to say that they already did it.
Well, see, here's an idea that I actioned, that I put into action, Chepper. Right, a big thing here in Australia at the moment is the government's actually making it really easy for you to change over from the old electric hot water heaters, hot water systems to heat pump hot water systems, which are about 7 times more efficient than electric ones. Right, they're bloody good. So you can basically get almost a free heat pump system and exchange it for your old electric one. They'll come and install it and put it in for free. I got a slightly bigger one, and because I already had a heat pump, I had to pay about $2,500 to have a new one put in. But it's about $4.5 grand worth of value. But it's really good. But in summer, right, the way they work, they take the heat from the air, right, and put it into the water, and they pump cold air out. So I've got this. So I've got this heat pump in the summer, making my hot water, and it's pumping out cold air out the top of the heat pump. So all I did was duct that into my back room laundry, so that it actually cools the inside of the house while it's heating the hot water. It's brilliant.
Did exactly the same thing, Paul, in Victoria. Did exactly the same thing, because it is surprising how cool the air that comes out of that unit is. Absolutely surprising. And you're just blowing it into the atmosphere, and you're thinking, this is a waste. It's an absolute waste. Yeah. So yeah, that's exactly what I did too. I just got some ducting, bent it around, and I just pumped it through the laundry window, and you'd open up the laundry door, so it would filter through the rest of the house. But it actually it made a real difference. Actually, it made a real difference. I was
What do you guys? I hate to try to change the subject on y'all, but how did they heat these buildings? Do we got to get into it? We don't got it.
Right, the Tartaria stuff, but yeah, how did this? I mean, I recently last year got a new electric hot water system. How long has this rebate thing been on for?
Years
now.
Years, at least 15 years, I reckon.
'Cause I don't think I've ever seen one. A hot water system with a fan on it.
Yeah, it's like a reverse cycle thing.
Yeah, I understand how they would work.
Can I make a comment? They used to put giant ice blocks and just stick a fan on it and call it a freezer, and it would just blow the cold air around. This is how people refrigerated things, with just a big block of ice.
And it's actually, if you're going to go for it, Jepper, it's actually cheaper to go for the commercial system over the domestic system. It's actually cheaper.
If you've got an existing electric one, Chipper, they were literally replacing it for free.
Oh, it's free. It's totally free now, Paul. Okay, so they've upped. Yeah, they had huge rebates back in the day when we got ours. But the company that we went through, because we wanted a large one because of all the kids and all that sort of stuff, they said it was better to go with the commercial version, not only because of the size, but he said economically you won't have to you won't have any out of pocket expenses whatsoever.
So even labour.
Yeah, nothing. No, it's all covered. All covered. Yep.
Wow. Okay. That's amazing. I should look into it because.
Yeah, you should.
I mean, it's brand new, but I mean, it's probably the highest cost electricity bill.
Oh, your hot water, your fridges, and your smart TVs are the biggest user of your power, plus your aircon and stuff. But they're your biggest ones.
The latest initiative, Bandy, is they've been going around towns telling people that they can get a free reverse cycle air conditioner. And it's right. Even if you've got reverse cycle air conditioning in your house, if you've got a room that isn't covered by that reverse cycle air conditioning and you're using an existing like little blow heater or something like that to heat it, they will give you and put in and install a reverse cycle wall, like a split system in that room for you for free.
Really?
Yeah, so you got people that are going out and buying little $15 fucking fan heaters and then saying, hey, give me a free reverse cycle air conditioner. Yeah.
Is this through the government?
Yeah.
I'm gonna because we are actually thinking about getting a split system ourselves. So
just for one room or for multiple rooms?
Well, because of the cost of them, we were only going to get it for the main room and then have that, just passively filter through to the other rooms. But damn, if I could get it for the whole house, split system in each room, I'll do it.
I don't think they'll do each room. I think they'll give you one.
But yeah, no,
I
if
think,
I can
yeah.
get one for free, it's better than
Yeah.
getting none. Yeah,
Yeah, it is, of course. Yeah, yeah.
So
Yeah, I ended up going with like I've put split systems in mine. I've put a split system in the living room, in the kitchen, in the bedroom, and in the music room. Right, 4, but they're all joined to one unit on the outside. So it's a multi-head unit. It's only one unit on the outside, and then that feeds up over the roof and into each. There's a little head in each room that cools.
oh, you've got to be. It's just a bloody Victorian thing. You've got to
Is
be
it?
kidding me. Yes. Oh,
Oh, there you go.
damn.
So I hate to try to change the subject on y'all.
Yeah, go for it.
I'm a little shocked to read about this thing called the World Fair in 1893. You guys hear of this?
Oh yeah, that's
Bro, apparently they burned down all these fucking structures. You know about this? They say that they built up all these structures for the World Fair, and then at the end of it, they set it on fire. That's literally what it says.
Really?
In Chicago, there was like all these fucking beautiful buildings with amazing architecture and fountains and courtyards. At the end of the 1893 World Fair, they set it all on fire. And now I'm wondering, well, what if they didn't really mean the word fair? What if they meant the world fire? And the Columbus expedition, they were just going around burning shit to the ground. I mean, I don't know. Does anybody else know about this?
Well, I've heard of the World Fair, but I don't think I would equate it to a world fire personally.
Well, why are they burning stuff down at the World Fair, though?
Well,
Were they just displays that they were burning, or like because I mean stone
Okay.
doesn't burn?
I'm referring to something that I literally just learned like 45 minutes ago. So I can pull up what I just watched, or I can actually research the World Fair right now. But somebody said that they set this shit on fire at the end of it, and
Well,
I
I was under the impression that they were stone structures.
right. I was under this.
Some of these structures were quite elaborate and beautiful, actually. A lot of the glass in them.
So you're saying they were deliberately burnt down, or were they just? Was there a fire that burnt them down?
Thought. That's what I understood from it, is that they build the World Fair and at the end they tear it down. Almost like how we build up a carnival and tear it down. Like that's what they're insisting happened.
Are you Googling this, Paul?
I don't have time to Google at the moment.
Are you a mind reader, Bandy?
Well, I was about to, but I thought you'd probably beat me to it.
Specifically, the World Fair of 1893 in Chicago is what I'm talking about. There was this place called the Machinery. I don't know what the Machinery something. And this was a building that would have been the second largest building in the world next to the Boeing airplane factory.
Well, here you go. The first result. So what I typed in was I typed in the words "burning down World Fair Chicago," right? And the first result that comes up, it says tragedy at the 1893 World's Fair. Fire killed 16 while crowds. Blah blah blah. So I'm about to read that.
That's interesting. So that made it sound like it was an accident. What I heard is that they intentionally burned this thing down as if they were tearing down a carnival at the end of a fair.
So the whole fair was like basically like quote unquote burned down, which is really interesting. I've done a lot of research on this fair, and it's like they had a lot of like really interesting things there that should have never been torn down, right? Like one of the things that they had there was like this Ferris wheel that I just posted in chat. This Ferris wheel, each one of the sections on there was the size of an apartment. It was just like this giant thing. It was like this crazy thing. How did they tear this down? all of this like gargantuan like
Look at that.
style
Look at that
architecture.
beautiful. That was supposed to be Chicago. They built Chicago in this place. Wait, what?
There was over like this one. There was some weird like baby viewing.
Oh, the baby thing. Yeah, I've seen photos of that.
But like the architecture is just super grandiose. Like this foyer here with all this water in and this like entry point. Like they had to like all that had to be that water had to be moved in. Look, there's this map here of the entire event. There was over like 200 something buildings to this thing. It's literally just like incredible. There's the entire map.
So they insist that they had to bring all that water there just for the fair?
Well, it took, yeah. The story is that I don't know. It was like all this man hours that went into building
I like what you're telling me, honestly. I like their side of history because I just heard a different side of history. I heard that all these structures were there when they first started settling in the 1500s. All these structures were there in the 1500s. That's what I just heard.
Well, yeah, that's the conspiracy, right? So they were, yeah. I mean, because there's really hardly any photos of its construction, which is really weird. There are a few, but
I work in Manhattan every day.
Popped up out of nowhere, and then was like all burnt down. And it's like, why was this all of this erected to basically be quote unquote temporary? It all appears to be, you know, really
immaculately designed. I work in Manhattan every day, right? And I'm noticing these kinds of buildings. You'll see like a clear difference from the base of the building going up from the new buildings. Old buildings always start underground. So you can literally see windows even with ground level like everywhere in Manhattan. And this just suggests that there was a lower ground elevation at one point, and they literally just were throwing not just tar, like, you think a layer of tar is maybe, I don't fucking know, but this shit is literally like 2 stories above the bottom of the building, like the roads are. So like this is what made me look into it more, the whatever I'm looking into.
Well, yeah, and then what you said about that one building that was supposed to be like one of the largest buildings in the world. That building could house some. I mean, it was just an insane number of people that were apparently reported to be there. And yeah, I mean, it's like how did a building like that even like what? Apparently, though, like I looked into it, like yeah, the story is that like they basically all this stuff was built rather quick, right? And it doesn't make sense because like some of the images I have here, just like you have these huge statues. They look like chiseled out of marble. All of this stuff, it's like, wait, what? How is this? Where did this go? What you got rid of this stuff? And so it makes more sense to me that like, yeah, basically this stuff was there already. And they needed a story to like burn it down and just get rid of it. Hide it, right? This is all the antiquitech that basically has been hidden over the past, 1,000 years. There has been a drastic effort to like hide all of this ancient stuff and like change the history because it's clear like those who control the history control, our future. Those who control the past, right? And that in a weird way, our understanding of everything gets smothered and completely ruined,
That's why I love this Discord. I research something, ask myself a bunch of questions, come in here and ask you guys, and get a better answer than the internet. Like, that's amazing to me.
So it turns out that the fire wasn't deliberately lit. It was apparently started by faulty electrical stuff that they'd done faulty wiring in a building.
4 people were eventually exonerated. I think we're reading the same article, Paul.
Yeah.
Sounds of it.
Faulty electrical?
Yeah, for it to assign.
And it burned down these. What are they made out of? Like, what did they say that these buildings were truly made out of? I'm wondering now. Like, you can't just burn a brick to the ground, right? Am I crazy?
No, but a brick building can be burnt beyond repair too, as well, where it has to be then
My bad.
too. You know, the mortar between the bricks can get that badly damaged where it becomes unsafe and stuff due to the heat.
Like I could tell you right now, I live in Newark, New Jersey, and there's all these brick buildings that were caught on fire, and the bricks are fine, and the windows and everything else is fucked. And the roof will be fucked, and the windows are fucked, and the door is fucked, but the bricks are fine every time.
There's apparently a photo of one of the photos of them building it, right? It's like, huh? It just looks rather like weird to me. I don't know why, but it just does. But like the picture above the one that I just posted, like look at all of that. Like where did all of that go?
That's
In
incredible.
a fire?
That's fucking huge. And there's only one.
Long
Well, like it just doesn't make sense like at all.
But that would have taken years to build all that.
They claimed that this was done by people on horse and buggy by the hundreds.
You said though,
Yeah, that doesn't make sense either. Like the whole, the story of how it was built specifically. Like if you look into how this was all built, it's like basically it wasn't even like that many people who did it, and it took like maybe a couple of years to do it, and it's like all of this stuff, like all of this, really, a couple of years.
Maybe it
Like,
was
none of that
paper
makes
mache,
sense.
or it was some kind of poured.
But we have evidence of these similar architectural structures that are still standing. Like I literally see them every day in New York.
No, I know.
I'm just wondering. Yeah, go ahead.
Like the structure that you see on the bottom one, that's obviously like scaffolding. There's a lot of it though.
So I have another theory. So you see the scaffolding. I think that these people actually tried to renovate these buildings at first and say, "Oh, let's make this our home." And then when they realized that they couldn't facilitate their own lifestyles at the time, like whether they were getting sick or didn't know how to plumb or have irrigation or have heating or cooling or any way to store their goods, that's when they said, "Okay, we suck at this." Like,
when was it? 1803, was that right?
1893, I think.
Oh, yeah, I see.
I don't know. There's just a big question mark on this little time period. And then you can look at stories about the Vanderbilts and these people that were going around and, they're pretty much migrating huge populations of people out of areas of, the other side of the world and making them responsible for building this side of the world, right? Is this crazy? East India Dutch Company or something like that?
Yeah, that sounds familiar. Another interesting thing at these world fairs is that they basically, this is where they introduced, because this was like a lot of these like rich people, and at the time a lot of the elites and stuff, they were the only people allowed to take cameras in at these events. It's well known that like you basically had to be even rich to get into these events in the first place, but to get cameras into these places, it was hard. So because you actually had to be rich to have a camera back then anyway, right? So but anyway, it was like at these fairs is when they basically started introducing the idea of these like Eastern mysticism and stuff, and these like Indian gurus and stuff, and like all of this like New Age philosophy rhetoric. It was all funded by the fucking one of these families. I forget their names, but the Bilderberg, not the Bilderbergs, but the fucking.
I want to say, like, I just watched a video about a few of these types of these royal families had like seals and codes of honor and all this stuff. What were their names? I can't remember. I'm sorry. One of them was Vanderbilt.
I don't know, some hotshot, right? This was all just funded and stuff, and the idea was basically brought over here and fucking penetrated the social sphere of the West, and it basically like totally started to degrade it, our values and our way of life, really. And you have these like mucked New Age philosophies over here that are just basically garbage, really. And it's all becoming like a hodgepodge of just ideas, like it's totally, all of it's just being smothered and lost, like traditions being lost, like everything is just being destroyed by the hand of these like social engineers.
Yep, social engineering.
How long did that World Fair go for? Because it was like a simulated society, right?
Yeah, let's look that up.
I can't see them bringing water in, but I could see them getting like a oddly shaped body of water and saying, "Oh, look, we could make a bank there quite easily, and make it, choose a location for it, and then to build
Check this
their
out.
elaborate
Check this out.
architectural ideas."
The fair ran from May 1st to October 31st. Jackson Park on Chicago City South Side, drawing in 27 million visitors over a 6-month run, celebrating the 400th anniversary of Christopher Columbus's
Holy
arrival
shit.
in America.
27 million. That's a lot of people.
And they say like, yo, we built this shit, come check it out. And it's like, nah, you just invited a bunch of people to some nice ass shit you found. How do you convince a population of people to go along with the destruction of history? Hey, there were these people that were coming through the country just willy-nilly, just burning shit to the ground.
Oh no, people love that when like, I mean, I was it just doesn't get reported on, and people don't care about it. Like, what was that one in Lebanon? There's a megalithic site in Lebanon that was destroyed, or it was ISIS was desecrating it.
Are good. Was that recently?
Yeah. I mean, like within the last 10 years.
Wow. Another example of just like, burning down something. I always find it interesting how people want to ignore how Central Park was actually like mostly like a black village, and they had banks and they had stores and schools and doctors. And one day people just went over there and just burned it all. They just didn't like the idea of people having their own shit. A black-owned bank is just not acceptable to these people. But that doesn't even have to matter right now. There's another example of something being burned to the ground by the will of just regular people.
I'm just looking at the person on the horse on that second picture, and those pillars wouldn't have been easy to. I mean, it would be like that. Just the structure they have there, that would have taken. Well, I don't know how many people. It depends how many people they had on it, but those pillars all have to be cast and then molded and then stood up, and to stand those up would be no easy feat.
Yeah, and like toppling some of these structures, you're gonna tell me you didn't take one bat to one wall, you didn't try to knock down any of just fire was the reason it all just fell to the ground.
Well, what were they building it up with? Like maybe they've inherited these stone column type skeletons of old ruins, and then they've gone, you know what, we can just build wooden supports and just make it look like it's all, and then we'll burn our stuff off, and then it'll. Oh, but what happened? What happened to all the stone pillars and that? Well, they would still be there, right? You couldn't remove all that from the site.
That's the thing, right? There's all these like Roman era style arches, spires, huge pillars. There's bridges. There's just huge waterways. There's just like all the boxes are checked when it comes to the World
And
Fair.
there's also tunnels and subways, apparently.
No, but let's say if you go there today, what was the site that it was on? Like, are you able to go there today and look at the pillars? Because that would still be in the like.
So that's something that I really was hoping I'd be able to do for this for you guys. I know for a fact there's like really ancient subways in New York that the trains don't use these tracks anymore, but there's still ways to get to them. Like the tunnels still exist, and one day I really want to fucking find the old subway station and just take a picture of the arches in the ceiling and just like look at how it looked. Because I know for a fact, like if you look at pictures of the subways from the 1920s, it's like these beautiful arches all over the place. You don't see that anymore. Now it's just, the subways are dirty as fuck and it's not the same areas. The tracks are just they just don't go towards these certain stations anymore. That's all it is.
Yeah, I know what you're talking about. The like triangular windows and like dome-shaped triangular windows with arches leading to it, and between the different rail lines that all connect up.
So I'm just trying to suggest that, like, who built this shit? Who were the Native Americans? Did they help build? Like, what was going on in America? I don't fucking know.
Well, it's 11:11. I should go to bed. I'll work tomorrow.
Oh shit! All right, I just woke up.
Oh, good.
Sleep best, my friend.
Good talking to you.
Thanks, guys, for knowing a lot about my questions.
There's a lot of old world architecture that doesn't make any sense. I always look at the Arc de Triomphe as an example in France. That big arch, heavily.
Let me look this up.
Pardon
I
me?
love looking this shit up.
Yeah, Arc ARC space DDE and space TRIOMPE. It's in France. That's the thing that was commemorated by Napoleon after he famously led all of those Rothschild-funded wars in the 1750s.
Dude, this exact fucking thing, I literally see it every day at Washington Square Park in Manhattan.
Yeah,
like I literally stand under this every day.
Yeah, there are these arc type of structures that are seen all throughout the world. The Washington Monument is another, obviously not the same, but it's a phallus type of structure, and a lot of people will talk about are we looking at circuit boards potentially help with electricity flow. The arc definitely has potential resemblance to something that would complete an electrical circuit if you were to look at the cityscape, the outlay of the design of the city, and resemble a circuit board if you want to see it that way. So there is a lot of in terms of the construction of the building, I definitely will look to the Freemasons, because I do think that they had the square and the compass. You don't roll around with the square and the compass just for shits and giggles. There's a purpose to that, and that's a heavy understanding of heavy understanding of math, geometry, things of that nature. So I think they have.
You just gave me a fucking brain blast, bro. Holy shit!
That's what we do, dude.
So crazy.
We're sitting around throwing darts at the board. Whatever sticks for you, you need to run with that. I appreciate it, man.
Bro, let me tell you something then. All right, so you got all these supposed cables, these electric cables that companies like AT&T have Verizon do that are underground. And then you also have these structures that are supposed to be like, you know, these points on a circuit board. It would make sense that, you know, maybe this area, the city could be lit up if there was something charging.
Well, remember, the canals.
Right. So what if like they literally already had underground cables?
Well, hold on. Slow your roll on the underground cable part. Let's come back to that. Right, and we're not done with the city observation just yet at surface. Right, you're going below grade. So let's look at canals, right, waterways, right, and remember that these weren't freshwater. These were seawater, right? So a lot of these things were moving seawater, and from my understanding, well, no, not my understanding, from what I know, salt is alkaline, so it will allow the electric flow of energy to pass through it. So seawater is in fact a conductor. So I wonder if the canals and the waterways were a potential. I'm not saying, you know, stick your hand in there and get electrocuted. No, I'm not talking about live electricity, but I am talking about the potentiality for a conductor, using the canals as a potential raceway. Again, you're just throwing darts at the board.
Good shit. Wow. Yeah, makes sense to me, I guess. I'm going to have to look at what a raceway is right now.
Well, when I say a raceway, I think of, you know, when you go to like one of these storage buildings, or you see the exposed stuff in the ceilings, right? And they have all of those metal channels.
No,
and
yeah, this is exactly what I had to do at my
those are
job.
called raceways, right? So whether a raceway carries water or carries cables, whatever, it's still identified as like a potential, or not potential, but it's still identified as a transport, considering it's like a raceway and let stuff go down it. So carrying water and cables, at the end of the day, still carrying something. But yeah, I
Has
definitely.
anybody ever tried to make a simulation of these, like, you know, old world raceways, like simulate how it would have worked? Has anybody ever tried to do this?
Well, have you seen the old pictures from back in the day of these cities lit up almost like a carnival? Like they had points of
course,
light
that's what I'm
everywhere.
exactly what's in my mind right now.
Exactly, and I don't believe that they laid wires. Again, guys, remember, when we see electricity, there's two theories we have to entertain. We have to entertain direct current, which was Edison, I think, if that's right, and then we have to entertain alternating current, which was Tesla. So when you have the two theories, you can't get electrocuted by alternating current, but you can get electrocuted by direct current. You need cables for a direct system, but you don't need cables for an alternating system, from my understanding. So if all of these cities that we saw back in the day that all had a potentiality for the transmission of electricity, my lily pad thought would be like the Egyptians, the pyramids, thinking about those gold or the capacitors that they had at the top that potentially were some kind of, maybe they harnessed the ether to transmit electricity. Voltage, things of that nature, currency, if you will. Currency being currency as in the current of electricity, not currency that you pay with money.
Wow. Yeah, I would love for this to be this situation because we have no explanation.
Well, that is again the theory of free electricity, right? You harness the ether to create what you need. And that whether it comes from I got up in a bad mood, so I need to meditate in the ether, the Christos, the ether is going to bring me to a positive place of happiness, so I'm not an asshole throughout the day, right? Or I need electricity, i.e. I need to harness and, I don't know, make something or whatever, so I'm able to...
like if the air is moving, wouldn't you be able to use this as almost like a windmill?
Exactly. And when you look at it from that respect, I believe, and again, you guys, jump in at any point in time, because right now I'm just like talking out my ass, but I'm thinking second law of thermodynamics, where you have a closed system and nothing can be created. It is just recycled and renewed within that system.
Man, we got to figure out what the fuck this little system is.
And I forget I'm talking to Electric. How fitting is that?
Yeah, it's funny because my name is Electric because of it has nothing to do with electricity. There's a band called the Blood Brothers, and they had an album called March on Electric Children, and it's a concept album. The character in the in the album that they're singing about, he's actually like a porn star. He's a porn director.
Ron
So I
Jeremy.
took this name when I was in like 7th grade for a video game.
Hey, you know, wait a second. He's in 7th grade. So what year were you born in, Electric?
I was born in '89.
Crazy. So I was born in '79.
Oh, no shit.
What I find interesting is like our, you know, I say our generation loosely because obviously there's 10 years between us, but like I remember in like 89, 90, that's when I found, and I'll never forget, I found my first pair of boobies in the woods. So me and my buddies were out doing our little our walk through there's like a ravine behind where we lived, a bunch of apartment buildings, and somebody had taken like an old school like Playboy whatever, and they ripped out pages and folded it up and tucked it away somewhere, and maybe their parents wouldn't find it. I don't know why you would hide it in the woods. Anyways, we're all hanging out like, dude, boobs. So we're 10 years old freaking out about boobs. It was hilarious. I'll never forget it. Anyways, coming back to the whole aspect of it, the fact that we went hunting in the woods for boobs, and now these days these kids are able to go into their pockets and get boobs.
Wow.
You know what I'm saying? Just Google it.
Yeah. But even though my name is Electric because of other reasons, I've always had a fascination with
electricity, currency,
accessing the supposed motions of when I was little, I would be like, oh shit, okay, the earth is rotating. Okay, how fast is it rotating? Okay, got it. How fast are we moving around the sun? Okay, how fast is the sun moving?
Yeah.
Calculate all these motions. If you could just move in the opposite direction of all these supposed directions, you should be able to just float off of the earth with no effort. And I used to like think about this a lot. Like, damn, there's got to be a way to just float off of the earth with no effort, without all these planes and firing and gasoline. Like, that was my issue with everything, you know?
Well, you raised an interesting point. And I'm actually like, well, I'm going to lily pad it actually for a quick second, take the opportunity. I realized.
Oh, and by the way, I don't believe in any of those.
Yeah, no, it's
astronomical calculations.
Electric, you're way past that stuff, my friend. But the ISS, that thing completes one revolution around the Earth every 90 minutes. That's the rumor. I just listened to Michelle spit for Vermin on some clip Eric Dubé had uploaded. Michelle,
you said the ISS goes around the Earth every 90
dude,
minutes?
that's the claim. She literally said she has friends in space, and they go around. It's one revolution every 90 minutes of the planet of Earth. So my thing is, I need to, and again, Electric, you talked about numbers. So take the cruising speed, or the cruising altitude, I should say, above the surface of Earth of the ISS. Right?
How far is the ISS? They say
cruising. That's the elevation. That's what I'm curious about. Because if we use that, and then we use pi, we're going to be able to figure out what the circumference is. And when we figure out what the circumference is, hold on a second. When we figure out the circumference we can take the circumference, divide it by 90 minutes, and figure out how fast this thing is going, because that's going to equate in centrifugal force, probably in the neighborhood of G's. And if you're telling me that astronauts are floating around in the ISS experience, oh no, the ISS isn't manned, is it? Is the ISS manned? Anyone know?
Yeah, there's supposedly people on it, yeah.
Okay, so if the ISS is manned, then that means that those people are experiencing G's, and you can't experience G's in free fall if you're traveling around the Earth in 90 minutes. That doesn't make any sense. Think about the speed that's required to travel around the entire circumference of the Earth in 90 minutes, and you're at an elevated plane, so your actual distance that you have to travel is even bigger than just the circumference of the Earth. You understand what I'm saying, boys?
Well, the circumference is quite easily worked out.
Few of the things are a little new to me, like G's. Like I'm not 100% sure what you mean by G's.
Like, so I'm talking about G-force, man. You know when pilots go fly?
No, I've heard of G-force.
Right, so I'm saying they go fly it, right? And if they screw up, they'll pass out, right? And the thing about it is they're under that constant load. And if you're not breathing, i.e. high pressure breathing into your head and then allowing it to come back down, you're going to pass out, right? So they literally have to constrict every time they experience these forces. Now we're going to lily pad and go to the ISS, and you're going to tell me that that thing is orbiting the Earth once every 90 minutes. So what is the speed of the ISS in order to achieve that 90-minute marker that you just claimed, Michelle?
Wow. Bro, they say that it's 227 miles above the Earth.
Yeah, 450k. Yep.
So if you were
I'm
that
gonna
far
have
away from the
breakfast.
Earth, it would
Yeah,
literally take you longer to go around it than if you were closer to it.
Exactly, because if you increase your distance away from the ball, right, you're not
That just
increasing
means you
the
have to go
viewing.
around a bigger ball.
Hold on. You're
I'm
not
sorry. No,
increasing
I
the
got you.
viewing angle, right? You're actually increasing the distance away from it, and then you have to, the knee-jerk reaction, you have to increase the distance around it so that you can get the total. It's like a racetrack. Think about if I go around the inside of a racetrack and then I go to the outside of the racetrack and try to go around the same way. It's going to take longer, right? Circumnavigation.
So yeah, you wanted to do the thing where we determine the distance based on 90 miles, 90. What was it? 90 minutes a day. What is it? I'm sorry.
It's 90 minutes. Basically, it's 90 minutes every 24 hours. So all I need to know is what the distance is. So that total, it would be the circumference of a circle, right, at that elevated altitude. And then we'll take that distance and divide it by 90 minutes to reveal what the speed is of this ISS. How fast is it actually?
Okay, how fast is the ISS moving?
That's what we're trying to figure out.
17,500 kilometers an hour. Thereabouts.
It's moving at 17,500 miles per hour.
No, I think it's kilometers an hour.
It shows me both 17,500 miles, 28,000 kilometers per hour.
There you go. Yep. So yeah.
So then how does that correlate? What is the force of a G?
Gotcha. .8 meters a second is 1 G towards the Earth. That's gravity, apparently. Wait, no, let me look into it. Wait, what was the question? What is G? What is 1 G? Yeah, 9.8 meters a second. That's a G. That's a G force. That's one.
Okay, 9.8 meters. Thank you for doing that. 9.8 meters per second. So the question is, what is the total distance that the circumference of the Earth again?
Well, because the ISS is where it is.
Yep.
Okay.
Cruising altitude.
Yeah, at the 450 kilometers above the surface.
Right.
It says that its gravitational pull is only 0.89 of a G.
Okay, so the gravitational
Earth's circumference
pull
is. Sorry.
Yeah.
Earth's circumference is 25,000 miles.
Hold on. 25,000. Hold on a second.
25,000 miles. Okay, you're gonna add 223 miles to that, and then 2.8 meters a second. So you want to do. What do you? No, 9.8 meters a second.
Okay, so
That's 1 G.
Flip the miles to kilometers.
Sure.
I'm in front of my computer now. That's why I started voice. I'm making
I
breakfast.
don't have all that up, so you got this right now.
Well, if you flip the meters, if you flip the miles to kilometers, and then you take the kilometers and convert that to meters.
40,000 kilometers for.
Okay,
Earth.
and then so to go to meters, we have to add on what 3 zeros, don't we? Kilometer to down to a meter is 3 zeros, 1,000 to 1.
Yeah.
Right?
Okay, go for it. Yeah.
And then we take that overall big ass number and we divide that number by 9.8 because they're saying the oh no, the gravitational force is different.
No,
You would
no,
have
no,
to.
no. It's different. It's different. So you've got
You're
to
right.
take into consideration what the gravitational force is.
At that point.
450. Yeah. So they're saying gravity is 0.89 of a G. Okay. So
0.89 of a G per meter.
well, it's just saying 0.89. So
How many meters are there in 223 miles? That's what you want to know.
You have to
and then you could times that by 9.8.
There.
What's 223 miles?
How many meters? There is 450,000 meters in 280 odd miles.
One more time, bro.
I think it's 450,000. Because 450 kilometers. 450 kilometers. There's 1,000 kilometers in each. 1,000 meters in each kilometer. So that's 1,000 by 450, which is
358,883 meters. So that divided by 9.8 would be the amount of G.
But
that have being 223
electric.
miles.
Hold on. No. Exactly.
No, it's not.
Yeah.
Sorry.
Bansaw's got it. Electric. So here's the thing. You're that 9.8 is what apparently we experience here on the plane, right? But what Bansaw did for us, he checked what the gravitational pull would be at the point of where the ISS would be experiencing it. So at that point, we're just trying to figure it out at that rate, it's a really good observation because again, gravity is way different apparently out there than it is here. If it exists.
Yeah, you've got to play with their numbers, unfortunately.
So really now it then becomes a question of what is the speed of the ISS? So is that a question we
I
can
had
ask?
that pulled up 2 seconds ago.
Oh, sorry. So what's the speed of the ISS? Sorry, dude.
I got you. 17,500. No, 28,000 kilometers an hour. 28,000 kilometers an hour.
Okay, so by their math, 28,000 kilometers per hour. So 28 is 28, and then half of 28 would be 14. 28 plus 14 is 52. So they're saying that this thing travels 52,000 kilometers in an hour in 92 minutes, based on that speed.
How many Jesus? Like, shouldn't this shit be ripping your head off?
It doesn't make any sense. And the entire time, it's avoiding space debris. Like the James Webb Telescope is apparently fine after colliding with space debris, but the ISS is chilling while it's cruising at these crazy speeds. But if you hit a bolt cruising at that speed, I think it would be game over, wouldn't it be? Like that would create a pinhole and.
Yeah, it would be similar to an atom bomb, right?
Would think so. I don't know.
Well, the ISS did get a hole in it, and the astronaut stuck his thumb in it and then put a bit of gaffer tape over it. True story.
Firing two things at each other at extreme speeds.
True story, apparently. But apparently, because of the gravitational pull towards Earth and the accelerated force outwards, they cancel each other out. So it's considered a pseudo force, and there is no G forces in the ISS. That's pretty much what it says here.
Now, where's that fucking sound? That
yeah.
What the fuck? So now G-force isn't real. How nice. How convenient for the space station.
Okay. All right. So the full story for them then, here's what I understand. When the astronauts are in the space shuttle leaving Earth, they experience insane amounts of gravitational forces, apparently. Once they get to space, they're in a free form floating atmosphere, and the ISS literally creates its own environment within itself, much like you cruising in a car here on Earth. And it's able to navigate the entire circumference of the Earth from an elevated altitude in 90 minutes. Those are the facts that they're telling us.
Yeah, the circumference of Earth is Get that up again real quick. Sorry,
20,
25,
crashing
40,000 kilometers. So, you know, go ahead, throw 223 miles on that. And then how fast it's moving. Yeah, I understand why you just broke all this down, man. The ISS is a ridiculous notion.
No, I mean, more than anything else, boys, thank you for walking through it with me, because there's been a lot of times I've thrown out ideas and we've, or not we, but friends and I have rationalized things back down to realize that we're, you know, is the microcosm view. You can be talking about the details when you realize the bigger picture, it actually does work. But I don't see how this theory of the ISS unpacks to such perfect observation that they're able to send back pictures of this peaceful blue ball. It makes no sense. There's too many holes to it.
I agree.
So what do you think's up there?
I don't think I don't think any man has been beyond where the Go Fast rocket collided with something. Operation Dominic, Operation Fishbowl, they were testing something up there. And then we've had enough evidence of stuff being launched. I think the Falcon Tesla operation was one of them, that show evidence of something, it colliding with something up there, and it providing, again, almost like a wake pattern of a boat on the ocean, right, where it has that sea foam that you notice.
Yeah. Look like
Weird,
it's going
right?
super fluid or something.
Yeah, and again, we started unpacking yesterday here on the show. The theory about this ceiling being comprised of plasma, right? And again, I'm definitely with the idea that it is some form of a giving. When I say giving, i.e., it's able to receive energy. But it's not catastrophic when it receives that energy, because it receives it. It doesn't like end it.
Does this sound crazy? What is this waters above, waters below shit? I feel like I heard.
That's where we're at, dude.
Yeah.
Right? A simplistic explanation of plasma. If I wanted, and again, here's where I am. I'm going to put on my thinking hat. If I wanted to describe a hard structure, right, that was still giving, i.e., I could crash into it and it wouldn't kill me, that would be a brick wall that was buffered with something, right? Like a jelly, perhaps, again, or plasma, whatever. So that if I much like a baseball glove, if I were to throw the baseball at it, it's able to catch it and receive the energy coming to it without it being catastrophic and blowing a hole into it, if that makes sense.
Wow.
So yeah. 7 up, 7 heavens, right? Each of those heavens potentially containing one refractory image being a planet. Mars being the first one, Venus being the second, all the way up to Jupiter at the very top. That's my theory, boy.
Wow. Well, I'm smoked to that. This is something that I never even tried to think about.
So that light in the sky that you see, right, which is very, very predictable, right? If you pull up the little tracker, okay, the ISS tracker, and you can generally find, a time where you can view it. Okay, everyone pretty much gets to view it at some stage, and it's pretty damn accurate. So, what do you think that light is that we're seeing? That is very, very predictable, and has been for many a year.
What are you referring to? The ISS, or are you referring to
The ISS, not the ISS.
Yeah, dude. The question of what are we actually seeing, and the
Yes.
pictures and all that that phenomena, I don't know.
No.
Okay.
I'm what we see with our own eyes here on Earth. When we look up, when I log on to the ISS tracker, and it says, okay, then tomorrow night at 10 to 11 at about 20 degrees in the sky, southeast, if I look there, I'm going to see this light swooshing across the sky. Everyone can get to see this, right? It is done by millions of people, and that has been around. Well, this light has been up in the sky for years, absolute years, right? Where they've had this tracker on it, where you can track it. So, what do you think that light is that we're looking at? That has been tracked.
So here's the thing: the ISS has been pictured in front of the moon, right?
Yes. Yep.
So, and the moon has been using a sextant with Pythagoras theorem, right? SOHCAHTOA. You're able to extract the diameter of the moon being 51 kilometers, diameter of the sun being 51 kilometers. So that tells me that the ISS is local to us.
Yep.
Right, if it's in front of the moon. So if I'm saying that the moon is an apparent 51 kilometers in diameter and the ISS is being pictured in front of it, and the ISS appears to be microscopic in relationship, because that's the pictures I've seen, we have a problem on our hands, boys. Right? I'm also going to tell you that the same people showed us planes crashing into a fucking building. Excuse me for cussing. So am I going to fully believe on something that I can't put my hands on? No, but I can understand the theories of the creation, i.e. there's a roof and the luminaries are located within that roof.
Where are these photos of the ISS in front of the moon? Can I see this? I'm about to try to look this up.
There's heaps. Just type into Google transit of ISS in front of moon and click images. There's heaps of them.
Gotcha. I will right now.
Yeah.
Transit of ISS in front of the moon.
The thing that didn't make any sense to me when I saw the pictures of it in front of the moon is, if you look at the actual ISS itself, it doesn't change its planar, I think that's the term, planar orbit, i.e. it always appears to be in the exact same orientation when we see it, right? Like the wings, the panels of it all stay the same angle. They don't appear to go obtuse and change. So I'm like, is somebody just putting a little black thing in front and just moving it around? Because it could be just a 2D object in front of that image of the moon being moved around, right?
Well, I would actually like to see with my own eyes, whether that's through a telescope or a zoom camera or something, the ISS actually transiting in front of the moon, because it seems to move pretty quickly in front of the moon. So you'd have to be pretty spot on with your clicking ability to get a clear photo. But having said that, there seem to be plenty of photos out there of it transiting the moon. So
I'm confused. I'm honestly confused by this video of the ISS. I just seen the video. So that's the only time it's going to pass in front of the moon? That's the only time? It doesn't happen every fucking 90 minutes like this.
Oh no, not in front of the moon, because it changes. It's changing. It's always, I don't know, whatever orbit it's on. If you look at the tracking app, when it passes over me, I might not get to see it again passing in a good location for another 4 or 5 months type of thing. Generally, it's too low in the sky for me to see where I am.
No. That doesn't have to be a space station. That could be anything.
Yeah.
It's the again, the size of the ISS in relation to an actual like commercial 747 or whatever. I looked at the two sizes. Apparently they're like roughly the same. Like the wingspan of a 747 with relation to the ISS is pretty close. I don't know. It's semantics, to small details to try to compare the two of them with relationship to the comparison of the moon. But the idea of the fact that it's been pictured in front of the moon tells me that it's local to us, right? Because the moon is local to us. It's like I see a cloud in front of the moon.
Right.
Here we go. Mark Taylor's just posted one in chat. I think it's Mark TVT.
And of course, Bill Nye the Science Guy is stating, humans need to understand that we live in a closed system and you cannot leave it. Brr.
Oh, there we go. There we go. Boom. It does go pretty damn quick. Did you do that through a telescope? Did you, Mark? I presume it's Mark, but TVT. Because you must be listening on YouTube. But it's still pretty cool. So there's definitely something there. Boom. If you look at that little video that he
Yeah, that's the video, and I kept thinking to myself the entire time, why doesn't it change orientation? I watch an airplane change orientation. Why isn't the ISS changing orientation?
But would you see it changing orientation over such a short distance? Like, we're only talking the width of the moon here. Would you actually see it changing?
I don't know. I know that microscopic movements over large distances make very, very large impacts on your visual. Like you would notice. Let me think about this.
Yeah. Oh, I think there's definitely something up there. I do.
That's fair.
Because
I just don't think it's a space station with people on it. That's my problem.
Oh yeah, yep. A 6-inch reflector.
It could just be any random metal object or something that
yeah.
they just have thrusting around in the orbit.
Yeah. Yeah, that's cool.
There's have you guys ever I don't want to jump into a super duper stupid bag, but you ever hear of this thing called the Dark Knight? It's just some object that they detect randomly, and then we don't know what it is. This thing just fucking appears in the sky sometimes. And they call it the Dark Knight. It literally looks like a black mask. It's the weirdest thing ever. It's like a tiki mask.
I've never heard of that, but I just thought of something. What if the ISS is just a highly sophisticated weather balloon?
Yeah, I don't see why not. Man, there's a little video I watched where somebody explained that every satellite that gets launched has to have thrusters and fuel cells, and that just struck such a bad chord with me. If it's not true that a satellite doesn't use it doesn't stay in the orbit based on gravity, and actually needs to be thrusting around to appear it's in this orbit. Every single satellite has thrusters. Well, what are you going to do with that information? I'm fucking. There isn't a point in the air where you can launch something and it's just going to start floating around. That's what I'm saying. Anything up there needs to be launched. But the way I talk about this stuff, you could tell I'm not fucking looking. I'm not looking at any articles right now. I'm just thinking about it.
That thing moves so damn quickly. So damn quickly. That's crazy.
Yeah, and apparently it would have to be falling along some geodesic lines, right? Wouldn't it be having to fall on a geodesic line? Is that crazy?
Mr. B, here we go.
I gotta look up the Lagrange point shit again. Something's floating out of Lagrange point. I don't know what it is.
But heaps of people have taken.
Oh, the James Webb Telescope. That's what's at Lagrange point.
Heaps of people have taken footage. I think even from memory, I think even Jeranism has taken some footage of the ISS transiting and stuff. If my memory serves me correctly. So yeah, there's definitely something up there. No one can deny that. But yeah, what's in it? Yeah, who knows? bunch of monkeys, probably.
What are they using to transmit data back and forth?
Or they just use, I don't know, radios, wouldn't they?
All right, so you got an object moving at, like, what do they say? 24,000. It was 40,000 kilometers a mile at an hour. And it's going in circles around the Earth. And a radio signal has to be sent in a straight line to a point on Earth that's supposedly spinning and rotating. Are we getting a consistent signal from these motherfuckers, or is there interruptions?
But I think they would have a network of aerials set up everywhere to communicate with it.
Okay, so there's other satellites helping triangulate like signals.
No, I'm just saying there'd be other receivers on Earth that they would use to receive the signal. So
With no
I got
no
you.
visual space debris at all, though. We haven't seen any other space debris beside the ISS.
Huh.
The other thing I want to outline is
where's all the people that believe in the ISS right now?
not
maybe TVT will come in. Be pretty cool. We're pretty
I
chill.
want to hear what they think about this stuff.
If he can come in, we're pretty chilled tonight. Look,
Yeah, I'm obviously new to all this, so I'm not gonna act like I know more than somebody else. Plus, half the information we have to get from them is from them, so that's what we're doing.
I don't think you get too far with being too adversarial, really, Electric. Yeah, maybe, they've got technology and they've got something up there. Like, it's not beyond the realms of belief to think that there is something up there very, very high that, perhaps people are going to and coming from. I don't really actually think that's out of the realms. Now, I don't believe, the NASA footage and green screens and all that sort of stuff. Like, I don't believe any of that. Well, a lot of it, I don't, because it all looks pretty, dodgy. But that's just my opinion on that. But I think it is quite reasonable to think that they do have technology that is up there and can stay up there for extended periods of time. That's what I think UFOs are. I don't think UFOs come from outer space. I think they're here. I think they're land-based stuff. They're our technology that they're testing right before our very eyes.
Wow. And he brought up something about. Yeah, he brought up something about fuck.
Doesn't extraterrestrial mean more land?
Yeah.
Yes, it does.
And if we're in a closed system, wouldn't it mean that there's no outside visitors capable of coming inside? Because if we can't leave the roof, how come they can get into the roof?
Well, their closed system is gravity, right? So
I was talking about the Martians or the aliens, whatever.
yeah. But if what they call a closed system is just a closed system via gravity, of course Martians can come in and go. Well, apparently we can go and come back.
Yeah, they suggest that there's like these these objects that can enter our line, like our site. We can make observations of spaceships like entering from other galaxies. Like, what? That's really what they peddle with this UFO shit.
And that's where, like, the aspect of like Lemuria, I fully think Lemuria is a place. I actually think that it's on the same plane that we're on.
Yeah, I think
think
that's what New Zealandia is. I feel like
Yeah.
they're just gonna say that this continent is rising out of the ocean. We got to slowly add it to our maps.
But what if? Okay, hold on, Electric though. What if that plateau that you're talking about is actually on the other side of the coin, and we're just on the other side of the coin?
Oh, you think that it's actually shaped like a coin?
What if we're on a coin? We're on the upper side of the coin, and the black hole Earth is lighting the other side of the coin on the other side, the underside.
I have to really understand what you're saying.
So you remember Black Hole Sun, the song?
Of course, but I don't remember the lyrics.
You don't have to.
Black
Just
hole sun, won't you come wash away?
No. It's just the concept of a black hole sun, right? Imagine, again, we are talking about aliens, so I think we're totally in the realm of we can speculate right now. You have a coin, right? We're on the top side of that coin right now, right? On the underside of that coin, don't think about how you can live upside down. We're not going to go there, right? We're just going to paint the concept of two sides of the same coin. On the underside of that coin, so the other side of that coin, the head plane, if you will, that plane, we're on the tails side of the coin. Now on the head side of the coin, the other side of the coin, that's where Lemuria is, as an example. And that's where the black hole sun lights the land. And it's always daylight there. Because again, sleep is the cousin of death. There's no death in what we would call heaven, right?
Bro, I'm so sorry. I got distracted because I had to answer a text.
Don't worry, it's all good.
So let me just tell you what I'm thinking right now, so you could just help me out. The other side of the coin. You said that. So let me get this right. The heads and tails. Do you think that America is heads and that Lemuria is tails? Like literally on the other side of the
Yeah, so think of all the continents and the landforms that we know of, right?
Okay.
They're all on the heads side of the coin. The head side, okay? So you look at the coin, that's the head side, and on the head side, you've got all your 7 continents, the known continents shown, right? But there's a hole in that coin, and that hole leads to the flip side of that coin. So you flip the coin over if you want to, or just imagine we're looking at the tail side of that coin, right? You got me?
Yes.
Cool. Just checking. So then on the
I know. I'm
underside,
sorry. This person is still texting me right now. I can't.
no, it's okay. I'm just making sure that we're walking together like step by step. You
Sorry
get
about that. No, I'm done
No, it's
talking.
okay, dude. Don't worry, man. It's all good. It's just a conversation. It's Sunday morning, man. It's coffee and breakfast, and ain't no place to go.
Damn, you just get me hungry. Fuck.
So on the underside of that coin, you have the black hole sun, and that sun lights the underside of that coin, so to speak. So you got your Lemuria.
When you say black hole sun, I'm sorry, but 5 different things pop into my head, and they are all different models of what could represent.
Talk about it, dude.
Black hole sun. I'm thinking of Rahu. You hear this?
Keep talking.
You know who you hear this Rahu character before?
I've heard of it.
Okay, so you think that the other side of the coin, Rahu, is the sun over there? My bad. I'm so fucking.
No, dude. You're doing a great job because you introduced the aspect, right, of a secondary sun. Right? Now, again, I'm not saying that the secondary sun is in fact the secondary sun. I'm saying that there is in fact an original sun. And I believe that we see the sun and the moon as replications of the original black hole sun. So because of the roof that we have, this firmament, the firmament allows the creation of the luminaries, as in refracted. No, not refracted. I don't even bring that stupid word in anymore. It's becoming too commonplace now. But the luminaries are able to take appearance in the moon in the firmament, the roof to the system that we're in, right? But through like reflections and all that crazy stuff, everything is created off of that original sun, which is located at the black hole. Like the aurora gas, the northern lights that we see. know what I'm talking about? So
Yeah, I'm listening.
the northern lights that we see, those would be the illuminated gases, the essence of that light going up to Polaris and then creating the sensation of the moon and the sun, or the luminaries of the moon and the sun. But I'm just coming back to the fact that I believe that we are in a completely closed system when we can't leave. I think everything is literally within this exact realm. I don't think there's anything like worlds beyond that. I think it's one central spot, and everything's located on that
I'm
one
actually
platform.
so mad that this person's like blowing me up right now. I'm way more interested in what you're saying. Fucking hell. This person just made me miss like half of what you said, bro.
It's all good. I'll throw I'm going to throw in a picture in the live stream just to give a little bit of proof to the pudding. And again, gentlemen, this is all based off of my my theory that the moon is the reflection of our plane.
Yeah, I come to realize that I'm like a visual learner, I guess. There's like 3 ways to learn. You know, you could hear, you could be hands-on, or you could watch or something like that, right? And if I could see the model, then I can understand it. But I understand the 2 sides of the coin, and the sun underneath us reflecting things above us. That makes a lot of sense, man. I get it. I'm still kind of lost on your model. Not your fault. It's my fault. It's my fault because this person is hitting me up too much.
Yeah, it's no stress, man. It's no worries, man. Check the live stream. That's my thought.
Check the live stream.
Yeah, the live stream text.
Oh, so this is the... Okay, look at that. So on the other side would be... Oh.
Will you see where that red arrow is at the bottom? The axis point with that red arrow?
Yeah.
That would be where the black hole sun is. So that black hole sun rotates on the underside, and then it reflects in the firmament, the dome, that blue line you see, and it creates one thing that we see as either the sun or the moon.
What is this I'm looking at? The sun is projecting to the outside of the circle?
Yeah. So that circle thing, that's the firmament. That's the
So what's the bigger circle on the firmament? What's that?
The blue circle?
There's if there's a firmament and the sun is there a reflection on the firmament to represent the sun?
Yeah. That's what I'm saying.
So
depending
would
on
that be
where
the sun?
you
So we
are,
don't actually see the sun where it is.
what I'm saying is, remember, the aspect of visualization has to do with the person visualizing it. And that's why if you zoom in on the plane, that blue plane
Oh my
circle.
God, bro. It just hit me. No, now I get it. No, now
Right.
it hit.
Yeah.
Okay, so basically we can't see what's behind the sun.
No, because how can you see you can't see the other side of your ceiling, can you?
Of course
Look at
not.
your ceiling.
Right. No, that makes sense. I get it. I think I get
that's
it.
why the image of what we see in the moon, right? It only opens and closes like an eye, right? That's the only action it does. But the actual image, wherever you are and you see the moon, the actual image of what's looking back at you never changes. Australia
You would
is
say
always.
that the sun is a sphere.
Pardon me?
Do you think the sun is a sphere?
Yeah. Well, I believe that the sun represents as a sphere because it's so bright, but it's still a planar object. Look,
Okay. So the light being created appears as a sphere, but whatever object inside is creating it doesn't have to be.
Remember, reflections, right? Reflections will always appear to have three dimensions. The only reason we know that they aren't 3D is because of the fact that we know it's being reflected in a surface. So if I told you that the sun,
my bad, go ahead.
It's okay. If I told you that the sun and the moon were reflections, then your brain would be able to unpack the idea that they're actually appearing as reflections, right? That's why in some instances, and I've had some people counteract this argument, but in a lot of instances, you'll see the sun appearing to be oblong, oblate, like it gets longer or it gets fatter. But that could also be due to the refraction that is, or not the refraction, but the disturbances that are present in the atmosphere of you seeing the sun, like the visual disturbances of, you know, the atmosphere, whatever. So you can go one or either way. However, I still lean into the idea that the sun and the moon are reflections of the main sun.
Really?
Yeah, I do.
Yeah, I can't go there.
No,
I can't go. Yeah, no, I can't go there.
no stress, dude. That's
No. Yeah, I've heard it. I just can't wrap my head around it being a reflection. To be quite honest with you, it just seems too consistent. And a reflection from where? From where is the reflection coming from? Like down here, and of what? Like,
the one thing I will say in terms of reflection is, again, we mentioned earlier the waters and the land being created, right? And we do know that water does carry a reflective surface, a reflective element to it. Like water does, in fact, reflect, right? So the aspect of like plasma, because plasma is obviously like water, like obviously there's some like water substance to it, and then we have this evidence of the planets looking like some kind of a colored colored watery type of appearance, right? It has that shimmery look to it.
Yes, when it's out of focus, of course, yes.
oh,
Out of focus.
Jose,
Okay.
there you go.
Again, so there's certain observations that do lead to some water being involved in our ceiling, and all over the place.
Yeah, but if you're talking about a reflection, though, right, you know, this reflection has to be consistent. Now, the surface that is doing the reflecting doesn't seem consistent.
Okay,
if
but
it's coming here from Earth, from the waters here, well, the waters are always moving. They're never
Exactly.
consistent.
Yes.
Right, so you don't get this consistency. But when you look at the sun or the moon, everything is very, very consistent. It doesn't change at all. You look at the sun, you can look with your own eyes at the moon, and you can see marks on the moon night in, night out that never change one little bit, and have been there since Adam was knee high to a grasshopper. It's never changed. So this is why I can't get my head around it, and I can't go with it being a reflection, because there's just too much
Well, I
dynamic
can.
activity.
Can I say
going.
something to
Too much
that?
of a cool
Yeah,
story.
I would like to add, like, okay, so I remember what was suggested, like maybe it was a while ago, that plasma is actually what's causing this reflective type water or something, right? I don't know what the fuck somebody
yes,
said. It
remember,
was so much. It was so
remember,
dense. Though. I don't know.
remember how plasma presents. Plasma presents as a jelly, right? There's definitely a watery essence to plasma. Now, the thing about reflections is, and I appreciate what Bansaw is saying with the idea of the observation of the sun and the moon being intense.
Well, intense, and also
We start with that.
Oh, you broke up there. I thought you paused there, King.
Yeah, no, I was getting my daughter's calling, so I'll call her back in a second. The thing I want to outline, and then I'll go to the call, is that the only thing that I believe will affect that is intensity. What if the light of the sun and the moon was an aspect of intensity? We literally wouldn't be able to tell that it's a reflection, because the intensity of the light was so huge. What do you think, Bansaw?
I just think
Oh my god! It just hit me.
that
Yo, I get it. Yo, I fucking get it. No, wait, he's right, bro. Because you can have something creating a light source, and like the dome or whatever you want to call it, that's like plasma, can literally like ignite the fucking light and make it like a magnifying glass on an ant. It's like the same fucking thing.
Yeah, when you see a cause and effect relationship, the luminaries that we see, the phenomena that we observe of the luminaries, and you guys are talking about the sun and the moon, those are still effects that are being caused and we can observe those effects in the medium above. How many layers of the mediums above our heads there are? We probably don't know how many layers, but the things he mentioned the planets, right? And when you look at the wandering stars, and they're always in relation to the sun and the moon, and it's like it's layers from where the light is going through in the layers above. So they're always depending on the angle of the light that is going through. So, and you also mentioned our reflection, but the image that we see of the moon doesn't necessarily has to be an image of the earth or anything like that. It could be the image of maybe the source above or on one of the layers that we are seeing an image of it in one of the layers that is, I guess, the
I mean, can I just say something to that? Like the light source
yeah.
could literally be projecting through this layer of plasma and actually helping terraform the fucking land under it. Like, why the fuck not? Like, why
Well, that's
can't
the
these
input into the
stargazers just be
system.
fucking carving and terraforming the fucking shit under it? Why?
Now,
Yeah,
again,
in this
remember, boys,
system.
we're operating in a gas-filled environment, right?
Yeah,
And
it's
if we're
just
in a
piercing through
closed,
all these layers of.
gas-filled, hold on a second, hold on, and I'm going to tell
Yeah,
you
I'll mute up.
why my theory makes so much sense. If we're in a gas-filled environment, the luminaries are only taking advantage of the gases in the environment to do what they need to do, i.e. provide light, provide heat, provide cooling, and those things, right? So it's something to think about, that the luminaries are taking advantage of the gases.
Is there anything with substance of what you guys talk about, or this is kind of just the
What do
cool
you mean
stories that
anything?
you are spreading around? This is
No,
all
flip flop.
this is
No.
all I hear is the what if, might be, could have been, I believe. It's all I hear. I mean, is there anything with substance that I can actually learn a bit?
I feel like you
Listen,
just
I'm
go
okay
into
with the stories.
looking
I'm
for
okay with the
information,
stories
or
that
are
I'm
you
listening to,
speculating
but I'm
with?
just
This
would
isn't
like to
fair.
learn. I'm just asking, is there anything with substance here? Thank you.
Okay, can you stop asking?
No, you can't drink this and be happy with it. You know, you
Hold
cannot
on.
drink it, bro. It's not something
Nah,
you can drink or
just slow
enjoy
down.
like that. No.
Just slow down. You guys must have missed a lot of the conversation. Me and him had based this Sunday coffee off of fucking bullshit. So don't be mad if you don't subscribe.
Seriously.
It's not about that.
If you walk into a conversation and you seriously get offended by the topic of the conversation, you should really reassess.
He wasn't
I'm
just
just
I feel like
that.
I just
I'm okay
realized
with the
something
stories that
amazing.
you guys are
If y'all
talking
didn't
to each
catch
other.
it, I feel
I'm okay
bad
with that.
because I feel like I
I'm
just
cool with
caught
that.
something. I caught something he was getting at, and if you guys didn't catch that, then I feel bad for you because I just had an amazing realization. I'm gonna go get a coffee because that was cool.
Electric, you and I will connect later, and Gem Z knows exactly what I'm hitting at, so it's all good. Bandsaw, you've been an amazing human. I'm not too sure what's up with our guy Flip Flop, but it's cool.
Yeah, you're cool, King.
I'm still here.
No,
I just need to get a coffee.
it's good to chew the fat over these things. Like I said, it's just me getting my head around or kind of accepting the whole reflection thing. Yeah, I can't really get there. I just see too many other anomalies that
No, and Bandsaw, you know what? It's not a matter of even. I appreciate the fact of you talking down the reflection, because we can get into a space where you meet yes men. They say yes to everything you say, right? So if somebody can't wrap their head around an idea that you're presenting, that just tells me we need to work on presenting the idea better. Because again, with the observation of us being in a closed system and it being filled with gas, because I can wave my hands around it, I can breathe it, I can feel it, that lends itself to the other physical observations that we can see and what gas does. So if I provide an ignition, if I provide an ignition source for that gas, i.e. the luminaries, the sun and the moon, then it's interesting that I can read a book behind the shade of a building, right? That means is not performing like the headlights on a car. It is performing like the light in a room, which means it's working on a gas principle,
I
not
literally gotta give this dude King's Clown like the biggest props ever. This dude just blew my mind in a way that I can't even fucking talk about right now. I'm not even gonna try to tell you guys what I'm thinking about.
Electric. You know it's Kiwi, right? You know it's Kiwi, right, Electric?
You're who? Kiwi? I
Kiwi
feel
from
like we talked
24/7.
before. Yeah, we've had good
Yeah, it's
convos.
Kiwi.
What's up, bro?
Yeah, and Kings, when it comes to the whole reflection talk, I could accept it more or get my head around it more if you were just talking about the sun. But when you're talking about the sun and the moon, all right.
Do you want to hear
the
an idiot
moon-
trying to explain it?
well, yeah, hold on. Yeah, 2 seconds, but I'll just finish my thought and then you can go for it. When it comes to the moon being so consistent and so clear, right, with all its, little dots and crevices and stuff on it that never change, you never see any difference in them whatsoever. Then if you're talking about the moon being a reflection, not a chance in hell can I get my head around that, because it just looks too consistent. Whereas the sun, on the other hand, I could accept the whole reflection thing more with just the sun. But when you're talking the sun and the moon, yeah, no.
Okay, now here's a mind-blowing thought for you. What if,
Yep.
okay, what if, and again, they say once you see something, you can't unsee it. What if the moon was actually performing like a spotlight? The moon was, and I'm talking about full moon pour, right? So you got the full moon in the sky. What if and I'm the stage director, I'm shining a spotlight on the exact spot in the firmament that shows the information I need to see? What if?
Cool story, bro.
So what? The moon is the source of the light.
Okay, hold on a second here. Flop, my guy.
No,
listen,
no. The
if
moon
I'm-
is not the source of the light.
Hold on a second here. If I'm going to make a statement or an observation and say, how about that? And then you're going to do a knee-jerk reaction and cancel out my observation by saying, cool story. I don't need to hear your cool story statements, my friend.
I mean,
Thanks for coming out.
I'm invited here by
That's
Gio.
color.
So
That's color
what are you gonna
commentary.
do?
That's just color commentary.
I like colorful commentaries. I'm a troll. I troll
Yeah.
responsibly, right? I didn't interrupt you. I waited for you to end your statement, right? And if you want to interrupt me, I take it because I'm a little bit trolly. But when Banzo is talking, I mean, it's not necessary to interrupt him or whatever. I can deal with you. But what can you do? Are you gonna server mute me, or are you gonna personally mute me, or maybe lower me down to 10%? You gotta take it, bro. I was invited here, so we can have a diverse and an entertaining conversation. I'm gonna be the contrarian, and the contrarian is I base everything in reality. That's my contrarianism.
All right.
Okay,
so maybe you're in the wrong place.
Let's start again. Hey, Jose, be the contrarian. I've got no problems with that, buddy, but it's supposed to be a non-trolling channel too.
It is. I asked specifically the first day. I said, I troll. I like trolling. I say, hey, as long as you you're respectful and you keep, you follow the rules, I'm okay.
Dude, can we get back to what the fuck we were talking about, please?
Yeah, the thing is that the thing is that Jose, he trolled himself. He just doesn't know it.
Here's the thing.
Go ahead.
Anytime somebody makes a statement that's what's called a space creating statement or observation, there's what's called onboarding. The person that you're talking to takes the time to onboard what you're saying. If you react to what I'm making a statement within a debate, an observation, or whatever, your reaction statement to what I've presented is cool story, that tells me I'm wasting my time.
So,
and if you think you're wasting your time, I mean, then you're taking it too hard. You're taking it personally, man. You continue with your belief, and you do you, man.
So, with the notion of the moon being the spotlight, King. So then, how does then the sun seem to be so much more powerful than the source?
So what we have seen is that sunlight does in fact report to be like there's a varying in direct sunlight versus shaded sunlight. There's a degree temperature, right? Now, what's interesting is the moon, the exact same observation happens, but in the flip. The moonlight is colder and the shaded moonlight is actually slightly warmer. So the
100% lie. That's a lie.
Wow.
That's a lie. That's a lie. Tests have been done by dozens of people, probably hundreds of people. I have done that test. I'm sorry, I was talking. You interrupted me. And the moonlight
I'm
is
going to
just not
interrupt you,
colder.
bro, because this is ridiculous.
It's just a lie. It's just a lie.
That's fine. I can pull in my friend's eyes to see from my other board, and he can back up my statement because I just learned this from him 3 days ago because I was pondering it for the last 2 weeks.
I heard this 6 years ago, and for 6 years I still looking for a valid test that the moonlight is colder, and there is not. Everything points to the way it should be. The moon reflects the light of the sun, and there's nothing colder about the moonlight. Boom.
No, I didn't, sir. My friend, I didn't suggest that the moon was reflecting the sun's light. I was noting the observation that the sun is hotter in direct light, and the moon is colder in direct light. There was no mention
It is
about
not colder. It's not colder, man.
There was no mention about the moon reflecting the sun's light. Now, my question to
That's
you,
the truth,
if
you know.
you're
And the moon
going
is
to
not colder,
engage in
definitely.
debate, my question to you, Flip Flop, is that do you think that the sun projects its light, or do you think it illuminates its light?
The sun is a star, a big, massive ball of plasma that we see. That's it. Well, I don't understand your question.
Does the sun project its light, or does it illuminate its light?
I don't understand what you say projects or illuminates. The sun just emanates the
So,
light.
if I take a book into the shade of a building, what light is allowing me to read that book? Is it the projected light of the sun, or is it the illuminated essence of the sun that allows me to read the book? Wow.
The clarity of the day. I mean, we got right now. I'm sitting in the shade, and I got it's all clarity over here. It's all clear. Why? Because everything is bright around me, and everything, and we get all this brightness around me.
Okay, so are you conceding that you can still read your book in the shade on a cloudy day?
I can read a book in a shade. I can read a book in the dark, bro. If
Okay,
I just keep my eyes closed for 24
I'm
hours
not
and then
asking
open it
about
in the
the
darkness.
situation of you being able to read the book in the dark. I'm asking if you can read your book in the shade of a building. Yes or no?
I mean, that's a silly question. Everybody knows that the answer is yes.
Okay, so if the sun was projecting its light onto the surface of the earth, and I block the sunlight out with clouds or a building, why can I still read my book in the shadow of a building?
If you're thinking the sun is a light beam just following you specifically and forgetting the other billions of people, then you are correct. If you block the sun, you wouldn't be able to see anything. But if you think like a normal, rational person that the sun is just emanating light, everything works perfect. I mean, there's no
So
science behind
my
it, man.
question to you
It's
then is,
clear,
what
bro.
is the medium that is presenting the light to me on the surface of the book that is allowing me to read the book, my friend? What is the medium?
Medium?
What is the medium? There has to be an engaging medium that allows me to get the light from the sun to the surface of the page. Is there not? There has to be a medium, a transferring medium there. Does it not have to be?
Yeah, a space between me and the book, between me and
So
the
what's in that
computer,
space?
between me and the
Space is
microphone.
considered a void. What is in that space that allows the medium to transfer into
What
of light?
void? There's no
If you're
void.
going to interrupt, the subject, and then you're going to gain the purview of the person that's engaged in the debate, and you want to interrupt.
There's no
Interrupt with
debate. It's a conversation. It's a discussion back and forth.
absolutely no points of observation. My point to you in saying that we're in a closed gas-filled system, and the illuminated gas is what allows you to read the book on the surface, to read the pages of the book. That is what does it. It's the
Is
gas
there any?
that illuminates, that allows you to read your book, not the projection of the light. So if you understand that the projection of light is not possible, that removes the aspect of us rotating around your magical sun.
There's no magic behind any of this. Now I got two
So you
points. You talk for a little bit, and I'm not going to be able to address anything of what you say. So give me a break. Give me 30 seconds, man. I'm wondering what are the parameters of this closed system, because I mean, humanity haven't progressed enough to go further enough to know the parameters of this closed system that you say that is just an isolated or whatever. Now, that's my first point. And the second point is that the space is not a void. You're just wrong there. Go ahead.
What the fuck did you just say? Now that we've engaged with you and you've realized that there's no, I don't see any proof of you or you providing anything really of substance to observe.
I mean, you're
Alexa,
telling me stories. You're just telling me stories, bro. I'm telling you the truth. I'm telling you the reality.
This guy came in and said, "I'm gonna be a troll and I'm gonna be
You
rude."
just
And I
told
don't
me
give a fuck.
you just told me that you were trying to observe light for 6 years and you made absolutely no progress. So thanks for
I
coming back.
didn't say that. No, I say for 6 years I tried to observe and acquire evidence for the moonlight being cold, and there is none of that.
Yeah, there is. You need to talk to the people that actually work in the field so that you can
I
understand it better.
I
Just
done
like
the
if I
test. A
wanted
lot
to
of
know
people
if
like
the
me
land.
have done
Hold
the
on a
test.
second.
If the
If
moon
I
was colder, I would have been able to already reach to that conclusion.
how do you measure? Anyways, you know what? Talk to the people
Can
that.
me and Kiwi break this out? I like what Kiwi's talking about. You want to deny? No. This can't happen. It's perfect. It works. Blah blah blah. Let's let the dude talk about what he's talking about without fucking magic.
Can I mock your voice too? Can I mock yours the way that you talk, Electric? I mean, green light, please.
Hey,
Please
you don't
mock
want
the
to
way
talk
I
about
talk.
anything,
Can I mock
bro.
the way he
You've been
talks?
talking
I
about
can do it. I
nothing
can
for
do
like
it a
10
lot
minutes.
better.
Talking about nothing for 10 minutes. Bro. Let Kiwi make a.
Come on, guys.
I just don't got patience for some type of shit that goes on.
Okay,
But
then.
anyway,
All right. Let's
I would like for more interesting topics to come from what Kiwi's talking about.
Where do you guys get the idea that the space is a void? Where do you guys get the idea that the space is a void?
Kiwi, you're trying to talk about something that you're presenting, and if you want to just talk about it, engaging in a debate is not gonna be the best way to do it, because Jose he's a debater and he's just gonna
I never
debate
debated in my
every
life.
point.
I have never debated in my life. I just like the
I mean,
discussions.
but you are a contrarian, and you're saying you're a contrarian. He's trying to present an idea, and you're just gonna pick every single point to move away from the point,
man.
from
It
whatever
keeps
he's
it
trying to bring.
entertaining. It keeps it fun and
Yeah.
entertaining, man.
Yeah, but he's
That's-
trying to
no,
present
that's
something,
boring.
and he's trying to
I
present
literally
something
almost
to
left
the
because
guys.
it was so freaking boring, dude. It was way better before you tried doing this shit. So
I
Kiwi's
mean, if you,
suggesting that.
you guys,
can we talk
please
about-
vote. Please vote.
Can we talk about the
Who
moonlight
wants me
for
to
a second?
live and who wants to stay in the
Can we talk
circle
about
jerk
the moonlight?
and patting each other in the back? Please vote. I need the voting. If not, I'm gonna stay. Unless if you
need
ever
it?
mute me, if you ever mute me, I guess that's the only way, you know. But I need a vote. Who want me to leave and who want me to stay? You guys want to stay in the circle jerk or you want me to leave? Please vote now.
Hold on a second.
No, hold on. Enough of the
Guys,
circle jerk
self-centered.
type of stuff. We were just having a cool conversation, right? And we want to continue just with that. Now, put some opposite ideas.
Perfect. Yeah. Enough of attacking me then, guys, and talk about the conversation. And if I got a point to make, I will make it, and you guys cannot shut me up.
Nobody's attacking you.
Okay, flip flop.
So moonlight, Kiwi. What is suggested creates this different type of light? Like, what are they saying?
Well, it's not a different type of light. It's just, again, so I was okay. Right at the very beginning, this was probably about, actually no, this was last week. There's a YouTube short that's uploaded where a guy observes a concrete slab in direct moonlight. And then, so he takes an infrared gun and he measures, I think the surface temperature of the concrete slab was like 50 degrees Fahrenheit. And that's in direct moonlight. Then he goes to the shaded part of the concrete slab and he measures the concrete slab and it's like 45 degrees Fahrenheit. So I'm like, wait a minute. That threw out my idea of direct moonlight being colder, right? Because again, 50 degrees in direct moonlight, 45 degrees in shaded moonlight. Now, again, I'm going to talk about concrete, which is an interesting measuring device because concrete has air inside of it. Concrete has approximately 5 to 8% air entrainment. So it has air pockets inside of it, which makes concrete a great insulator. So I thought to myself, I don't know if this is still reliable, but again, it speaks to the contravention of 50 versus 46. So then I brought up this point on Glatt Flobe. I don't know who's on there, who's not, but Glatt Flobe's discussion one night, and his friend Eyes to See, who was in the field, added in the fact that yes, direct moonlight is actually colder than shaded moonlight. So it's just the observation that the medium is the exact same, which is the gas. because we're in a gas-filled container, from our understanding, with a roof on top being the firmament, which is what the Creator created on the second day, stated in Scripture, right?
Can I
So when
interrupt
we have
you?
the gas,
Can I
it's in
interrupt you
the
real quick?
sure.
You said the shaded moonlight would mean that, okay, so like moonlight under a tree. Let's say that the shade is being created by a tree.
Exactly.
You're saying
Exactly.
that
Well, you
this
just
is
think of a
45 degrees. Hold on, let me ask him, bro.
Yeah.
You're saying this is 45 degrees?
Again, this was
And
they were measuring
the direct moonlight is 50 degrees.
again, right? He was measuring the surface of a concrete slab. So the concrete slab direct was showing 50 degrees Fahrenheit, and the shaded was showing 45. Right? So it was directly contravening my thought. It was the opposite, right? So I'm like, my theory didn't work. And I'm like, shit. So I threw that out. Then I had a discussion with Eyes to See. And he explained it to me. And he said, no, actually, the direct moonlight is actually colder. So the only thing I can think of is that this concrete that this guy was measuring was actually insulating the ground beneath it, potentially, and using, I don't know, maybe showing a different reading or something. But again, based on Eyes to See's testimony as a valid witness, because he works in the field, he stated that the direct moonlight is actually colder.
What's
So the
his
gas.
field? I'm
What
just curious.
field
What's his field? Yeah.
does he work in? What field does he work in?
I believe he works in meteorology. I will search him right now, and I will find out. Bear
Yeah,
with me.
no, it'd just be because I would actually like to see a
test, a test.
a
Yeah.
proper test, exactly
Yes,
right,
thank you.
where
No testimony is
all
kind of a little wishy-washy.
well, yeah, but like a proper test where anomalies, like you got on concrete and then you got underneath a tree, so you got all these other anomalies that can come into it. You've got the heat from the tree, you've got the shade from the tree, you've got all these other things. You need to have, say, a glass of water on a bench, and then another glass of water on a bench, and you shade one glass of water, right, and you have the other glass of water there. So you got to compare apples with apples. You can't compare an apple with a banana. It just won't stand up.
Okay, so here's the thing. He is engaged in the flat Earth debate and all these things, and he's stated that he has unpacked this 50 different ways from Sunday. So again, I'm gonna find out what he went through and everything else. But again, based on my questioning of him, I was comfortable enough to come forward in this forum and present what he found as his findings, right? So again, me questioning, and again, I'm going to for sure, but realize that when you come to questioning professionals, again, I work in the field of architecture and I work with surveyors all the time. Like these are questions and coffee talk, water cooler talk that we have to extrapolate in the understanding that we're in a closed system.
That's fair, and a lot of people will accept that, but I go better by evidence and tests and something that can be validated over anybody's testimony. That's my point.
What about the spin of the Earth? What test did you get that validated that?
Oh my God!
And if
Thanks,
he's
Bob.
I'm not trying to change the subject. I'm just pointing out the hypocrisy in that statement. You can continue.
Exactly my point is that
Wait.
if you're going to sit back and observe the fact that we're operating I can say that I breathe gas and I literally move my hands around and I can feel it. Well, I would think that we're in a closed system, and it doesn't take much to realize much after that.
Well, breathing equals we're in a box.
It'd be pretty cool though, Kings.
That's some
If this
disgusting people
fellow
here. I gotta
is
go.
if he is a meteorologist, one would think that he has done conclusive kind of tests that kind of back up what he's saying. It would be interesting to get what those tests were and what the results were. If you
I just want to get something straight with Kiwi, if you guys don't mind, because I'm like really curious about something. So this is just suggesting that the moon is a light source, right? Or rather, you're saying that it's illuminating.
I'm only suggesting that the sun and the moon do the direct opposites to the atmosphere that they engage with, or even the atmosphere, the environment that they engage with.
So you think that any light coming from the moon is a reflection from the sun?
Nope.
No.
Nope.
Okay, gotcha.
I think
Thanks,
that the
man.
sun and the
That
moon
was
are
my basic.
independent, so to speak, but they do the exact opposite to the gases that they interact with.
I think that's the problem with the heliocentric model, that people want to be glued to the idea that the sun is creating all the light that we see. That's the thing that people got to get over, I feel.
It appears to be, though. It's easy to see that it appears to be.
Is that like you connect the sun, like when he says, oh, because I breathe, therefore closed system. And like just breaking that down, because I breathe, we are inside of a box or a you know, like that's such a far extrapolation. Same as like, to me, oh, there's this bright spot in the sky, therefore it is the source of all our vision and whatnot. And I'm like, I don't know. There could be another mechanism.
So, my friend, you're suggesting that there's a Terminator line that exists then?
When did I? Again, I didn't say that. That's you know, you're
in the essence. Are you not suggesting that the sun is projecting its light like the headlights on a car?
No, I don't think that's how. it works.
The sun works on. Okay, well, the sun either works on one of two principles. It either illuminates. Hold on.
I don't think that.
Hold on. It either illuminates the gases it interacts with, or it projects its light. Which one is it?
Well, see, there you go. You're just saying, I know how the universe works. It's either A or B. And I'm going, so you're like God almost, in that you can tell me this invisible mechanism and say, it's got to be one of these two invisible mechanisms. And I'm going, no, I don't agree with you, because you're not. You didn't make the system. Those are your personal thoughts, right?
My guy.
My friend, listen. But just bear with me. Those are your personal beliefs on how you think light can work. But you're putting a label on only those two, right? Those are the only two you can believe in.
Do you realize why I feel uncomfortable with the words that are coming out of your mouth right now? Because you're claiming that you're putting that creator on me. I'm explaining to you that these are wow. You want to interrupt again? I'm explaining to you that these are the two things that I observe, and I'm asking you for a more intelligible explanation. So maybe we can add on a third. But I only see two. Okay. If you want to introduce it to a third potentiality, feel free. The floor is yours, my guy.
Do you observe, you don't observe the sun, the mechanism. You just see, right? You just see a rock, you see a tree, right? You see the bright spot in the sky. You have no idea how that happens. Now, you think personally, well, maybe the medium, the air, is somehow doing something, and then maybe the sun is somehow doing something. But you don't see either one of those things. You just see. Now, again, when you bring forth these two explanations, and when you bring forth, it has to be A or it has to be B, and you either give me a C or you're not adding anything into the equation. No, I can add something into the equation by going, you know what? What about D? None of the above. You're all wrong. You have no idea how it's working, and stop trying to say that you do.
Y'all need to rewind to 30 minutes ago. Y'all need to understand the context of why this was being talked about. It'll make way more sense. For real. I was here listening. I appreciate everything you're saying. I understand it all. It's because I heard the beginning. Y'all need to hear the beginning. For real.
Yeah, I don't need to hear the beginning to.
I don't know. Like, y'all are coming at him so hard. I'm like, damn, I understand so clearly. Like, what are y'all missing that I'm fucking getting? That's what I'm asking myself.
Either way, everyone just gotta calm down, man. You don't gotta like scream, bro. Like, geez Louise.
So if I could just break it down in my little dumbass way, because I'm a really fucking simple how to explain stuff. Me and him kind of broke down how, okay, there's gases. Okay, we're kind of being contained. The gases are contained. And who's to say that the light coming through these gases is within the gases or outside of them? So we're talking about like a plasma dome. We were talking about all types of random stuff.
Yeah,
you would have to argue for. We were just allowing all of this to develop without asking if any of it was. So that's why we got to this crazy place of. And you
I feel like
respect to like the context.
Electric.
Of the
You know what this reminds me of? Electric. Okay. This reminds me of when Noah was swinging his hammer for 120 years, and all the people walked by and laughed and scoffed at him. It's the same shit, dude.
Like, it's a build. If you weren't here to see it get built, don't be mad when you see we put a feather on top of something. Or, you know what I mean? I don't know. Whatever.
I'm just saying there's everything we are given, right? Light, how it works. It's all been given from the mainstream, right? None of this comes from, nobody had their friend Bob, right? Hey, you know what? I don't think this is how it works. It all came from this one source that we have no real interaction in. It's the Wikipedia source, the mainstream. Light works like this. Gas is this. I don't believe any of that, right? So
Okay, so
just
this is
me, man.
your-
I'm just
this
saying.
is your
I think there's a
point.
third. I think there's
Wait a
3
second.
options. I think there's 4, man.
Wait, can I offer a third option? So, like, actually, it looks like light is nothing more than like the etheric background effectively being vibrated in layman's terms. So the sun is like an energy source that inputs a certain vibrational resonance or pattern, and then that's what illuminates the background medium. We perceive that as light, which is nothing more than a portion of the background. So it isn't like some little light beam being shot out and little physical balls hitting you in the eyes and none of that nonsense. It's just the sun is a certain energy source, and it vibrates the etheric medium in a certain way.
I meant to make one final point. Like I said something about, is the sun within the dome or is it outside the dome? And he suggested something crazy to me, that it's actually almost like there's something creating a light source, and the plasma dome is causing it to intensify. And that's what's actually terraforming everything we see. And this suggestion to me was fucking awesome. Like, I've never heard anybody say that. So yeah, if y'all didn't catch that,
Thanks, Fleischrick. I appreciate that, man. But it's not my idea. I'm just following a model
Just
that I see that makes sense.
I don't know.
Pump
Yeah,
the
that's what
brakes
I got
on
from it. If that's not what you meant,
the
then I
brakes
don't
on. Sorry, but I'm saying maybe pump the brakes on confining your explanation to like a physical location, because it doesn't seem like that's the case. It seems like there's an energy source. Sure, that energy source would be maybe inside or outside the firmament, but it's just an energy source. It's not like a physical light bulb or anything like that. Because
Above the firmament.
Wits, hold on a second. Wits, at the very beginning, when your third suggestion was very, it reminded me of the theory of illuminating. Again, they're described as luminaries, and what you described is basically luminaries interacting with the gases. That's what it sounds like to me, based on the vibration explanation that you gave, right? The aspect of us being able to figure out more, and again, I'm speaking specifically to the ghost of Ruth or whatever your name is. If you're not going to be adding to the points of conversation, you're just going to talk down everything, then what is the point of even engaging in debate?
Okay, so picture there was 2 guys and they were arguing over whether the Easter Bunny is yellow or whether the Easter Bunny is red. Now I come forth and I'm going, in this particular just analogous, right? And I go, hey, maybe we can consider that the Easter Bunny is not real. And you're going, you know what? To just come in and say, this is fake, it's wrong, you're not helping the debate. And I'm like, well, actually I am. I'm adding another leg to the debate, right? I'm switching it from like this pointless debate of, oh, maybe it's the Easter Bunny's red, maybe it's blue, or maybe there's no Easter Bunny, and we're just arguing over. And then again,
what's the third
if you're a
option?
biblical man,
What's the other option?
Here's the funny part.
Well, let me just say this.
Here's the thing, though. I have Easter eggs at my front door, and I have bunny trails in the snow. And you're going to tell me that I can't look at the evidence and think what it could be. Thanks.
I don't want to hear anybody's wrong. I want to hear other examples. That's what I want to hear.
Okay, but this is almost like when people are like, oh, that trolley problem, right? One person, 5 people. Oh, what do? Do you pull the lever? Or do you not pull the lever, or whatnot? It's like, look,
someone give me another example. Stop telling me someone's wrong. Stop telling me someone's wrong. Give me another example.
Example of what?
Anything. Just stop telling me people are wrong. Just give me an idea.
What do you want me to do? You want me to, so you want me to just you want me to use my imagination right now and come up with a way in which we could see and then tell it to you? That's tree of knowledge, bro. This is the tree of knowledge. It's the wasteful time of debating endlessly about how God uses his invisible side to work. That's why he said don't go into the tree of knowledge, because you'll never get out.
You don't have to be here. You don't have to be here.
But I don't have to not be. I can be here and be like, hey, you ever think that maybe this conversation is a pointless conversation, kind of like the tree of knowledge, how it doesn't really lead anywhere?
What do you want to talk about then?
This, like how talking about all these things is completely wasteful, because 6 years ago in this same server or whatever, others, they were talking the same thing. I was too. You're just, oh no, it's this. Oh no, it's blue.
Are you mad that things aren't going the way you want them to?
I told you what I'd rather be talking. I'm just saying.
You're mad that things aren't going the way you want them to right now.
But look, man, here's the deal. We're just trying to figure out different aspects of where we live, right? And so we're limited to speculation. And so we're just trying to figure it out. I don't see any problem with that. And what the guy's saying, there's really no value in just saying, you could be wrong, you shouldn't talk about it. because everyone here knows they could be wrong. It's speculation. You know what I'm saying?
Yeah, thanks, Mom, for letting us know that maybe some
that
ideas
wasn't
are
my
wrong.
point. That wasn't my point. So see how
Thanks,
we
Mom.
let me say my point so you can get it wrong. I'm not just going, oh, you're wrong. I'm going, the entire idea of conversing endlessly over how some invisible component to reality works that you can never confirm, in my opinion, is like eating from the tree of knowledge. It leads down a path that there is no coming back from, except to say, you know what? I have to stop walking down this path because it leads nowhere and it's wasting my time.
So if the creator told you that he created the firmament on the second day, you're not going to get curious as to how that interacts with the plateau that you're standing on?
Well, if my purpose in life was to be curious about that, if he created me to do that, that would be what I would do. I don't believe he created us to try and work. You get what I'm saying?
Understand that you're being narcissistic.
You're wrong,
Asking for my motivations on why I'm looking into stuff. You understand that's narcissistic, right?
I never said you're looking into it because of this. I said this is my belief.
Bro. Enoch, you said he didn't make us to do that, but that's like literally what Enoch did. Like Enoch was taken up and shown how everything works. He was so curious about how everything works. And so since he was so righteous, he came and showed him.
Because
are you Enoch? Are you Enoch?
Friend, listen to no.
Is that why you were created?
Enoch,
so you're using why somebody else was created and what he did to justify.
Listen, let me drop some
knowledge
knowledge on you. Let me drop some knowledge on you right now.
Oh, here it comes. Here it comes.
Yeah, that's right. The reason that God chose Enoch was because Enoch was a righteous man, and he knew right from wrong in his heart.
Oh, you knew this because
you need to
how do you know this?
Thanks for coming out.
Oh, so the only so you're
without even having
you're just repeating what you heard in a book, dude.
You're
just repeating what you heard in a book.
Created by Moses, which was before his
Ghost, you
time.
have to stop.
So
Can I make an
Ghost, you have to stop
observation,
interrupting.
please? Like, dude didn't want anybody to
it's getting
speculate where
frustrating to
we
listen
are
to.
because supposedly we already have all the fucking answers. Like, great.
I didn't say that. That's not what I said, though. Again, you're putting words in my mouth. I never said we had all the answers. So if my point is so shitty and it's so wrong, why do you have to change it? I never said we have all the answers. So why do you, but again, this is part of the conversation. This is part of the conversation. This is part of the conversation that I think is important. Because when you have two people, even a flat earther or ball earther, when the ball earther, flat earther says something, the other party hears something totally different.
You're robotic. Ether doesn't want to hear you.
God just intensified your intensity, bro. Like, that was crazy.
I just want to point out, look, dude, not everyone's the same, okay? So, like, I don't know if you're talking about the scriptures or not, but the scriptures say to, like, seek knowledge. And whether or not you believe in the scriptures, that's cool. It's an independent discussion, but we just want to figure things out. If you don't want to, that's okay, but don't pretend that you have some intellectual superiority because you don't want to. And also don't, like, try to shut people down for talking about things. That makes no sense. You've offered no viable options. You've added no additive input. It's only, you shouldn't be talking about it because you couldn't know. It's like, well, that's your own prerogative, and maybe they want to try to figure it out, bro. I don't see why that's so complicated.
Okay, hold on. I never said you guys shut up, right? We were having a discussion. They were talking about light and this, and I offered my opinion, and I was like, this is my opinion. Okay, then you took my opinion and turned it into me telling everybody what to do. I never told everybody what to do. I only offered my opinion, right? And you're getting defensive about it. I don't care. I mean, because if you want to fucking debate it, then go debate it. I gave my opinion.
Why don't you entertain it? Why not try
yelling,
something
dude.
different?
No one else.
You run around, think you got the right formula for tackling this issue. Why not entertain it and see what happens? What happens when you might think that this is
I'll tell you why. Because it's the same thing like with a baller. When you entertain the baller thing, right? And the baller will say exactly what Witsit just said, or a flat earther will be like, the baller will be like, well, then give me a better explanation. And the flat earther will be like, well, I don't need to give a better explanation to show you how that. Hold on. Let me. Come on, don't interrupt. So one of the things ballers do is go, well, then you explain it. And a flat earther will say, and we've also heard it, I don't need to explain this just to say that your explanation is wrong. But then when that same logic gets turned back on something you believe, right? Oh, now I got to put forth another explanation in order to say that you're, it's just the inconsistency of logic in your belief.
This is
I can't believe I'm agreeing with Right the Hand. I'm
Yeah, I
agreeing
know.
with Right the
Sometimes
Hand.
that makes sense, right?
The reason
Sometimes
it's
that
not
makes
the
sense.
same is because you didn't falsify what they said, though. Like, the difference is when a Glober makes a claim, we falsify their claim. We're like, we don't have to replace it. You didn't falsify their claim. You just said it could be something else, so you shouldn't be talking about it. It's useless, and that's just a useless point.
Well,
Wait, so I can't say a baller's wrong.
Sorry. We're actually having a
Sorry.
pretty cool conversation about the sun and the moon and what people thought it was and how it was all working, and now it's turned into this.
You shouldn't debate it at all. Yeah.
Over nothing, really. I'd like to go back to a
But it's
more
not
productive conversation, more productive conversation.
Yeah, so I think that
I
maybe
think this
because,
conversation is just as productive as debating how light works, right? To me, I think it's just as productive.
okay, maybe sit this one out then, right? So, like, if we look at how light works, because to know what the sun is, we have to understand that. And then mainstream tells us that it's like these little physical material photons that are massless but still physical and material at the same time, and all this nonsense. But it actually looks like it's the background itself. So it seems like an energy input will cause illumination to the human eye, right? So if we actually take that and then apply it to the sun, it seems like the sun is an energy source, and it causes illumination based on the way that we perceive light. And so really it's just the background being vibrated with a certain energy input, and the sun is an immense energy input. At least that's how I see it. And that does kind of intertwine to the reaction with the Atmos, if you will.
Nice.
Thank you for that, Whitsit. I appreciate it.
Definitely.
Especially coming from you, my guy, because I know you've been at this for a long ass time. Thank you.
Well, when you think about it on a cause and effect, when you think about it on a cause and effect relationships and the build of and design, the patterns of the luminaries and all that kind of stuff. The luminaries are effects that are being caused in the median between the ground that we're standing on and the layers above. You can kind of see the phenomena. It could be demonstrated down here in a sense, like with lenses and light going passing through mediums and gases and all that kind of stuff.
Shadows.
And you can kind of demonstrate the effects that we observe in the luminaries. But the sun, the moon, the wandering stars, those are still effects that are being caused in the sky that we observe, right? So the input into the system that we call the sun, the sun rises and input the light and causes the gases and the matter in the air to high temperature, that kind of stuff, right? So that input into the system is causing this change of temperature and gases to do things. But that's still not the source. When we call the sun the source, that's still part of the effects that are being caused by the light passing through the layers above. That is coming from above.
It's an ignition point. Think of it as an ignition point.
Yeah. So when we look at the light passing through, like when we look at the moon and we see the shadows on the moon and that kind of stuff, you look at Venus. Venus also had these shadows. It's kind of like similar to the lunar phases. So we're looking at the light passing through multiple layers and giving these effects. And depending on the angle that the light is passing through, that's why we see these phenomena in the lights above. And you see the wandering stars always in relation to the sun and the moon, always in the same region of the sky with the sun and the moon, because those effects that we are observing are being caused by the design of whatever is above our heads. How it completely works, we don't know, because we cannot break it down and look exactly how it works. But it's this light show that we're observing with patterns, and then I will say that it's a mechanism that is being inputted into the system, but it's a flow. It's an input and an output, and I think that has to do with what you said about the moon and someone was saying reflection or whatever. You know, when you have a negative of an image, the moon, black and white or whatever, the way it looks. When we look at the image of the moon, I would say it's kind of like an image that you're looking at in a, let's say, a plasma TV in the sky, right? You look at an image of something that might not be the image that you're looking at. That might not be the source of the light, just like the sun. But I don't think the sun and the moon are the source of the light. But you're looking at the light going through certain mediums, and from this standpoint, from the ground that we're standing on, we see the sun and the moon, and it's designed to look the way it looks. That's kind of obvious. The patterns and all that stuff.
You guys see the live stream?
Let me check.
Yep. Yep.
So
What's that?
it's like a very complicated machine, and I think it be above the, let's say, what we call the firmament, or there's multiple layers, and above that is an actual structure, or like a machine that is actually causing the effects. So cause and effect relationships. The sun and the moon and the luminaries, those are effects that are being caused by
I agree.
bunch of a whole design, a whole build-up. That as a result, we can see the light show that we see in the sky.
Did you guys see that image
Yeah, I
I
agree.
posted?
Yeah, this makes a lot of sense to me.
All right, you know where that image comes from? Check this
No.
out. Because I've always presented it one way. I'm actually presenting it the opposite way today. I'm presenting it backwards. I'm presenting that image first, and I'm going to show you that it came from this image, which is that. You can see I'm at that's actually me in the bottom right hand
I've
corner.
seen that. That's the
Right? Vibes of the
documentary.
Cosmos. Those
Yeah.
two pictures, all I did was rotate it around.
Oh wow.
Right? Rotate it around and all that stuff starts to pop out. Now, there are land masses on there that we can't explain, right? And this is the concept that I was explaining to you, that it's two sides of the same coin, because I believe that, as Gemsy was just saying, the image of the moon is actually an inversed, so it's reversed, but it's also see-through. We're seeing two sides of the same coin. Landforms on either side of the coin present in the same image. Because, Guy, I'm telling you, the world map aligns to this model. I'll put the original image that came from. Hold on a second. Now again, this is the moon as pictured from the northern hemisphere. So if you look at the moon from the southern hemisphere, it's going to appear inversed, the flip, because the equator is the flip point. That's where you transition to looking at it upside down, i.e., you're looking at your asshole upside down.
I would say that the sun being an input into the system or some sort, there has to be like a flow. So I would say a left and a right arm, or people say positive and negative, or in and out, high pressure, low pressure, heat and cold. There has to be that kind of input and outflow of the system. And I think we might be looking at like imagery of that happening up above our heads. When you see the wandering stars and you see the relation to the sun and the moon, and depending on the angles that they're moving, right? You see the wandering stars kind of moving. And then you see, like I said, you see Venus having similar phases to the moon. And that's, you're looking at the light going through multiple, like a lensing, like a camera. When you put an optical device that have multiple lenses, and you see the artifacts expressing in the lenses, the light going through the lenses, and you see where the light goes through the lens. In multiple, if you have multiple lenses, you see that expression, that image of the light in the lens. That's what you're seeing above with the lights. You're seeing the light going through multiple layers.
So
and
layers
it
of
changes
water.
angles. It could, me myself, I think it's containment, like let's say a lens of a crystal or whatever, and then there is water or gases in between each layer. I would say each layer or
So the idea
each
of the
level.
plasma, then, right? Because that's
sure.
Because like imagine, Gemsy, we look at these images of Mars and Venus and all the way through, and they appear to have this like shimmery look to it. So if we were again shining a colored light through a plasma-like gel filled, I don't know, container, if you will, right? We're shining a light through that, we would get that effect on the ceiling, as an example. Like you were messing around with that whole thing with your cat the other day with the bowl on the wall or the bowl on the ceiling, right? Imagine we were introduce like a cup of water into that equation, what it would do to that projected image on the ceiling that you were creating. You know what I'm saying?
Yeah, I get it. I've seen that phenomenon happening, and I will say we can kind of demonstrate what we see as the luminaries down here. It's just that it's such a big scale that I cannot tell you exactly how it works. But I would say that we're standing on the ground. There is the medium that we're in between the ground and the floor and the ceiling, and you could describe it almost like a plasma TV that is above our heads, and we see these images.
And again, you and I've talked about this on a private, on a back and forth on DM, and we aligned on this whole idea of like there being present plasma, because even when we observe like the Go Fast rocket and the Falcon rocket, the Tesla rocket being launched, and it created that crazy pattern. I pull it up right now. I mean, if you were to skip a rock across the lake, what happens when you skip a rock across the lake, Gemsy? How many skips you get?
Recently I've got like 5 skips. Recently. Yeah, I was just playing around, just throwing some rocks. Yeah.
Now you're by the ocean, right?
Yeah.
And so were you skipping the rocks on freshwater or seawater?
Seawater.
Okay, so you got do you think you created enough speed with the rotation of the rock to create a wake on the surface of the water, you think?
Create a wake?
Yeah, you know what a wake is, right?
Like a ripple?
You know the wake. Here, I'm gonna look it up right now. I'll post in the chat for you. Walk with me on this this little path, my guy.
Yeah, I'll walk with you.
I appreciate that, man. Always. So, the definition of wake.
I could look it up.
I'm gonna pull it up for the chat because I'm actually gonna just clip it off my screen and.
What up, Jamsy? What up? Yeah, I don't think you can skip a rock without making a wake. I don't even think that's possible.
Hey, yo, Jared, what's going on, man?
Hey,
Jeremy's
what's
here.
up, bro?
Sick. And he can back me up on the wake observation.
Yeah,
wake
anything
in water.
anything touches the water, it's going to make a wake. I mean,
especially when it's moving at speed, right?
Oh yeah, I get it now. I see what a wake is. Yeah.
All right, cool. I appreciate it. Thanks for looking that up. Can someone throw that up in the chat? Because I'm actually going to pull up a picture I want to share with the chat for them just to get an idea of what I'm looking at here. I got to the
Bro.
work PC.
Kiwi,
Yeah.
I got a serious question for you.
What's
You
up?
said that there was a black hole sun on the other side of the coin. Is there any evidence that a light source would appear black through like a prism or something?
Yes, it's a negative. It's like an inverse of the light. Like a light can look completely
I know my question
like
might be
dark.
wrong. I might be asking the wrong question.
No, you are asking the 100% $1 million question, and you're such an educated fellow, Electric. I love you for that, man. Listen, what is above, so below? What is negative? Balance, yin and yang. The transition point of this being the surface, where negative becomes positive, becomes light. Evidence of that being the aurora borealis, as pictured in the northern hemisphere, being the visualization of the illuminated gases in the atmosphere all the way up to the North Star. The North Star has, I don't know, and this is where speculation can get really heavy. The North Star has some interaction in the creation of the luminaries. The luminaries happen. I don't, and again, I'm not sure if it's actually, okay, here's the thing. And here's what's making a lot of sense now that I'm talking about it. If you have one source beneath the surface, and it comes to the hole and it transitions and it's reflected in the firmament. You with me, boys? Everybody good so far?
Yes, I'm with you.
All right. Then I'm standing in Australia and it's daylight. I see the sun because it's daylight. Though I go across the hemisphere to Ontario and it's nighttime and I see the moon. Has the sky changed or has my vantage point changed? Boys, has the clock changed or has my vantage point within the room changed?
Yes. Wow.
It's simple shit, right? So if I have one centrally located light source being underneath the crust, okay? And I see the aurora borealis being created on the nighttime sky. Let's go further with this and say we're in Alaska. It's nighttime, right? We see the aurora borealis coming up through the essence of the atmosphere. That is being that reflection happens in the firmament, the ceiling, right? That reflection item thing that's in the ceiling, because you can't change the ceiling when you're standing in the floor of the room, right? The ceiling is the ceiling. You can't see the other side of the ceiling because you can't do that. Give a shit who you are. And now I'm gonna stand in Australia and I'm gonna say it's daytime because it would be nighttime in Alaska when it's daytime in Australia, would it not, boys? Check. So I'm in Australia, it's daytime. I'm in the southern hemisphere. I walk across the plane, across the transition point being the equator. So I go through all of I follow, actually, what would I follow in flat? I would follow the longitudinal lines, because the longitudinal lines will always walk me from the southern point into the centrally located northern point, right? Because the longitudinal lines lead to the middle, do they not? Boys?
Longitude lines lead to the middle. Yes, they do.
Okay, so we walk the longitudinal lines from Australia across the equator to the northern hemisphere where it is nighttime being Ontario. We look up, we see it is nighttime, we see the moon. Has the sky changed or has my vantage point changed, boys? Pardon me? I need chest answers right now, boys.
You heard me.
Your vantage point saying.
Thank you. Holy shit, man. I'm trying to prove your damn point. I need motherfuckers with chest. Sorry to cuss, folks, on my roll. But boys, this is the bullshit that we're in right now, huh? You see this? Because we're in a place. Listen to me very carefully. Let me speak with some inspiration on this Sunday. Let me get the Holy Spirit in me right now. Whew, let me speak. Listen, we're in a place where we believe we believe we're on this plane. We observe we're on a plane. But I just walked you through a very simple example of real life observations. And I asked you to walk with me on their points of observation being the longitudinal lines crossing their observed being the equator from our observed Australia landform to Ontario, which I don't know if anybody is that ignorant in here, but y'all better know where I'm sorry to cuss, but Ontario, Canada, 6 hours away from New York, in the northern hemisphere. And I'm asking you to say with your damn chest, what has changed? Did the sky damn well change? Did our vantage point change, boys?
What's the significance of what you're saying, man?
Sun and the moon are the same damn thing, bro. That's what I'm trying to tell you.
Okay.
Well,
I get it. I honestly am fucking. My brain is fucking really understanding this, dude.
If that is so, right, let's just roll with it. Let's just roll with it for a minute. If it's the same thing, why then? And going back to your original, one of your original thoughts, where you suggested that the moon is the spotlight projecting the light. Okay, where does then the moon go? Right, because we seem to lose sight of it for about 3 days, but we still see the sun. What happens?
Yeah, bandsaw, dude. I appreciate you pulling me back down to earth on everything. Okay, so we're gonna walk with my crazy idea that this is potentially the same source that we're observing. Okay, so we're gonna introduce the idea that we have an observed common axial point of rotation. This black hole sun would rotate around this common axial point, and then that thing would be reflected in the firmament, which we all agree that the firmament is the roof, the closed system that we're in. So as the black hole sun rotates around, the thing that we observe in the roof would rotate around. Now it creates this pattern. Hold on, I'm gonna go to my other account because I have this on too. Hold on. See, the interesting thing about the moon that kind of, I don't know if it helps us or hinders us, but there's the evidence of the whole, like, the eye opening and closing, right? The waxing and the waning. So, like, that's, and then obviously it introduces another aspect, which I believe firmly is geometry, which is the whole idea of, like, how, oh my God, how an eclipse would work, right? Like, how do you then start to move the lights around to create that? And then I start to think about, like, how a disco ball works. You shine a light at it and it spins around and all kinds of crazy stuff happens. So it's, okay, hold on. Sidebar myself. Okay, wait, that's a great one. So, Bandsaw, you see this, right? Oh no, this one. There we go. You saw this one, right? Okay. So that's kind of the full unpack of what I'm kind of thinking, where again, you have this the green line being the common axial point of rotation, the red arrow being the thing that rotates around that axial point. Again, where I stand, I think in this picture, I can kind of ascertain that I believe they'd be on Australia here on the black and white, right? Which is showing in the half moon that's shown in the top right. And then when I skip across, so again, I go to the other side, like we were just talking about, to the northern equator, I observe the sun, right? So it's the same spot, it's the same thing. The sky hasn't changed. It's just our vantage point has changed. So this is the visual representation of what we just unpacked. Yeah, that's kind of my thought. Now, let me think, where's that pattern? Have you guys have seen the fish pattern, right? Of the there we go. This one.
Maybe.
I just posted it up.
Oh yeah.
So if you were to take that and you
Wait,
think of
before
that,
you get into it, bro,
up?
I already know what the fuck you're about to say about that fish pattern. That's so fucking wild. I'm seriously losing my mind right now.
Yeah, I love this stuff, man.
Flipped on top of each other. That's
Pardon
fucking
me?
wild, bro. I'm literally losing my mind right now. Like, I don't know if other people are, but
Yeah, well, this is just what I like. Vibes of the Cosmos. Vibes of Cosmos. They're the ones that presented this whole thing, and I just like looked at it, I'm like, holy crap, this totally makes sense.
I thought that's what you were
what's the tail of the fish? What is this arrow pointing at the fucking two domes? What's the
arrow
tail?
pointing at the two domes. What?
Yeah, they draw a line to represent the tail, or is the tail open or closed? There's that part
Okay, so everything is encased within these two firmaments under us and above us, right?
Yeah.
But then you have the outside, which is the tail, like the cross. That's like the crossroads, and then the open-ended. Is the tail open, or is there a line to represent that tail being closed?
I don't even know.
Wow, you know what? I'm fucking. Y'all are not thinking what I'm thinking.
No, and that's like, and that's what's so cool about this is like we theory craft because that's all we're doing, right? This is just like a crazy ass video game at the end of the day. We're theory crafting. We're just sitting around the campfire and having beers or whatever, throwing the ball around. Because like I may say something like exactly what just happened, and Electric is like, "Holy crap!" and he just takes the ball and like runs for the end zone, maybe or whatever it is.
It's because I have all these preconceived notions about like duality and as above, so below, and like all these things I hear that are kind of like not super pertaining to the conversation. That makes sense because there's a lot of syncretism and symbols, and the fish, like the two simple curved lines to make the shape of a fish. That's like Christ. That's Yah and all that other stuff. And I'm just trying to make a correlation between that and how El and Helio and all these fucking characters and like the worship of Serapis. All these characters come from the same shit. It's just the idea that you're just warping the dome to represent one entity. I'm fucking bugging right now, dude. I seriously am thinking some wild shit that I can't even explain.
I think the theory that if you understand the main storyline, I think it just becomes a question of how many times you can rewrite it. And whichever one's going to stick and they're going to run with becomes his story. So I want to show you guys this this sky craziness that happened when they launched this the SpaceX rocket. Did you guys see that?
Okay then. All right. So.
Oh yeah, when the car crashed. Yeah.
And again, this comes back to the original point we were making. Gemsy, you still with us, buddy?
I'm here.
Cool. So you toss a rock. You toss a rock, or a boat, or a ski boat runs or goes across the level of the ocean. I don't know, man. It looks like it makes the same kind of pattern. So I'm like, okay, what if this dome structure that they attacked in 1960, Operation Fishbowl, Operation Dominic, was this like Star Trek? Yeah, I went there. Star Trek type of dome, protective dome, right? Like put up the shields, right? And that those shields can receive energy, right? So they launched this rocket at the shield, and the shield received the energy and just allowed it to kind of cruise along its surface, right?
So
the
you
plasma
think
surface.
like a rock skipping across the surface.
Exactly. That's why I say that the whole wake observation, when a jet ski goes across the surface of an ocean, it creates that wake type of sensation, right? Be right back, please. I really appreciate this place to just talk about this stuff. Theory crafting. Appreciate it.
No, it's good to explore different ideas. All for it, even though I might not agree. It's still cool to. But that's a cool photo, that one. Is that on a dash cam or something? That was cool.
I'm so glad I wasn't hot micing just now.
Really?
I was crying over my wife, and I was like, "Holy shit, am I fucking hot micing?" Live in constant fear of hot micing and saying something absolutely insane.
Dude just gave me a whole new model of the fucking world, bro.
We've all got a model of reality inside our heads, right? They say it's in your neocortex or something inside your brain, and everyone's is different. No one has the same model.
I've never heard anybody talk about this before. I've never heard anybody suggest this two sides of the coin thing, and that would explain this third sun and eclipses, and how all things come from one source, and how the moon is on a simple trajectory relative to the sun. It's so crazy to me right now. Like, this is just blowing my mind, bro.
You never watched Vibes of the Cosmos YouTube?
Say that again.
The Vibes of the Cosmos, their YouTube channel.
I'll subscribe to them right now. Just give me 2 seconds. I'm on my way to work.
Yeah, well, it's pretty easy to remember. You can do it whenever. But yeah, they got a lot of cool information that's like this. They seem to put in a decent amount of work.
And so tell me
Like
this
this-
guy don't sound like Brandon a little bit right here. This guy.
Yeah, a little bit. Yeah, I was just thinking the same
I thought it was
thing.
him a few days ago. I asked him, I'm like, dude, who are you? What is your name again? I forgot.
Yeah. Come on, turn your camera on. We need some proof of this.
One of the cool things that Vibes, the Cosmos put out there that I think is pretty compelling. Like everybody has seen the, I don't know if everybody, but most have seen the moon reflecting the continents or whatever, right?
Yeah, the political world map.
Yep.
Yeah, but then they take it even further. I don't know if anybody's seen the further part where the stars, with the reflection of the stars.
Talk about it, my guy. Go ahead, because it's a great thing to mention. Go ahead.
Yeah, well, if anybody has seen it, the way if you take a picture of the moon, it also reflects the exact position of the zodiacs. Once you have to dim it, right? You have to kind of dim it and get just the most highlighted portions of the moon, and it eventually goes down to just being little dots, right? And to what's the most highlighted portions of the moon. And once you get to those little dots, it's the exact formation of the stars. Just about every star is seen in the moon, in their zodiac, in their place, organized how they are in the sky. That's pretty amazing.
The energy ley lines, they all reflect, and I'm about to post the backup for you. I think this is it. Yeah, I got it here. So I just posted the political world map for people if they want to take a look at it. And then, yeah, here the energy. This is the energy point map. That's exactly what you were referring to earlier. Yeah, guys. Thanks for the backup on that. I appreciate that.
This is almost like Pete Shea type stuff right here with the continents and the moon. Isn't that what wasn't he always on about that?
Oh, he was. Yeah, definitely. All right, guys. Thanks for the cool chat tonight. I'm out of here.
Have you heard? All right, later, man.
Have a good night, Ben. I'll be well, man. Always a pleasure.
Right, electric, yeah, good one. Sweet.
It's okay, buddy. Thank you. Appreciate that.
I just had a random thought, not truly relevant to what's going on right now.
What is it? Break us off with it. What do you got?
Yeah, my mic is crazy right now.
What are you thinking?
The hammer. I was thinking about how something that's bothering me a ton lately is how the roads are above the doorways of a lot of these buildings in New York. Like, just to me, is very telling that these buildings were here before they built the roads. And then I thought just now, I looked down and I said, hey, look, all these roads are above a sewer system. So they literally built these sewer grates and these gutters, and they're lining the roads with water, like the waterways. What if when they first got here and all these waterways that were laid out around these cities, they just started shitting in them, contaminating it, realized, oh, we don't know what to do. And then they turned it into a sewer system. And they said, okay, we'll just bury our shit pipes. I know that sounds...
Well, I'm all for us being more advanced in the past than we thought we were. You know what I mean? I don't know how or whatever, but there is evidence of it in certain ways, and I mean that's a viable scenario. You know, I don't know about the buildings being underground. I mean, no, when you
These
build a
people were sitting in
skyscraper,
these man-made rivers, these man-made ponds, and they were just using these fountains as places to like shit. And they're like, "Oh, damn, we ruined it. Let's bury it."
Here's something for consideration. This is Washington. No, sorry, not Washington. This is Texas. So exactly what you just said. If you check out the picture I just posted, that elevation, and you check out the basement windows, it's the same story that's been throughout. Why are there so many below grade stories? Evidence of like soldier coursing above windows and big windows, and sometimes you even see the windows are buried, right? But you'll still see the soldier coursing. The soldier coursing is the arced brick that sits above windows. Why do you see that stuff? Like they wouldn't be putting soldier coursing decorative bricks at grade. It makes no sense. Now the thing about it is they talk about mud floods, right? Mud floods, I don't see them coming through and filling things up as conveniently as demonstrated. Mud floods are destructive. What I think happened is a series of backfilling. Backfilling is just a process of where you take earth and you just literally throw it back into the hole. That's what it seems to be too precisely done to be something done by nature.
well, there's when you have a flood, and there is massive amounts of evidence for insane floods that have happened. But when you have a flood, I mean, it can move a massive amount of sediment or dirt or whatever, you know, pretty quickly. You know, if you have a structure and there's a flood comes through, it might push a ton of dirt up against your building, and now your whole city's an inch or two or a foot underground or whatever. No?
Yeah, the other thing too, I know that we've entertained. I think anybody's familiar with A. Warrenon's work. He's talked about the mud floods a lot, and he retracted that, of course. But the one thing he mentioned was these cities that appeared to be deserted. That is something worthy of note. However, there is also something called is it long term? Yeah, long term film or long term picture exposure. Basically, taking a picture of a long period of time. Where if you have people that are moving around within a picture that's taken over like, you know, a couple hours or whatever, those people will appear as ghosts because they're obviously moving around, right? Like if you're looking at the cityscape of a town, unless that person's standing there for 6 hours not moving, they will appear to not be there. So the aspect of were these cities vacated completely, I don't know. But the aspect of population, that's the other thing, because there's a lot of stories that talk about orphan kids being moved into cities. Have you guys heard about that stuff?
No, I haven't heard about it.
The orphan trains.
More shit. Pardon me?
The orphan trains.
Yeah, the orphan trains. Thank you for that.
I'm at a train station right now, and I'm telling you, bro, this structure is not from the 1900s. There's like no fucking way.
You're in a train station right now.
Like these metal beams right here, these are metal beam arches. Like, I should take a picture of this right now. Hold on.
Let's think. Yep. And what's interesting with these older buildings in terms of their construction is the amount of openings. I'd say glazing, which obviously are windows, but the amount of openings that they have, there's a lot of talk about these buildings generating power.
believe that.
Electric and I were talking about earlier. Electric, I remember the whole discussion about these wireless cities from back in like the 20s, I think, where they would show landscapes of cities all lit up with electricity. And you knew full well, like they didn't run wires for that, right? So if there's no wires, that means direct current, DC current, was not a thing. It had to be alternating current. Again, based on my understanding of this binary system, there's only two choices. And that's why I say the sun can only do one of two things. I observe things in one of two choices. If there's a third choice, I'm always willing to entertain it, but I only see things in black and white. Sorry about that. There's not much gray for me, unfortunately. And actually, I'll go a statement as far as to say that I will engage anybody on a debate in terms of that aspect of things, that everything is a binary choice. Black and white.
Do we still curve metal beams on those structures like the picture I posted? Is there any modern examples of that?
Can we still do what, sorry?
I posted a picture.
Yeah.
There's like these, the beams are shaped like arches.
The curved girder.
Yeah, do we still do that?
How would I make a curved girder? How would you? It's a good question. Maybe it's a curved girder. Because like a linear girder, which would just be like an I-beam, right? It has a top flange, bottom flange, and then the mid flange, which goes in a 90-degree fashion, right? An I-beam. That's just welded, right? So they weld the top flange, bottom flange, side flange. But this...
This is the group of the New York Penn Station. And this has been since they supposedly renovated it. However, 120 years ago. Who knows? This metal beams has been the roof of this train platform probably since before they renovated. Like they don't need to update it. So why don't we use this style of why not?
Construction.
I think it's because we don't know how.
I mean, I do think we've lost some technology from the past, like the Great Pyramid. We got worse at building pyramids. They had the Baghdad battery. Göbekli Tepe. There's just a lot of evidence that we were doing more advanced things than before they thought. The Sphinx got dated wrong. The whole Giza plateau was dated because they said there was no civilization that could build things before that. That was their justification. Zahi Hawass, the head Egyptologist. Yeah, there's no way anyone was on Earth that could have built this before then. That's what they have. They have this paradigm. Even with the shit your guys talking about, they have this paradigm of how things happen in history, and they just roll with it. And they can't think outside of the box.
One of the interesting notes was the pyramids operated on a principle of hydrostatic pressure. So there's these underground water fissures that existed beneath them at the time because at one time, apparently the water level came to the paws of the Sphinx. That's how far inland the water came. So, I mean, there is the idea that using water, I believe they could have, if we want to start theorizing how the pyramids could have been built, they could have potentially floated those blocks around to make transporting them easier, right? Just lasso the boulder and kind of float it along the waterway. But I definitely pardon me?
They could have built a canal right up to it if they wanted
exactly.
to.
And I think it's what is it? You can how you build like a reverse dam where you can move water through a dam system, almost like using like a what is now? It's like a drawbridge type system where you can almost suck the water upwards. Familiar with that?
Have you ever seen a Fresnel lens and sunlight before? You ever seen what it does?
Oh, I love the Fresnel lens. Yeah,
You
hell
can
yeah.
melt rock with sunlight. So
Yeah,
do you
that
really
shit is-
think the Egyptians cut those stones out of solid rock and then drug them up there? No. They took concrete or sand, they poured it into molds, and then they hit it with a beam of light and they melted it. It's real easy. Come on, guys.
Hit it with the Fresnel lens.
Hey, now. Listen, man. No need for the come on, guys part. Matt's still learning, damn it.
I mean, I don't know how. Well, there's some good ideas, but ultimately they definitely got the dating wrong for some of that stuff over there,
Yeah, for all we know,
Even
the
in
pyramids were
even
built
in their
200
own
years ago.
paradigm. Sorry, what?
Thanks for that, Flighty.
What'd you
Check
say?
this out.
So even in their own paradigm, they're getting their shit wrong. The dates. They got soft tissue and dinosaur bones. Like, I don't know. I'm not buying their stories about how history played out. You got major people stepping forward telling you this shit's wrong, like geologists and shit. They're like, yo, this you guys got this fucking wrong.
I love it. Flighty, thanks for the backup, homie.
That's a cool video. It talks about how they float the rocks.
Yeah, this
using
is
like
what it is. Oh shoot, you have it in here. Hold on. This is it. Holy shit, guy. Yo. I love this place. I love this community. So awesome. And look, listen, when I express me being like excited about stuff, I'm not trying to suck up to anybody. I don't blow smoke up nobody's ass. Let me tell you about that shit right now. When I get excited about stuff and teaching people
Don't worry
shit,
about it.
that's what makes me happy. An upward dam, yeah. That's what makes me happy. And I get excited about that stuff. So please don't ever think I'm ever sucking up to
We can make
somebody when I
water
express
flow up.
genuine appreciation for them. Pardon me?
You said we can make water flow up to a higher elevation.
Exactly. And that was, I believe, how the boulders may have been moved, man.
How's that work? That's perpetual motion right there. Are we using energy to do it, or is it something we can like make happen naturally?
Pressure, I guess, because it's an enclosed kind of tunnel.
I just want to give a shout out to Electric.
Did somebody posted a video with this upward dam thing?
Yeah, it's just go up further. Flatty posted it at what was the timestamp? 30. Funny enough, 33.
Seriously,
Flatty, do you remember?
I really
hold
wish
on a
you
minute.
guys would take what I said seriously.
What, dude? Hold on a second. Just wait. Give us a second here. Brian, hold on. Flatty, do you remember when you and I first interacted? What I said to you? It was the number 30. It was the number 33, right? You were telling your family about it, and I was like, "Holy crap, 33!" Right? He posted that link at 33 minutes after the hour, my guy. Anyways, yes, 33 minutes past the hour. Flatty shared it, and yeah, no, rookie. I'm not by no stretch of the imagination taking what you said without sincereness at all. It's everything for consideration.
Is this saying that they floated the rocks up through that one chamber?
It's the explanation.
Float a rock?
That's how it would work, though. Like, because when you...
Rocks don't float, though.
The video contains you use water. And by using water, you're able to, if you build a raceway, it's funny because Electric and I were discussing the theory of raceways earlier today. But, yeah, no, if you were to slide water down a raceway, it works on a sucking type action, right? It's similar as how you would suck fuel out of a gas tank. Or get fuel out of a gas tank. Same principle.
I like those old tubes that you used to have at a bank that you stick your stuff in and then they shoot through the little tube.
Bingo! Ryan, that was a great lily pad, man. Great example. Everything's possible as long as you have a greater pressure occurring on the other side. You can draw or suction the boulders up using this.
That chamber that looks like they slid the rocks up with. I mean, there's evidence that they were dragging a rope over fucking over the rock.
You got to remember, they lasso the rock, and here's the other thing that's interesting too. And again,
there's evidence that something was dragging against a rock multiple times in like the same spot because it wore it out crazy. Like they cemented it over since, but that we have pictures from before in that same chamber. Oh, there's definitely something being dragged over this one spot, like a lot.
What if? Okay, so you're saying that was evidence of a raceway then?
No, I'm just saying like something was dragging over. I don't know. Maybe they were using pulleys in conjunction with this flotation thing you guys are talking about. But something definitely got dragged over this rock. Like
I got you. It's crazy.
What's the name of that chamber called? I'll see if I can find it.
What you mean
the real
chamber?
name for it, not the flotation chamber. The chamber that were in the Great Pyramid. Were they?
Yeah, I guess it would be.
You know what those
flotation chamber,
contain, right? You know what's in those rocks that the pyramids are made of?
Sandstone, isn't it?
How did they get the crystal into the sandstone?
Yeah. Well, hold on a second though, but isn't sand a crystalline structure already? Or crystalline sand has crystalline properties, right? Glass. Because under pressure, doesn't sand forms glass under pressure.
And the silica. Silica.
Hey, holy shit, dude, you're right. And again, there's evidence that these things were covered in what's that substrate? Granite. They were like crazy reflective back in the day.
Yeah,
right, so that would
best with pyramids, Drake. There's a lot of people. I think they have like this kind of like healing, kind of good energy property thing. Just the shape itself.
No, what I'm saying is, I seen a thing about how the rock itself actually contains crystal, like the kind of crystal, the piezoelectric type crystal, and that the weight of the rocks stacked on each other causes some kind of a magnetic field. I'm not sure if this is true or not. I'm just, throwing it out there.
I have heard stories about people that go to the top and they say it's kind of like you get this electric feeling or something. I definitely say something going on up top. And it might have been crazier if the whole thing was together working. You know what I mean? If they had the capstone on it or the whatever.
Yes, sir. A highly conductive point.
But not electricity, but I could be wrong.
No, hold on a second. Hold on. Let's run with this for a minute here, right? So we have the aspect of, or the understanding or idea that there's fissures that exist underneath these pyramids. So water is going to be an important aspect if we're going to consider what these things did. We also know that the water would have been seawater, which gives evidence to the conductive aspect of water, right? Because seawater is conductive. I don't think fresh water is conductive, but I know seawater is conductive.
Have you forgotten that back in the day, the desert was filled with water?
Exactly. No, I said earlier that the water came right to the Sphinx's paws, right? Came all the way up. Like that whole place was an oasis. Now the aspect of if it were covered in, but if these pyramids were covered in granite, right? Granite again is a conductive material. Sand is a conductive material because glass is made of sand and glass can conduct. And then you've got a capstone made of gold, right? That would indicate that this thing has electric properties from the base, the fissures, all the way to the very top, being the pyramid or the cornerstone, which was removed, the capstone cornerstone.
Or instead of an electrical thing, it could make it could emanate frequency.
Yeah.
Think about it.
Yep.
I mean, there's a lot of different ideas about it, but I don't know if any of them are even true. I mean, we don't know about things. I mean, it's kind of hard to tell like how somebody or how something was made or how something was put somewhere. I mean, there's ways of finding the evidence of it, but I mean, I don't know. You know what I mean? Like, I believe that they could probably have built the pyramids with primitive technology. I do. I just don't think that it would be primitive technology of trying to carry a rock up the side of a pyramid. It just makes more sense that they'd start at the bottom, raise the water level up, and just keep stacking them, or they would make concrete, or maybe it was concrete at some time, and then over time
No.
the sun got hotter or whatever and melted them and stacked them together better. I don't know. Who knows?
Listen to me. Hold on. Rookie, though, something for consideration, though, right? I think it's the Great Pyramid. The Great Pyramid, I think, is 755 feet in the in each dimension, right? Left and right. They vary in dimensions by 2 inches. Modern day building can't even achieve those tolerances, my friend. These were not primitively built structures by any means. There's no way. Even the application of the measurements
they
of
also
them.
told us that crop circles were made by aliens, and we all know that that's not true now, don't we? So I mean, come on, they say a lot of things we don't believe them.
We had a comment in the chat from Doofus Manfred. Now, if flat earthers could only figure out why hydrostatic equilibrium is a thing. Okay, hold on a second. I don't think hydrostatic equilibrium would differ if you were on a flat or round Earth. I think it's just the question of how you understand it to be applied.
Probably doesn't matter, but yeah.
Yes.
Talking about pyramids, you know, the phenomena people call meteors, right? Or sporadic meteors, that phenomena that we can observe.
Yeah.
And people say, oh, those are rocks coming from space, right? But let's not think about it like that. We label this phenomena because there's multiple phenomena on the sky that we can observe. But there is a specific phenomena that is called sporadic meteors. That there is this university, they set up electro-optical equipment, and they set up I think it was 3 cameras 3 to 6 kilometers apart from each other. So they set up the cameras at multiple spots to have a bigger angle of the sky pointing towards the north sky, what we call the north, or where we see Polaris, celestial north, and that. So they utilize this very it's called electro-optical. It's not just any optical device. So to see where the phenomena we call sporadic meteors come from, so after 365 days of observations, they concluded that all sporadic meteors, come from 6 radiant sources up in the sky. And this is specific points in the sky. It's not random. And the imagery that the devices, the camera, the electro-optical camera showed is very interesting imagery. I'm gonna post some of it here in the chat. Let me post it. Electro-optical. Talking about pyramids, right?
Mm-hmm. Bingo, bango. I'm so glad you shared this, my guy.
So the phenomena that we call electro. What was that?
What do you think these images are showing us?
So this is showing a region of the sky from where all the phenomena we call sporadic meteors is come from. So these 6 radiant sources are around this region of the sky. And we were talking about pyramids, and the infrared imagery, 365 days, shows kind of like a pyramid in the sky.
And it looks like almost a cornerstone, maybe, eh?
Look at the 365 days imagery. Electro-optical.
Now, the thing I want to outline that you mentioned is you said, what did they show? This was a measure of what? Radiant, who now?
Radiant sources, where the meteor,
Okay.
when observers stand in the ground and they say, "Hey, let's watch meteors today," they
Right.
always point to the radiant. They're always looking for the radiant,
Okay.
and all sporadic meteors come from radiant. 6 of
Now,
them.
for the audience's purposes, what is radiant an explanation of?
Well, that's the description, how they label it, and it's just basically like a circle, like a kind of like a point in the sky, almost like a circle. I would say it's a circle, and the phenomena that we call sporadic meteors come from those points in the sky, and they label them radiant sources.
Okay, I'm gonna throw up the definition of radiant into the chat for friends so they just understand it. This is the idea that we're looking at a radiant source, right? Sending out light, shining or glowing brightly, of heat transmitted by radiation rather than conduction or convection, i.e., it removes a solid object, right? Conduction is the observance of conducting heat, or convection. Plants convert the radiant energy, so we're safe to assume that this is an observation of gas, right, Gemsy?
It's that phenomena that we see, and is that yeah, that's just, I will say there's definitely got a medium involved, and that medium most definitely includes gases.
So what I did ahead of your shares at 46 past the hour, I posted the gas light color spectrum. So the hotter the gas burns, that's the color that it presents. So if it's blue, it's hotter. As it cools down, green, then red, so on and so forth. What's interesting when we look at sky stuff, shooting sky stuff, is that shooting sky stuff presents these colors, these gas colors. So it's either in a closed gas environment, we're dealing with shooting stars like fireworks, or this apparent open system, the idea that we're dealing with flying rocks. But either the interesting thing, again, from your observation, is the fact that it's radiant sources. Radiant, not radiant. Okay, let's look at that.
Radiant with a T at the end, for my understanding.
Can you guys hear me?
Yeah, we can hear you.
Yeah, you guys are using the whatever key we described, whatever he posted, you're using the word in the wrong context. That's radiant, right? To radiate, to shine, release of electromagnetic radiation. That isn't the radiant related to meteors. You know, like a meteor radiant is where we expect a meteor's path to have started, to have originated. What you just said now, Kiwi, has nothing to do with meteors or sporadic meteors. It has nothing to do with what Ben's talking about.
Well, my whole point is that all the phenomena that we observe and label as sporadic meteors come from specific points in the sky. And they also, these points in the sky also have how do you say, the they kind of have their own cycle, and it's 365 days, or you know, the year cycle. So these points in the sky also reset within the year. So they it's pretty interesting. And one of those radiant sources, guess what, is the sun. One of them. And it all revolve around a certain region of the sky. And then you can see this pyramid up in the sky, this pyramid shape around that region of the sky, which is very interesting, talking about pyramids. And then you can go to this. So you see in the back of the dollar, right? They we were talking about structures and man building pyramids, blah blah blah. And yeah, that's very interesting. Behind the dollar, right, you see the man, let's say man made this pyramid depicted in the dollar,
that is a structure made by man, blocks put on top of each other, however they did it. And then you have a separation from the pyramid of the ground to the pyramid in the sky. And it's like a light coming from this pyramid, which is pretty interesting. And you can see these depictions of pyramid in the sky. It's been emulated by the pyramids on the ground. It's been depicted, and also one of the most magnetic, what was it? Iron oxide. It takes the shape of kind of like a pyramid structure too. It's one of the most magnetic materials on Earth, on the ground. And all the meteors come from this region of the sky, which is pretty interesting.
But Jamsey, what do you think is the significance of that? Because I'm assuming you're a flat earther, you don't believe in space and stuff. What do you think is going on? What's the connection between?
Well, I would say it is a big piece of the cause, a big piece of the cause and effect relationships that we observe from here. So we observe phenomena, which are effects, and there is a cause to those effects. And I see structural, we stand in the ground, then there is a build or a roof, and that those layers that we see the phenomena, we see the luminaries, those effects are being caused by a source. And I think this structure that is all the phenomena, sporadic meteors and the luminaries and all that stuff, all that happens kind of around or below this structural thing. So the pyramid shape makes sense to me. It looks like the shape of creation. It's expressed on frequencies. It's expressed on many things, and even people have emulated this build. So yeah, I think it's the cause of the effects. I will call it the source. That's what I will label it, maybe. The source, the input into the system, the cause of the effects. You can also see an expression of it, like in the, let's say, what was it? Okay, even the Big Deeper, right? The Big Deeper, or let's put it like this. Big Deeper, you can put it like that. And people label it whatever, and also you cannot see the four sides, the four corners, and even the tip of the structure being represented on both sides of the sky. And also you see how people have depicted the thing in many ways. And even people recently depicted like this, and even people in the past have depicted this. I will say this is what's causing the toroidal field. That will be the big piece of the cause of the effect. This is the top of the machine, or the structure, the construct. That's the top piece. See the expression of it and many things. Resonances. So we're basically standing below. Yeah, obviously.
Do you have the link to the actual citation for this? I want to plot it over flat Earth rather than on the celestial spheroid model that they have it planted.
I have the PDFs of the research.
I have a thing that talks
Here.
about it.
Could you DM it to me?
I think so. Yeah. Hold on.
I'll post it somewhere around here. Let me see.
Appreciate you.
And remember, I'm saying the devices utilize electro-optical
Send me a DM so I know which one.
equipment. So there is an observation in place, right? And I think the conclusion of the researchers, let's say they're thinking they're standing on a globe, right, that is spinning. So some of the conclusion might be, in my opinion, incorrect, but still the observation is there. So I'm just saying, many of us will come with some sort of conclusions, I guess, but I'm just saying the imagery, and we're talking about pyramids and all that kind of stuff. And that's very interesting to me. Posted in the live stream voice text. Let's see if it goes through. Some PDFs.
Here's when I get some time, I'll dig into these and plot them on a flat Earth. I wonder how that's going to change the shape that it draws.
You're gonna do what?
Right now, it's plotted on a globe model. I would be interested to see what shape it draws when plotted on a flat model.
Okay, so yeah, I mean, I don't know. I don't know what model I will utilize, but I will say standing on the ground, looking up to celestial north, this region of the sky, and I don't know how would you input in any model. It'll be interesting. Let's see how you do it. I want to look at that the way you yeah. Whenever you're done with that, I'd like to see that.
Definitely, yeah, I'll show it. Just fair warning, it won't be today. It's my girlfriend's birthday, and if I get stuck into that hole, I won't ever see her. So,
Yeah, that's fine. No rush.
You gonna hurry it up or?
Posted it in the live stream text at 11:01 a.m. I just posted the second one from Iowa State University. Take a look at those two. That should help you. Right?
It must be the 12 o'clock for me. Okay. So still going on about the vibes of the cosmos. What's going on?
The pyramid in the sky, the cause of the effects, the source, 4 sides, 4 corners, 4 rivers. The crazy part is that what we call celestial north, that's where they're looking at the north sky, celestial north, from my understanding.
And what was Extremis saying? He was saying something about that. That's what's predicted on a globe model or something. He said.
I think the people doing the research, they set up the equipment, right, and they did the observations. But maybe they were saying, "Oh yeah, this phenomena that we're observing, it's rocks falling from space or whatever, right?" And they might have kind of, in my opinion, a wrong conclusion about the ground they're standing on, possibly.
Is his point? Is the point that, or is his point that whoever gathered the information did it under the idea that we live on a globe, therefore it's a globe?
I think that he might be thinking that possibly, but these people, they, like I said, they set up special equipment to do the observations, because the equipment that they were using before the electro-optical, it was the Canadian meteor observation. They had certain equipment, so they actually build and use the electro-optical equipment to do the 365 days observations. So that gave an extra spectrum of what we can see up in the sky. The electro-optical. So whatever conclusion they had about the ground, I don't think it really matters much. I think the observation itself is very intriguing, very interesting. And the fact that the phenomena that we call sporadic meteors, it comes from 6 radiant sources: helion, anti-helion, south apex, north apex, and the other one has another name. I forgot the other 2. It's you can actually logically think about it in a, let's say, flat, motionless, contained ecosystem, dynamic system, because you need an input. You need I think is a big piece of the machine that it's required to be able for us to be able to see the phenomena that we call the luminaries and the input into the system and the flow of because I wouldn't say it's just input, it's like a flow of energy.
And
But yeah,
I mean, I don't have any thing to back up this claim, but I do believe that somebody, the powers that be, know how to harness some of these energies. They know the reason for it. Like they might know. I don't know. They might know that the one star Capella powers volcanoes. I don't know, and they might know how to harness that energy the same way we harness solar energy.
Oh yeah.
And these things in the sky. That's what I posed that question. I say, well, what do you think the stars are for? They say, oh, for navigation only. I say, I don't think so, man. I do not. I think that's just like a byproduct. We use them for navigation, but that's definitely not what they're there for. They're there to power, receive, and give back power to the earth that we live on, or the oceans, or whatever.
The stars are like an expression of the toroidal field, so those are effects that are being caused in that medium of the sky. And the toroidal field that is being caused by the actual structure that I say is above the layers that we see, the roof above the layers above our heads. Above that is the actual structure that I'm saying is a pyramid, a four-sided pyramid.
Have you
So
guys
that
heard
will
what
be-
the popular science interpretation is of stars? Like what their purposes are?
No.
Like what astrophysicists say stars are there for? I'm sure you've heard, their whole idea that stars are the building blocks of life. We are stardust and all of that. Stars are what allows us to be here. Like we are deeply connected to them. You guys don't find that a bit poetic?
I've heard we're made from the stars. Yeah, we came from the stars. Yeah, I that it's like a secret hidden truth. Is that what you're saying?
No, I mean I just feel that like it shows how significant we are, in the grand schemes of things. That it shows how on such a deep level we are connected to everything else that's out here. If we are made of stars, if everything we know is made of the same stuff, we are deeply connected to the world we live in, right? We're made of the same stuff that the dirt and the wind and everything else is made of.
Well, we are in this environment or this ecosystem, and without the input that is coming into the system, including what we observe of the luminaries, the stars, which is part of that expression of the input, without that input, there'll be nothing. There'll be no this conversation. There'll be none of this. You need that.
But what do you mean by input? Like input of what?
Okay, so from above, what we see, the light coming into the system, flowing into the system, because there's an in and out, but there is a resonance. Let's say people say resonance, vibration, sound, all that is being inputted into the system.
What system? Earth? Is Earth
the system that we're in?
What system are we in? Like, what do you mean?
The place
Earth?
that you're standing on, the place you're standing in, the place you live and do things. This place.
Where we live, this system. So you're saying
well we live in our bodies, right? We live in our bodies and we dwell in this system, in this environment that we're in.
Okay. So then the input into the system would be heat or light from the stars and the sun. Is there a corresponding output? Or?
I'll say it's a flow, from my understanding.
Okay. So you would say even that shows that there's a deep connection between this system of ours and the things in the sky beyond our system. We are interconnected, whether we're sharing energy or light or heat or whatever.
So
Still
cause and
sounds like
effect
he's saying it.
relationships, right? Cause and effect relationships because there's layers above our heads. So the sun that is inputting this light and causing temperature to change and plants to grow and that kind of stuff. Because it's not just the sunlight causing the plants to grow, right? You need water, you need nutrients of the soil. It's a combination of things. And you're saying the phenomena that we observe as the sun of the moon is doing their thing into the system, and then the stars at the layer they are part of that. We can observe that toroidal that is doing a circle in the sky. That is part of the build. And what you're saying about the relationship, yeah, it's a cause and effect relationship and a expression of that from the sky that we can see it above, expressed in the sky, down to this place, down to the ground. So what you see in the sky, it's an expression of that.
Well, I mean, chicken or the egg? What came first? You can't answer this, and then you lost that. You lose all credibility. Chicken or egg?
You're asking what came first?
Yeah, not really. You don't really lose credibility. But what came first? Did the star create the Earth, or did the Earth create the stars?
No, the stars are effects of the build. The build has to be set up. It has to be set up the specific way, the way it is. The machine, the clock, it has to be set up with the layers and the environment correct to do what it does. Those cycles in the sky are not random. And those effects that we observe as the luminaries are part of constructs. And above the luminaries is the source of that, the cause of the effect. But it's not
Why
just
not
one
below the
thing
Earth?
doing. It's not. Yeah, it's a combination. I'm saying that including the Earth, below the Earth, and above it, it's a combination of things for this environment to be happening. It's not just one thing doing everything. It's a combination of things, cause and effect relationships. And I'm saying the input into the system is necessary because we could have soil, we could have rocks and this and that, but without the input of, people call it energy or resonance or vibrations or whatever, without that input, there'll be nothing going on.
So we could all unite as one, and just kill stars from the ground with our
Kill the
input
stars
from the ground. Everybody,
Yeah, from the
think
ground.
thoughts now. Boom, take them out.
Yeah, right. I don't think we can devise something to break the sky. I mean, ourselves. I don't know. You will have to go through certain layers to reach the stars.
Yeah, so like when
Or
these
whatever
stars,
that
they say
is.
these stars, they say these stars burn out, right? Like they're gone from view or whatever, right? Is that us changing something on Earth? Like, did we do something to burn out that star?
I think you're talking about, they're saying that the stars are other suns, like the sun that we observe every morning rising, right, and setting. That
No, I
that's
mean,
just crazy.
whatever they say. But if the fact remains that the star is gone, whatever it is, if it's gone now, if it was once there and now it's gone, whether it dimmed so that you can't see it, or something went in front of it, or it literally is gone.
No, because the stars are just an expression of the toroidal, the input into the system. Like you could put a magnet under, you could make a chamber with gases and a magnifying glass, and you put a magnet in between these two, between the chamber, and you get a field, like a toroidal field. You can see stars as well in the lines that the field crosses. It's just, I don't think the
Yes, but I'm
stars
saying that
are
energy.
this. Yeah.
Yeah, the energy that's lost, that I'd imagine, right? When a star is, if a star is there, right? If I'm making that field, right, and then I, with the magnet and stuff, and then I make like a little adjustment, or I walk in with my 5G cell phone, and then two of the stars disappear. Doesn't that tell you something?
Yeah, I mean, if that's a phenomenon that is happening, I wouldn't be surprised.
But yeah, I'm just pointing out that. I mean, I haven't verified that stars really disappear from the sky. I don't know, but I mean, I've heard it. I've heard that they're not. You know, some they're there and then they're gone.
Yeah, I wouldn't be surprised because of something phenomena like that happens. But for my understanding, there is you know, the phenomena we call stars, and they're moving in this cycle, and that's just the way it is.
Yeah.
If
And like when you're born,
maybe because there might be lights in the sky that are there temporarily, right? We see people call whatever the comets, these lights, right? That we can see temporarily, and then they go away and they come back. And there might be, like you're saying, there might be a light in the sky, and then you point it and it goes away. I'm not surprised by that.
I mean, in this, I mean, maybe it's just a coincidence, but when you're born and a human being is born under a certain constellation, they're made a certain way, and they seem to have very specific personality traits.
Expressions, yeah, you can see the expression kind of higher expression depending on the year and the alignments of the luminaries or whatever, but still it's a spectrum of people can learn things, right? But yeah, I think there might be some type of imprint maybe by the moment of conception or something, that it might be related to the input
Then it
into
would
the
be difficult to
system.
say. Yeah, is it when you're conceived or is it when you're born? I mean, you're under certain. If it's 9 months away or whatever, but it seems to be more exact when you're born. I don't know why it would be that way, but I would imagine it should be when you're conceived. Under what constellation?
There's 14 astrological placements that have to do with your birth time, your birth date, and your birth location. So even down to it's within half an hour, it changes for your ascending sign. So knowing your birth time is important. But I see it all being related to your birth time. However, the observation of conception point is also something I think is worthy of mentioning. It's a good point. But the other thing, again, 14 different placements make your astrological character. You have your sun sign, your moon sign, your ascending sign, and there's a whole Mars, Jupiter, all kinds of stuff.
Yeah, like I could just say, well, we just got to rotate that personality clock because we're all born 9 months after conceived, but then we're not all born 9 months after conceived, so that kind of breaks that idea. There's premature people, babies born, and people who go longer. I know we really was 9 months. I think it's more like 8 months. But. If I was very rich, I guess I could just build an army of affordable children. I'd probably start calculating it to the stars and be like, all right, I want this dude to run this part of the world, this dude to run this part, and start popping them out. Have the exact personality I need for the situation I need.
Yeah, no one person can do every task. You need people to do different tasks. Let's say in a family or community or nation.
Yeah. One little Virgo baby to plant all the plants and feed us all. Then I'll have another little Taurus baby to do different things and bunch of Geminis to avoid confrontation and be sneaky about it.
I'm a Gemini and a twin at the same time. Identical.
Sneaky son of a bitch.
You guys know who JP Morgan is?
No, never heard of him. Who is it? A member?
So JP Morgan he made a lot of money. And he eventually became what we know as JP Morgan Bank nowadays, of course.
But he was famously known for his involvement with the Titanic, not showing up for the maiden voyage of the Titanic because he had a room booked and everything on the voyage. But having said all that, he was famously quoted as saying, "Millionaires don't use astrology, billionaires do." So it's to say that it's the observation that astrology can show important times as to when wealth can be made and wealth can be lost. So again, very worthy statement to have, one type of sign controlling finances, another type of sign controlling science stuff, like Sagittarius folk. They tend to be really good with the science stuff.
Oh yeah, there's cycles to things, including the finances and the way money and the currency, because currency, energy, the input into the system. if people didn't put their energy, their currency into the system wouldn't work. Just like I was talking about the input into this place that we're in, and that input is coming from above as a design, as a design cause and effect relationships.
Gemsy,
And the finances definitely the big people that actually depict these things and utilize the cycles to move the money. They definitely they do use the cycles for sure.
And think of the words that you just used. Currency, right? Currency, right? I think I spelled that right. Currency versus current that you observe with electrical current and also the water current. It's all the observation of the terms, right? Currency, current. Know what I'm saying?
Mm-hmm.
Yeah, but I think that's on purpose. I mean, I think that's the reason it's called currency.
Catch the flow, man. Currency.
Yeah.
It only has value because you're promising to put energy into the system and get stuff done, and being rewarded with the whatever token
Yeah,
or
I'm literally on the side of the highway, so let me just get this thought out. Isn't it funny how it's also a conductor of man? And that's all I want to say.
What's a conductor?
That was the currency is a conductor of man.
Huh.
Think about the ones who conduct. Think about the currency, right? And then think about the conductors. I mean, it's a crazy concept. That is such a good, another good observation. Holy crap, man.
Yeah, but I mean, I don't know. I don't feel like these things are like sneaky. I feel like they're on purpose and you're supposed to in this way. Like, bad conduct, like poor conduct.
Now imagine that's coming from yourself, right? And you're here engaged in this chat and we're throwing that ball around. Imagine, do you think your ignorant friend down the street thinks the same way as you, my friend?
I think he doesn't even have to think about it, but he understands it the same way.
This might sound like a stupid question. Is the sun on an elliptical orbit or a perfect geocentric circle?
Perfect elliptical orbit.
Perfect elliptical, so it's not in a circle.
What are you asking? What specifically?
Is the sun on a circular path or an elliptical orbit path? I'm on the side of the highway.
So the sun is in this cycle they call the yin yang sign. It makes like an 8 in the sky, like a number 8, the infinite sign. People say that's my understanding.
But
the sun makes this.
But it could be making that sign not due to it being elliptical. It could be due to rising and lowering, and therefore being a perfect circle being perceived as elliptical. Yeah.
So that's why I wanted to say, we're talking about currency, conductor. You could throw in the word circuit, could represent circle, but I'm a super reacher over here.
Yeah, circuit doesn't mean. I mean, circle, circuit, they're similar, but circuit just means you can make it doesn't have to be even close. It could be a square. It's wherever it started, it went back and made a full circle. But yeah, circle. I mean, that's exactly what a circle does. And any point on that circle could be said to be the beginning of it.
That's assumed if we're dealing with an axial rotation, right? Are we assuming an axial
We're talking
rotation of the sun?
I'm assuming a circle on a piece of paper, right? But
So
yeah,
what
whoever asked about it being a perfect the sun being a perfect circle, I'm not, I couldn't attest to it exactly.
I'm just overanalyzing words with a CIR or CUR.
Circus?
Circus, circuit, conductor. I don't know. Whatever. Please, sir, can I have another?
And does it make more sense to be in a perfect circle? I guess it makes more sense.
What, the
Only
sun
because I
being a
guess
perfect
time
circle?
zones, maybe
Or the
time
Earth?
zones, etc. The sun, the Earth being a perfect the Earth doesn't need to be a perfect circle at all. I mean, doesn't
I
need to
think
be any shape.
we have circles present on the plane. I.e., I think that through circumnavigation, again, there's another sir for you. With circumnavigation, we can even see that north, the relationship between north and south, where you have north as the center point, and you circumnavigate north and realize that south by default is the ring around north.
Yeah, interesting enough. They just did this. What is it called? An ocean race or whatever around the world. I think it came to like maybe 40,000 miles or something to go in a big circle. And it took them 2 days, I think. Or no, 6 months. I'm sorry, not 2 days. It took them six months.
Where did they cut through? Did they list the points of that they traveled?
Mm-hmm. You could just Google something along that lines, like 2022 ocean race.
Ocean race? Thanks, man. I'll look it up now.
Yeah, I mean, there's flat Earth proofs everywhere. I mean, but nobody really realizes them. Like, and that's why flat earthers don't need to be that smart. I mean, I don't need to know math and geometry. I know you fucking went around a circle, and it took you longer than what you said it should. And you went twice the distance. That's it. Done deal.
That makes me want to ask this question. Is the ISS considered to be on an elliptical orbit, which is, being helped by gravity? Or is it just flying in a circle at 40,000 kilometers an hour? I don't know.
Yeah, I asked a Glover before, like, how do you deal with the reality that we've never seen anti-gravity? Like, we've never seen anybody just float in the air, right? You've only ever seen them free falling in a orbit. You've never actually seen just somebody floating motionless. It's like a stupid thing to say, but
Coming back to your observation about the race, the ocean race, why didn't they go through the Tasmanian Strait off of Australia?
I asked them the same thing.
Because the Tasmanian Strait off the coast of Australia would be the observation of the 60th parallel, and that would be the extremity. Right. That's where that big boat or that fishing boat got caught by the big boat for trying to go through. But that's the 60th parallel. So if you're going to feed me a story about going around the world, you got to show me you're going at least. You got to roll past Australia. It's a must.
I think
Wait,
I'd have to look at the map.
Showing a globe through navigation, that's it? That you're talking about?
Say what?
You're saying that they have to do what to show the globe?
If you're going to
go
say
to
that
Australia?
you successfully circumnavigated our plane, you have to go through the Tasmanian Strait, minimum, or at least go by Australia. You have to. It's a must.
I mean, even if someone accomplished certain type of route on the waters and reach point A to point B to point C, in whatever circuit, they gonna be doing it not on a globe, 100%.
Right. So if you
There's
go
no
to,
there's no
did
way
you
they'll
hear?
accomplish any movement on these waters if this place was spinning and curving at the same time.
Okay, so Gemsy, did you take in the point that of this 2022 ocean race that sorry, I just gotta look at the name list.
Yeah.
No,
The
Tanks just
ocean
outlined.
race.
Yeah, no, but so when I looked at the route, they show a route off of the coast of Africa. Now,
Yeah.
okay, that's the coast of off of Africa, but I don't know how this successfully shows that you went around the world. It just
They're
looks like
just
you drew a
navigating, bro, on
random.
the
Yeah,
waters.
you drew a
They'll
random
never,
point and just went with the path. Okay.
bro. If
If
you
look at
come if you come on board of any of these boats and I'm the captain and you bring a globe and start telling my crew that you're gonna use this spinning globe to navigate us around, I'll throw you off the boat.
Yeah, so if you look at the map, I mean, if you look at the route that they took, and you put it onto a, I guess a flat AE map or whatever, it's just a big circle. It is a big circle. I mean, I'm looking at the map, the routes that they put up, and they're showing like 4 Africas and 3 Australias, like trying to stretch it out to show how they went around the globe or something. I don't know. On a mercate, like on a flat projected globe. But
I stand corrected. It's there.
Yeah.
Yeah, you're right. You got the southern tip shown, Cape Town, South Africa, right? And then from there, they went to the 60th parallel. That's where that point would be. That is the Tasmanian Strait right there. That's where I missed it up. I was looking at the map totally on the right. My bad, guys.
So they are
Yeah,
going
but
to the
yeah.
place you're saying?
Dude, that's it right there. That if you look at the point where you've got Cabo Verde, then you come down, you've got Cape Town, which is the southern tip of Africa, right? Then you head east. That is Australia. That's the Tasmanian Strait. Now, when I show you the map of the moon, and I say like that, the 2-3 o'clock position, you see Australia. That's that tip. That would be the outer ring of the moon map. That point right there.
Yeah, so I mean, I don't think they were doing it to prove anything about the Earth. I think they were just having fun doing a race around around the ocean. But then you look
They're
at the route, and,
definitely they're definitely enjoying themselves and concentrated on water and currents and wind and that kind of stuff.
yeah, it's just that when you step back from, I guess, our perspective, and so they shouldn't have had to go 50,000 miles around a 24,000 mile, whoa, 40, 45, I think.
It'd be interesting to find out between the Tasmanian Strait, right, that point off of Australia, and they show the path going to the east, connecting with South America. I would be curious to know if there were what their observations were, what they saw along that line, because that is where I believe you would be observing the ring, the Antarctic ring, so to speak. So that's the southern point. That's where you can't cross.
Yeah, I don't think they got close enough. That's what I mean. I don't even think they got close enough to the Antarctica to see it. I don't believe they did. If they did, they probably have some different stories to tell. Like, yeah, man, I just kept on sailing against this ice wall, and I don't know what the fuck happened. That was crazy.
This is gonna sound crazy what I'm about to say, but I can imagine, people wanting to circumnavigate the entire quote unquote globe, and then they go to try to get permissions and grants, and then someone just makes their entire fucking itinerary.
These guys all did it. I don't know. I'd have to look up how many people did it. There's a bunch, a whole lot. It was it was different people from around the world, or just racing, having fun, racing around on these, speed sailboat. Like, I don't think there's no engines. It's just sailing. Took 6 months to sail it, I guess. I don't know where and then it shows, they had to obviously park up and, get a shower and eat and stuff.
And you gotta sleep as well, right?
You gotta sleep, you said?
Yeah, on this trip, people have to sleep, eat, rest, but
Yeah.
you have a full crew to take care of everything.
I mean, it's not a. And that's what I'm saying. It's not a steam engine boat. They're like sailboats, like wind powered
Yeah,
sailboats.
Wow, yeah, that's amazing.
Yeah, it's unreal. Yeah. That's what I mean. I don't think they're nobody cares until they realize they're lied to, right? Like nobody gives a shit until they question it. So I don't think they really cared about that. It's just funny that it comes out as a very strange anomaly on a globe.
So what do you think? They just say, okay, we're gonna head due east, and they just keep clocking east? Because even that, I think, because a circle on a plane is not a globe.
Yeah, but that's
I mean,
why we circle navigate.
But nobody navigates in a circle like that. People go from port to port. From if
Not
you're
all.
sailing if you're sailing, you have to go with the wind, right?
No, you
That's what I was suggesting
circumnavigate.
before.
You circumnavigate.
Oh, is it called the Golden Globe race? Oh, shut the fuck up.
Golden Globe race.
But if you know, like, an island is due, like, east X amount of units, degrees, and all these things, the direction, you know you're traveling in that direction, right? But that direction is relative to a central point. And that central point is ultimately north, that central point that we observe. I just talk about circumnavigation from a standpoint of, like, okay, well, if these guys say that we are going to go around the world, then are you circumnavigating a central point to say I'm going around something? But what is the thing that you're going around to say that we're going around the world? That question, is it not?
Yeah. I mean, they figure it out. They going long distances on boats, on the water. So yeah, they can navigate for sure. 40-something thousand miles. They figure it out for sure how to navigate.
So I'll counter with the idea of what's called control points. Control points meaning, like, places that you may be in a boat, but you have to maybe go to landfall. Maybe they have places along this ring where you have to have your touchdown points. I don't know. I'm throwing ideas out there.
That's what I'm thinking. If there's a group of people that want to, go around the world with a boat, they're going to say, okay, well, you can't go here, here, and here. And this part of the ocean is actually very dangerous. There's a storm front, so don't go here. And this is now the legal type of surveying. You're basically surveying like the most safest way to navigate the globe in this time period. So they could just throw any variable at you and say, "Oh, sorry, I can't do this right now." But that's me just
You have to
speculating.
follow this path. You have to follow this path and don't get away from it. Go ahead, navigate. If you have to stay within certain areas, I mean, how do you know there's other ways to do it?
All these questions come up to me. Who's providing them the data when they're on international waters that is like mostly being surveyed by the government? And they say, okay, you're now at this tournament, man. Turn a little bit left. And okay, well, we're in the middle of the water. We don't know where we are. And we're trusting this guy to tell us where we are. He tells me to turn left because I'm going to go head towards the storm front. What if he's just telling you to, like, they're getting a little too close to the ring, guys. Let's make sure they don't see that thing.
Yeah, we need to reinvent the whole thing of celestial navigation if you want to find out the place that we live on. What I mean is,
I don't know if they win at night or day.
what I mean is, if you're using one reference frame, I mean north, regardless if it's the magnetic or the celestial north. If you're using the celestial north, if you pass the equator line and you can still see Polaris, you still can have angles of elevation to Polaris, meaning that your circles around Polaris just increased beyond the equator line. Problem is when you don't see Polaris anymore, and you need to turn around in order to see another reference point in the sky, the Southern Cross. And then you do elevation again to the Southern Cross from the same horizontal plane. So you have two circles on the same plane, which is the lines of longitude and latitude that we guide ourselves from. And you can never go beyond those lines.
I don't know. Is the Southern Cross a good thing to navigate by from the equator? Isn't it very difficult to see?
The Southern Cross, I don't know.
I don't think it's an easy thing to navigate. I don't think it's used very often.
No, what they use is for the grid system. You know, you need to have a grid system, a Cartesian system, lines of longitude and latitude. So they do elevation angles from Polaris and elevation angles from the Southern Cross, meeting at the equator line, which is the movement of the sun overhead. That gives you the zero, and then the so-called poles at 90 degrees. So you need to have a straight line from the equator line to the poles in order to have a 90-degree angle for the elevation, meaning it's flat throughout on both sides, same plane. And we use those coordinate systems to navigate on. So for you to pinpoint your location on the surface, you need to use those grid systems, the Cartesian systems. Problem is when you go beyond them, what happens?
Oh, no. But
You don't,
yeah,
you
what
don't
we were
have, you
talking
don't have
about was
a reference? Yeah, go ahead.
yeah, what we were talking about, George, was how there's this 2022 ocean race performed, and they went and they appear to have gone in a large circle on the outskirts of the world, right? Like kind of whatever it was, 10,000 miles off of, or whatever, 5,000 miles off of the coast of Antarctica. I'd have to look that up exactly, but somewhere off of that coast, in a big circle, and it took 6 months, and they sailed 45,000 miles around a 25,000 mile circumference globe just to go in one circle.
Yeah, I heard of this before. Yeah, it was a competition of going around the Antarctic continent, the so-called island, but it took them 6 months to do so.
Yeah, so it's not like the
Yeah, it's not
1717
the
or 1786 ones. This is the 2022 one.
Yeah.
And I mean, I know the ones from the past, where they had a big vessel. They were trying to map Antarctica, in and out, outlet, going in and out of the land. That took, I thought, years, but this was a race. It was mapping.
That's why I still insist the only way we can find out the truth is by playing this them. Trying to begin this record or something or a survival, places that you wouldn't go. With an issue license for you to explore if you want to explore, they wouldn't let. If it's addictive,
I couldn't hear you. It might have been my phone, but I couldn't hear you.
He was
Sorry,
he
guys.
was cutting out. Yeah.
I apologize. I just had my mic open. I wanted to share. So I threw it up in the chat, a link to a video from my channel about a fishing boat apparently that tried to make a run, and that's off the off the coast of Australia and Tasmania, called the Tasmanian Strait. Apparently, that's the 60th parallel. That's where the treaty kicks in, the 60th parallel. So this big boat stepped in. It was it's an 8-minute clip of the interaction. Take it for what it's worth, right? Feel free to, I don't know,
take it on face value. Think it's a lie? I don't know. Yeah, take it for what it's worth.
Yeah, I mean, who would lie? I mean, I've seen the video. Who would lie? Like, you tell me that government with that big ass battleship was in on the lie? I don't know. And they'd all have to be in on it, right? Like,
you just say
well,
who? Why?
Realm asked a question in the chat. How would you know it was the 60th without assistance? Well, just by knowing that that's the 60th. You're in the area of Australia and Tasmania, and with I guess you can realize that based on the location and the world map, with the longitudinal and I guess it'd be a latitude line. Yeah, it would be the 60th parallel, right? The latitude, because latitude is what draws the rings around the central point. Because longitude would measure the orientation in and out of the central point.
I wonder if the place where Jesus supposedly was born is on the 33rd parallel.
Nah, they do it from they do it from two different reference points. They use
I was just kidding.
They use they use elevation angles from Polaris, and then they use elevation angles of the sun. So they use the sun as the zero line.
is the dude
So the
realm?
Cartesians,
Like, how do you know? How do you know? Other than them saying, "Hey, we're going across the 60th parallel, and look what's happening to it." Like, how do we verify without believing them?
hey George, George.
Well, it is a valid question, but
So George, you mentioned
how do we know
celestial
anything?
north. I've seen people talking about mostly magnetic north, right? The compass pointing to magnetic north, and then there is geographical north that is depicted on a map. People depict a certain point and they put it on a map as geographical in the map north. But then But then there is celestial north, that is the actual reference that you could probably see from most of the navigations. You can build the Cartesian based on that point in the sky and the degrees that is on above your head, right? So that's why that's an important, because people say, oh, navigation with the stars. Yeah, but the main reference point is celestial north, and then you also use the position of the sun and other stars to be able to put together as an orientation.
Yeah, it can have the from 0 plus or from 0 minus from that line of the equator, depending which side you are from that line.
Okay, yeah. Yeah, it makes a lot of sense actually. So, not many people speak about celestial north in that sense. I mean, practical people do.
Imagine you have a protractor in your hand, yeah, and you draw a horizontal line from the 90 degree all the way, to the end of the protractor, the 0 line, yeah, and then you have an angle of elevation, 90-degree angle, where polarity is just above. So you need to have a straight line between the equator line, 0, and the 90-degree polarity.
Is there where in an actual place that we can go can Polaris be 90 degrees above my head? Like I'm standing on the ground and above my head 90 degrees I see Polaris if I look 90 degrees. Like where in the world can you do that?
I would love to be for someone to be able to demonstrate that, and I don't think it's possible, because in the north, in the globe, they give us an empty space, isn't it? Where the magnetic north thing is in an ocean, isn't it?
Yeah, but they
No,
also
that's the
claim that
geographic
magnetic lines curve, and we all know they don't.
It's
Not
the
like
geographic North Pole is where you would see Polaris directly overhead.
Yeah, but again, we still ask
Or
for
can you even
someone.
get there?
How do you get there? That's the question.
With a boat. Or if it's frozen in the winter, you could get on the ice.
Are you going to find Santa Claus on the way? I mean, I don't know.
You might.
I think the thing is when you put cause and effect relationship, I think the people say that the magnetic north it varies, and I think it has to be in relation with what Polaris actually represent as an input into the system, and maybe the small circuit that Polaris does in its own place is actually kind of moving that magnetic region in the ground a little bit.
No, the magnetic North Pole is pretty good ways off from the geographic. It's like 1,000 miles off or something like that.
Okay, because that's what I say about that. Because there's three norths. There is the one that they give us on maps. Oh, look, you see this map? You see this picture right here? This point is geographical north. We're talking about map, a representation. But then you were talking about magnetic, that you can build a compass to kind of follow that magnetic north. And then you have Polaris, which is celestial north. Which that one is right there visually always.
Yeah, that one coincides with the geographic North Pole.
But the geographic is in the map, not in reality, right?
No, it is in reality. There is a point. There is a point of rotation.
That's correct. But the information that we get is in a map, right? I haven't been there myself.
Yeah, but the geographical one is driven from the grid system, on the map. We're assuming Polaris GP overhead and angles of
90
elevation.
degrees.
Yeah, correct.
Yeah.
And then as you move away from Polaris, your lines of longitude increase. You're moving further away from it.
Yeah. But my thing is that in the depiction maps that we get a lot, that geographical north in that map is not necessarily the actual geographical that we can walk to and see Polaris at 90 degrees.
That's correct. There is a correction if you're using, depending which north you're using. If you're navigating, there is a correction need to be done, depending where you are.
So the maps, probably the depicted maps are kind of incorrect.
If you are navigating using only a magnetic compass, you're going to circle navigate. If you go east or west, you're going to end up in the same place.
Yeah.
You're going to go in a straight circle around north because your compass will be pointing at north always, and you go east or you go west. That's circle navigation. Now, if you want to keep your course, if you want to deviate from straight, you cannot guide yourself by the magnetic one. There's corrections that need to be done.
So have anybody held a compass in their hand and be under Polaris 90 degrees and look and what is the compass doing then? Going in circles?
I would love someone to do that. I'd like someone to be able to do that. They say they can't do it.
I want to do it.
What about the north? Can they do it in the north?
Let's go, bro. Let's go 90 degrees under Polaris and see what happens with the compass.
Why not, man?
Take photos.
I mean, whoever invented the compass already must have known that, it's pointing somewhere. It's pointing somewhere,
So one point that I wanna, because I'm just talking obviously, but about the north, geographical north, celestial north, and now magnetic north. Is that what we call magnetic north? Is that I've seen people talking heard people talking, saying that magnetic north is not a specific point, that it varies, it moves.
I don't think it does, to be honest with you.
Okay, hold on.
I think that's a global cues as to why there's the axial deviation, which is what we observe from the sun movement from one equinox to the other. Again, it depends which point you're guiding yourself from. If you're using sunrises and sunsets, your north is going to deviate.
Yeah.
You know what I mean? If you're measuring
Sailors
from
use
sunrise
to
to
navigate the world.
the east and west positions, you don't need to know the north. If you guide
Yeah.
yourself by east and west, you'll know
Yeah.
that at
Yeah.
12 noon the sun is above your head. Either it's aiming south or it's aiming north at 12 noon. One of the two, depending which side you are. So you don't need to use the magnetic one. Depends what you're using. Now, if you're using different reference points, you're going to have different readings all the time. You're just going to equivalent yourself even more.
No, that's very practical. Yeah, I get it.
Now, George, don't you use a sextant?
What if you get to the north and it's dark?
Don't sailors use a sextant to figure out their location?
Absolutely.
Okay. And don't they observe the sky stuff to figure that stuff out?
Yes,
Correct.
they do.
Okay.
And not only that,
So with the backup of Electric, because he's still here on the chat, we've entertained the idea that there's a potentiality of a hole at the center of the crust, the Earth, right?
Oh yes, we did.
The black hole sun. The black hole sun has been. Hold on. Slow down. Let's put it in park for a second and talk about this because this is huge. Gemsy and Electric just had a baby, and I think it's called Polaris. Reason being, there's a void at the center of the Earth. There's no magnetic rock. Okay, so there's no magnet that North is attracted to. So, gentlemen, I believe that the main field of the attraction point, if you want, the primary north, is heavily driven by the location of Polaris because we observe the movement of north ever so slightly. There is a variation that's reported, and that variation is because it's the star that north is tracking. That's why the variation occurs. However, if we all circumnavigate north, south is behind us, and north will always be a central point observed, whether it's in the sky or it's on the ground, because we are all relative to the North Star. Because sailors use the sextant to figure out where they are, right? If North Star, you can see the North Star, you can always find your way home.
Before you start using the sextant, you need to know a few things. You need to count the Earth to be flat and stationary in order for the sextant measurement to work.
No, that's not true, George.
Yeah, it is. No. He's proving a point right now. George, keep going.
No, the celestial bodies, the lights in the sky, to be moving and not the ground beneath your feet. If you're using the sextant, for example, during the day, you need to wait. I mean, using the sun as your reference point, you need to wait a few minutes apart for the sun to move to a different position. So it's not you moving to a different position; you are still on the same position. So for celestial navigation or for any navigation whatsoever, you need to account for the Earth to be flat and stationary.
I'm ready.
Thank you so very much for proving that point, my friend George.
Yeah, but how do you accommodate for the 1 degree per 60 nautical miles? That doesn't work on a flat surface.
Now that's what you're saying. Listen.
No, that's fact. It's observable. You can observe that.
Let me address that. If you're doing celestial navigation using a sextant, you can only use up to 90 degrees. You can never have more than 90 degrees. What you're trying to do is trying to divide 360 degrees, to give you the measurement of a globe. That's not the sextant measurement, You can never have, for example, 91 degrees, because if the star is above your head, it's above your head. Any direction that you move, you'll have minus 90 degrees, 89, 88, so on. You can never have more than 90 degrees on celestial navigation. So the 60 miles ratio per degree is between 15 degrees of elevation and 90 degrees of elevation.
So let me ask you this, George. Why is it that I've never seen and no one's ever attempted to demonstrate sextant navigation on a flat Earth? No one's ever done it. I've not seen it.
What do you mean no one's
What are you talking about? Are you
man? What is wrong?
The only examples I've seen are people using globe mass and presupposing they're on a spherical globe.
Can you give us your definition?
Lost your mind.
Your definition of an elevation angle, please.
Yeah, it's a elevation of a celestial body above the horizon.
Exactly. You used horizon in your definition, and the horizon is observed from left to right. The issue with commonplace
The
use of
horizon
the
is not curved,
sextant,
my friend.
they
Above
discount.
No, it's not. It's not supposed to be curved.
They discount the use of the horizon and the use of the sextant. This new globers, right? You can't discount the use of the sextant when you show celestial navigation using a sextant.
No one discounts using a sextant. Everyone knows you use a sextant in celestial navigation.
Then why are globers reporting not utilizing the horizon when you use a sextant? We have that on record in a few different places where globers state you don't utilize the horizon to use the sextant. That completely that's befuddling.
If you use the bubble sextant, there's no need in using the horizon.
Yeah, correct.
So you're telling me then I'm gonna, okay, so
but if you're using the nautical sextant, you are using the surface of the Earth to navigate, because you are aiming at the surface of the Earth, the horizontal plane. So you're going to draw a tangent to a horizontal line, and that tangent to the horizontal line needs to be corrected in order to be at the 90 degree with the zenith line. So you need to do a height of eye correction. So you need to deduct the height of the observation.
That's if you shoot the horizon. Yeah, that's if you shoot the horizon. You have to do it. It's called a dip correction.
Using the surface of the Earth is one thing. If you're using a bubble sextant is a different thing, or an artificial horizon.
Correct. Yeah. You don't have to do a dip correction with a bubble sextant.
Correct. But if you're using the surface of the Earth, yeah.
So the horizon must be below your eye level, or you wouldn't have to do that dip correction, would you?
Correct. If you were in the water, you wouldn't have to do that.
So why is there a horizon on a flat surface, and why is it below your eye level?
Because it's different levels, isn't it?
You're on an elevated vantage point.
Exactly. Different levels, bro. Come on.
The horizon always stays, and the thing about the horizon always stays level from left to right.
It's like you walking on the plane and asserting that your eyes are at the same level as your feet. I mean, it doesn't make any sense.
Yeah. Well, as far as referring to the horizon not curving, it's not supposed to curve. Even on the globe model, the horizon's not supposed to be curving.
It doesn't curve. It's not the leading edge of the sphere. It moves with the weather.
Supposed to. Yeah.
Okay, so
the horizon with the weather.
It's a paper towel model then. Or are we too small to see the curve from left to right? Ants on a
that's it. It's a ginormous ball.
Yeah, that's
okay, so you're proposing multifaceted like a golf ball, multi faces to one giant orb.
No, I don't.
Because above sea level, that's another thing that a lot of people relate to is above sea level. And I can't figure out how you report above sea level on a globe.
That doesn't make sense. I don't know what you're saying there.
Above sea level is a common observation that's reported on land surveys. When they survey land, they'll report, like here in my local municipality, it's like 150 meters above sea level. So they report above sea level as a common observed thing. So it's like you establish the point of sea level, and then you say, okay, well, we are on land, which is above that sea point.
Right.
I understand how that rationale applies to a globe model, because I'm thinking, how do you rationalize above sea level on a globe?
Well, I don't understand what your problem is with that.
It does, because it's called planar surveying. So they already know.
You can draw a circle. You can draw a circle, and then you can draw another circle that is maybe 1 inch in radius larger than that circle. That 1 inch radius would be level to the surface.
Yeah, but
level to what surface?
You
the surface,
need a plane for your
the circle that you just drew.
Okay, so
Yeah, the
you made it.
elevation. There is no elevate, no
Do you
problem
know
with
what the
elevation
definition
on a
of level
globe.
is, dude?
There's a lot of problem with elevation on a globe because your
No,
elevation on a
no, there.
globe.
You
Hold on,
say
hold
that,
on,
but
hold
there's
on,
not.
hold on,
It's
hold on. I'm
not a
saying,
problem.
my friend, understand to me. Sorry, not understand to me, but understand me very clearly when I say above sea level, which is a unit of measurement reported on drawings, which are legal documents. And then you tell me that
Yep.
C is a common point that you globers use to identify the base of the pen. That would relate to me that water is able to defy the container it is located within.
Yeah,
And that
you're
is
not making any
not.
sense.
I'm
Sea
making
level
perfect sense.
is depicted as a global recognized globally as a reference point for elevation and altitude.
And then and in the same breath, you're suggesting that elevation is the base point, if you will, the bottom of the sea level, be the base of the pan, and that would indicate that there is what water sticks to a globe. Water is sticky, so it's able to defy the container.
Say that sea level is curved.
Do you understand what I'm saying here? You have above sea level. You're identifying
Because you're being a big straw man.
No, I don't think so. Well, I appeal to the
Yeah, I
court
do
at this
think
point.
so.
Am I strawmanning this idea of above
I
sea
get where you're
level?
coming from, but you're confusing me with it.
Okay.
What he means is if the Earth was curved, there would be no level because level means flat and straight. It doesn't mean curved, dum dums. That's what he's trying to say.
If you go by the definition, there is a definition with reference to the Earth that follows the curvature of the liquid parts of Earth, right there in the dang definition.
Pretty sure a sextant, like a bubble
That's
sextant,
your
like you said,
interpretation.
you would be able to see a curve from left to right.
Yeah, that didn't make sense either.
Yeah, it did. What?
Your mind isn't working right.
No, the thing is that Kiwi is trying to explain something that is practically done and you can objectively do. But Leftline is talking about drawings and things that you can do in paper. So he's describing things from standing on a globe in his mind. So he's speaking from there in paper. But when you go to the practical place, when you go to the practical place to do things, you don't need that drawing and that explanation that he's talking about.
Well, I just presented a drawing. I think if you
I think
identify
it's funny
sea level,
how level is defined as flat and straight. It's not defined as curved with the surface of the Earth. So unless that's
But it
changed,
is.
I don't see how they can
It is
consider
defined.
that makes it curved. It's dumb.
I just told you with respect to the Earth, that level is defined as following the curvature of the liquid parts of Earth.
That's when you start with the ball, dude.
Yeah, because he's standing on a spinning ball and he's speaking from there. He's using the language that is spoken in this place that he's talking
Yeah, I
about.
like
The
how
story in the paper.
I like how they like to twist stuff around and make it sound like, oh, that's what it means.
Well, no, it's twisting. It's just arguing from the point of the model. I'm not making anything up or anything. I'm just stating facts about the model.
Yeah, about the model, exactly. You're standing in the piece of paper
We
in your
don't
mind in the
live
model and you're
on
speaking
a
from there.
model. Dude, like how many times do we have to say this? We
But
don't live on
he
a
is speaking
model.
in we don't, exactly.
Model is an imagination, not reality.
No,
Well, he's
I
speaking
use the
from there.
model to make predictions and to represent and make predictions.
Okay,
so
so
what? I can do the same with the horoscope. Big deal.
So Left Lane, if you look at the chat, I just put a drawing up at 10 past the hour, just showing the illustration of sea level, and then what the idea of like where it's written different ground levels. There's those lines that would indicate above sea level. So the issue that I'm having is that if we were to apply this idea to a globe, it would suggest to me that the sea level is somehow able to wrap itself around a ball and create like almost like defy the laws of the container that it's located within. The
Yeah,
walls of
you
the
just
container on a globe would almost have to be these giant like walls that come up and curve and hold it even bigger, almost like a goblet of a glass.
Dude, I don't think you understand. It works because of a ball. Sorry.
No, electric. It's all. I appreciate the humor, man. It's all good. The left lane, like I have a tough time conceptualizing how this one observation called above sea level would actually, in theorem, apply itself to a globe. Like, do you think you could draw that on a globe? Sketch that out? Left lane?
Yeah, you're just making a representation of a small section with a beach and a body of water, and that's not representative of the entire Earth.
I thought that this was pretty representative of every coastline that existed against all the major water water masses that we have on this Earth.
When you're
Is that-
lying, you have to constantly change the structure.
I'm not lying, and I'm not lying it now. I'm not saying anything that I believe to be untrue.
That's fair. That's a very fair statement. Because again, remember what you said. You're
Keyword
not
is
lying
believe.
about anything you believe to be true, right? Then it's a very clear statement. I appreciate it.
He's not lying about how things work on the globe. And you remember the cartoon, the circles that he was talking about. You were talking about the level of the sea and the elevation of the land, and he say, "Oh, but circles. You know circles." And
Yeah,
he's speaking from
he
there.
was suggesting that you would create a chamfer, what's called a cut, into an existing circle, so that you would basically create a container within an already existing container. But it's just the aspects of their gravity doesn't work in that model.
But all you
It's
see is
preposterous.
level and horizontal. You see level and horizontal, and he's saying, yeah, he's going towards that depiction of things, of the globe.
I see the.
You have to go to the drawing to understand it. You have to go to the. He has to depict it in a piece of paper and make an image and make a cartoon and say, hey, from here, from this cartoon,
This is a satellite.
this
Is this a
depiction on
satellite? Yeah,
paper.
these are satellites.
This is how
He's show-
things work.
He's showing a satellite that's 50, I guess, meters above the surface of the Earth, and there's a profile registering. I would assume that that's an elevation measurement, and then maybe the coastline over the years. So maybe he's showing the graph of how long it's taking the coastline
yeah, there's
to change.
nothing in particular about that graph except that would be more representative of a larger section of what I'm talking about, rather than just a shoreline and what body of water.
So what is it showing? Tell me. Because I just told you
curve.
what I thought without you saying anything. So tell me what you think.
See that representation's got the curvature in it.
Hold on a minute. Wait a second. Slow your roll. You mean to tell me that you brought this picture of a graph which has a whole bunch of numbers on it just to show that the background shows that it's curved?
Yeah, that's more representative of my reality rather than just looking at the beach and a body of water.
I'm gonna stop. I'm sorry. No, I can't. Have a nice
Why?
day, guy.
What's wrong with that? Oh,
So you just choose to believe what people tell you rather than going and looking at it for yourself. That
No,
makes
it's
sense.
it's what I experience as I drive across this flat desert.
Where do you experience that?
And
Experience that in physicality.
And I
Not
see
in your
these
mind.
cloud. I'm trying to explain to you as I drive across this flat desert, and I see these cumulonimbus clouds, and I can see the base of the clouds here near me. And I look off on the horizon. I look off on the horizon, and I just see the very tops of those puffy clouds at eye level, and I can't see the bottom of them. I wonder why that is.
Don't bring clouds into this, dude. Don't. Because here's the thing.
No,
I just
answer my
know
question.
left
Answer
lane,
my
left
question,
lane.
though.
No, left lane. I'm gonna appeal to your intellect right now. Honestly, I really am. Because my next move is to call you intellectually dishonest. But I'm saving myself from that point because I'm gonna really appeal to your intellect at this point. I just presented you with a real life observation because I review drawings Monday to Friday, like every day of the working week for what I do for a living, right? And this is an observation of a unit that's reported in the real world, stated above sea level, And I showed you an example drawing of that. And then you brought back a random graph with a picture of a globe in the background to say it's more representative of what you see in your mind because of puffy clouds? My guy, this is not how you debate.
That drawing is not indicative of what I'm talking about, of what I'm seeing with the clouds
Exactly
on the
what I'm
horizon.
saying he's been doing. He's just presenting the cartoons when you're talking about reality. That's it.
No, I'm talking about the clouds and what I experience every day and what I see in reality. Tell me how it is. Tell me how it is that I can't see. Tell me how it is.
Globers? Is this an
Wait.
example of the
So
Globers?
what do you see that you're talking? What are you talking about? What do you see that's telling us something? Explain.
Out on the horizon in the distance, I see just the tops of some storm clouds, and I cannot see the bottom. They're obstructed by the horizon. Why? But they're at eye level. But why can't I see the bottom of those clouds?
You cannot resolve that with your eyes, dude.
No, I can resolve the top of it. Why can't I resolve the bottom of it?
Really?
Yeah, really.
Yeah, the bottom's supposed to be closer.
Yeah, the bottom is bigger than the tops.
Mm. Yeah, I wonder.
It's because its surface is curving away. That's why.
Mm-hmm. Sure it is.
The clouds tell you that the
Kiwi.
surface is curving away.
Kiwi, where are you from, if you don't mind?
Ontario, Canada. Thanks for asking, my friend. Who was that? I missed the name.
I'm Bacon.
Bacon. Yes. Yeah. Toronto, Ontario. How about you, my friend?
All right.
Hey,
Where
you
are
can
from,
only you can only cook bacon on a flat, contained environment.
No, levelist. Yeah. This was good engagement. Believe me, Left Lane. I appreciate the again, guys. You know me, right? I'm the first proponent to say, any punching bag rendered is great to exhibit, keep my karate sharp, so to speak. It's all good, man.
Oh, good. Have you guys watched Better Call Saul? Better Call Saul.
What?
Better Call Saul. Off of Breaking
Oh yeah,
Bad.
I've seen a couple of episodes. I never watched the whole series. A lot of truth dropped in that show, though. I heard.
Hey, Left Lane, you should get some pictures of those clouds on the horizon.
I thought about that a while ago. I should stop and get up on the overpass and take a picture of the clouds that are close to me and those off on the horizon. It would be a good example.
Yeah.
But it's hard for me to stop when I'm being productive.
Right. You can. There's a. What kind of phone do you have? An iPhone or an Android?
It's a 22. S22.
Hey, that's the new one.
Oh, wait. Which phone? Is it Apple phone or
Samsung?
Right. So
Samsung. Yeah.
There's an app called Dioptra.
I've got it.
Oh, right. Yeah, it would be good if you took a picture with that as well to show where eye level is, because if we just take a picture, we don't have a reference for eye level, right?
Right. Yeah, I've done that. The crosshairs actually, driving down the road and holding it as steady as I can. The eye level's hitting the tops of those clouds, which are probably 20 or 30,000 feet.
Interesting. Hey, what's up, Nate?
This is stuff Doofus was pressing me about with this hydrostatic equilibrium. What's this stuff that this guy is hinting?
Do you know what hydrostatic
equilibrium is? You have water or any fluid, and it's gonna reach its equilibrium based on all the forces that are being applied to it.
Basically, the other liquids around.
So, sorry.
Well,
what does that have to do?
well, they say the atmosphere, with its density gradient being most dense at the bottom, is in a state of hydrostatic equilibrium.
Oh, wait a minute. Hold on a second.
Yeah,
So
they say that,
do
but
you say it's an open system or closed system then, Left Lane?
Well, that's sort of a gray area, and whether
Why is it
we
gray?
consider it, I think it's considered a closed system, except for the thermodynamics of it, how energy gets in and out. But I think that for practical purposes, it's considered
Energy
closed.
getting in and out.
Hold
What?
on, Electric. Hold on. I'm going somewhere with this. Give me 1 quick second.
I
I
have
need
to
some
mute
space
up.
on this.
Sorry.
2 seconds. 2
I'll
seconds.
be
No,
staying
don't apologize. No, don't apologize. Just I'm curious about Left Lane's appeal to this. Go ahead, my guy.
What?
Just about your idea of the closed system, how it functions, how you see it functioning.
Well, because things can come and go, like we have the meteors that come in and we bleed off a little bit of atmosphere. But if you think about it, other than rockets, which we propel out of the atmosphere, nothing ever leaves except for a
heat.
little bit of atmosphere that bleeds off,
And heat.
Okay, so
and heat, yeah.
So with the rocket observation, though, question being the Falcon rocket that took off and it appeared to be skidding along the roof of something, or it appeared to be hitting something. What are your thoughts on that?
Oh, that was an interesting observation. I would have to know more about that to make a determination of what I'm seeing.
No, but no, well, dude, it's no, you see it, and I would like you. I'm curious to know what you specifically think about it. Do you think that there's an interaction between this apparent rocket and some surface that's above? Again, based on the observation that the powers that be back in the 60s launched a whole crap load of missiles directly at something in the sky. Do you think that's the same? Those are the same two items? That's the same item?
The same item.
You ate your robot.
I don't understand what you mean by the same item.
I'm asking you. So we observed this rocket that was launched by Tesla, and it was skipping. It looked to me like it was skipping across the surface. I don't know. We appeal to the court on that, see what they think. But then we have this documented occurrence. We have visual evidence of that, of Operation Fishbowl and Operation Dominic back in like the 1960s, where they launched like over 200 explosive devices up into the sky to observe I don't know what. But my question to you specifically is, when you say you think potentially we're in a closed environment, I'm asking you, could this be the identifier to the roof of the system that we sit within?
No, I don't believe that by stating that we're in a closed system that I mean there's a roof. That's why I was sort of not explicit, but I did explain that things can come and go, but they don't generally, on the big scheme of things, come and go. We can shoot rockets through it, but nothing on the surface of the Earth ever leaves it, unless it's under powered flight.
Okay,
how do we know that?
I've never seen anything go up.
But here's what we've observed. A solid object was launched by a company at the sky, and it didn't go where it was supposed to. And it looked like it was running along something. It was interacting with a solid, somewhat forgiving surface.
What do you mean it didn't go where it was supposed to?
Well, my appeal to you at this point in time is based on the observation. I'm not really asking you for what you think in terms of what can come and go. I'm asking you for what you are actually visualizing seeing with your eyes as to, like, holy crap, what happened?
See, that was an image you posted earlier, but I've actually seen that footage, and it appeared to me as though the rocket was leaving Earth's atmosphere and entering the vacuum.
Well, here's
because
the footage.
that gas plume that was coming out the back, it was getting increasingly larger, expanding more and more, and that's what I would expect the rocket exhaust to do as it went into the vacuum of space.
Okay, so you're saying that what we witnessed in terms of this outward, like whatever's coming out the back, is the rocket's expulsion, its gases indicative of it
No.
leaving the Earth's atmosphere. Okay. I can, my guy, I could totally see that as a potential explanation. Appreciate that.
Yeah.
Okay, that's that. I just want to know that. Sorry, Electric, I was along with that. I'm sorry. But yeah, that footage
Yeah,
is
why do you sound
yeah, there
Brazilian,
it is.
man?
Go ahead, Bacon.
I'm just asking why. Like, Kiwi sounds Brazilian to me. I don't know why. This is.
I sound Brazilian?
You
I
do,
mean,
yeah.
I grew up in Barbados and Trinidad. I spent a few years down in the islands, but I was born here in Toronto, Ontario, and moved down there, lived a few years down there, and then came back up here for grade 3.
I mean,
Been
Barbados,
here
they
ever
also
since.
speak English, don't they?
Yeah, English straight through, just different like dialects, like not really dialects, but like patois kind of thing. You'll throw some slang in there, whatever. But for the most part, I straight English, and that's that. Thanks for asking, Bacon.
I only knew one person from Barbados. I mean, not that you're from Barbados, but you're the second person I know have been to Barbados.
Mm-hmm.
First one is Rihanna.
Very fair observation.
But yeah, you do sound like
Rihanna, really?
a Brazilian speaking English.
Maybe I'll pick up Spanish then. I mean, my grandmother is from Venezuela, so maybe that has something to do with it. We'll see.
Yeah, I'm sorry, distracting from the subject.
No. Sunday, we're not in school.
Hey Howard, you still doing the aviation classes?
Oh yeah, we've had a little break. The plane had a problem, and the instructor went on vacation again, and so I've been like 4 weeks without flying.
Right.
Wait a second. Sorry, you fly left lane?
Yeah.
Okay, cool. Sorry, Bacon, go ahead.
I was just gonna ask if any chance you're gonna learn anything with the bubble sextant or something.
I think all those ideas and things we talk about, I try to incorporate that into, a project or something I could do from the air, and it's definitely something I've considered.
Right.
It would be a fun project.
Right. It's interesting to me that I heard in Oakley server that the zenith angle you get from airplanes is the same as you get with the sextant, even though they're much higher from the surface.
That's right.
Which is a bit weird if you don't accept the light is coming in parallel, because for those angles to be the same, those lines should be parallel.
Yeah, it would have to be, wouldn't it?
Always parallel with the horizon, isn't it? Even at 120,000 feet in the air, our eye level is still
horizon.
Level with the horizon.
Not
No,
talking
that's
about
not
horizon.
true. Yeah.
Sorry, what?
Oh, you
We're
don't
just
think
talking
the
about
horizon drops from eye level? You don't think horizon drops from eye level?
1 second.
So since I installed the Ultra, I check it every time I fly an airplane, which is
Yeah, that's
actually
my
very often.
understanding of the horizon. Is the higher you go, it just continues to stay eye level. This has been witnessed in every single fucking. Right?
No, it doesn't.
No, it
No.
does. I check that all the time. My girlfriend lives in a different state, so every 2 or 3 months I'm flying in an airplane, and it's something I always do is just turn on the diopter and point to the horizon, and it's always below eye level. I don't get why you guys so firmly claim that if it's so easy to demonstrate otherwise.
Damn. Where did I hear the other side of this argument from, man?
You're not wrong.
It's been a common argument from the flat earth side that the horizon rises to eye level.
And if that was the case, if that was the case, you would not need deep correction for celestial navigation.
Ever.
Because if it's always rising to eye level, every time you point to the horizon, there will be a horizontal line. So you wouldn't need to do any corrections. You would already have a elevation angle. Hey, Electric, you have background noise.
I know.
Yeah, I don't understand why they keep claiming Horizon rise to eye level always, and at the same time try to talk about dip correction.
Claim? What do you mean claiming it? It's true, dude.
Yeah,
It's not true,
Yeah,
though.
you saying it's true is also a claim. Why do you think it's true? And how
I'm
do you
sorry, but
reconcile
It's
that
funny
with
how
dip
you
correction?
guys say things
until
that
you're
everyone else in
180,000
the
feet in the
world
air,
has
bro.
never said.
Why
but
am I
then you
trusting what
claim
you're
that
saying?
it's always been that way.
Just next time you're in an airplane, just pick a software that shows eye level and point to the horizon.
You really think that I'd be arguing with you if I hadn't been on an airplane before? Really?
I'm not saying
Did you
you
measure
haven't
it?
been. That's
I've
not
been
what
on
I'm
an
saying.
airplane plenty of times.
That's not what
Different
I'm
kinds of
saying.
airplanes.
I
Hot air
didn't say you
balloons,
haven't
even.
been to.
What
I'm
about
saying
it?
next time you go,
Yep.
you use a reference for a level.
I've done
There
it.
are many apps that can
Done
provide you
it.
that.
Done it. I've done it.
Oh, you've done it. Can you show that?
Yes.
Yeah, can I
Well, no,
see
a
it?
picture of it, Nimrod.
Let me see if I have one from the Optra here. 1 second. I might have to turn on my previous phone.
And like Bacon's saying, if the horizon actually rose to eye level, regardless of your altitude, why would there be a dip correction in sextant observation?
Yep.
And the higher you go, the more significant that correction. That means the horizon is dropping as you go up.
You know how you can produce the same table as you have in the almanac? Is to do the geometrical way you would expect a dip on a sphere with 7/6R, and that's gonna exactly match
You would expect,
the
huh?
almanac. Yeah. It's called geometry.
It's called bullshit.
So if you look at pictures of skydiving, just Google it.
There's
You
no
can
reference for eye level there.
Skydiving horizon. You'll
That's how
always
they'll whittle their way
see
around this. Oh, well, there's no reference point. We don't know which way the camera is facing.
that depending
There's
on
no
where
reference for eye level.
the camera is, right, in reference to the horizon.
Where's
If
your
you want a
reference point for the
picture-
Earth turning then? Because there isn't one of those either.
I'm not making any claims about that right now.
If they want to get the horizon
not.
in reference frame, they will.
Hmm?
They will always get the reference frame. If they choose to get the horizon in the background, they will get it for the picture, or they can shoot the skydiver from below or above. However, from the skydiver's perspective, what the skydiver sees from his purview, he can never escape the view of the horizon because he's always looking at it. It's where the air and the land meet. Always flat, left to right, no matter which way he turns from that angle, and it's always level to where he is because it's his vantage point. Do you understand
nice
sight
claim.
lines? Hold on a second.
That's
Do you
a
understand
nice
how?
claim.
Do you understand how sight lines work with vanishing point? You ever sat in grade 3 art class and did the vanishing point?
Yeah, that
I've built
observation is
renders.
dictated by the globe model.
I have built renders. I
Yeah.
know how perspective works. Don't worry.
So if
you're
you're
just
going
making
to say to me that the horizon can go below you, you are literally suggesting that you can change your sight line by saying that the horizon can go beneath you. You understand what you're saying in the
I'm
argument?
not understanding what you're saying.
If you focus, you're looking at the horizon. You're
Okay.
looking down the line, down the street, whatever it is. Okay? We're going to climb up the building. We're going to go up a building's view, right? And we're going to go look out on the horizon.
Right.
You know that you're on an elevated plane, your view, right? But what you're looking at, right? Let's say the crest of the triangle, you're on one side of the triangle, the point of the other side of the triangle is there. That is an opening and closing.
What
angle.
triangle? 1 second. I'm
Sight lines are
not
based on
I'm not being
triangles.
I'm not
Sight
being
lines
able
are
to
based
picture
on
what you're saying.
triangles. Sight lines are based on triangles, my friend.
I'm trying to understand what you're saying. Do you have some picture or anything that can help illustrate what you're saying? Because I'm not following it.
You know that sight lines work on triangles, right?
I don't know what that even means.
No, what does that even mean?
Oh,
Line of sight is a line.
Yeah, line of sight. It's only a line outside of your view. In your view, it becomes a point.
Can you tell me what the definition of a line is? Can you just read it for me?
Oh God.
Oh my God.
Would you like me to help you? Because it says straight,
gonna
level,
get
flat, direct, not curved at all. Period.
Line
Bottom
is
line.
necessarily flat and straight. What the hell? So curved
I
lines
gotta
are
run right.
lines.
Yeah, I gotta go right after I say this, but I just looked up
Yeah,
dip
they're gonna
correction
make a
and
bunch of.
sextants. I looked up dip correction, sextants, and elevation based on your vantage point and all that stuff. And it's funny how nothing truly says that the horizon actually lowers the higher you go. There's nothing is
Well,
saying.
what the fuck?
What do
What
you
do
know?
you
What do you
think the
think dip
correction is
means?
for, man?
What do
God
you think
damn.
dip means? It's the dip
You're
below
just
the
making a
horizon.
correction.
The horizontal.
You're just assuming that you're making the correction is made because the observation you're making. Okay, sorry, but I can't explain what I just read. I'm sorry.
Let me simplify. Let me simplify that to you. You
Hold
measure.
on. You think that dip correction is the dip of the horizon?
It is.
Yeah,
Really?
that's what,
So
exactly
if you
what
were
it is.
if you were to lay your head on the floor,
That's not what it says. A dip correction is supposed to be you're adjusting the supposed altitude because of the viewer's eye.
the viewer's eye, yes. So if
Yes,
you were to
so
lay
you're
your
That means you're
eye,
not actually observing a dip. You're just assuming there's a dip. Okay?
No, that's not how it works. So let me
yeah, no,
illustrate
that is
that to
how
you.
it works.
Let me.
That is how it works. But
Yeah. Instead of just
yeah.
claiming that, let me.
Oh,
just
that's what's actually cite it. Cite it.
Can I answer you?
Can you cite me? Can you cite me where it says that dip correction is a dip of the horizon? Can you look for that for me and instead give it to
All
me?
right, let me pick up the manual of my
that'd be
section here.
easy.
1 second.
Sure, find it.
And by the way, I want to thank you guys. This is another topic I'm not yet fully in. And me looking it up is interesting, man. I like this stuff.
So
Yeah.
I posted up a little building or whatever I found on Google just to get the idea out there. But again, if we take the idea, the vantage point that we're on the building at the height, the top
Okay, let me-
building on the right side, right? You have the top of his eyesight, right? That's the very top. He sees out to the distance, which is the horizon in the distance. And then the bottom of his line of sight is the next. So his peripheral vision gets to take in the bottom, and that's why I say the viewing angles are based on triangles, and that's why the aspect of a sextant works, because a sextant is based on angles, i.e. triangles, and that's why they're able to extrapolate the diameter of the sun as they were able to, but I'll leave
Angles
that there
don't
for now.
imply triangles.
So from astrobladesailing.com.
Hold on a second. Did you just say angles don't dictate triangles?
Wow.
I said angles don't imply triangles.
That is the
Only
most
thing.
ignorant statement
Are you
because
serious?
it has it has the name angle in the name of triangle. You,
Yeah, and
my
also
friend, are
triangle,
unfortunate.
which means tree. You dumbass.
Are you
what?
really
Yo,
serious,
really?
Jake?
My
Are
guy,
you
3
serious?
angles. What do you think makes up 180
Yeah, it
degrees?
requires
3
three.
times 60 is 180. Triangles,
have-
3 angles.
You're not
You
To have
saying
a
anything
triangle,
please
to have
don't
a
put a label
triangle.
on me. Don't put a
have a
label on me,
triangle.
dumbass. When I've been respectful of you the entire time.
Yeah,
so
you
try again.
If you do
All
that
right,
one more
I'll
time,
take
if you
that
do that
back.
one more time, I will
I'll take
mute
that
you.
back.
I will give you a timeout.
All right, I'll take that back. So let me
So from
finish the sentence.
astrolabelsailing.com, there we need to make a correction to what your sextant says to get your reading converted to sea level reading. This is called dip.
No.
Or listen,
No,
I'm
not
reading.
corrected to
I'm
sea
reading.
level. No.
I'm
That's not
reading.
right.
This is what sex. This is from a celestial navigation. This is called dip or an adjustment for your height of eye.
Yeah.
Correct.
That's right.
Go
Yeah,
on.
that's what's called dip correction.
Yeah,
Yes, because
That's
your
right.
eye is above the
Adjusting
ground
your
when
your
you're
height
standing
of
up.
height causes the horizon to drop, and the amount it drops, it's what the dip is measuring.
Wow, so you just extrapolate that.
No,
Okay,
it's
now,
written right
can-
there. Just keep reading. Keep reading your reference.
Hold on a second, but
Just
can
flip
I
it
also
around
paint
so it sounds right.
let me paint the aspect for the court, so you all understand the idea that when you use a sextant, whether it's a sextant or a bubble sextant, the identifier being an elevated plane, when you're on a ship and you go up the mast of a ship up to the tippy top so you can have the best view of everything, you are on an elevated plane, which is where the aspect of the bubble sextant comes in, so you can account for your heightened purview.
Yeah, what happens if you let me ask you a question. What happens if you add up the angle you're measuring with a bubble sextant to the angle you're measuring with a nautical sextant? How much that adds to?
How much does that add to? What do you mean?
Yes.
That would be the difference between the horizon line and your elevation plane and whatever your celestial reference point would be. It would be the sum of those two angles.
Yeah, what is the sum of those two angles?
I have no idea. I'm not using the sextant. It's not going to be more than 90 degrees.
That's what we're talking about. That's what we're talking about. If you're measuring...
Do you understand what a mast on a ship is?
Sorry?
But here's the thing.
Do you understand what a mast... Hold on. No. Wait. You just wait, left lane. Do you understand what a mast on a ship is?
Maston?
I don't know that word. M-A-S-T. A mast on a ship is a pole that the guy who navigates or helps with navigation climbs up the center point of the ship to the very top, and then he pulls out his sextant so that he can look to the distance to figure out what he is. That is where he would introduce the dip, because he's on an elevated plane. Holy smokes, dude.
How is that answering anything that I said?
Yeah, the thing is,
Are you really serious? I just told you why the dip
after your dip correction is done with the marine sextant compared to the bubble sextant, the angles will be the same. Thank you.
Yeah, only when you
one is
only
using the surface of the earth,
oh my
the other one
god,
is
George
not.
is here. Yeah, conversation's over. So if you
There
add
is no conversation, man.
if you add the angle of the bubble sextant to the angle of the nautical sextant, that exceeds 90 degrees, which means that the angle from the angle of the horizon from your zenith is bigger than 90 degrees. If it was at your eye level, it would be 90 degrees, which means that when you add up the angle from a bubble sextant to a nautical sextant, it would add up to 90 if it was at eye level. You would not have to correct for dip.
No one does that, man.
Were you conceived in a
No
sex?
one does that, man.
Do you understand that, QE?
QE, wow. Did QE hurt you this much?
Hold on a second. I'm getting a picture right now so I can better illustrate.
He's talking to Kiwi, not QE. Kiwi.
Yeah, I have no idea what's the difference in pronunciation between the two times you said it.
But it's just a difference of two different people, but it's okay. It's no stress. It's no worries. Listen, here's a picture that'll help. Okay, now this lady is standing on a ship, right? She's on an elevated plane. This is where we call the observation deck. Now she will stand there. She's using what I believe is a handheld sextant to figure out where the hell she is. Right? You've got the horizon in front of her, which is the topic that we got onto this discussion about. Right? Now, as she changes her location, she goes higher up. Right to her left, there's I believe, an elevated deck, perhaps. Right? But then, if you look at let me see. I'll leave that. Anyways, with relation to the picture, her eye level goes out to the horizon. Right? That angle that goes down to beneath her, that's where your bubble comes into play. The sextant
What do you mean
that
her
was
eye level
originally
goes out to the horizon?
the sextant that was originally used was meant to be used on the surface, so to speak, like just the deck of the ship. But with the introduction of the mast, which gives you an elevated plane, that is where the bubble comes into play for that additional area below it.
Yeah, no one uses bubble sextants on boats. They use nautical sextants because they can't. The bubble keeps swinging, and that sort of prevents bubble sextants from giving accurate readings. So they use nautical ones. That's why they have to correct for dip. But bubble ones don't have to correct for dip. Which means if we add up both of them, you get an excess of 90 degrees, which means that
the only difference between
the zenith
bubble
angle of
one
the
and
horizon
regular
is
one
bigger than 90 degrees, so it's below eye level.
Three-dimensional ball floating in there with a weight in the bottom of it. That's all it is. Instead of being a regular compass. I don't know what you're talking about.
Okay, George,
Okay,
thank you so much for posting those pictures. So, my friend, my question exactly. There you go. George just posted it, dude. That's the point. Right? So if you had a sextant using it on the first picture he showed, I took my sextant and I went up to the very tippy top of the mast of the ship, the mast being the top, right? The bubble would be the difference between my eye level horizon and the angle down to the sea. That's the depression, the bubble. Now, when you use just a regular sextant, you would be standing on the deck of the ship, the surface level of the ship, and using that would be assumed because your horizon, you're so close to the seafloor or the sea that you can basically state it's right in front of you, and then use the celestial stars to navigate your location accordingly. It's all based on triangulation. You pinpoint everything with triangulation. It's all based on
you don't.
triangles.
You use
Triangles.
first of all,
Oh,
and second of all,
Yeah, you need
that
to
first
have
picture,
you need to have
first
the right
picture,
angle.
that first picture that George sent, in which the guy is not at the surface, he's above the surface, and the bottom, there's two lines on the angle he's measuring. The line below it isn't horizontal; it goes down. So if he's aiming at the horizon and that line is aiming down, then the horizon is not at eye level. That's the whole point of it.
Of course, it's not at eye level. That's why.
Yeah, this is what the guy is trying to argue. He's trying to argue the horizon is at eye level.
Point is,
I need to
point
ask
is
George a
that
question.
you need to have a
George.
You need to have a tangent line from your position all the way to the GP of the star in
No
order
one's
to
asking
have
that,
the
George.
90-degree angle.
George,
No one's asking that,
in your pictures you posted there, why have you not shown the co-altitude angle?
That's the next step.
Oh, okay.
First, you need to determine your reading of your angle to deduct from the 90-degree. Yeah. So your triangle, your right angle triangle, your tangent needs to go all the way from your position to the GP of the star.
And
which
your
you're going to correct for
co-altitude
it.
angle is
Now
the
that
co-altitude is the result of subtracting your
co-altitude
altitude
angle,
angle
correct.
from your
You need
90 degree of
to
your zenith.
deduct.
He's
You
not
need
gonna
to
let me.
deduct from the 90-degree angle, yeah, the angle that you are observing to give you a co-altitude angle. That will give you the distance to the GP.
And the co-altitude angle is from what point?
It's the same point. It's from the celestial star to you.
No, it's from your zenith, George.
Yeah, to your zenith. Yeah, you can say that. Depends depends which instrument you're using. If you're using a sextant, it's a different story. If you're using an astrolabe, because you're holding the astrolabe on a string, you are
George, you stole the conversation.
You are determining your zenith line, which is what you're trying to find out. Your zenith line, your position on the ground.
So, question, that second picture that you shared, George, are you suggesting that observations would be taken from the lower level of the deck of the ship?
No, the observations. No, if you're using the surface.
So where's the surface measured?
If you're using the surface for your elevation angle, yeah, which is the case, you're using the horizontal plane. You are aiming at your horizontal plane. Yeah, which is what it's your line of sight as far as you can see, where the sky appears to meet the land or the sea. Yeah,
AKA
that's
the
your
horizon line,
horizon.
yes.
Yeah,
Right.
so you are aiming at it, and you're going to correct from it in order to have a not just a tangent line, but to have a horizontal line that is going to meet the zenith line, an imaginary line that goes from the celestial body all the way down to the ground, where X marks the spot. So that imaginary line needs to meet your horizontal at a 90-degree angle, a right angle triangle.
Okay,
which you're going to deduct your elevation angle from those 90 degrees in order to give you the distance.
Okay.
The conversation is whether or not horizon drops from eye level.
So once that you have that distance,
the dip of the curve of the Earth, I say it's not.
so once you find that distance, now you can grab your compass and draw a circle of equal altitude around the GP of the celestial body that you were observing, and that circle is a circle of equal altitude. You can't have that on a sphere.
which dissects the
No
sphere
one's
at
yeah.
circumferential altitude.
Nice red hair, George, but we're trying to talk about whether or not the horizon drops from eye level.
Okay, so well, my next question for George is I'm trying to figure out is, George, what is the average height of a mass
Oh, we were talking
on a
about something
ship?
else, but you changed it to this. Yeah.
Oh, sorry, I didn't realize I changed it.
The average height of the mass of a ship, it depends on the ship, no?
Okay. But what I'm saying to you is that to observe the horizon, that somebody would climb up a mast to pick an
Yeah,
observation
correct.
point. My question to you
yeah.
is the difference between the use of a sextant versus a bubble sextant. The surface of a ship, the deck of a ship, versus the mast of a ship. Would you use two different tools depending on your height, or would you simply extract that calculation for the height of the elevation, the peak that you're at?
Well, again, depends which instrument you're using. If you're using the nautical sextant, if you're using the surface of the Earth, like the horizon, you need to correct for it. If you are above the sea level, you need to correct for that because you are above the sea level. Now, if you are at sea level, there is nothing to correct for. Now, if you use more sophisticated instruments, like a bubble sextant or an artificial horizon established, you just need to establish the horizontal plane that requires to meet the same zenith line at the 90-degree angle. So that angle of 90 degrees needs to exist, But the nautical sextant is using the surface of the Earth to achieve this. That's the point.
Appreciate it.
Right. So how do you address the issue that if you add up the angle of a sextant to the angle of not bubble sextant, you don't get 90 degrees, you get an excess, which is what the dip is trying to tell you. And how is that not the horizon below eye level?
Ridiculous.
Yeah, I see what you're saying.
So that's how you address
It
it. You
has
call it
nothing
ridiculous.
to do with
That's a
it.
nice
You
response.
cannot-
Thank you. Appreciate it.
Facts are ridiculous.
It's not facts are ridiculous. It's ridiculous what he's saying. He's comparing two different instruments. First of all, if you use both instruments at the same time on the same ship, you're going to have exactly the same angle. What are you talking about?
Well,
first
of all, the bubble sextant
You guys trying to say that the sextant don't work anymore. You're not arguing with me. You're
Look, if they
arguing
gave
with,
you
against celestial navigation.
if they
man.
gave you the same angle, if they gave you the same angle, you would not have to correct dip for one and not the
Two
other.
different triangles, one being more than 90 degrees, that does not indicate that the Earth is dipping
That's
in
not
a
what I
convex
said.
pattern.
I didn't say one of them is bigger than 90. That's not even what I said.
Okay,
Did you hear what I said?
That's what's happening. Stop
cannot-
whistling.
Yeah, you're going to have more than 90 degrees.
Did you hear my argument? What's my argument, Gregory?
Sitting up here talking, listen to what someone is saying to you. You are trying to add one triangle that is 90 degrees and another triangle that is more than 90 degrees, and then try to sit up here and argue that therefore that indicates that we're on a curved surface.
No, that's complete straw man. I never mentioned curved surfaces. I'm not even arguing that the surface is curved. I'm simply trying to. Can you stop interrupting me and let me get to the end of my sentence, please, Gregory?
Let Bacon
Thank you.
finish his statement. Thank
Yeah,
you.
I'm simply objecting to the claim that. Oh my God! Thank you. I'm simply objecting to the claim that the horizon always rises to eye level, and I think the way we use bubble sextant and
Whoever
nautical
said that?
sextant can confirm that.
I didn't
Kiwi
say
said
that.
that. Kiwi said that.
No.
So why do you say that?
Kiwi said that.
No, the horizon doesn't rise to eye level. Come on, guys. The horizon rises with you.
Thank you.
As further up you go, the horizon rises with you.
Exactly.
Now, to say that the horizon,
No, it doesn't.
to say that the horizon is at your eye level is to say that your eye is at the same level as your feet. If you were on the beach,
Contradicting himself.
yeah, if you were on the beach with your feet on the water, the horizon level is at the same level as your feet, not as your eyes. So the horizon is not at your eye level.
That was my
Contradicting
point.
themselves.
That was my point. If you look horizontally, you won't see the horizon because it would be below horizontal.
And
On
yet
a
you
sphere
don't
with a radius of 59 miles, yeah, the horizon drop needs to be 8 inches per mile square, approximately. So as you rise, the
You don't
horizon
add in
cannot
inches.
rise with you. The horizon cannot rise with you. You need to have
What's-
a drop from horizontal.
What's the
You
horizon?
imagine.
What's the horizon?
don't measure the dip in inches, George.
I think
What's
Jeremy
the
wanted to get in
horizon?
here. Hold on. I think Jeremy
You
was
think
trying
so?
to get in.
Is my mic fucked up?
Yeah, it was a little low.
Am I low?
Yeah, a little bit.
Anyways, so yeah, sometimes the horizon goes above eye level. George Hanna photographed this on one of his little refraction measurements. So I mean, goes above, below, right at. Depends on the medium, right?
Yeah, but it has an average, and once you get past some altitude, it gets more stable.
You don't measure. You don't observe averages. The hell's the matter with you?
Of course, you don't observe
What if
measures.
you're
No
not,
one's saying
what if
that.
you're on a what if you're not on a submarine? You know, as submarines they do elevation angles as well. You know, that's how they determine the distance to the enemy boat. Yeah. So if you're on a submarine, which you are under, yeah, the sea level, observing the horizon, obviously, and the enemy boats, and doing these the same thing, you know, elevation angles.
What? Elevation angle from a submarine? What?
Yeah. Elevation angles from sea level, yeah. The sea level is what determines the elevation angle or depression, you know, above sea level or below sea level. The sea level is the zero, like a protractor line, you know, zero line. Anything above that it has an elevation from it. So that's the zero line of a protractor. That's why we use the sextant for navigation, you know, the zero line, the baseline that we dwell on top, where the elevation angle needs to happen from. On a 90-degree angle. Yeah, right angle triangle is required.
Okay, if you need to look below horizontal to see the horizon, and how it makes sense to say it rises to eye level, or it rises with you?
What if you need
It
to look
moves with the
above
weather.
level to see the horizon? Then what? Oh,
I didn't hear what you said, Jeremy.
I said
George
that.
spoke
What
over
if
you.
I said, what if you need to look up to see the horizon, up above level to see the horizon? Then what? Oh, plot twist.
Then what do you mean?
Why do you argue like this, Bacon? We should be seeing curvature. We don't.
No, we shouldn't. No, we're not. No, our model does not dictate that you should be seeing curvature at eye level.
Yeah, because there's no curvature. That's why you don't see it.
Really?
Oh, we
Hold
can
on a
see
second.
from high altitude balloons.
What's blocking the bottom of boats and buildings?
Why do you respond like that, Left Lane? You know exactly what I'm talking about. You get to a certain height, you should see the curvature. You don't.
You
That isn't what you said to start with, though.
That is what I said. It's what I meant. But you people don't want to respond to what is said to you.
High altitude balloons,
You
you
don't
see
want
curvature.
to understand what is said to you.
High altitude balloons, you see curvexure.
No, you don't.
Yeah, you do.
Okay,
You don't.
you're,
No matter
you're
how
just
high you
looking
go,
at
you go through the earth convexly curving down in all directions. You don't.
No, if you
People lie to
pick
me.
one, if you pick a footage with rectilinear lens, you find curvature, not
Pick the right footage.
Find convexity, not concavity.
No, you don't find the listen. The curvature. Hold on a sec. The curvature of the supposed globe Earth, yeah, it needs to be happening at 1.2 miles times the observer height in feet. That's the distance from the observer to the geometric horizon of a sphere with a radius of 3959 miles. So when you observe something in high altitude and the horizon still appears to rise with you, it doesn't fit on that geometry. It's
not to eye
black
level,
phone
right?
images all around. We just decide to ignore them.
Right. So
We just take the face value that it's normal. It's not normal.
Sure. If I'm in a high altitude and I look horizontal, am I gonna see the horizon, or I'm gonna have to dip down a little bit to see the horizon?
You're going to see the horizon rises with you. That's the problem. On a sphere, you need to have depression. It needs to deviate from horizontal. It needs to go down.
No, Bacon,
Listen,
stop pretending like you've never seen the distance.
It needs
Can
to
I get an
have
answer for my
a deviation from straight, yeah, in every single vector, 8 inches
Yeah, I
per
don't
mile
think so.
squared. It's a ball, no? It's meant to be one. It doesn't fit. The geometry doesn't fit the observations. End of the story. I don't know why you're still talking about this.
World. You want to pretend like you don't see the horizon constantly rising with you as you increase your elevation, as you increase your altitude. That's what you want to pretend like.
It does
Because
rise,
you
but
want
not
to
to high
protect the
level.
religion ball.
No, I'm
Because
saying
you
it
want to
doesn't
protect the
rise.
religion of
It
the ball.
doesn't matter if it's high level or not. It rises with you. It shouldn't. On a scale, it cannot rise with you.
Well, it doesn't rise at the same rate as me. It rises lower than me. That's why it drops.
No,
It doesn't
making
drop. You can see further
So
away, man.
Gregory,
elevation,
so
the
Gregory,
horizon rises with you.
yeah,
It
Gregory, I
doesn't come
posted
back
an
down.
image. Yeah, Gregory, I posted an image from a high altitude balloon that's got grid work on it, and that shows you the curvature that I'm talking about.
Is that curvature at 1.2 times the observer height in feet? I don't think
That's
so.
nothing to do with
So
that.
whatever curvature you're seeing, yeah, it's welcome to flat Earth, man. It's beyond the
That's the
geometry
curvature
allows
you'll
for
see.
a
If you
sphere.
see curvature,
It's
welcome to flat
beyond.
Earth.
It's
In
Yeah,
beyond
you
the
That's what.
clearly see
geometry
that
allowed
blue
for a
and
sphere
purple
with a
line is
radius of
wrong.
39, 59 miles, man. It doesn't work out.
Yeah, that's what you'll see at 120,000
You
feet.
can clearly see the
Okay.
blue and purple line is wrong.
Left lane.
120,000 feet.
love
What do
your
you expect
graph.
it to
Chaotic
see?
fabrication.
Left lane. I love your graph. Question being, over a 60-kilometer distance, what is the expected depression on your globe model?
A what now?
On your globe model, based on a 60-kilometer observed length, that's a distance observed, what is your expected depression on your observed globe model?
You say depression. I'm seeing concaved when you say depression.
Concave, no. So you say that your model of a globe, right, is it goes around, right? A basketball, it's round, right? So
Mhm,
if I
mhm.
look at it, I take a distance of 60 kilometers across the surface of your ball, what is the expected depression as a result of your ball geometry?
Yeah, depression. Yeah, I think you're meaning to say drop from horizontal. Is that what you're saying?
Yes. The negative, yes, please.
I don't know. I'd have to punch it in the formula to tell
Okay,
you.
you take your time. I'm here hanging out. I'm just curious to know what that works out to be.
I'm driving. I can't do it. I'm
Oh, okay.
driving.
So I looked up the Earth curve calculator, and that it gave me an expected depression of approximately 600 feet based on the globe's math. So I went down to Burlington, which is local here to Ontario, Lake Ontario, if you will, and I took the time to take in the observation, long distance observation of Burlington to downtown Toronto, where the Blue Jays play baseball. Now, the Blue Jays play baseball in this building called the Sky Dome, the Rogers Center, and that building has an overall height of approximately 300 feet. Now, what I found interesting was based on a 60-kilometer distance, which is the distance between Burlington and Toronto, that distance should yield an approximate depression of, again, 600 kilometers or 600 feet based on the globe geometry, but that 300-foot building is still visible. So where's the curve?
Are you calculating for refraction?
How do I introduce refraction over a long distance observation, 60 kilometers?
Well, you have to consider refraction because we know that happens.
How do I introduce
in order to
60 kilometers over an observed distance of 60 kilometers? How do I introduce refraction into that?
Use
I have an
you
elevation
can use
angle.
you can use a curve calculator that
No, you wouldn't have an elevation angle.
that accepts refraction as an input.
No, the refraction you're trying to invoke is deviating from straight. Yeah? Which kind of refraction are you invoking here? Let's be clear
terrestrial
about that.
refraction, isn't it?
No, wait a second.
it's
Which
just
one is
refraction,
it?
man.
I don't think it is.
Just refraction.
No, but
It's just
which
refraction.
one? Which one?
Yeah, there's only. I mean, refraction is bending light. I don't know what do you mean by which
Bending
one.
lines. So deviating from straight then.
No, there's three kinds of refraction.
If you have light deviating from straight, you cannot have geometry, man. Not the geometry that we're talking about required for celestial navigation, which requires straight lines, not bent lines.
Yeah, but when you say terrestrial refraction, I would think that would apply to what you see on the surface.
But that's
No, but
irrelevant to what Vicky is talking about. You're not trying to locate a particular item.
Terrestrial refraction, you require a radius value for it, which is driven from the curvature of the Earth, which is exactly what we're talking about here. So to
That's a
invoke that
3-year-old
would be begging
argument.
the question. That would be assuming the outcome for a starter, yeah? Because that is the very thing we're trying to prove here. Yeah, the curvature of the Earth, that it's not detected at the distance required for the Earth with a radius of 3959 miles. It doesn't fit.
And again, refraction is not relevant to what Kiwi is talking about. He's not trying to locate a particular item. We're trying to observe the supposed curvature of the Earth.
And see what's weird
The
is
curvature of the Earth should be measurable anytime. Should be there. Anytime it should be there.
And what's weird is a lady who was to the south of that centrally observed point, being the CN Tower, because the CN Tower is located right next to the Rogers Center. She was located due south, and she posted a video of the exact same observation. So I'm like, hold on a minute here. You mean to tell me that I have one centrally observed point observed from the west and the south that both, and they're both over water, that both show the same result? An observed 300-foot building in the landscape, 60 kilometers away. It's impossible. Impossible.
What you're expecting, elevation angle, right? They're using the same flat plane. They need to have the same result, obviously.
Yeah, I'm still trying to reconcile what you guys mean by it doesn't rise to eye level, but it rises with you. So,
what's funny
I'm trying to
really,
understand what you guys mean then.
I don't even think we're really appealing.
The horizon is not a physical place, yeah? The horizon is not a physical place. It moves with the weather. It moves if you move. Yeah?
I'm not disagreeing with that.
Regardless which vector you move, the horizon moves with you. Simple as that. Sometimes it's further away, sometimes it's closer to you, but it moves with you.
Right. So let me ask
Going
you a
up,
question
it
then.
makes no difference. Going up, it just means that you can see further away.
Well, let me ask you a question. If I point to the horizon, am I pointing horizontally necessarily?
If you're pointing at yeah, it is horizontal, yeah.
Okay, so it's at eye level.
Not at eye level, no.
The horizon is not a physical object with your eye level.
If you're looking
has
horizontally,
nothing to
that
do-
is what eye level. That's where eye level is. Looking
horizon is the
horizontally
same
is
thing. Hold
looking
on a
at
second.
eye level.
Yeah, well, there's a problem. You will have to correct for dip correction on there.
Horizontal,
Because
hold on a second.
unless you're
It's the same thing.
hold on, give me a second. Unless you're level with the floor, it is not horizontal.
It's the same thing, man.
No.
That's what I'm trying to get
It's
to.
because you're
Hold on a second. A
you're-
horizontal
if you
line
are
and a
5
level
feet high,
line. A horizontal line and a level line is the same. It's just at the different elevations. It's the same thing.
I mean, the point is very simple. The Bacon is insisting on trying to insist that the horizon is a physical object that can be below eye level.
I
And so
don't.
therefore it's curving downward convexly. No.
I'm
it's
not. This is
physical
just a
object.
straw man. I never said any of that.
What you're trying
I'm
to
just
get
trying
at.
to understand. I'm just
Stop playing boy.
I'm just
Stop.
trying to understand if the direction you think I'm gonna be seeing the horizon is a horizontal direction, or if it's lower than a horizontal direction.
It's a horizontal. It's more than that. It's a level direction.
It meets the floor. You know what a horizon is. Stop playing coy. I don't play bullcrap.
Not and also doesn't answer questions apparently.
It does answer the question. The horizon, get the point. It's not a physical object. It's an
And how that
optical.
answers my question.
So yes,
does
you
that
can
answer my
stretch your arm and point your finger at the horizon. Your arm may or may not be horizontal. Very likely is going to be horizontal because the horizon rises with you. The optical phenomena of the horizon
No, it
rises
doesn't.
with you.
If it did that, there would not be a
does
correction, a
rise
dip
with
correction
you.
in your sextant
You have not
observation.
seen one time the Earth convexly curving down. I'm sick of people lying to me. You've never seen it. You've never shown it to anyone.
It's
Never.
called the effect. It's not that you see curvature; you see the effect of curvature.
What the
No,
hell?
it's not
does
that you
mean?
see curvature. You just have to pretend it's there and then do a bunch of math to fit it in.
So why did they have a dip correction? Why the
full of
dip
it up your
correction?
eyebrows, and it leaks
It's
that
not the
tree.
Why
innocence, Your
dip
Honor. It's just that they have the effect of innocence.
Tell me,
Oh,
answer my question. Why is there a dip correction in sextant
Oh,
observation?
left lane
Can you
stop.
show what it says dip correction?
Yeah, I
Can you show
explained the
where
dip
does it say
correction
dip
thing like an
correction?
hour
Damn.
ago. I
Yeah,
Where
explained
does
that
it
dip
say dip
correction
correction?
posted an hour ago.
Y'all
Left
just
lane.
keep on.
You're not allowed.
Yeah, but where
to
does it say
I'll
deep
read.
correction?
Left lane. You asked for calculations. I just posted a link for you to look at. Okay, it's 2 minutes. You asked for measurements.
Yeah.
I just shared them with you. You and Bacon can
Yeah,
go through that 2-minute video, right?
Yeah, maybe Bacon could check it. I'm driving, but but why is there a dip correction in the Sexton observation?
Show us where does it say deep correction? What it says is height of eye correction.
It's by
That's the dip
definition
that you
dip
need to
correction,
correct.
George. It says it right on there.
Listen to the man answer your question,
Sexton
Howard.
observation you
A
use
height
says
of
you've got to
eye
calculate the dip
correction.
Answer your question, Howard. George, please. There you go.
If you are in the water, there is nothing to correct from.
Correct. Because the deep
There
correction
you
is zero
go.
there.
There
So
is
as you gain height,
there is no deep correction. Yeah.
as you gain height,
The
as
tangent
you
line, still needs to go from you to the GP, meeting at the 90-degree angle.
Gotta contain, George. As you gain height, your dip increases. That is what's called height of eye correction.
Yeah,
but that's not addressing the question, George.
Which question? There is nothing else, man.
All y'all are doing is just denying dip correction. And my question is, why is there dip correction in Sexton observation?
Is for angle correction, my friend.
Given we just went through
Dip correction.
What
Dip
angle?
correction.
Yeah, the dip correction
Howard,
is
what
the
is
angle
dip
correction.
Which angle?
Yeah,
Which angle?
how does it
Hold on a
work?
second. Which
Well,
angle are we
based
talking
on
about?
your vantage point. Jesus Christ.
Exactly.
Yeah. Yeah.
If you're on
Would
the,
that
And
be
as
an
you get
elevation
higher,
Where
angle?
does it
If
find
you're
a
on
dip
the
as you
correction
get
that mentions
higher,
vantage point?
if you're on a
Yeah.
beach, you use a
I posted
sextant,
it.
and if you climb up the mast of a ship, you use a bubble sextant. There's your
No,
elevation.
people don't use
no,
bubble
no, you
sections
don't
on
use a
ship.
bubble section on a ship. No.
Where are you getting this from? Or are you
Nautical
just assuming
sextant
that's the
is
case
the
because that's how you understand it?
Now, do you
The
understand?
nautical sextant
in
uses
my
the surface of the earth for
in my
navigation.
ignorant example, do you understand the example I'm trying to point to you? If you
No.
change the elevate, oh my gosh! So if I'm standing on the beach, looking off at the horizon, using the sextant, right, and then I jump on the ship that I'm sailing on, and I climb up the big ladder at the middle of the ship, the mast, which they also hang the sails from, and I look out at the horizon. Do you think that elevation change is going to impact my reading?
Yes.
This is my point to you. That is your depression.
Yeah,
Yeah, but
That's because the
depression.
horizon is
you
dropping.
need to establish the first thing you need to do
That was
is
half
to
an hour later,
establish
literally.
the horizontal plane. No matter which instrument you're going to use,
I
the
don't know
first
why we keep
step
saying
is to
that.
establish the horizontal plane, because your elevation is going to be from that horizontal plane, regardless which instrument you're using. You need to establish the horizontal plane first. Now,
what
if
do you
you're
mean
using the nautical sextant, you are
angle of
using the
depression.
surface of the earth. That's why you aiming at the horizon and at the sun at the
Well,
same time.
I
Angle
don't
of
know why
depression is below horizontal.
Yeah, why are we going all around this? The answer to my question is because the horizon drops to your eye level as you gain in elevation. That's the simple answer.
Drops
Where do you see that?
Wait. Drops to your eye level as you increase your height.
Drops from your eye
Yes.
level.
From your eye level, yes.
That doesn't make any sense. If the horizon's
that
going
makes no
down,
difference.
then you're on the side.
Makes perfect sense.
Okay,
It doesn't.
let me.
You don't know what you just said. The horizon's going down. It's going down as you go up, and somehow it's going up while it's going down.
No, I didn't say that. Yeah, you're
That
just
is what
strong
you just said. You said it rises as it goes down.
No, you misunderstood me.
Howard,
Say it again.
hold
Howard,
them accountable, Gregory. Well done. Hold them accountable.
Geo.
Howard, the dip correction over a planar Earth is simply a triangle from your feet to your altitude, whether you're 10 feet up or 30 feet up, and then the third point of that triangle is at the horizon. So it's a triangle from your feet, like from your feet parallel to the ground, the horizontal. From your feet up to wherever you are, if you're on a mast, 20 feet up, 30 feet up, whatever, that's actually that's why you're getting the dip angles because of that altitude. Then the last line is from your eyes to the horizon. It makes a triangle.
And so as you go up in elevation, you must make a bigger correction because the horizon is dropping as you go up, right?
No.
No, if you
It's
go,
not real. I wouldn't
you,
really. I mean, yes, you do
you
have
use
to
a
take
different
larger
instrument.
corrections for the higher altitude you go, but it's not really because anything's dropping. It's because that angle is increasing.
Yeah, which is an angle below
because
horizontal.
the horizon is dropping.
Yeah, they're
Yes.
denying it's happening at all. So
You insist that the horizon is dropping because you insist that the horizon is this curved, convex, physical thing going
No.
down. Not.
No one's saying that. No one's saying that.
So what are you saying then?
The
It's
horizon
pretty simple what I'm saying.
The horizon is always going to change based on where you're viewing it from.
Exactly.
That's
Think of
our
what you're
point.
suggesting. You're saying the horizon, it's dropping. The horizon can't move.
Oh, it's not physically dropping. We're talking about the direction.
Age.
We're
This
talking
is what
about the
I'm saying.
direction of
And
the
so
horizon.
in order for you to ascertain, you need to start speaking as if you're actually experiencing it. What's changing in that equation that's being presented? The horizon is not dropping. The horizon is not possible to drop. You are elevating your viewing angle, are you not?
Yeah, and the direction that I'm looking at when I
Thanks,
look
that's
to the
all I needed.
horizon is dropping.
What is the
I'm not saying
horizon?
the horizon is physically dropping. No one's saying that. It's just the most obvious and ridiculous strawman of the conversation. We're talking about the direction
is
of
the
the
horizon?
horizon.
Somebody's got to find a 3D model of like the viewpoint of a horizon being able to change. Like I got to find that for you guys.
fairly simple. I mean, I posted pictures of it, but it's very simple. What's being said on our side, which is that
Stop ignoring my
in your
question.
frame of view, in your frame of view, there's a center point. You call it your eye level when you're anywhere. It's your eye level is going to be the center point, the center line. And as you raise in altitude, the horizon is going to lower in reference to that center point, your eye level.
Which is implying that the horizon is physical.
It doesn't imply that at all.
No.
So then, what is the horizon then? I'm not going to allow
doesn't
this.
matter. It doesn't matter. That's completely
It does
independent of the
matter.
conversation. No, it doesn't, because we are all we're referring to is our experience.
So it doesn't
on
matter what is the thing in dispute.
No, because we're talking about its direction. All of the point
The
is
topic of debate doesn't matter in the debate.
that's not the
about the
topic of the debate. Stop. Yeah,
That's idiocy.
let me answer you. Stop just calling me idiot. So we see the horizon, regardless on what it is, it's at a certain direction.
You don't know what you're talking about.
As you go
You don't know
higher,
what is the thing
that
you're trying to talk
direction
about.
changes, regardless on what the horizon is. We don't have to know what
You
the
don't know
horizon
what the
is
thing you're
in order
talking
to
about.
know if the. Can you stop speaking over me for one sentence?
You're
For
not gonna
God's
sit
sake,
here and
Gregory.
just
Gregory,
Yeah.
Gregory,
Can't.
if you can't stop that, I'm kind of timing you out. Somebody already muted you.
Right. So all we're referring to is this observation. And then the direction we point to when we point to the horizon changes as you go higher. As you go higher, that direction gets slower. Regardless on the what horizon is, it doesn't change the fact that this direction is now lower. This is all what the argument is. You can talk about the horizon is once you acknowledge that, but that is the subject. And that doesn't depend on knowing what the horizon is.
You can't debate a topic not knowing what you're talking about. You're running your mouth talking about something you don't know what you're talking about, or you do know what you're talking about, and you just refuse to tell me
You're not
what
gonna
you know.
address. So you're not gonna address what I said at all.
So you're
You're just gonna say I don't know what I'm talking
You're
about.
up here running your mouth about the horizon. What is the horizon?
It doesn't
Because
matter.
all your arguments imply a certain nature of the horizon. What is it?
No, we're not talking about the nature of the horizon. You're talking about how our observation of the horizon changes as we gain altitude.
What is the thing you're observing?
Yeah, but what is it?
That doesn't matter for this conversation. Can you
What do you
acknowledge?
mean it doesn't matter?
Because we're talking about the observation.
You
We're
saying
talking
that
about
it moves. You're saying that it is moving.
No, we're not saying it physically moving. We're just saying it to point at it. If you want to point at it and you're very close to sea level, you're pointing. You're pointing horizontally. As you go higher,
you're saying that
now you point.
So you're saying that.
Oh my God, George!
You saying that the distance to the horizon changes then?
We're just saying that direction we have to point to when we look at the horizon.
What about the
changes.
distance? What about the distance to the horizon? Does it change as well or not?
That's irrelevant. Can you first acknowledge that
it's
the angle is
irrelevant?
changing? because I just want to know if the
He
angle is
doesn't
changing.
want to have a conversation. He just wants to demand that people answer his questions, but he doesn't actually want to have a
Because
debate
that's
and
the
a
point.
discussion to understand what we're
distance of the
talking about. He doesn't want to understand what we're talking about. If you don't
That
know what the
is the point of
horizon
the
is, you don't
conversation.
know what you're talking about.
That
Wait a
is the horizon is where the ground seems to meet the sky, and when we point to that junction,
you said, correct?
when we point to that junction, are we pointing horizontally or not?
It seems to meet the sky, correct? It's the apparent meeting point between the sky and the floor, correct?
Yes.
So it's not a physical thing, is it? Right?
Then.
Yeah,
So
I'll take that.
You're pointing towards where the horizon seems to be.
Exactly.
Okay, where it seems
So
to be. So it's not an actual location, right?
So it's not a
Yeah, no, I'm
physical
saying
distance
that's
to
an
the
actual
horizon. I'll ask
location.
again.
It's by
So I'll
definition
ask
apparent.
again. So I'll ask again. The distance to the horizon changes.
I don't know, and I don't think we need to know the answer to
What do you mean
answer
you don't
whether or
know?
not
You
the
just
angle is
said it.
dropping.
So it's not a
If I
physical
change,
thing,
listen,
correct?
if I change my elevation,
Yes, it's by
the
definition
distance,
apparent.
if I change my
Thank you.
elevation, yeah, if I just go up on the ladder, yeah, just going upwards, I'm not moving forward or backwards, it's just going upwards, the distance to the horizon will increase, correct?
We don't know the distance to the horizon yet. We're simply
Doesn't
treating it
matter.
as something apparent, George.
What do you mean it
Just
doesn't
not
matter? It
deviating
does
from the
matter.
conversation. That's
Now,
not
why
the
are you
It does
subject.
avoiding that
matter.
question? I'll answer the question for him.
Because
Yes,
he's
the
branching the
distance will increase.
conversation.
There you
No, dude,
go.
it's a simple question. Just answer the question. I'll
The
answer it for
horizon
him.
is
Yes.
not a physical place, man. The horizon is not it's not the leading edge of a
You
sphere.
just
It's not
Right,
defined it
that's
as
still
a
not
distance.
addressing the point, George. That's why I don't care about answering your questions.
Yeah, Bacon's
It has-
talking strictly about the apparent horizon and where it appears in your frame.
Yeah, we know what he's
the
talking
apparent
about.
horizon, there's only one
Whether
horizon.
the horizon is physical or
There is
not.
only one
Because
horizon.
either it is a physical thing, which has a fixed location, or it's not a physical thing, and it's just an optical phenomenon that changes all the time depending on your altitude and the conditions of the atmosphere.
Yeah, it's the second option. So given that, what happens as I gain
Yeah,
altitude?
welcome
What
to
happens
Flat
to
Earth,
the
man.
direction? What happens to the direction in which I see the horizon? What happens to that direction? It drops. This is what
You
it means to
don't
say the horizon
see the
drops from eye level.
horizon drop. You
Define
don't see
drop.
the floor drop. You
Sorry?
keep saying that because you're religiously devoted to this notion. You're not actually an empiricist. You're denying what you actually observe empirically. You don't see that. Show it me.
You do. You do.
Dude, it's been shown to you in the chat.
God damn.
You're
Can
either
you not
trying
look
not
at
to
the
understand
horizon?
this or you strictly don't want
Yeah.
to. But he's not saying that it's
Yeah.
physically dropping. He's saying that in your vision, it's dropping in reference to where it was when you were lower. That's
You
it.
can just
So this silly picture at 20 minutes past the hour really demonstrates that the horizon is curving downward.
no one's saying it's curving downwards. That is not the topic of the
So
conversation.
you're not
It's
trying to
just
argue for a convex surface of the earth?
no. I'm trying to argue that the
So what are you
direction of the
arguing
horizon
for?
drops with altitude, which can't be denied.
What are you arguing for?
I just said it. If you don't speak over me, you might be able to listen to the answers of your own questions. So I'm telling that the angle to the horizon drops as you gain altitude.
So what?
This is
What does
observed.
that have to do with the surface of the earth?
Right.
He's saying
So
it's a flat
you are
plane, so
acknowledging
that's
that. Are
observation.
you acknowledging that
Not all the time.
generally? Yeah.
Oh, okay. So not all the time, though, right?
He's agreeing with us, man. He's agreeing with
I'm
us.
asking him.
What-
Not all the
what
time,
he's
right?
saying-
Hold on. Let him answer. Not all the time, right?
Sure. If you don't gain altitude, it's not going to change. So
No,
no,
if
not
you
all the time.
if you gain altitude, sometimes it goes eye level, sometimes it goes under. It changed depending on how far you can see and whatever the atmosphere is doing.
I haven't seen any observation of you getting above the horizon as you go up. So I'm not going to attest to
Isn't
that
that-
possibility.
Isn't that still an elevation angle, regardless of the altitude? Didn't we
So can
just
I
went
get
through
a
that?
acknowledgement?
Regardless how further you are from the surface, you only use the surface for the nautical sextant, and anything if you're not using the nautical sextant, you're using something else, but it's still elevation angles. And your observations from
George, no one's
up
talking about
above
that,
is
George.
still elevation angles too, or depression angles.
Oh my God, George.
For you to have the depression angle, you need to establish the horizontal plane first. For you to have the depression angle,
to guide yourself from. That level plane is the one that it should be dropping in every single vector, 8 inches per mile square. It's the same one, you know? Non-existent.
Okay, the dip. Anyway, I was talking. Yeah, the dip of the horizon that we referred to is how much its direction drops from horizontal. So when you're talking about dip,
That's
you are
nonsensical
talking
what you're
about.
saying.
That's
nonsensical what you're saying.
How is that nonsensical, George?
Yeah, because the horizon is horizontal, so you cannot drop from horizontal. You mean
No.
from different levels? You can have different levels, different horizontals.
George.
You can have different horizontals above or below horizon level.
George, if the horizon is always horizontal, then its direction isn't changing as you gain altitude, because it will keep in horizontal direction. So the direction wouldn't be changing. It can't.
Unless you were
it
looking
can't
at
have
the
dip
end of the world,
and
unless you were looking
always
at
be
your end of the
horizontal.
world, then it wouldn't drop. I mean,
Horizontal and level is the same vector. Horizontal is mainly used for drawing and artistic things.
It's not even a vector.
The horizontal line. Yes, it's the same vector as a level. You know, if you have a horizontal on a piece of paper, in practice, you use the same vector, which is a plane, a level plane. The level is the horizontal. You know, one is in practical terms, and the other one is in drawing terms. Same thing as a vertical and a plumb. You know, one is drawing, the other one is physical. So when we're talking about the horizon, the horizon is what gives us the horizontal lines, and any level line will be a parallel line to the horizon. So even the picture that Kosho put it there with the horizon at the end and a water level on the other. Yeah, no shit, man. Your eyes are not at the same level as your feet.
So, George, you mentioned plum, which is an interesting word.
Yeah.
I'm starting to love plum more and more because a construction plumb bob. Anybody that's heard me talk about this thing in the last probably like 5 days, they're like, this guy's like a one-trick pony. But a plumb bob, a construction plumb bob, also like a crane would be an example. Like a construction crane would be another example of a construction plumb bob, because they both have this observance of down. Agreed?
Not quite. No.
Tell me.
A plumb bob consists in three items. Yeah, you have a weight part, which is the heavier part. Normally it's pointy, you know, and you have the back part, which has exactly the same dimensions as the way, exactly the same thickness, one or the other. Yeah, and then you have a string that connects the two. So if you wanted to test if a wall, for example, is plumbed, you would go to the top part. You would hold the secondary item against the wall, and you will drop the plumb bob by releasing the string, slowly going down, and you will see if the plumb is going parallel to the plumb.
See the chat. It's in the chat.
Yeah. Yep. It needs to go parallel to it. So if it's dragging on it, it's not right, obviously. If it's deviating from the wall, it's not right either, isn't it? So the same dimensions on the top, you know, away from the wall, needs to be the same as on the bottom one. You can do this with anything, but it needs to be the same thickness on the top and the bottom. Point is that you cannot have, without the horizontal, you know, you need the horizontal first. If you want to build a wall, if you're going to build a wall, you know, you don't start on the vertical, do you? You start on the horizontal first.
Well, how did you start with the vertical? I mean, with the horizontal, by starting.
You have to establish the
vertical.
first. You need to establish the horizontal first. Yeah, correct.
Well, how do you establish horizontal first if you have to use a plumb bob first to establish vertical to establish horizontal?
No, if the
Yeah.
plumb bob is secondary.
No,
Plumb
the
bob is
plumb bob is the
secondary.
first thing, right?
But you to
Because the second,
establish
the first,
no.
if you're
The first thing you establish is
if
the
you're
horizontal
assuming,
plane, which is a level.
no, because now you're begging the question. You're assuming that the Earth is flat.
Exactly.
No,
Bullshit.
I'm not assuming the Earth to be anything. If I'm going to build something, the first thing I'm going to do is to plane the surface.
He's
I'm going to build
assuming
on.
that the
If you can use-
horizon is
yeah.
level. That's
That's
the only
right.
thing
That's
he's
what I'm saying.
assuming.
Well,
No,
that's
no,
fucking
it is
shit.
level. The horizon is level. It's called
The
sea level
horizon
for a reason.
The horizon does not rise to eye level.
No, it
Horizon
doesn't rise to eye
Yo,
level. Of course
I
not.
can't listen to
Yeah,
this.
we've
Yo,
been
y'all
through
are in
that.
denial.
Yeah, it's called sea level for a reason. The sea
Okay.
level will oscillate, yeah, by low tide and high tide, but it will never go further down or further up than those levels. You know, sea level, it's sea level. Means no
Okay.
part's higher than the other.
You have the idea that you've established vertical by a means. Now I'll just use a tree branch as my assumed vertical, and I'm going to use a long vine that I found off in wherever, and I'm going to use a big rock and tie it at the end of that vine. So I've used the tree to illustrate your vertical, and then I've used the long vine, if you will, or rope, and a big weight at the end of that rope, and I've hung that from the tree branch. Do you agree that I've created a plumb bob?
Like I said, it needs to be equidistant. You know.
Do you agree that I created a plumb bob? The hanging
If it
vine
has
or
the same
hanging rope
thickness on
from
the
the tree
top,
branch.
not just a line on the T branch. No, that's not. That will be a pendulum.
I said to you, a line on a tree, right?
Yeah, that will be a pendulum.
At the end of
All
it, is
plumb
that
bobs can be
not a
pendulums.
plumb bob? Yes or no?
No, it's not a plumb. That will be a pendulum.
A pendulum means you're swinging a plumb bob, dude.
No, not quite. No,
Yeah.
a plumb bob
It could be
consists
either
of
one.
3
It
items.
doesn't
No,
mean-
plumb bob consists of 3 items. What you're describing is 2 items: a piece of string that you attach to something. Yeah, it's something heavy on the other side. That's not a plumb bob.
I asked you.
And I said
Plumb.
no, it's not the plumb bob.
Plumb bob.
You're wrong.
No, it's not.
It's a long line with a weight on the end of it. Is that
Yeah,
not
that's 2
plumb bob?
items. That's not the plumb bob. No, plumb bob is 3 items. You can
And what's
Google
the
a plumb
third item
bob.
missing for it to be a plumb bob?
I just told
God
you,
damn.
man.
The
There's
vertical
a back
item, right?
Not a vertical item, man.
So what is the
Why don't
third
you
thing
Google it?
to make it a plumb bob?
Why don't you Google it? Let me Google for you, man.
I can't
No,
believe
Let
we're
me do the
arguing
homework
about
for
what a
you.
plumb
So
bob is.
complicated. I know this guy's
Man.
so
George, I posted a
Plumb bob.
picture in the chat.
funny.
Have you? Let me see.
Yes. It's that
I
one
could
is
tie a rock.
that's actually
I could tie a
that's
rock on a
construction
string
plumb
and call
bob.
it a plumb bob.
And,
No,
and for
that's not
all
the plumb
intents and
bob.
purposes, it does the
That
same
is
thing.
that is a construction plumb bob, my friend.
Yeah, but why don't you
Look,
show
there's
the
a
top
tape
part?
measure and
Why
cut
don't
wood
you
in the
show the top
background.
part?
It's like a
Why don't you show the
construction
top
site.
part? Why don't you show
Pardon
the
me?
top part?
I'm saying to you that is hanging down, right? So
Yeah, but where
I'm
is the top
asking
part? No, I want to see
you.
that. No. I
What
want to
does
see
it
the top
matter
part.
about the top part? Why does that matter to
It
you?
does.
Why?
It does
Appealing
because
to your
what you're
intellect.
doing. Listen. What
Why?
you're
On the
doing
top.
here.
Why?
Listen.
What does it matter if I
what you
hang
do?
it from? What if it matter if I hang it from a tree or if I hang it from a telephone wire? What does it
Or
matter?
just hold on to it.
It matters that you don't need the tape
What if I
measure
just hang it from
anymore.
my finger?
You don't
We're
need the
not
tape
asking
measure
you to
anymore.
measure. No. We're not asking you to
I'm not
measure
asking you to
anything. We're
measure the
asking
length of
you
it.
to observe down.
That
That's
You
all
need
we're
to
asking.
measure the length of
yeah,
it.
but why are you measuring it?
I'm asking
What do
Because
you
you
need to
want it to
measure?
be you want it to be the equidistant on the top and on the bottom, don't you? You want the measure to be the same. Yes,
You're
that's
already
why.
setting up. George, stop it, please. You're
No,
already
that's
setting up a
why
question.
you need.
All I asked you, George, was, does it illustrate a plumb bob? The construction
It's
plumb
not a
bob
plumb bob.
would illustrate the
This dude
measurement
couldn't get in his
taken.
own car if you
I'm
gave him a
asking
No.
you to take the plumb bob, illustrate down, because I'm going to guarantee you what happens once you illustrate down by observing 90 degrees, you automatically paint a
It's not
perpendicular
observing
line,
down.
horizon line.
The plumb bob is not observing down; it's observing the 90 degree, which
No,
is the
plumb bob
perpendicular to the
Ah,
level.
damn.
observe down.
Ah,
This is
damn.
goofy shit
And then
right
you can
here.
observe
Yeah,
from
The
man.
perpendicular
level.
to the level, man.
Pure goofball.
This is funny.
You
Listen,
gotta.
what you're saying, what you have here,
Listen.
what you have here is what you have here on your example is a pendulum that you are using as a plane bob, because you are using the measurement, the tape measure, to measure the top and bottom to be equidistant from the wall. Yeah. Now, if you have the third of the device that I'm talking about, which is the same diameter as the weight part of this conical device here, it's exactly the same size. You don't need a tape measure to make it equidistant because they need to run one equidistance from the other. That's why the expression of dropping a plumb bob. Yeah, so you hold one side and you drop the string that goes through the middle of it, and the plumb goes down. A plumb bob requires 3 items. In this case, the third item is the measuring tape.
That's not what that's a plumb bob. A plumb
That's
bob
exactly
or
what
plummet
it
is
is.
a weight, usually with a pointed tip on the bottom, suspended from a string, and used as a vertical reference line or plumb line. Period. It doesn't
Yeah,
say
but it
proceeded from a
needs to run
particular.
equidistant, man.
It
That's
doesn't
the
say
Buddy,
part.
anything
It needs to
about
run
being suspended from
equidistant.
a particular.
The only
Nah,
way,
none
the
of
only
that
way
is
you
what
know.
you're trying to establish something against something else. That's not what a plumb bob already is. That's what a plumb bob
That's what
does.
it is,
What a
man.
plumb bob is this. It is a weight, usually with a pointed tip on the bottom, suspended from a string and used as a vertical reference line or plumb line. Period.
That's all it is. That's all
so
it is.
Nah,
George,
it has
my next
nah,
question to
Period.
man.
you, George.
Now, if you
My
swing
next
it,
question
it's a
to you.
pendulum
No,
because
man.
that's all
I've
that
used
is.
many. I've used
George.
many plumb bobs, and
Okay,
it's
so
3 items, not just 2.
when they
Sorry,
take that measurement,
wrong.
George, and it's 3 inches at the bottom of the string off the wall, and then it's 2.5 inches at the top of the string. What have they realized with using the plumb bob?
The wall's out of plumb.
Did you have to answer for him, Left Lane?
It's easy. It's easy.
Yeah, of course.
I
But
mean,
of
this is
course, but it's
elementary
the same
stuff. I don't
don't
know
have
thing.
what
all
we're even
day.
Of
talking
course,
about it
it is
for.
We don't all have all day
That's
to fuck
why,
around.
in order to listen, in order not to have the measurement with the tape all the time, yeah, you have equidistance from one another, because for you to have the plumb, you need to be equidistant. The same thing as the level. It's you need to refer one point to the other always.
It's
And
just a
you are
vertical
referring
reference.
with a measuring tape, with a measuring tape, with a tape measure. You go along the line, measuring the distance between the line and the wall.
You could eyeball it.
When
So, yep, that's
I'm
true.
asking
you
myself
have
a
it
crazy kind of
already,
question.
when you have it already equidistant from the start, from the top, and you drop the plumb bob, you can see the differences.
So if we go back to I think it was Kiwi was referencing a crane as a plumb bob. What was your point with that?
Because it's the observance of down. Because if it has a weight at the end of that line, it's the observance of down.
Yeah.
No argument there.
So now I'm
And
asking
90
myself.
degrees to down is level.
So can I ask you guys a question?
So without the down, do you still have the plumb bob? Can you have a plumb bob in space?
No, dude, you don't. Because there's no
That's my
mechanism for
point.
without
That's
the
my
down, without the
point. Without
gravity,
the
there would be no
horizontal, you
direction.
cannot have
There would
without
be
the
no
down, without the
what
horizontal,
we
the surface.
call
The
what
plumb bob
we
points
would
to the surface,
direct
isn't it?
use.
Can I ask you guys a question?
Without the
Oh my
surface.
god, this guy just starts ramping up every time I start talking. He just
Yeah, go ahead,
blasts
man.
away.
No, I'm sorry. It's because I'm in the street. I feel like I got to shower.
No, it wasn't you, man.
I'm just wondering, how do we explain things finding level? That's what I'm wondering.
Liquid dynamics.
That's an interesting question because if I hang a TV and I live in Australia on my living room wall, or I hang a TV in my home in New York City, I still have to use level, which is the observation of level, which is 90 degrees to down, no matter my hemisphere location.
And down would be the surface of the Earth.
Checkmate. Oh yeah, welcome to Flat Earth.
No, down would be the surface on the Earth. That's not a checkmate. That's literally, it's what our model is in the globe model. That is down. Everywhere on the globe that points towards the ground is down.
Yeah, so right now what I've done is I
If
basically
I
have you
step outside
arguing
of
what
that
is,
reference frame
I have
and,
you
and look at the
arguing.
entire Earth, then
No, but now I have you arguing
then
as
I'm looking
to
at this.
how
Wait,
far
you have me
down can
what?
be observed, don't I?
You have me what?
I have
So
you
hold on a second.
arguing as to what is down, right?
Arguing?
Let
No,
me
I'm just
ask him a
telling you
question.
what the
So
standard
if you have
model
a,
says
if you have
about
a,
what down is for a glober.
let me ask you this: if you have a level line and you have a plumb line, like you said, they are perpendicular to each other, correct? 90 degrees.
Yeah.
Correct.
100%.
So what if you put two more 90 degrees lines on the same level? Can you do that?
Yes.
Not unless they're very, very close.
Will those
together.
will those be parallel to each other?
1 degree.
Always parallel to each other.
1
They
degree
will
of
never
divergence
intersect.
for 69
All
Regardless,
models have to intersect.
regardless how long the horizontal lines are.
Exactly.
No, it's not true. It's
Bridge construction, pier
What do you
bridge
mean it's not
construction.
true? Hold on a second. He's saying it's not
Right.
true.
High-rise
And
steel construction for condominiums, I've observed the exact same thing. Even the towers in Dubai, they all use the rationale of the observance of plumb, and plumb is exactly what we just illustrated with the plumb bob and that little fight.
Yeah, all
because
buildings
in that
reference a
local
plumb at their location.
Yeah, at that location. But if you start comparing the buildings together, you notice that the buildings diverge. The tops of the
Oh, so
buildings
you're
diverge 1 degree over 69 miles.
so you're stating that there is a 1 degree divergent point on all construction that takes place on this ball of yours.
And this ball of yours.
So you're saying that the planet Earth looks like a big germ with sticks sticking out of it.
If the planet Earth was shrunk down to the size of a basketball, then yeah, you would see that from your little perspective. But from your little perspective, you don't see that because the Earth is so much bigger than you.
Okay, so again, you sound
Wow,
smart, guys.
man.
So over a 60-kilometer distance, what would be my expected depression?
Almost 1 degree.
No,
Divergence.
I need on 60-kilometer distance. What is my expected depression? There should be land depressed beyond that point, should it not?
It just answered you. It just answered you. 1 degree.
Yeah, I don't even understand why you don't understand. That's what the problem is. I can't even see where you don't get it.
They see 1 degree depression on a right angle. You cannot have a depression on the right angle, man.
Therefore, it's not a right angle. It's only a right angle
It needs to be a right angle.
Only to itself in the ground, not to each
No,
other.
no, it is a right angle. No, it's an elevation
No, you
angle.
didn't
That's
connect
why the
all the
degree
buildings
difference.
together to check, did you?
Listen, the degree you're talking about is a degree of on the elevation angle. On your protractor, you'll have 1 degree because you moved further away, so it looks like it dropped from the previous point 1 degree. So you're still navigating on a horizontal plane, same horizontal plane as you were 1 degree ago, 60 miles ago. Again, if you use the celestial navigation, it goes from 15 up to 90 degrees. You cannot have more than that. And that 1 degree of depression angle, it's not a depression angle, but you know what I mean.
No, I
Deviation on the angle reading, yeah, it's a linear measurement.
Oh, so you observe the angle and you come up with your own excuse for why you see it, and you still say you don't see it.
What is an angle?
The 1 degree of 69 miles.
What is an angle? We're going to measure an angle, isn't it? What is that?
It's the
Two lines
difference
sharing a
between
point.
two lines.
What's
The
that?
area between two
360
intersecting lines.
degree circle. Yeah. Drop a circle on it, 360 degrees, mark them out. I mean, if you have
What
to
do you
do it
mean
all by
360
hand,
degrees?
or you can use a
Oh,
protractor.
you mean the circle of equal altitude, you mean?
Well, I can't help it that you don't know that we use arbitrary units of measurement.
Yes.
And
It's
those
still
agreed on
elevation
units
angle,
of
no?
measurement are what we call degrees in this case.
Yeah, but it's elevation angle, isn't it? Elevation angle is elevation from a horizontal.
No, it's not the elevation angle that we're talking about here.
Yeah, it is. You're talking about your elevation angle dropped, your observation, your angle dropped 1 degree. Your angle requires a horizontal plane to be made. Your
Yeah, and a
angle is
horizontal plane is very
a
easy to be made
depression
when you
from
drop a
a
plumb line
90
into the center of
degree
it.
right angle triangle. It's a depression from 90 degree, correct?
No,
Yes, it is.
it's a divergence from 90 degrees. Just because you change the word.
Divergent from 90 degrees, yeah, but 90 degrees required between you and the GP of the observed celestial light. It cannot run from it, man.
A divergence from one position in relative to the other position. They're both plumb
Yeah,
to
the
their
positions are
location
something else, man.
in themselves, but relative to each other, they are not. They should be. If you were right, they should be. There is no reason why they would diverge, unless you've invoked some sort of refractionary lensing effect that you can show us. You don't have.
No, it wouldn't fit the geometry, you see, because the measurements are repeatable. And that's why it's successful, the celestial navigation, you know, because many people use it from different ethnies and different backgrounds. You know, they use the same concept the same way, and it works out. The elevation from the plane that they are navigating on, sea level.
Hey man, I got 2 Grubhub. Oops, I'm not muted. Yeah, I'm working Grubhub right now.
Don't worry, guys. They'll come back tomorrow and they'll say, "You'll pretend this conversation didn't happen."
Yeah, you will.
Everybody here does. It's like we've had these same conversations for years. That's the
You
truth.
just pretended like it didn't happen right now. You got your
Did
whole
it?
ass handed to you on a platter, and you pretended like you didn't eat
I
shit.
don't. I don't think anybody's asking handed on a platter.
What conversation?
The guy not realizing that a plumb bob is completely irrelevant to have this third part that he needs to have. It's a string
Yeah.
and a weight. That
What
was
about the
the
elevation
thing
angle?
started.
Listen, guys.
What about the elevation? The third part
That's
that you,
you
as you
using a
demonstrated on
measurement.
your picture.
That's you taking a measurement of something else.
The third part.
Afterwards.
The third part is the tape measure that
But
you
George,
introduced that. You introduced that on your picture.
See what I
Okay,
mean?
George,
This
hold on a
whole ass.
second. Do you understand, right, that when I'm appealing to your intellect in attempting to paint the picture of what is down, right? When I say we're going to hang a line from a tree and we're going to put a weight on the end of that line, and we can literally say down. Like cavemen, if they actually existed, they could have done the same thing. They didn't have tape measures, right? All I'm trying to extract from you at that point in time is the illustration of down, because we can say this is something we can observe and it exists. Then once we illustrate that, we can automatically extrapolate the fact that the horizon always remains level to that point. I can literally lean down and see that, like, that line
of the line coming down of the vine aligns in a cross with that thing in front of me, right? That's what I'm looking for you on that feedback loop.
Yeah, but you cannot call it the plumb bob, though. You just have a waiting piece of string, like a pendulum.
That is
You don't need,
no.
you don't need to
Listen,
call it a plumb
George,
bob.
See
I'm
what I
gonna be
mean?
A plumb bob
specific.
needs to be
No,
equidistant
no,
and the
listen
top
to
and
me.
bottom.
No, George, I'm gonna illustrate this again to you, my friend. The word pendulum, right? It's an identifier of a necklace, things of that nature, right? But for the aspect of you have to realize that is almost like giving it an action, right? This is not something that we're seeing moving. It hangs still. So you can't say that it's giving any kind of pendulum. No, it's literally a plumb bob. That's what it literally is.
I'm not denying the fact that it's going to be aimed down. That's not what I'm saying.
And
I'm
no,
just what I'm saying is I don't think we're using the right word, even though
No,
English is
we
not my
are.
first
You're
language.
not
I
using
might
the
be
right word.
using it wrong, but I
No,
don't think I am. I don't
no,
think
I'm
this is
using
lost
the
in
word
translation.
100%.
It's using it wrongly.
Listen to me
And
carefully.
here's the video that I love about, and it goes and it demonstrates near the end that divergence. It's like a half a degree over almost 34 miles of divergence on the towers, and you
Now,
can also see very
for the example that
clearly.
was given
You can also see very
from the
clearly
something
a
hanging out of a
demonstration of
tree.
no cutaways. Why are you interrupting me right now? And I'm trying to preface this video that I'm linking that talks about
You go ahead.
your very confusing situation. So here you go. I mean, if you just take the time and take a peek at this, it's been around for years already. And I never see anybody actually address any of these points. And all of the points that are very necessary for your reality to exist are pleasantly quelched.
You lost me there, man.
That means you've been debunked.
I've been debunked? With what?
With your
With
That
what?
video he just
your
posted.
little,
That
yeah, your
A
little
video
he
that you just
posted.
posted.
your
What's
explanation
in the
that
video that you just posted that it
these
debunks what I
buildings
said?
are all vertical and horizontal to each other,
Yeah.
or
Hold
parallel
on a
to each
second.
other. They're
Yeah.
not.
They are parallel to each other. Yeah, they are.
No, they're absolutely not, and you'll see very
No,
clearly.
they are. They,
Okay,
are,
no,
they,
they're not. But I haven't
they
watched the
do
video
run.
at all.
Listen.
But no, they're not. Right? Okay.
Listen. If you do the test, if you do the test
Talk your way out
yourself,
of it all you want to, but I'm not your mom,
if
and you
you
can't
do
run
the
that shit
test
on me.
yourself, I invite you to do the test yourself. Go to the top of both
Here,
buildings
this
and
is me
drop
in
a
Tel
plumb
Aviv.
bob.
Look at my video. Shut up.
Drop a plumb bob. Yeah,
God
drop a
damn.
plumb bob from both buildings and tell us the deviation how much it is.
Lordy.
Well, have fun watching the video, right? That you didn't. You can't
I want
do
to
it.
see you
It's
dropping
like
a plumb
putting
bob
your
from
hands in put your head in the
a
sand.
100th floor building, please.
Okay.
Yeah, George, if I
I'll
drop
get
a
right
plumb
on
bob
that.
from this building and then I go 10 miles away and drop a plumb bob on that building, has that
I
told
want to
me
see
anything
that.
about the surface?
I
Has
want to
that told
see
me
that.
anything? All it's told me that those buildings are plumb,
I would
but they
like to
don't
see
reference
that.
one another. They don't
Yeah, but I
reference
would
one
like
to
to
the
see
other.
that in the first place. I would like to see that in the first place.
Man.
You know, someone dropping a
Okay.
plumb bob on
Oh
a
God, this guy's
100-story
crazy.
building and see the plumb bob reading. I want to see the reading. I want to see you going with your measuring tape to measure on the top and on the bottom and in the middle to see. It's not going to happen like that. It's already
There's no
measured
utility in that for this
before
conversation. Is the whole point, right?
before
There's
you
no
even drop
utility in
the
that.
plumb bob.
Which means you'd be
There is.
wasting your
Before
own
you even
time,
drop the
right?
plumb
Because
bob,
how come you
before
don't
you
understand
even
that?
drop the plumb bob, you're going to drop it equidistant to the top part. That's what makes the plumb bob.
Poor guy.
So you won't need a measuring tape.
He
It's the
doesn't even
same thing as
understand
the
his own
measuring
word
tape.
salad.
You're just saying the same thing, man. It needs to be equidistant. Yeah, you just use a different way. You don't use a measuring
I
tape.
don't know what you mean by equidistant. That doesn't make any sense.
Uh,
To the wall?
How do
it's
you
what the
know?
tape measure is
The
for.
vertical
You're going to
line?
measure the bottom and the top. Yeah, you need to measure the bottom and the top. The measurement
But you
needs to
need to
be
compare
exactly
the
the same.
you need to compare
Listen,
the
hold
two
on.
buildings though, George.
That's what
It's like
means
saying this,
equidistant.
George, if I make a box over here and every angle is a right angle in my box, right? And then I make another box somewhere else and every angle is a right angle in that box. How do I know if those two boxes are lined up without actually measuring them to each other? Dummy.
Well, if they are on the
Thank
same
you.
level playing,
Thank
if they are on
you.
the same level playing,
I would
if
drop
they
my
are on the
mic,
same
but it's
level,
on my phone.
Let's not call
if they are on
names.
the same,
That's not
if
really
they are on the
appropriate
same
here.
level playing, it's easy. But even if they are at different level planes, yeah,
I don't
you
mean to
can
do that.
do
I
it.
just somehow do it.
Listen, man, the water level doesn't require to be on site in order to measure the water, the level to be
I
the
have a
same.
whole box of blue paper clips.
Yeah.
Another non sequitur.
And
Doesn't make any sense to what we're talking about. Just like you.
talking about measuring
I love
angles
strawberry
to
ice cream.
different levels.
Now, if the argument is we don't know if the Earth is round or flat, we need to actually compare the two locations.
No, that's
that are
not correct.
plumb. Oh
That's
yeah,
not
it
correct.
definitely is. Because how would you
No, it's
discern
not
it?
correct.
How would you
Since
discern it?
2000,
How would you honestly
2020, it's been
discern
debunked.
whether or not? Why are you interrupting every time I talk? You
Since
get so
2002, it's been debunked. The horizon is not the leading edge of a sphere. We don't live in a sphere.
no one says that the horizon was an edge of the sphere. That doesn't make any sense either.
Exactly. So why do a bunch of people act like that's what they're seeing?
The leading edge.
Another anti-flat earther.
Leading
So
edge.
Graham, wouldn't it have to be
the globe plane.
Wouldn't it
The
have
edge
to
of
be
the
for
sphere,
your idea of
the edge
No
of the
one claims.
sphere is the surface of the sphere.
No,
yeah, wouldn't it
no
have
one,
to
no
be
one
that
claims
if
that the
that's what
horizon
is
blocks the bottom of
Every
boats.
location on the
George.
sphere can be the edge of the sphere from any observer from an observer's location.
You're not hear
within the
Geo talking? Hello?
Yeah, y'all are talking all over Geo.
It seems like a lot of people are talking at once. No, I just want to say real quick. I mean, if it's not the leading edge of a sphere, then why would folks say that it's cutting off boats from the bottom up on the horizon?
Here's the point, though. If you consider it as the leading edge of the sphere, then it's also now always a location. It's an observation that relies on the observer. So this edge of the sphere is every single surface of the sphere, depending on where the observer is. There is no single edge of the sphere.
There is correct. So there is no sphere then.
Yeah, I hear you, but I mean that's what you're claiming it is. If people are going to say that's what's cutting off boats, you're right. It's not. There's not one edge to it. Everybody would have their own leading edge depending on their position and their their point.
So it wouldn't call it the leading edge of the sphere then, because it's only for an observer at that time in one location. The whole entire surface is the edge of the sphere. It's the outside edge.
Yeah, the word itself, edge. I see a box, the edge of a box, or something with right angle or something like that. I wouldn't use the term edge in reference to a sphere.
Yeah, it's a misnomer.
Well, you can.
So what blocks the bottom of boats and buildings then?
It's like calling the plasma from the sun a solar wind. It's misleading to a lot of folks. They think of a wind blowing around and shit.
But I mean, if you want to say that, whether you call it an edge or not, I mean, just whatever word you want to use, but whatever the leading Earth, the leading physical matter, whatever you want to call it in terms of that. But my point is that if you're going to call that it's cutting off boats from the bottom up, and you're going to call that the curve of the Earth, and that's why it's happening, then that should be happening consistently in other places. Like if we saw that consistently, like if that was what we always saw was things cut off at that geometric horizon point, you guys would have a much stronger case for a sphere, but we don't see that at all.
Well, when you take our words like curvature and you start adding your own words like edge, you misunderstand what's happening and you confuse yourselves. I didn't use the word edge. That's why I had to correct that, because that was a flat earther confusing himself about what we think the Earth is.
So what do you call it if you think it's the sphere that's cutting off boats from the bottom up? What do you call that?
Earth curvature.
Okay, then we'll just use the word Earth curvature instead of edge. That's fine.
But they don't like to use that word. It's going to suck. See, that's my point.
It's the edge of the sphere. It is the edge of the sphere from your perspective.
Would you agree? Would you agree? Would you agree that the distance to the edge of this, to the curvature of the distance to the curvature would depend on what?
I mean, the first definition of edge, Grim, is a line or border at which a surface terminates. So that's where the sphere is terminating. The word edge is perfect for that. The surface is terminating at that point on your
terminating. The sphere is not terminating. And
From
any
your
point.
visual point, it
It's
is. It's the
curving away from
termination
you.
point of the ground that you can see. The
No,
surface
there's
is
no
terminating.
direct remember, you made us. You argued this for months. There is no horizon. It is all it's no fixed location, right? It is dependent on the
Yeah,
observer.
welcome to
So there
Flat
is
Earth,
no
man.
cutoff
Correct.
zone. There is no.
Yeah. We are in agreement, man. The horizon, it doesn't block the bottom of boats and buildings. You know, it moves with the weather.
We see
It's
it.
not a place.
I'm sorry, I
It's
meant
not
to
a
say
place that you can
geometric.
go to.
There's no
Yeah, it's
geometric
not
horizon from the
geometric.
location.
Yeah, you cannot measure to it because it moves. So when it comes to the globe claim, they claim that the horizon is the leading edge of the sphere. The thing that they measure depression angles from.
I know.
The
Sorry,
problem
you
is that
interrupted me to just start stumbling around. I just wanted to clear something up.
that disprove that. Yeah, we can see the horizon, the distance to the horizon be greater than 10 miles from the observer.
Okay, well, okay, just for the record, I'm not saying I don't believe that there's not a geometric horizon. I'm saying this is the argument that you guys present. So you can't then take that.
The geometrical horizon
You're
is not
interrupting me.
not
You were
observable.
never here for any of that. I don't even know who you are. So I'm just talking to Geo right now, if you don't mind. All right. I'm sorry, but I'm not trying to be rude or anything, but I'm trying to directly respond to what Geo said, not anything that you're throwing in the mix right now. And so if Geo, you can't really, rely on using that logic if you, before that, limited yourself by saying there is no geometric horizon. So now you can't say there's an edge either. You see what I mean?
Sorry, I was texting someone. I don't think I fully was following. Do you want to
Well,
say?
you know how we came to the conclusion, and as flat earthers, not me, right? I'm saying that I don't believe there's not a geometric horizon. I'm saying that the flat earther argument is that there isn't a geometric horizon, right? And that so then you couldn't then say, well, if there's no geometric horizon, but there is an edge. That would be counter intuitive. That would be two opposing ideas that you're believing in. That it's a cognitive dissonance to me.
I'm not sure what you
have
mean. You mean
both.
the edge of a sphere, or what? Or do you
Yeah,
mean
you
the?
wouldn't be able to call it an edge of a sphere because an edge would be the edge of something. That would be a geometric edge, right? You would have there's no geometric horizon, therefore you can't say there's an edge of a sphere either. You have to use your own logic and back that up, and and say that it's an apparent edge, or to you, but you're still using the wrong word, edge.
I think if we were on a sphere, there would be a geometric edge.
Yeah, if we were on a sphere, like if you put a little camera on a
geometric
basketball and
horizon.
you look out, if you put a camera on a basketball and you turn the camera on, you're going to see like an edge, like it's the end of the basketball of what you can see, because the rest of it is curvature. So that's kind of at the crux of what a lot of these discussions have been. Like, if the Earth is a sphere, we should see that consistent 8 inches per mile squared edge or curvature, whatever you want to call it, and things should be cutting off consistently at long distances everywhere we look, because that's a physical thing. But obviously that doesn't happen. And so, of course, on an extended plane kind of a surface, the idea is that obviously the horizon is just an optical point. It's not actually a physical edge or a physical curvature. And then, of course, the globe earthers, obviously realizing that we see too far and all that kind of stuff, they've then had to say, well, there isn't really a geometric horizon. It's actually all refraction. But when it's cutting off boats, it actually is a geometric horizon. That's for sure. But otherwise, when we're seeing too far, we got to make up a bunch of refraction to explain it away.
No, they don't say that, dude. They say that it's both. They never say it's not that, it's this. They say
they've
it's
had
always
to kind of
refraction. There's
patch it
no.
up.
I'm sorry, Gio. You're making shit up, dude. I've never heard a baller say that it's not refraction at all. There's always refraction in the equation, and curvature. It's not one or the other.
But every time boats are cut off, it's not refraction.
No, it's always a refraction also, but not refraction at all. It's not completely refraction that's doing it, is what they're saying. Not entirely refraction alone.
What's stopping us from repeating the measurement?
I'll give a really good example, right? There's an image, or you can Google real quickly, of a pencil in water, and it's clearly displaced from refraction. But it's an apparent position of the pencil that you see in the water. But without the real pencil, you wouldn't have an apparent pencil position, would you? Same with the horizon. Without the real horizon, you wouldn't have an apparent horizon. That's my point. Thank you.
But you don't have all the horizons are apparent. That's the thing. Only on the globe they reify as being physical.
Yeah, the
When it's not.
geographic horizon is the antecedent to the apparent horizon.
Thank you.
We only have one horizon. We all observe one horizon.
We got a smart one in here. But you knew that, didn't you?
No, you pick it on me, man.
Yeah. But in a loving way. It's an enduring
Yeah.
manner. Yeah.
Yeah.
Today. You watch out for tomorrow.
Yeah. Who knows?
Yeah. Say something bad about Electric Universe. I'll be all over you. It's weird how we get so much kick and flack about the Electric Universe stuff, and there's literally, it's not like it's treated worse, and I think some people are more scared of it than the flat Earth, because there actually is scientific papers and studies and data and shit that comes from some of their own sources that explain the phenomena that can't be explained in the standard model, and it's got a lot of power to it. And for some reason, it's just way dumber than anything. I think it's because it's scarier to deal with.
Yeah, try having both of them when you really have the truth.
Exactly. What if that is true too? The Earth is flat and it's all that, right?
Of course,
I mean,
yeah.
imagine the person who holds it and ties his identity to the beliefs he has. Imagine the deal he's gonna have to deal with, or she. You know, like I don't have any problem if it turned around tomorrow and was like, "Hey, we've been lied to. The Earth is flat." I'm like, you know what? I'll fucking call around my flat Earth buddies and tell them high five and shit, and invite them over to the house for a big party because we were wrong and they were right, but we were all together in this fight. And that's not fighting against the flat earthers, dude. It's just a waste of time. You want to help them. That's cool. Help people come to a realization whether or not they believe in it or not. But I mean, fighting against them just makes them, double down and do things that they might not normally do that aren't even good for their own theories. I'm not trying to hurt any flat earthers like that. It's just stupid to do. But I definitely
I don't
will
think
argue for positions
I don't think
believe in.
you're going to find anyone here that believes that the world is flat.
Well, there's at least 2 or 3 of us in here right now.
No, I don't think so. No, they don't
Okay,
believe.
listen, hold on a minute. Let's draw
Not
the
that big a
idea
deal,
that
though.
like you can connect yourself however you want to connect yourself to whatever you want to identify with. I don't think you have to sit in a somewhat public server and speak with this cynical attitude that like, oh my God, could you imagine blah. Like I don't know what the truth is, dude. Humble enough to accept it either way. But like judging the whole idea tied to what other people can think, I think that's way you're better than that.
Yeah.
Yeah, I don't know if you understood what I meant. If you're thinking there was some negative connotation to my sentiment, because
We don't believe the world
at
is
all.
flat, man. We know the world is flat.
Again, stating how
I
somebody
literally
would
just said
feel when they
it's
found out the
yeah.
quote
I'm not
truth.
emotionally tied to that argument, and I was talking about people who are emotionally tied to it being a ball. When they
Right.
find out, or if they find out tomorrow that it's not a ball, then some of their emotional identity that they've tied to this thing and fought
Yeah.
so hard against you guys and everything, they might be crushed
Share your
personally.
pain.
It might be pretty hard for them to,
That's a paradigm
deal
shift.
with. That's all I'm saying. It's a
Right.
paradigm
That's a
shift.
paradigm
Exactly.
shift. The thing about it is, at the end of the
If you
day,
need a shoulder,
we don't have to be
I'm sure
held
you're going to find a shoulder. No
responsible,
worries.
right, for them to see it as they see fit. Like whoever wants to see it as they want to see it, you have at it. I don't give a crap. At the end of the day, we're just here to throw stuff at the wall to say, hey, this is what I see. What do you guys think about it?
Yeah, and personally, from my perspective, I care more about people in general than I do about how they, how they see their reality, and I'm able to talk to them about it. And I'll get in a heated argument about it, but in the end of the argument, I still care about that person. I don't.
Yeah.
Yeah,
Well, that's why I like
try to
you.
get along. I like you too, man.
I notice that about people. You can see there's a lot of people that they just want to hurt the other people that they're talking with, or they think that okay, here's an outsider to the group. If I attack him, then the other people in the group are gonna like me more. Shit like that. And I know that a lot of us don't get down like that here, right? but that does exist in a big way out in the internet spectrum.
Yeah, but that happens
You
from
know?
both sides, isn't it?
No, that's what I'm talking about is the baller side right now. I'm not even talking. You're being too defensive, my man. I'm not talking about you. This isn't like that. I'm clearly saying that that we're talking about problems with people having to listen to alternative ideas somehow that hurts their ears. Is what I'm talking about.
Agree.
Yeah.
My point is, my point was that whoever comes to a flat earth server, he comes with the idea of trolling us, and let's troll these morons. They don't know what they're talking about. They're stupid and ignorant. They've never been in school and so on. So they come already with a mindset. We are the underdog.
Yeah, I agree. A lot of that happens. Definitely. It happens on all the alternative cosmologies and things like that. With these guys are, like I said though, they hate the electric universe more than the flat Earth. But they'll
Well, you
address the flat Earth
are
argument.
interesting, Grim, because you do you're in the middle in a way, like meaning that there's like if you were just to go on Google and Google everything about the Earth, there's like a mainstream narrative. There definitely is, and there's all the support for it, and the government space agencies and all the rest of it. And then there is, let's just say, I guess we have to say, quote unquote, alternative, even though it's just alternative to the mainstream, which is already wrong. So I don't really like that word alternative, like
Me
as
neither,
if it's
but
some
go
kind of
ahead.
side
I
thing.
agree.
But the thing is that you do. Question, you go up against, some of what they have of the pseudoscience. And so you have experienced some of that flack, of the kind of mainstream, that kind of stuff. But then you
high
also,
levels of it.
Yeah. So you are interesting in that way. Kind of rare actually in this entire community that you kind of experience some of that, like actually get some of that kind of flack from that kind of mainstream.
Yeah. It's worse, man. It's worse because I'll use data from their own people. That pisses them off worse because they have to address it with absolute. Listen, they have to turn me into a problematic personality to beat me in an argument now. They can't just beat me in the argument anymore. Now it's, oh, Graham, you never shut up. Oh, Graham, you're always interrupting. Oh, Graham, you don't. And it's not ever about the argument. Ever.
Now replace that by flat
Go sell
earther.
some more weed.
Yeah.
Yeah, I mean, it's kind of like I'm going to use the term gatekeeper, and I don't mean some like CIA agent thing. I'm just saying like it's almost as if there's this mainstream narrative thing that a bunch of people, they're almost like blindly gatekeeping. They don't really know, they haven't really verified, they've never been to outer space, they don't know there's the Earth's a sphere, but they're just like gatekeeping it just anyways because their ego is attached to it or their identity or whatever it may be. So anyone who goes up against that, they're gonna flare up and react against it.
Yeah, I got a whole theory about. I got a whole fucking theory about that. If you want to hear it.
Hold on one second. That's
It's
why
the Good Samaritan.
That's why, Gio, I like to avoid arguing for the globe. I will argue against globers on all their cosmologies, basically, and I'll aid the flat Earth, and because I am more of a proponent of alternative cosmologies, meaning that even if I think you're wrong, I love you doing it. It doesn't matter because I could be wrong. And since I know I could be wrong, then you could be right. So I don't, you know what I mean? Like, I won't put my energy into proving you wrong. That's wasteful energy. Yeah.
How long this about to take? A long time.
Sorry. I'm done.
You have the occasional case of the Good Samaritan, someone who comes in with the good intentions, let me help out these people because they're in hell, they're in need of help, There's also that view,
Well, no, I what do I empathize, right? Because I've been treated badly in the same ways that you
That's what
have
I'm
been.
saying.
Yeah, exactly. Okay, we agree. I felt it too, so I know what you're feeling. That's why I'm trying not to feed you that, because I know we don't agree
Now,
on
once
certain.
you go down the rabbit hole, I mean, there is no turning back, man.
I know that's so true.
I also think there's kind of like a bigger picture too. I mean, like, I know, Grim, if you think the Earth's a globe, then that's not necessarily where you see the deception, meaning that you might see it in electric universe and some other things. But But from the perspective that the Earth isn't a globe at all, then that means that there's like, it's almost like this is like a trap in a sense, like a huge trap for humanity. Like they're deceiving us, leading people astray. And then the globalists, quote unquote, are also, starting wars and doing all this other corrupt stuff. So it ends up being in the situation where, two people could be debating about this or arguing about it, and they could have their own personal thing. But on a larger scale, there's the perspective of we're being deceived on such a level that if these people continue deceiving, continue doing their wrath, that gets into the jabs and all the other stuff, all the rest of it, GMO foods and all of it, then like the entire human race is at risk in a sense. Like not just because they believe in a globe, but because those globalists are not only convincing them of the globe and getting them wrapped into that, but then all these other deceptions are wrapped into it. And then are they going to jab us until we're so genetically modified that we can't even, reproduce? And
dude, don't get me started on the jab.
Tension behind it is the tension behind these discussions of what's true and what's false is even bigger because the group pushing those deceptions is also threatening. And then there's people defending it, which is wild. So
yeah, well, that's how that's kind of how I got into, I guess waking up to the idea that there is this huge global conspiracy, and it was through investigating all the likenesses of these so-called separated world religions. They're so alike, and there's so many actual literal repeats from over and over again. It made me wonder, well, that was the media of the day, wasn't it? And if we could get everybody to think along this, give them the same certain basic foundation of thought, then it would be easier to control them as a mass, because they all basically think relatively the same. There's this leader that owns everything, and then there's
that's why the globe is a religion.
Absolutely, dude. I mean, let's not derail into jabs or whatever, but I'm just saying when the whole thing hit, why do you think everybody started wearing a mask for a week? It's because they're already trained to believe that the mainstream story is correct, and the schooling system and all this shit and the globe and all of it, to where the minute that authority tells you wear a mask, get a jab, whatever, people just instantly do it.
Yep. Okay. Exactly.
Hey, Electric, hot mic, man.
That's what I was going to bring up a second ago. I think these people get rewarded for regurgitating shit, to summarize quick.
Well, yeah, you're right. They do, because, citations equal money and funding. So if you write along somebody else's already approved theory, whether or not it's right or wrong, you get citations, and then with more citations, you get better funding, and then you can do more stuff, with more money. But it's not about, they never really reward the guy who, tries to debunk Einstein, do they? They pound him and destroy this guy. And they never reward the person who wants to, shine the light on germ theory versus terrain theory. They pound them and destroy them. So there's not a big, what's it called? When you
double standard. It's a double standard.
Yeah. There's not a big reward for finding out new things. There's more of a punishment to explore new things than there's a reward. And that's the point, I guess. You're right.
The quest for truth is, it doesn't have to be thankful, it can be thankless.
Come on, guys, there's nothing else to explore. We live in the sphere.
That's what they want to tell you, isn't it? We got it all figured out, down to the 16th decimal point. The Big Bang is real. The microwave background radiation doesn't come from the Earth's oceans. Oh, God. Oh, or does it? Re-emitting microwaves from high-energy cosmic rays being absorbed into the Earth's oceans and the salt water oceans, and then re-emitted, and then interacting with the hydrogen, creating a monopole, magnetic resonance, which they're reading as monopole data and calling it remnants of a Big Bang. They're so stupid, it's ridiculous.
Yeah, but for you to reach that point, meanwhile, you spend a fortune in studying the nonsense,
Well, luckily I enjoyed it. So it wasn't that much wasted
You
time.
need to learn it in order to be able to debunk it. You know, the problem is a lot of people come here, the anti-flat earthers, they don't even spew the globe rhetoric. You know, they go against the globe.
Yeah.
Yeah, pretty much almost on our side. They're almost spewing the same. You know, but it's still arguing with us though.
Look, we're closer than you think, right? Because no flat earther claims they know the shape of the Earth. They only give you an attribute, flat. Well, I mean, I can agree with that. We don't, you know, you don't have. I don't know the shape of the Earth. Excuse me.
Well,
From where I'm sitting.
the Earth. It depends what you mean when you say the Earth. You know, the Earth, the ground. Yeah, it cannot be flat because it contains the oceans within. Yeah, there is ground under the ocean. So, what makes me a flat earther is not the ground that I'm standing on, is the realm that we live in, not the planet Earth, the Earth. Yeah, without the word planet attached to it, the
Right.
realm that we live in, the way we navigate, it's on a plane. We navigate over the sea level on a plane with elevation
What if it,
angles for navigation and so on. That's what
what if
makes
it
me a
turned
flat
out?
earther. Yeah.
What if it turned out that the whole plane that like for if this is for flat earthers, but if the whole thing is actually real, but then there's like half of a sphere underneath it, not even getting used.
Well, Hebrews. I mean, if we're
You know what I
okay,
mean? That only the top
real
cut off
script.
part is being used.
Yeah, but that is doing the same game that they are doing to us, isn't it? Observe and declare. What if? What if? What if? You know, you're gonna
Well,
just,
that's kind of what.
you know,
Yeah, but I mean, you know it
you,
exists, right? You know that the deeper you deep underground, you dig
you might get the
underground, the
grant
further
for
you
it.
go. Well, I
You
mean,
might get
you
the
can
Isn't it
grant
only.
for
8
it, you know,
miles?
to study these things.
I don't think anyone has ever dug, deeper than they can. They've never found the end of the extent of it. So I mean, we could
8 miles,
say for
isn't it?
sure. Well, no, the 8 miles until you didn't reach the end though. You just reached. It got so hot and everything started melting right there,
Is it
right?
so hot,
And the
or was
pressures
it
are
an
so great.
impenetrable surface that they met
No,
Not
it
only
was like
that,
it's like a
at the
milkshake.
8 mile
The more
point?
you dig, the more it
the
fills up the tank.
geologists,
It
the
becomes like a milkshake.
geologists,
Why
they,
are you? Hold on just a second, buddy. He just asked me a question, and I'm trying to give him the answer that they give us. And the answer is it becomes like a hot milkshake, where the more you dig out with your drill, the more it fills back in. You can't dig any deeper. You can go deeper if you could. You know what I mean? Get through that. It's not impenetrable in that way. It's just that you can't actually keep digging the mud out. It's not mud, but it's
Oh,
like
okay. Because
super
what
hot.
I heard was it was 8 miles, and at 8 miles was the point that they hit where they couldn't physically dig any deeper because they didn't have anything hard enough to penetrate that surface. That's what I heard.
Yeah.
So interesting point you have.
Yeah,
Thank you.
yeah. This is a little different. It's like mushy milkshake, and so they can't keep drilling, and shit gets
yeah, but
melted.
the geologists were wrong all the way down the perforation, you know.
Oh,
They were
absolutely.
predicting to find things and they found something else and so on.
Every time. Same
So
with their
that was
space guide.
proof that it's not science.
Exactly. Like same with their space dudes. They told us that gravity alone is doing all the heavy lifting, and it's like a vacuum with vacuum permeability, epsilon, which is a very very no real electric currents can go over vast distances because there's no medium in all of this, and so all of their basic theories that they still rely on today rely on those premises. And now that they know that those electric forces are very much involved, they also know that the electric force is 1,000 billion 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 times stronger than gravity, and it's present. Then gravity alone can't be doing all the heavy lifting and structuring and organizing of matter. It has to be in part the electric force. But they didn't incorporate that into their theories yet, but they know they need to at some point. See, there's their problem. And their theories right now are so perfect. We had gravity so dialed in that it was definitely only gravity. But now they have this other fucking forces that they know now are there. They have to go and eat crow because the gravity theory was wrong. It had to be because it couldn't be so perfect all by itself because those other things are present doing work that you're not giving values to and pretending that only gravity is doing it. So there's a problem in cosmology, and it doesn't just start with the rotational velocities of galaxies. It is now moving into the actual orbits of planets and the star and the movements of the stars in
It's the
even throughout the
whole.
galaxy. Exactly.
It's the whole thing, man.
It could be a lot more static than they gave us than they said. Is what the point is.
It's using their words. It's the whole model, which we're still waiting to see the model. But it's the whole model that implodes. Without the curvature of the Earth, there is no model. It starts and it ends at the curvature. The horizon. If the horizon is not the curvature, there is no curvature, there is no sphere, and so on. The whole thing collapses. A house of cards collapses.
For me, it's just not that much of a stretch, just for me. I mean, it's just easy for me to imagine that we're on a sphere just like the other planetary spheres that are also orbiting the sun in the patterns that they go in. Because I've
It's
seen the
easy for
clouds
you.
run through.
It's easy for you to imagine, but where do you
That's what
see
I
this?
said. It's easy for me to imagine that that's what we are on, being that the other planets, they don't have any wonky different shapes.
Other planet. We don't live on the planet. That's the thing. We don't live on the planet. The lights in the sky that we call planets, we are not one of them. We don't live on a light in the sky.
But how
There
would
is
you
no
know that?
sky, and there is no sky beneath your feet.
Speaking of epistemology, how could you possibly know any of that? That sounds like you just made that up.
No, because we don't observe that. Anywhere you go, the sky is always above your head, and the ground is always beneath your feet. There is no way you can go with the sky or stars underneath your feet. If you dig the ground, you're not going to find stars. Definitely no planets either.
Yeah, Grim, I'd say maybe you could like compare it to like like we have immune
No,
system,
I don't have a
right?
dollar, bro.
We,
I'm sorry.
hey, Electric, you're hot micing. Like we have an immune system, right? And not to get into the whole V talk, but like you're wise enough to realize that they've reverse engineered or had all the
Oh yeah.
excuses all worked out. Like you're asymptomatic, so you have
Oh,
it. You just don't know you have it. Like all
that's why
these
I'm
like
cautious.
yeah.
That's why I'm cautious and say words like, it's easy for me to believe because I know I'm making assumptions and relying on certain assumptions. Hold on, I just took a big dab.
Yeah. So I think when George says he knows we're not on a planet, it's similar to saying like we know we have an immune system and we don't need to have something that boosts our immune system out of nowhere because we know people really didn't need that ever before for something that just came out of nowhere, and like all of the signs are there to see that it's for a reason, and it seems like just as obvious with the ball earth
Yeah.
idea.
I'm real careful about that because that's why I don't like. I've changed my position where I'm not so frustrated with flat earthers because I see that there's there's an obvious mechanism that distracts us from knowing the truth about almost any topic that has a
Right.
phenomenal effect on anything, right? So I understand that, and then, like you said, they'll put this whole system of bullshit in place, the checks and balances, to make it look like this substantiates their fact, and this next
Yeah.
assumption substantiates the first
Like you have
assumption.
to accept like the Goldilocks zone thinking about everything. Like, oh, it's just the right distance from the sun to have this
Exactly.
Goldilocks zone, but then it's also just the right size that you can't really see the curvature, but it seems like it's there. It could be like perspective, but it's not. It's like every single thing is just like with the
Yeah.
pandemic. It's like, well, you do
Exactly.
have
And
it.
I'm not
Well,
that smart,
yeah, this is supposed to test you, not to give it to you. And oh, you got it. I guess it must be it. It's like all of these like runaround excuses and made up jargon to cover their ass everywhere you look. Every single thing seems to be like that when it comes
Yeah.
to the glow model, for sure.
It's really true. I mean, when it comes to any model, any human story has its biases, and you know what I mean, that you have to watch out for, and especially like orchestrated, organized, secret societal type, constructions or concepts. Those go for generations on. They're not like me and you having a life plan. It's like a secret society has written a thousands of years life plan for the secret society to achieve these certain goals. They talk about, when technologies are good enough, they'll do this, and when technologies are better, they'll do this. And that was the onslaught of television, radio, and television. You know, and they really started hypnotizing people. I'm just saying, I understand that there's this huge thing going on that I am completely.
I
so
think that
tired.
your electric Earth stuff. I think that you know, is totally like what you were just saying about gravity was awesome, because that is what's happening. They have to account for that part of it, and they can't exclude it, and it's probably what it
They
is,
are.
the acceleration and everything. You know,
They
they
are
have to,
excluding
right?
it. Yeah, and I go as
Yeah,
far
they're
as to
trying
point
to.
out.
They try to, but they know they can't anymore. At
It's
least I
like
hope
what?
some of them do.
Listen, what in their model, right, makes the Earth spin faster?
Right.
Nothing should make it would only decelerate. There's nothing in their model that would add energy to the spin. Nothing. But their data keeps showing the Earth spinning faster. Faster and faster and faster.
So
as it
that
gets
must be
electrically driven.
so do you, so with the electric Earth, the reason that it spins faster, or the readings
That's
might look like it's
interpretation.
spinning, the ether could be the what they're picking up again, that's spinning faster for whatever reason, right? Or whatever readings they're getting could all be about the ether. It seems like space time, like they hijacked the ether and called it
Come on,
space
guys. It's
time.
not spinning fast. What he's saying is the day doesn't have 24 hours. That's what he's saying.
Right. I know.
Well, they actually say that the Earth is spinning faster, shorter days, meaning that it's gone around one revolution in a faster
And why do they
time.
say that if it wouldn't fit their reverse engineering? Why would they even say that?
Because that data doesn't come out from them first. This is discoveries in universities and things that people couldn't ignore. And now that
And where
it's
do those
happening,
readings come from?
and,
Like
and
what
I think a
what
lot
kind
of
of
those
instruments
guys,
do you use?
a lot of those guys
Grim.
believe their theory, right? So when new
Grim.
data comes up, they don't know not to post the new data. They might suspect that the new data somehow will support what they're.
But
Grim.
what's used to
Grim.
get that data?
Somebody's calling me.
Yeah,
I'm gonna have to address this.
Yeah, I am. You said there's nothing in the model that could make Earth spin faster, right?
Well,
I
not
think you're
accelerate over and over and over. Now there is like you can have a Greenland ice melt where you get weight towards the
Unless you have
equator.
Superman.
Yeah,
right.
if the
That
weight-
would
if the weight
increase the
from
speed,
equator-
wouldn't it?
No, that would decrease the speed. If the
Well,
weight would have to
no.
go from the equator up towards the poles to increase the speed.
No, it's the opposite because the poles are further from the center, right? So if
Excuse
you
me. When a dancer spins her feet, when a dancer spins in an ice skater, does she put her hands out to spin faster, or does she pull them in to spin faster?
pull them in,
Thank you.
right?
How do you have poles on a sphere?
Sorry?
How do you have poles on a sphere not being equidistant?
Right. So that's my whole entire point. So if I were to drop weight from the poles down to the spheres, I would slow down the system. It's losing energy. If I were to take weight from the equators and push them to the poles, I would speed up the system because now I'm transferring that energy towards the center, not making it so hard for the thing to rotate. See, that's
Yeah, it actually makes sense. Yeah.
Yeah. So, in other words, the only thing that's been theorized in the standard model is the slowing down. That's the whole death model, right? The whole thing is supposed to be slowing and slowing and slowing, and it's not. It's speeding up. That means there's an external driver. Something is driving that spin. We know what electricity does, so I don't even have to say anything else after that.
And the moon is moving away.
Bacon, did you disagree with him? Bacon, did you disagree?
Yeah,
Did you
he's
just
right.
see
Yeah,
that
he's right.
one? Okay, so you also agree there's nothing that would make it spin faster.
No, I don't know. I'm just saying that the melting of the ice doesn't seem to answer that. At least not at the surface. I'm not sure what the explanation is, but yeah, just thinking roughly about the subject. Yeah, his reasoning is correct. I just know I don't know a lot of details on the subject.
I think there's probably cycles. I think we have two. I think we have a dipole, but they're adjacent above a flat Earth. Like I always say, I think there's two rotating star systems with two poles. I think that at least at this point, that's what I think makes the most sense, because that's what we observe. And one's going counterclockwise, one's going clockwise, and it
You
works
would
like
love this video.
thermodynamics. And there's probably pulsating going on. and there's
Dude
probably
loves this video,
faster
dude.
times, and it slows down and speeds up and has a rhythm to it for some reason.
I love that.
Yeah.
There's a video from MR2 Tough, the number 2 Tough, and the number 2 again. So MR2 Tough
All right.
2, and it's called Electric Coriolis on YouTube. And you were gonna
Tough spelled how?
Electric Coriolis.
TUFF.
Okay, got it. MR2 Tough, yeah, electric. Got it.
Electric Coriolis, and all this, and you also have like electric geology in there, and all kinds of different stuff where he creates crater chains, just like you see on the moon. He creates different land masses like plateaus.
What's
and things
electric
like that.
Coriolis, man?
I'm sorry.
What's electric Coriolis?
Oh, it's a video. It's just called it's a video that he made where he basically takes this like a partially conductive fluid, puts some tea leaves in it, puts an electrode, and an opposing electrode on the other side of this, and the two tea leaves start spinning in opposite directions.
I'm posting it right now.
So it shows that
That's not Coriolis, though.
the ionized material draws in the unionized material because it's not just the same charge, it's oppositely basically, has charge potential difference, which draws in the unionized material because the ionized material is in motion and constricted by the electric force. The unionized material starts to draw towards that motion, and that motion is a swirling motion. And that's
Oh yeah,
why
exactly.
you get rotation. That's why I say you get the
Yeah, but
rotation
that's
of the
not
planet.
Coriolis, though.
Well, no, it's not Coriolis. The video is called Electric Coriolis because it's an alternative to the idea of Coriolis.
Yeah,
It's
but
not actually
no.
Coriolis. So it's mentioning the word Coriolis, but not claiming to actually be Coriolis. You got to understand the title of a video does not just say as much as you think it's saying.
Yeah, but it has nothing to do one with the other. That's what I'm saying.
Okay, you don't like it, but that's fine. You don't have to watch it. I don't care.
Coriolis has nothing to do with different rotations. It has to do with an observation
we know
made
the
from
claim.
a spinning reference frame.
Right, we know the claim, but
You need to be on the spinning reference frame to observe this, not exteriors to it.
I don't know who you think you're talking to right now, but I argue for the actual Coriolis, right? I argue and I understand it. So I don't know what you think you're doing right now, but I'm talking about an alternative idea to the formations of cloud patterns and storm depressions, like tropical depressions and such. And that the reason that they form may not be because they form in spiral in their own like directions, might not be dependent upon the idea of Coriolis at all. It might be dependent about the actual direction or flow of charge on that hemisphere. So that's literally
hemisphere.
What this means to me. Yeah, I'm not a flat earther, dude. Flat earthers can then take this and extrapolate data from this to help with their
I can tell you're not a flat earther, man. I can tell that.
Yeah, because the data supports the electric force can rotate things. So this also works for a flat earth argument as far as the movie dome idea, which I invented, by
I
the
don't
way.
know why you have to excuse both sides, man. You seem to have an argument.
9 years ago. It's called the movie
You
dome
seem to have.
theory. What is wrong
You
with
seem
you?
to have an
man?
argument
Are
for
you-
both sides, man.
That's right, because I'm being non-biased here. It's fine to do that
Are
when
you?
you're just showing evidence of
You
both
put the
sides.
questions and you answer your own questions, man.
Is everybody else having fun with him engaging with me now, or was it better before?
I'm
I just
enjoying
get a
this.
little- I think you
I
make
don't understand what he's
great
asking
point.
me.
Well, yeah, George, look at the video, the little clip I just uploaded into the live stream. Like if that was above us and there's two poles and that's what we're observing, one's going clockwise, one's going counterclockwise, just like we observe. It seems like they're going parallel to each other. They are going parallel to each other through the celestial equator. And it totally could work like that above a stationary plane. And that's exactly what we observe. So it makes sense.
So it seems like I'm being
I
helpful.
have no
by
problem with
presenting
that.
this information.
The only
Right?
problem that I have with is clockwise and anti-clockwise. That's the only thing. It's like
that's
you
the way it
crossing the road. No, it's like you crossing the road to the other side. You know, the cars are coming from your left to your right, and you cross the road to the other side. You know, they're coming in the same direction, but now they're coming on the other way from your right to your left. Yeah,
that's true, but that doesn't answer. That
So
doesn't. That's not. That could be the
the
case.
answer
but it
is
doesn't seem like
the
it
answer is all the
Rotating
stars,
and
all the celestial
counter-rotating.
bodies,
How about that?
apart from Polaris,
How about
all the
rotating and
celestial bodies,
counter-rotating?
apart
Would
from
that be better
Polaris,
for you?
will rotate in the sky from east to west. All of them.
That's not true because they're actually going in circular motions, which isn't just
Yeah,
east to
but
west.
yeah, there's two rotating points in the sky, but they're all going east to west.
Well, through the celestial
no,
equator,
George.
through the celestial equator, they are, but they're actually going in circles, which
Yeah,
isn't east
correct.
to west. It's circular. That's not east to
Okay.
west. All the stars
Listen,
go circular. We
So if
see it
you
with we see it with
they
the time
follow.
lapse
Listen,
photography.
they
George,
follow the same path as the sun. Yeah.
the stars,
I
the
understand that,
stars
George, but I'm
below.
saying
Do they
there's an
follow the same path
alternative
as the
idea.
sun? Yes or no?
I'm saying this debunks the globe better than the idea that perspective answers the star
Yes,
motion.
but listen. My
Can I
point
answer, George?
is, both star rotations in the sky, yeah, they go in the same vector as the sun and the moon.
It's not a
Not
vector, George.
not
From
really,
east to west.
because
Yes.
Oh,
there's
so
two
so George
circles.
is a
It
flat
seems like
earther
there's
then,
two
right?
circles of stars.
Because I'm confused. Is George a flat earther?
Yeah.
Okay, well then,
Yes,
George,
I am. Yeah.
you're just damaging your own ideas right now, and like throwing
Really?
rocks at people who are trying to help
No,
you.
I'm
Yeah,
not.
yeah. Well, in my
No,
opinion,
I'm
you
not.
really are.
Hey George,
Yeah.
I'm gonna
I'm
send you a video.
trying to
I'm
clear
gonna send you
things.
a video by my friend who addressed this point. He left the whole discussion in 2016 because he's like, well, there's two sets of stars. I know it's a motionless plane, but if we're gonna just call the southern stars a matter of perspective, then why are they going around even an
No,
area
I
that
don't.
seems like a pole, right?
I don't say that. I never said that. I never
Okay,
said that. And I never refused the
there are two sets of
second
stars.
point of rotation in the sky. No, no, no. It's actually part of my argument because
Okay,
it is how the both models were driven from. Yeah, there is
right.
no globe model. Let's face it. Yeah, what they have is a flat Earth model. Elevation angles from Polaris going
Right.
outwards toward the equator, which is the sun's path overhead. But then you lose sight of Polaris. So what you do is you turn around with the sun still above your head. You turn around on the same horizontal plane, and now you have a different reference point in the sky, a different star rotation system, still going
Okay,
pretty
good.
much in the same rotation. The sun is still rising in the east and setting in the west, for that matter. Yeah.
But if there's a second rotation point, then one needs to be going clockwise, the other one would be going counterclockwise. Literally.
But
Literally. Just
Right,
like that
and that
little
would
video
be
that I uploaded from what Grim
clockwise
recommended.
and
That's the way it
anti-clockwise,
seems.
they're not objective
that's why
directions,
that
man.
video is so
Well, okay, yeah,
important.
you're right. You're right. They're not
It
objective. One's going
demonstrates.
in one direction, one's going in the opposite direction, so that they can go east to west through the celestial equator.
Yeah, and it demonstrates an actual physical mechanism in a laboratory setting, where basically you're demonstrating it with, you know, the same environment basically that you're claiming is doing this. It would be electrical, right, with partially conductive
Yeah.
fluid dynamics, which would be the gases in the air, right? And so you understand that that's all very feasible things that support the idea that it might not have to be because of the spinning of a round Earth that causes the storms to rotate in those directions. It could be the electric fields that those storms are in that causes them to rotate in
Exactly.
those directions. The right hand rule.
And it answers a lot of
Current
questions
flow,
that
and then
flat
the
earthers have problems with. You know, the globe, I think a lot of maybe Bacon would agree, or a lot of any glober would agree that the southern star rotations is like one of the main arguments that they hold on to as proving to them that we must be on a sphere. And this takes care of that with the stationary Earth, which they hate.
It's not that it proves you were on a sphere, it just doesn't make sense on a flat Earth.
Well, it does this actually with the idea that there's
yeah, this
the
could
two
support their
rotating
argument.
stars above our stationary plane. It does make sense. It makes more
This
sense.
really could
How
support
does
their
it?
argument. Well, if we
Because
find that
Still
there's a
elevation angles, isn't it?
yeah, if there's a
Still
net,
elevation angles.
can you
Yeah,
stop
George
for a
won't
second,
allow
please?
you to answer that perspective.
Well, if you do the time elapse photography, this is what we see, right? You can see there's a point where they there's two different circulating star patterns. They funnel through the middle and they go out. And if they're next to each other, instead of all those stars staying parallel, which we have no proof for, in fact, there's evidence that it's converging and diverging at the ends of the at the point where those star systems meet, even on Stellaris, it seems to be converging and diverging. And unless the stars were close, you wouldn't see that unless, from an infinite, if the stars are infinitely far away, you wouldn't see that at any point observing the star rotations. You would only see that at the point where those two star rotations seem to meet in the middle.
All right,
And that's
hold
where
on.
that seems to be what
I
the
never
case
thought
is.
of that.
I'm really trying to understand what you're saying. Is the last picture you
You
sent?
see what I'm posting in the live stream?
Yeah,
No
that's what I'm
intersecting
about to ask you. If the
circles
last picture you
intersecting.
sent is Grim, please.
I'm saying-
Is the last picture you sent representative of what you think the stars are doing over the flat Earth?
That seems to be the case, yeah, as far as I can tell.
Right. So if I'm at Australia, this southern celestial pole is not due south, right?
That's actually Antarctica at the bottom.
Yeah. So if I'm at Australia and I wanted to look to that circle that it sits above Antarctica, it's not gonna be due south, right? It's gonna be.
I'm not
south,
saying that I'm not saying the land
southwest.
positions in this map are exactly correct. It's just an
Right.
idea of how it would work. But as far as the star systems go, that seems to be the case, yeah.
That's what my point is. There is no distribution of continents you can make that is gonna match all of the observation. You can match it some observation. The problem with the celestial poles is to match all the observations with a map.
Right.
Right, but
So
if you can see that North Star from 30 degrees below the equator, then it doesn't make any sense the way that little GIF that someone else posted. It has to be perfectly spherical in the way that whatever that for that to work, and you'd have to be like upside down looking at it the opposite way, and all the stars going in the same position. With the stars going in opposite directions, funneling through the middle, which is what we observe, it makes a lot more sense, in fact. Because you can't get 30 degrees south of the equator and have it work.
Is that like a
don't get it.
refraction, like a Snell's law issue?
You shouldn't be
though,
able to see the North
refraction?
Star, is what I'm saying, from that point. You'd be upside down and you could be blocked by it.
You're saying we can see southern star from 30 degrees south latitude?
They say you can
I
see
think
the
close to it.
Oh,
Star.
you can't because
On
I'm
the
at 25.
horizon.
I'm at 25 degrees of latitude, and I can't see Polaris. And
Well, I could find the claim for you if you want. I don't know where that came from, but that's what I've heard.
right,
might
yeah,
be a
never saw.
Regardless,
There's many.
regardless,
Listen, there might be
the
a
reason that
mountain,
this
because they weren't looking at from
makes
6
more
feet
sense
up.
is because everything else about our experience requires that we're on a stationary level plane. I mean, that's just everything about our senses. So to disclude that as not important is just out of the question for most people.
Well,
that
they
are
only,
listening, in my opinion.
yeah, the only
That are
claim that I've seen of observing the North Star from south of the equator was Samuel Robotham, and that's been discredited many times.
Okay, there's probably another one too. I think there's more recent one. I'll try to find it if it's important. But the more interesting thing, the idea is that if we do actually have the rotations going in the opposite direction over a stationary plane, it can work that way too. And that's what a lot of Globers hold on to is like, flat earthers have no answer for it, but actually there is one.
Yeah. So, well,
Yeah, I still don't see it fitting a flat surface because if the sky is just something that rotates. So for you to have opposite directions, you have to look. I'm sorry, to have opposite rotations, you have to look towards opposite directions. And if we all on the same flat surface, and one person has to look up to see one direction, the other person will have to look down to see the opposite direction, not again up, because
Not
then
true.
they wouldn't be opposite directions.
What do you mean
Sorry,
look down? What do you mean
yeah,
look
so
down?
for example, I have to look up to see the counterclockwise rotation. I'm sorry, the
No, you're
clockwise
just gonna
rotation,
see.
right?
It's
You
gonna
mean
look
down
like
from your perspective? Oh, you mean down from your
yeah.
perspective, not
You
down
gotta
like on the
remember.
globe.
You gotta
When I say
remember.
down, I mean below. Like I have to look towards the
That
ground.
direction, yeah, towards the direction of the other of the land that would be disappearing into the distance towards the ground, just like everything else. The sky disappears towards
That's
the
what I was
ground,
gonna say.
just like the
Even though
horizon.
in the flat Earth model it's going around in a circle, the observation is that it's going from horizon to horizon. So that
Mhm.
gives that's why you're not going to see the same exact thing. Even if that was the mechanism of this thing being flat and blah blah blah, it would still look like the way it looks now. But the thing is they would have to fill in the blanks of all those optics and different things that are at this time unknown. You know what I mean?
I
Like
don't.
if that even exists.
Mm.
Well, there's got to be some special optics that even make the, because if we're on, okay, imagine we're on a flat Earth and there's this disk and the sun is rotating around, and instead of coming in at 270 degrees and going out at 70 degrees or back and forth, whatever, then it's actually, going like, from horizon to horizon over your head. You know what I mean? But so if that's what you're seeing, but that's not what's happening, then we have to figure out what is this optical effect that would cause a thing going in and out, and it should be showing us all kinds of angular size perspective and different things that it's not. So there's got to be some sort of a lensing effect that would, keep that, sustain the size of that object with also altering the direction of that object. And that's a tricky ass fucking thing to try and figure out. An optics.
I think our
Yeah, in
argument
other
is
words, you need to get us an actual. In other words, you need to get us an actual position of something and show us that it actually is happening the way you say it is.
Yeah, how much leeway can you get in, like, let's say you're like, hey, explain this. Okay, can I use like things that are not really physically possible? That I can't demonstrate, like a minus world, like where you like Pac-Man. I can't show you that, but that's like a mechanism, right? So how much leeway does this
That's what I
explanation?
mean. We gotta try and make that mechanism happen in a laboratory setting by maybe, adding density, because if we don't have enough distance to cover the ground to see if we can get objects to appear to rise and set, even though they're coming to and fro. Like
You
on
can
a.
you
Like
can
we
at
need an
least
explanation if we're gonna, you know what I'm
You
trying to say?
can't you can't make a heliocentric
He's asking if you
system in a
can have
laboratory.
elevation
model
angles
that
from sunrise
before
to sunset.
But Grim,
before
that's
you
pretty easy to recreate. I mean, I've often brought up. I mean, this is not the right ratios, but I mean, if you're driving down a street and there's a stoplight, a red light in the distance, it's going to look like it's right, converge with the horizon. As you drive towards it, it's going to rise. It's going to, when you're right under it, it's going to be right above you. You can look up your sunroof and see it. And then as you move away, it's going to set.
Yeah, but but it is going over you, right? It's in that direction because you've traveled under it, right? So it would be.
Elevation angles.
It's not, but it didn't come in like a boomerang and then fly out the other direction, like the flat Earth sun is. It's coming in like a boomerang, right? It's coming into you and over you, and then but you're seeing
The flat Earth sun. There is no other sun. There's only one sun.
Not only what Geo said, but we also have Skiba, Rob Skiba, showing us how things can rise and set on a flat surface. We've all seen it.
Right, but is the thing going around in a circle?
What if it's moving straight? Right? What if it's just
going straight over you? Well, that's basically what we're already telling you is happening, right?
Yeah, so
You're
it's
saying it's going
interpretation.
around in a circle over a disc, and we're saying that you're spinning and it looks like it's going around you, but you're actually just changing your location.
Yeah, but I mean, if you're in the northern region, like if you're up in Alaska at the 24-hour sun, you will watch it circling you. Literally, it just circles you. But if you're in the southern, if you're more like near the equator or something, then yeah, obviously you're only going to see a section as the declination angle is going to be what it is, and you're just going to see that section as it passes over you.
Yeah, but you see for half
that's exactly what you would expect to see on a sphere, though.
Yeah, you see for 12 hours, which means you're picking half of that circle. And at the same time, it's rising due east and setting due west.
On the equinox?
No, if you're at the equator, it doesn't...
The elevation angle is reduced.
If you live at the equator, you don't
less
even
of
need
the
the
sun
equinox for that.
above the horizon.
That's like every time.
You have less of the sun above the horizon. Your elevation angle is shorter.
The sun
In
isn't
the winter,
always
you
up
have
for 12 hours.
In the winter, you'll have the sun closer to the horizon. In the summer, in your summer, the sun will be further above your head.
Yeah, at the equator you have a little bit more than 12 hours the whole year.
The sun is local, the local sun.
Yeah. So I local.
Obviously,
The sun is local.
Yeah, it's easily provable. Just the inverse square law of light, the inverse square law of infrared heat functions precisely like a close and local sun. There's no correlation to any concept of a 93 million mile. None of that is even in reality whatsoever in terms of the way that actual light and heat function within distance on the Earth.
How exactly that works?
We don't even know if there's 93 million miles of open space, right? Like I've gone from Italy to New York or whatever, and that was like 1,500 miles, right? So you have to assume that there's just this vast expanse, millions of times the size of where we've been.
How the inverse square law implies a close sun? I didn't get that one.
Yeah, that's an interesting thing you just brought up.
elevation angle.
How do you explain seeing the sun not cast rays parallel, but rather at different angles? And I think it's called corpuscular rays. That little thing that I heard about really interests me. Nobody
It's
has
called
yet to
perspective.
explain that.
That's easily explainable by perspective. Just like you have railroad tracks.
So you're saying it's an illusion of my eyes?
No, I'm saying it's perspective. It doesn't have to do with your
What
eyes.
does that mean? I'm always seeing perspective. What does that mean?
Any optical device is gonna see that effect with parallel lines. It doesn't have to be a human eye. It has nothing to do with the eye. It just have to do with how perspective works.
So we see them converge, and it's not really happening. So it's just one more thing that we see in the sky that's not actually happening.
Yep.
I'm just saying that if you see them converging, that doesn't mean they're parallel, because you have to account for perspective.
Because what? But you're just saying because nothing.
I'm just saying that's one more thing that we see in the sky that's not actually happening. Cool. I'll put that on the
I'm not
list.
saying that. We're saying you have to know a little
That's all
more
I'm
to
saying.
claim that. No, the electric claim was that they are converging. That shows that they are not parallel. This is
Yeah, and you're
just
saying
wrong
that they're not
because
actually.
you're not taking.
And you're saying they're not actually doing what we see them do. They're doing
No,
something else. Yes, I know. I'm putting it on the list.
I'm saying you have to take into account perspective. You ignoring perspective.
Are they
just
actually
makes
converging?
My point is, if you ignore perspective, that argument doesn't work. I'm not arguing otherwise.
All right, we see them converging. Are they actually converging?
In your field of view, they're converging.
We see them converging.
corpuscular.
We see them converging. Are they actually converging?
You mean corpuscular rays?
Yeah.
They're by definition parallel.
Okay, but do we see them converging?
Corpuscular rays are
I think I already
parallel?
said that. Apparently,
When?
yeah.
I'm just trying to run.
I can't hear somebody say shit like this and not get upset, bro.
I'm just trying to run through this.
That's
with you
not
real
what a
quick.
corpuscular ray is.
I'm just trying to run through this with you.
So
real quick. We see them diverging or converging. They're not actually converging, right?
Yeah, only on your perspective.
Yeah. All right. Cool. I'm gonna add that to the list of shit that we see happening in the sky that's not actually happening. All right.
Yeah. So in
it's
that
actually not
image
about
that
the
I
sky.
posted,
It has nothing to do with the sky. If you have two parallel lines and you take a picture of it, it can always look like they're converging.
This has nothing to do with the sky. Corpuscular rays has nothing to do with the sky.
so that
Perspective
image
doesn't
that I
have to do with
posted
the
in
sky.
chat.
I'm talking about things
Yeah.
we see in the sky. I'm talking about things we see happening in the
look.
sky that's not actually happening.
Yeah, I'm talking about the flaw of his argument. I'm not talking about the sky.
Yeah, I'm not talking about his argument at all. I'm talking about this new.
I was.
That
but you're answering me,
Okay,
and I was
now
talking
we're
about his
moving on.
argument.
All right, we're moving
Yeah.
on from that, and now I'm
Yeah, you
talking
move
about
on with your
this
own.
list that I have. Well, I just wanted to make sure that this thing was, we see it happening. It's not actually happening. No, I'll put it on the list.
Congratulations. You successfully branched the conversation to
Just
something I wasn't talking about.
Kosho showing shadows to show light rays. It's like you get A. Reality is A, and then there are people like, oh, it's B. I'm like, where are you getting B from A? I don't understand.
Well, Kosho has posted a few images in chat there that show the parallel rays, and then I posted one with corpuscular rays, and you trace those rays down, it shows the sun below the horizon. That's kind of strange, isn't it?
That would be against the celestial navigation.
Those are
Yeah,
shadows.
that would be
shadows,
against.
not fucking light rays.
It would
Look
be
at
against the
Kosho's
celestial
shadow.
navigation. Yeah, if you're using celestial navigation during the day, obviously you're using the sun. Yeah, and you're shooting the angle of elevation to the sun at a different position. So, if the light rays of the sun would be parallel, it wouldn't make a difference at what time you're going to measure the angle to the sun.
Only on the flat Earth.
Not
a
only on
globe,
the
it
flat
does.
Earth, man. Listen, if the sunlight was parallel, you wouldn't have a GP of the sun.
Not on a flat Earth. On a
Anything,
globe, you would.
any part of the ground illuminated by the sun would be, the GP of the sun.
Only on a flat Earth, George. That is correct.
Not
That is
only on
correct. If the light,
not
if the
only.
light, let me try to explain you, George. Please pay attention to what I'm going to say. If you're over a flat surface and all those lines are in the light coming from the sun is parallel, then everyone has the same direction towards the sun. So if we are all on a flat surface, everyone has the same angle to the surface, to the sun. But if we are on a sphere, and you have the same parallel lines, everyone has that same direction, but no longer that same direction compared to the ground. Now the ground is changing. So your elevation angle is going to change on the surface. So there's only one spot on the sphere that is going to have the sun overhead, even with the lights coming parallel. Your reasoning only makes sense on the flat Earth assumption.
No, you're begging the question of a sphere.
You are,
If you have
George.
a look, listen. No, you are, because the sun cannot be parallel, because we do use elevation angles to the sun. 10-15 minutes apart. You use the sun's position. So the sun's position must be different. It cannot be the same. The light of the sun cannot be parallel. It can't.
On
It's
a globe, you
against the
can't
model.
because you're referring.
It's against the model.
George,
No,
George,
I'm
let me answer you,
sorry.
George.
It
You spoke for 2 minutes, George. Let me
cannot.
answer you.
It cannot.
The
The
angle you.
almanac tells you the position where the sun is above your head.
Can I
Above
answer you,
your
George?
head on that particular point, nowhere
George.
else. In that particular
stop
point. So
monologuing, George.
it can't be the way you're describing.
Right. So the angle we need is to your vertical. We need your zenith angle. If the lights are parallel and your zenith isn't changing, then the angle is not going to change. It's going to be the same for everyone. There's not going to be a GP, correct? But the zenith.
Listen.
Let me finish, George. Let me finish. But if the zenith isn't changing, that's a flat Earth. On the globe, the zenith is changing as you move across the surface. Your vertical changes. So your angle to those parallel lines is going to change.
That though. We don't
What do you
observe
mean?
that though. We don't observe that. The sun's GP overhead, if the sun is right above your head at 90 degrees from you, it's going to be there for a brief moment.
Correct.
So correct. So the light rays cannot be parallel, can they?
Why not?
Oh man, it's painful. It's painful. It's
agree,
against the model, man. Listen, different light sources, the different lights in the sky, they all have positions over the surface, which are the GP positions. Those lines are all running parallel to each other. That is the only light that we observe coming down parallel from independent light sources, not from the same light source, because it's against the model.
How is that against the model, George?
Because the object moves and you can do a reading again. So the light cannot be running parallel, can it? Any
just a
place that you
non-sequitur,
would go and measure the angle would be the same angle if the light is coming parallel. It wouldn't make a difference if you
Not
are
if the
1 mile
surface
this
is
way,
curved,
1 mile
George.
that way. No.
Yeah, no, that makes perfect sense to me. I mean, I caught that 100%. I don't know why dude's not catching it. Probably because it needs to fit a ball, but it doesn't.
Okay, you explain me then, because I don't understand George's reasoning. How he...
George, go ahead.
If the sunlight is coming in,
I understand.
Explain
so
that then.
if the sunlight is coming in parallel, it doesn't make sense for you to have, for example, 12 noon, where the sun is at its highest point above above your head in the sky.
Okay.
You know, you would have the sun up in the sky not just for an hour. You would have it all the time because the sunlight is coming in parallel.
Yeah, but the Earth's spinning. Why are you assuming a stationary Earth with a stationary sky? That's no one's claim.
I'm not assuming anything. The sun
how
is
are you
moving
making
in
sense,
the sky. Listen, the sun is moving in the sky. We are
Hold
doing
on, George.
elevation
Hold
angles.
on, George. Be patient, bro. Dude, did you just assume the Earth is spinning?
No, I said he's assuming it's not, which is not our
You're
claim.
assuming it is. You're assuming it is.
That's the hypothesis he's trying to say it doesn't work, right?
Listen, for this to work,
Are you talking about
are
you talking about a globe in which
For this to
both
work-
the globe
No.
and the sky are stationary? Of course, that's not going to work. No one believes that.
For navigation to be possible, you need to account the Earth to be flat and stationary. Those are the first steps.
Yeah, says people who can make a fix, George.
Making a fix, for you
Yes,
to make
only
a fix,
people who
you need a
can't.
flat plane.
Only people who don't know how to do a fix say that, George.
No, if you
Only
don't have a
people
fix,
who don't know how to make a fix. say
that's a
that,
red
George.
herring. Nothing to do with what we're talking about. Yeah, nothing to do with what we're talking about.
You're saying that
Unless you-
celestial navigation requires flat plane, but the only people who
Correct.
can actually find a
Elevation
position
angle.
in celestial navigation are not flat earthers, George. None of them are flat earth.
But they need elevation angles, do they?
Yeah,
Don't
and
they
you
need,
think that implies
don't
the
they
Earth
need
is flat.
elevation angles from a horizontal plane? That's it, man. They don't need anything else. That is enough for me, man. Elevation angles from a flat plane.
Yeah, no one says the horizontal plane is the surface, George.
It is the
And
surface.
it
We're
has
using
nothing
the
to do with the
second
argument.
to, it has to. Yeah. The surface is what we're using. The horizon, yeah.
Okay, but the line to the horizon is in the horizontal plane. Otherwise, we don't need deep correction.
No, you need to correct to be
The
not just
line
in the
of the
horizontal
horizon.
plane.
Oh
Not just,
my God.
you
Why
don't
though?
need just
Why
a
are you saying it's not?
horizontal plane. You need a 90-degree angle, not just a horizontal plane. The problem is you cannot do step one on a sphere, man. You cannot have an elevation angle on a sphere.
Obviously, you can. You don't have to
No, you
reference the
cannot.
surface for that.
No, you cannot. Can you show us, please?
Says you, George.
Can you show us how does it work an elevation angle? You're going to need a protractor for that. You need a baseline, a horizontal line, a zero line, and anything above that line will give you the angle from that place. You cannot put a protractor on a sphere. The geometry is not compatible. It doesn't work.
Yeah,
You need a
I mean, George,
protractor for
I'm
your
done
elevation
listening
angle
to you repeat
measurement.
that for the 100th
Yeah,
time.
you need a protractor for your elevation angle measurements.
Can you stop
and then you need a right
for a
angle
minute, George?
triangle. Yeah, go ahead, man.
Right. So electric. Apparently, you understood why we cannot have parallel light. We can have parallel lines of light coming from the sun on a globe. Can you explain me that?
We don't have parallel sun rays hitting the Earth. We don't.
It's not the question.
We do.
I'm not
No, we
asking whether or
don't.
not we.
Where are they?
I'm not asking whether or not we do, but George's argument is that we cannot have that on a sphere. Otherwise, a solar noon would be the same for everyone. And you said
Why
that
don't-
made sense to
How
you.
come? Okay, so let me ask you something. How come if I were to look at the horizon and the sun is on the other side of the ball, I don't see sun rays passing the fucking horizon and shooting up from the fucking edge? Why don't I
Can
see
you
that?
answer my question?
No, because your
Yeah, I
question
didn't think
pertains
so.
to a ball, and there's no
No.
ball to be pertained to.
No, the question is George's claim was about a ball, and you said you understood it. I wanted to understand from you what the argument is, but if you don't want to explain it, then you're free
about the ball.
you're
Was
free to
about
refuse to.
was about sun rays being divergent or parallel. There was nothing to do with balls.
You said they can't be
I
parallel on the ball.
said that it's against the model. It's against the
Which model?
navigation.
Against
Which model?
Which model?
Our model, the
I got a
flat Earth
question.
model, the model that you guys been using, that you call it the globe.
Yeah, which is it?
Elevation
Yeah, right.
angles.
So you're talking about the
elevation
globe.
angles from Polaris. No,
So
elevation
you
angles
are
from
talking about the
Polaris.
globe.
No, elevation angles from Polaris. That is a flat Earth model.